Hello and welcome to this course, Creating Android UI with Jetpack Compose. I'm Mehdi Habgu and I will be your teacher in this course. First, let's see what Compose is. Compose is a modern UI toolkit for creating Android application UIs. It is declarative and also entirely written in Kotlin. This means that it can benefit from most of the features of the Kotlin programming language. But what will this course cover? Some of the content that I will be covering in this course are as follows. First, we will have a brief discussion of how Compose works. Then we will talk about setting up the tools that we will be using to create our Jetpack Compose applications. These tools include Android Studio, and I will show you how to install it on different operating systems like Linux, Mac, and Windows. We will talk about composables and preview. I will show you how to create composables and how to preview them while you are developing your applications in Android Studio. We will talk about built-in composables, the composables that have been implemented already by the Android team inside the Jetpack Compose library, and how you can use them in your applications. And since Jetpack Compose has a very good support for material design and material components, we will have a discussion about material design and how we can use material components in Jetpack Compose. A big and important part of the course will be state management and how you should manage the state of your application or different states in your application when developing Jetpack Compose apps. I will talk about layouts and how you can create layouts and customize them. And also I will show you how to create constraint layout when creating Jetpack Compose apps. We'll also talk about theming and how you can create a theme for your Jetpack Compose application or customize the existing one. Animation is a significant part of a UI framework, and Jetpack Compose is not an exception. So we will cover animation and how you can create animation when creating Jetpack Compose apps as well. I will talk about interoperability, which means you will learn how to use your existing view trees inside Jetpack Compose UI system, or vice versa. You will learn how to integrate your new Compose UI inside your existing view trees. When you are developing an application, navigation is inevitable. You will need to go from one screen to another. So I will show you how to implement navigation when working with Jetpack Compose. And last but not least, I will show you how to test your applications written in Jetpack Compose. And that's it. These were some of the topics that I will talk about in this course. But that's not all, and we might talk about some other topics that are not mentioned specifically in this list. So now let's dive into the course and start creating beautiful applications using Jetpack Compose. Reading code samples when you are learning an API can be very useful. In this video, I will show you how to access the code samples for Jetpack Compose when you are working and learning a new component of Jetpack Compose, like for example animation or navigation or other component of the Jetpack Compose toolkit. So to do that, we head over to Android Code Search, which is available at cs.android.com. Here's a heaven of Android developers. you can find different projects of Android like Android, Android X, and Android Studio. The source code for these projects is available in these repositories. Since Jetpack Compose is part of Android X or Android Jetpack project, we open Android X for Jetpack Compose. And then I head over to platform/frameworks/support. Here you will find the up-to-date code and source code for this project. You can find different components of Android Jetpack project, like you can see activity, ads, annotation, and many other libraries and projects like Hilt. I'm looking for Compose. The Compose project and its source code is available here. Compose. I open Compose, and then you can find different parts of Compose like animation, compiler, desktop, docs, foundation, material. As an example, we are looking for the animation samples available in Jetpack Compose. So I open animation, and then you can find that animation has several different components. Several different components are available in the animation component of Jetpack Compose. I open animation core to see the basic animation examples, and then samples, src, main, Java, Android X, Compose, animation, core, samples, and then we find several Kotlin files that contain the samples. If you are looking for animatable samples, you can find them in the animatable samples.kt file. So I open this file, for example, and you can find different and several different examples of using animatables, like animatable animate to generic type, which shows you how to animate an offset using animatables. And there are several other different examples of using animatables in the same file. Each one of them are annotated with @sampled. There are different files, different Kotlin files. There are several different Kotlin functions that are annotated with this same annotation, @sampled. The last one, for example, shows how to animate fade in using animatables. So this is one way to access Jetpack Compose samples on Android code search. The other way, which takes advantage of Android code search capabilities, is by getting a reference in Android Studio online documentation. For example, if I'm reading the documentation for animatable, which I have accessed by control clicking animate to in my source code, I see a reference to this sample, androidx.compose.animation.core.samples.animatable fade in. To find it, I simply search for animatable, the last component of this package name, animatable fade in. I can copy it, or I simply type it, animatable fade in. I type it in the search box here, animatable fade in. Let me see if I typed it correctly, animatable fade in. And one of them is for the samples. you can see the file name hints that this is a sample. And because we are looking for samples, this is our file. This is the file we are looking for to see the samples. The other one actually contains the source code that has a reference to that sample, that specific sample. So I open the first one, animatable samples, and there we go. We found the sample we were looking for. It is a Kotlin function, animatable fade in, that is annotated with @sampled, and this will show you how to use animate2, which was referenced with this documentation. So after watching a video for a lecture, if you still have problem understanding how an API works, how a certain API works in Jetpack Compose, or you simply want to learn more and dive in more and get a deeper understanding and actually expand your experience and skill set, you can simply head over to Android Code Search and see different samples that are available here and read them, try to implement it yourself in order to learn more. So that's it for Android Jetpack Compose samples. Happy coding! Hello! In this video, we will have a technical introduction to Jetpack Compose, and we will talk about its different components. First, let's see what Jetpack Compose is. The term Jetpack Compose refers to the whole project that consists of different components and different projects. These different components are often inside the package androidx.compose and its subpackages. For example, androidx.compose.material or androidx.compose.foundation. So here are the different components of Jetpack Compose. First, we have Compose Compiler that includes Kotlin IR plugin that allows your code to be compiled. And then we have Compose Runtime that handles composition and also is responsible for some other UI related tasks. And then we have Compose UI, which is a toolkit built on top of compiler and a runtime. This is basically what is used to create UIs in Jetpack Compose. Then we have Compose Foundation that is the building blocks for creating UI in Jetpack Compose. For example, we can mention rows, columns, and lists as examples of the components that are present in Compose Foundation. And finally, we have Compose Material that is a material implementation for Compose UI created using Foundation. So if we want to see that in a picture, it's something like this. First, you can see we have Compose Compiler and Runtime. On top of that, we have Compose UI, and on top of Compose UI and built on top of it, we have Foundation, and then we have Material that is in turn built using Foundation. And now, let's see what Composable is. In fact, Composable is a Kotlin function that is used to create UI in Jetpack Compose. Whenever you want to create a UI or define a UI in Compose, you create a composable function, and this function is a normal Kotlin function that is annotated with @composable. Its main responsibility is to turn data into UI elements. Here's an example of a composable. We have a composable function called myComposable, and it receives a parameter that is a resource address for an image stored in the drawable directory in Android resources. This composable receives it and then displays it with another composable, another built-in composable called image. And then if we preview it in another composable that is also annotated with @preview, we can have this output. We can see this preview from running this composable. So basically this shows you how a composable works and what its responsibility is. We will have deeper look into creating composables, and we will in fact create composables in the upcoming lectures. Before getting started with Jetpack Compose and creating Compose UIs for our Android applications, we will have in this section a very small introduction to composables and how we create them. Then we will talk about modifiers, how they can help us change the behavior and appearance of composables. So stay tuned. The best way to know what a composable is and how it works is to create a new project with it and use it in action. So I have Android Studio and I press new project to create a new Compose project. On the new project dialog, I select empty activity, empty Compose activity, and press next. And here for the name of my application, I write Compose Demo, for example. The focus in this lesson, by the way, is on how a composable is created. And I'm not focusing too much on how the project is created because we will discuss that in another lecture. Package name, save location. I set the save location to the folder of this course, and I make sure that minimum SDK is API 21, and then press finish and wait for the project to be created. Alright, our project is created. Now we are going to create our own composable inside main activity. As you can see, already we have several composables that have been added by Android Studio. For example, we have a composable named greeting that receives a name and then prints hello and then that name. In fact, it greets that name. And we have another composable that has also the preview annotation, and its job is to preview that composable and show the output inside the preview pane on the right. In order to have that preview, we need to build the project in order to make the preview appear on the right. So I press the hammer icon on the toolbar to make the project. Alright, as you can see, we have a preview of the composables that we have defined. In fact, Android Studio has defined on the left. You can see that it's pretty simple. It's a Kotlin function with the name of greeting, but it has been annotated with the @composable annotation. And we also have another composable that is annotated with the preview annotation, and that is, as I mentioned, used to preview another composable. So let's take a look at the set content section. In the onCreate method, which is a normal function, a normal method of the main activity class, we have a special method called setContent, which sets the content that is to be displayed in our activity. And that content in turn is generated using composables and the Compose UI. We have our theme here, Compose demo theme, that has a body, and inside the body we have another built-in composable, surface, and inside the body of surface we have greeting, which in turn displays Android aligned with hello and greets the name that is passed to this function. This might seem a little bit overwhelming for the first time, but I'm going to make it very simple to understand. So I'm gonna remove the composables that have been added by Android Studio, and also the call to surface, and also the call to compose demo theme, because we are not going to deal with themes just now yet. So we only leave set content, and later we will fill in this gap. Here, after the end of main activity body, I'm going to create a new composable. In fact, let's create our own versions of composables. I'm going to create a simple composable that gets in a parameter for an image, a resource address inside the drawable directory, and then displays the image that is represented by that resource. So I call this function, for example, fun my composable, my picture composable. It has a body because it's a function, it's a Kotlin function. And here, let's not forget that it also receives a parameter that is the image. And that image is of the type integer because it's a resource address. And here we use a composable from the Jetpack Compose library for displaying images. I call image, and as you can see, we have several options for importing image. Import. I select the second one, which is from the androidx.compose.foundation library. There are a few ways to call the image composable. I use the second format using a painter. So I write painter equals painter resource, and then I pass it the image that has been given to the function, image. And then the second parameter to this composable is content description. Content description, a sample image. In fact, we can pass the content description aligned with the other parameter to my picture composable. So we pass it there, description string, and then we use it here as the value of the content description parameter for the image composable. All right. Now let's have a preview of this composable in another composable. So I create a composable and I make it a preview by adding the preview annotation @preview. I create a function, Kotlin function. I name it preview picture. Preview picture composable. And for preview, you should not pass in any parameters. That's a limitation and that's a rule from Compose you need to respect. Inside the preview, but we can pass any parameter that we want to another composables. So I call my picture composable, and for image I pass in, for example, r.drawable.eagle, some image that I will have in my drawable directory. Currently I don't have it, but I will add it to the drawable directory. And for description I write eagle. I already have the picture of an eagle downloaded to my pictures folder. So I go there in order to bring it to my drawable directory in Android Studio. Copy, Control-C, and back to Android Studio, project, Android view, and drawable, paste it to the drawable folder with Control-V. And make sure that you put it in the drawable folder. Okay, I name it Eagle to be consistent with the name that we used here. There we go. Now we have our image recognized here, and we have our composable. In order to be able to see this preview, we need to refresh the preview pane. So I press this button here, the refresh button, to make it build and refresh the preview. There we go. You can see that our preview is being displayed. We have our composable, and our composable is being previewed on the right in the preview pane. We have it. What if we want to have several previews of composables in Android Studio? Fortunately, it's possible. For example, if you have several composables that create UI, you can have several previews of them. In order to show that, I'm going to create another preview composable. And I'm going to name it, for example, preview composable 2. And what it's supposed to do is to do exactly what we did here, but with another picture this time. So I call my picture composable, and image and description. For image, I'm going to use another picture. So I go and find another picture to be used for this composable. I go to my web browser and go to a photo sharing website like Pixabay, and here search for a picture like bird, for example. I select this picture, open it, free download, select the smallest size, download, save file. I save it in my pictures directory, and then I pick it from the pictures directory by copying it, Ctrl+C, and paste it to Android Studio's drawable directory. Ctrl+V, the drawable directory, OK, I name it bird, an easy to remember name, and then I use it as the value of the image parameter sent to my picture composable, r.drawable.bird. And for the description, I use bird, for example. Alright, now I refresh the preview section and wait for the new preview to appear. Didn't work. I refresh it again. This happens sometimes. Alright, there we have it. Now we have two previews in our preview pane in Android Studio. This shows that you can have multiple previews in Android Studio, and this works by creating a preview for every composable that has been annotated with the preview annotation. The next step is to run our application on an emulator or a real device. For that, we need to put our desired composables and UIs inside the set content section. So inside the set content block, I use one of these composables, for example. I use the first one, preview picture composable. Inside the body of it, you see my picture composable. I copy the whole line, Ctrl+C, and paste it inside set content. Alright, now we are ready to run our application on the emulator and see the output on the device. For that, I will be using my Pixel 4 API 30 emulator. Also make sure that from the Run Configuration section, you select App. So I press the Run button and wait for the application to be built and installed on the emulator. Alright, our application was launched. You can see that the content of our composable that basically displays an image is displayed on the body of our screen or our activity. So that's it basically for how we create composables in Android Studio and how we preview them when we are designing our UIs in Android Studio. I hope that you like this video, and I see you in the next one. Sometimes you like to customize the appearance of the composable that you are designing beyond the parameters that you pass into that composable. For example, in our image composable, we have specified an image to show and also its content description. But what if we want to change its size, its width and height, or if we want to give it a border, or if we want to make it clickable? How do we do that? In fact, Compose UI has a mechanism for changing the behavior and appearance of your composables when you are designing them, called modifiers. Modify is an English verb That means changing, altering, manipulating. So, a modifier is a mechanism that can be used for almost every composable out there, especially built-in composables, that allows you to change the behavior and appearance of that composable and, in short, customize it. So let's use modifiers in this video in order to customize the composable that we created to show our image. Currently, I have two images on my preview pane, but to make it simple, I'm going to comment out one of them, the second one, and I'm going to work on the first one. In order to add a modifier to our image composable and make it easy for reuse, I'm going to send a modifier parameter to my picture composable. So here I'm gonna add to the list of parameter a new parameter called modifier. The type is modifier. And make sure you import the modifier from androidx.compose.ui package. Alright, in order to make it simpler to call and make it optional to pass in the modifier, I give it an empty modifier as the default value of this parameter so that we don't have to always pass in the modifier parameter. So now, in order to call it with modifier, I'm going to my preview picture composable, and here I'm gonna give it the modifier that I want. So I type modifier equals, this is the third parameter as defined by our composables list of parameters. Before using any modifier, let's see what we are going to do. Let's lay out our plan. I'm going to specify a background for my picture composable, and after that I'm going to give it a padding, and after the padding I'm going to give it a border. Yeah, a border. And in fact we could even start with a border and then padding and then another border, and after that we add some clipping to our image so that it is aligned with our border. Let's see that in action. So for modifier, I start with the modifier. This is the way we start creating modifiers. Modifier dot background. This is one of the modifiers that are defined by Compose UI API. So I give it a color, for example, color dot white. I import color, and to show it better I'm gonna press enter. And the good thing about modifiers is that you can chain them. So I'm gonna show the modifiers, each of them in one line. So I chain them to each other. When you chain a modifier, it returns a modifier so that you can call another modifier on it and therefore create a chain of modifiers. It's very beautiful. It's very beautiful design. And after background, we were supposed to give it a border. So I give it a border like this. I import border, and the border starts with the width. There are several ways to call it. I select the third one. So for the width, I give in 5 dp or dip. I import dip. This is the way we specify units in Jetpack Compose. And after border, I specify its color, color.blue. And for the shape, I leave it as its default shape, which is rectangle shape. And the next one was after the border, we were supposed to give it a padding. So I give it a padding of 16 dip, for example. Make sure you import padding as well. And after padding, we were supposed to add another border. You can be very creative. This is just my design and my taste. You can change it to whatever you like. After padding, I'm gonna give it another border. And I'm gonna make this border a little bit more exciting. First, I give it the width. Again, 5 dip. You can give it a different width. And after width, I specify the color. For color, I give it color.yellow. And for shape, I'm gonna pass a circular shape. So for the value of this parameter, I type rounded corner shape. This is one of the composables of Compose UI API that allows you to create round corners. And what do we need to pass into this composable? One easy way to make this composable is just to pass in the size of the corners. So I give it 5 dip. And that's it. So let's see the output so far, see what we have. We need to refresh our layout. All right, now we have the preview of our composable just the way we designed it. We have our white background, then we have a blue border, and we have a 16 dip padding, and then another yellow border that is rounded corner shape. As you can see, if I zoom in, you will see that its corners are round. In fact, you can give it bigger size to be more distinguishable. But as you can see, we have a problem. Our image corners are standing out of the border that it has been given to. What can we do about that? In fact, and fortunately, we have another modifier that we can use for our image composable so that we can clip parts of it. This modifier is called clip. This allows us to cut its sharp corners so that it stands nicely and aligned with our yellow border. So I call .clip, I import clip, and what it does, it receives a shape parameter. So for shape, I use a rounded corner shape. In fact, I'm gonna use the same rounded corner shape that I used for its border with a size of 5 dip. And now let's refresh our view. We should be able to get rid of those sharp corners. There we go. As you can see, now we have our preview of the composable just the way we want it to. So you see that modifiers give us a lot of options to modify the appearance and customize it for our composables. And also it gives us capabilities like adding behavioral changes, for example allowing us to make a composable clickable, that we will talk about in the upcoming sections. But for now you got a good glimpse at how modifiers can be useful in designing our composables. In this section I will show you how to install Android Studio on 3 different operating systems, including Linux, Mac OS, and Windows. In this video, I will show you how to install Android Studio on Linux. I'm using Fedora Linux, but you can use the same steps for installing Android Studio on other Linux distributions as well. The first thing we need to do is to go to Android Studio's website. So I open my web browser, then I go to developer.android.com/studio. Note that there's a tab for preview. There you will find the latest preview version of Android Studio. We will install Android Studio Preview to be able to use the latest bleeding edge features of this IDE. So I select Download Arctic Fox 2020-31 Canary 8 for Linux. It automatically recognizes my system on which I'm browsing the website. I'm on Linux, so it suggests me to install the Linux version. If you want to see other versions of this IDE, for example, the Windows version or the Mac version, you can select More Downloads, and then you will be able to see all the available versions by agreeing to the terms of Android Studio. So I press I agree to the terms, and here the latest version is Canary 8, and different versions are available here: Windows, Chrome OS, Windows, Mac, Linux. First we have the installers, which are Windows and Chrome OS, and then we have zip files, which have Windows, Mac, and Linux versions. I'm gonna download the Linux version. I press the link to the zip file for Linux. This is the latest version for Linux, the latest Canary version. Then I select Save File in my browser, and then OK, and I save it in the Downloads directory. I'll have to wait until the download is complete. Currently I have hidden my downloads from the browser, but I can easily see them by going to Downloads, About, Downloads. And here it shows me the progress of downloading Android Studio. I'll have to wait until the download is complete. So I'll pause the video here and resume it once the download is done. Alright, Android Studio is downloaded and it is in my downloads directory. The next step is to go to our downloads folder and extract the Android Studio archive. So I open the downloads folder, and here we can just extract the Android Studio archive here and start using it. However, I'm going to use another method that's more suitable on Linux system. First, I'm going to launch a terminal. I'm using GNOME terminal, but you can use any terminal of your choice. I go to my downloads folder, and here I extract the IDE to my home directory. You can choose any path that you like. Alright, tar xvf, I use this command for extraction, Android Studio, and then the path to which I'm going to extract the IDE to, I extract it to the home directory. I specify that with this sign. Okay, I press enter and wait for the IDE to be extracted to user's home directory. Alright, the IDE is extracted. Now I go to my home directory and check it out. Home directory, there we go, we have Android Studio here. And if we open it and then go to the bin directory, we will find a file named studio.sh. This is the file that launches the IDE on Linux systems. And we also have two files, studio.png and studio.svg, that are the icons of the IDE in case you want to create a shortcut to the IDE. Alright, first let me show you how it is launched. I go back to my terminal and then change my path to the home directory and then Android Studio and then bin. These are the files that I just showed you in the Nautilus File Explorer. Now in order to launch the IDE, I use this command, studio.sh, and then I also add the & sign and then press enter and wait for the IDE to launch. It is starting, as you can see. There we go. The first thing that we see is that in case you have another version of Android Studio that you have installed in the past, the IDE will ask you whether you want to import the settings that you had in the previous IDE or you want to start from scratch. Since this is a tutorial, I'm gonna start from scratch to go through other steps as well. So I don't import anything and then press OK and then wait for the IDE to start. Next, it will ask me to go through the steps of setting up the SDK and downloading, if required, some components that we will need for developing Android applications. The setup wizard will validate your current Android SDK and development environment setup. You will have the option to download new Android SDKs or your existing installation. Once the setup wizard completes, you can import an existing Android app to Android Studio or start new Android project. I press next. You can go ahead with standard settings or use the custom. I'm gonna choose custom to go through some options. We have to select JRE or Java Development Kit that we will need for Android Studio to work, because Android Studio is an IDE based on Java, so it needs a JDK installation to work. And fortunately, it also has an embedded JDK inside the IDE, so that you don't need to have Java installed on your system. So I go ahead with the default settings, that is using the default embedded JDK from within Android Studio's installation folder, or you can select other version of Java if you have Java installed on your system. For example, I have several versions of Java and I have Java home set in my path to this path, so I can select and go ahead with that. But for ease of use, I'm gonna select the first option, embedded JDK, and next. I like the dark theme, so I select dark theme and press next. Alright, the installer wizard has detected an existing Android SDK on my system. So I can go forward with that settings with that SDK, and Android Studio will have the option to only download the missing components. So I don't need to select anything because everything is installed, and total download size is 0 kilobytes. But in case you don't have Android SDK installed from before, you will have to install at least Android SDK and then Android SDK platform and a version, preferably a latest version of Android, and then also Android virtual device in order to be able to run Android applications in a virtual phone inside Android Studio. Alright, now I press next and wait for Android Studio to finish the setup. There's also notice here about KVM, kernel-based virtual machine. Most systems nowadays have the option to run virtual devices in accelerated mode. And if you are using an Intel-based system, like what I'm doing, you will need to enable kernel-based virtual machine or KVM acceleration on your system. And the way you do it is first you enable it on your BIOS and then also install KVM packages on your system. I have already done it, but based on your Linux operating system, you can select this link, open it, and see the different steps for installing the required packages on different operating systems, whether you are using Ubuntu or Red Hat based operating systems like Fedora, or if you are using Windows. There are different detailed steps for setting that up. Alright, back to Android Studio, I press finish and the setup is done. Now our IDE is ready and we can start developing Android applications, including Jetpack Compose applications. There we go. One thing you might want to do for your Android Studio installation on Linux is to create a shortcut for your IDE so that you can easily find it from the applications and you don't have to go to the terminal each time and then cd to the directory in which you have put your Android Studio installation and then launch studio.sh and all that hassle. What we do is we create a GNOME desktop file, which is a shortcut basically to the IDE. So let's see how it works. First, we go to this directory, local share applications, and here I create a file. I name it, for example, android.desktop, and then a curly braces, angle brackets, in fact, desktop entry, and first a name for it, Android Studio. Because it's preview, I name it preview, and then type is application, and then I specify the path to its executable file. So I know that it is in this location, home, Mehdi, and then Android Studio, bin studio.sh, and then the icon, home, Mehdi, Android Studio, bin studio.png. There we go. I save the file, and soon my system will be able to index this file and know that I have an executable on my system that launches the IDE. Now I will be able to go to the list of my applications and find the IDE. By the way, you could also make this file using gedit. We don't have to do it using VI. Alright, let's go and find it in the list of our applications. Here in the search bar, I search for Android Studio. There we go. You can see that Android Studio is available and the system recognizes it. And if I click it, it will launch the IDE. Now it's much easier to access the IDE this way, and you don't have to go through finding it from within the terminal and running it from there each time. It is much more accessible. There we go, we have Android Studio. In this video, I will show you how to install Android Studio on Windows. Although I'm Linux, I will use VirtualBox to show you how to install Android Studio on Windows. I have Windows running in VirtualBox and I'm gonna maximize its size. The first thing you will want to do on Windows in order to run Android Studio is installing JDK or Java Development Kit. In fact, what Android Studio needs to run is a Java runtime environment. So at least you will need a JRE installed on your system. You can use different versions of JRE that are available on the internet, for example from Oracle or from other sources. I'm gonna use the Red Hat version of OpenJDK, which is free to download from developers.redhat.com. You can find it by searching on Google for Red Hat OpenJDK, and then you will land on this page and you will find the JRE installer for Windows. I'm using Windows 64-bit, so I have to use JRE 11 Windows 64-bit. I have already downloaded it and installed it on my system, so I will not download it again. And the next step is going to developer.android.com/studio/preview. On that page, you will find the latest Canary version of Android Studio. Since I'm browsing the website on Windows, it automatically displays the Windows version for me, the link to the Windows version. So I can select to download it from this link, or I can select more downloads to see all the different archives and all different versions that are available. By selecting that, in fact, I can see the installer version versus the zip versions of the IDE, and I have the option to select one of them to download. There's a button to agree to the terms. I agree to the terms, and then different versions are displayed with the latest version on the top. Android Studio Arctic Fox Canary 8. You can see that we have installers and also zip files. For Windows, I recommend using the installer version because it is easier to install and get started with. So all you have to do is click this link and it will start downloading. Also, since the file size is a little bit big, about 1 GB in size, I recommend using a download manager so that in case something happens with your internet connection, you don't lose the part of the file that you have already downloaded, and you can resume the download later on. I have already downloaded it using free download manager, and I have Android Studio installer on my downloads folder. So I go to my downloads folder, I press the Windows button and E to to open Windows Explorer, and then I go to my downloads folder, and as I told you, I have already installed Java 11 OpenJDK from Red Hat, so I don't need to install it again. But now I will install Android Studio from its installer file. So I open it. I recommend running Android Studio as administrator when you want to install it, so that later on you don't face problems with permission or accessing directories, especially when working with the SDK and saving SDK files. Run as administrator. It might take several seconds to evaluate the installer. Yes. Verifying installer. I press next. In addition to Android Studio, also Android Virtual Device is being installed. Since I'm on VirtualBox, I don't need to enable Android Virtual Device because it will be difficult to launch Android applications from a virtual environment and create a virtual device there. However, if you are on a normal PC, you can leave this option checked in order to have Android Virtual Device installed along with Android Studio. I press next. I accept the location for Android Studio installation and press next. Install. We wait until Android Studio is completely installed. Let's get these windows out of the way. I'm gonna scroll down the screen for Windows so that I can see the start menu. Alright, the installation is complete and I press next. And Start Android Studio is selected by default. I leave it unchanged and press finish to let Android Studio launch for the first time. We don't have a previous version of Android Studio, so we don't import any settings. I press OK. Alright, there's a prompt from Android Studio to allow data sharing to improve Android Studio. I select to share some data, some diagnostic data with Android team by selecting send usage statistics to Google. You can opt out of it by selecting don't send. One of the important steps in setting up Android Studio on Windows is setting up the SDK or software development kit for Android. If it is the first time that you are running Android Studio on Windows, you will be shown this window that guides you through the steps required to set up the SDK. I press next. There's an option for standard installation of the SDK. If it's your first time that you are installing Android Studio, it's better to go ahead by selecting the standard option. But if you want to have more control over what is installed and what is not installed, you can select custom. I select custom, press next. I'm asked what is the location of the JRE for Android Studio. Note that we have installed Red Hat OpenJDK on our system, so we have a version of JRE installed on our system. But There's also an embedded JRE inside Android Studio, the installer versions that you can use so that you don't have to necessarily have JRE installed beforehand. So now we have two versions of JRE. In fact, I can enter the path to the Red Hat JDK that I have installed on my system, and it is in the C directory. Red Hat Java 11. I can use this path and enter it here, but it's safe often to use the embedded JRE from Android Studio itself. So I don't change this and press next. In fact, it's a very good option in Android Studio that it gives you an embedded JDK so that you don't have to install JDK by yourself and set up the environment variables for Java Home and the path. I press next by after selecting the theme. After choosing the theme, I leave it as the dark theme because I'm a fan of the dark theme. I press next. And on this page, you will need to make some selections if required, if you want to customize the installation. For example, do you want to install the virtual device? No, we don't want to install. So we unselect it. We uncheck this option because I'm already on a virtual environment and I don't want to run and create a virtual device in this environment. But on your system, I recommend that you install that if you have a decent and strong system. Also, performance, Intel HacksM, this is also related to virtualization. I don't want to do that. I uncheck it, but you should select it. And this option and this option, Android SDK and API 30, the latest version, the latest stable API of Android, are mandatory, so you cannot uncheck them. I leave them selected and press next. Also make sure that you agree to the path that is selected by Android Studio for your SDK installation. I recommend choosing a path that is straightforward and easy to find, like one of your drives. I change it to, for example, C Android SDK. And since the folder is not already there, I will need to create it by selecting this button, new folder, Android SDK. You can name the folder whatever you are comfortable with. Okay. I select OK. Let's wait for Android Studio to see if it likes the new path. It likes it. I press next. And I press finish and wait for these components to be downloaded and installed in the SDK path that I just specified. So we'll have to wait for these downloads to take place and complete. Alright, the SDK components have been installed. I press finish, and now Android Studio is ready to use. Great. We can press new project to create new projects in Android Studio and start our Android development journey. In this video, I will show you how to install Android Studio latest Canary version on Mac OS. I'm using Mac OS Catalina, and the instructions should be similar for other versions of Mac OS as well. So, I go to my web browser as the first step, and then head over to developer.android.com/studio/preview. Here you will find the link to the latest Canary version or preview version of Android Studio. By default, it will show you the installer for Mac. Download Arctic Fox Canary 8. But in order to see, and if you like to see more downloads for Android Studio and all available options, you can select more downloads, and then there's an agreement to agree to, after which you will be shown all the available versions. For the latest version, Android Studio Canary 8, we have Windows and Chrome OS installers and then zip files. Under zip files, we have a Mac version that is specific to our Mac system, and this is the version that we will need to install, download and install for Mac. I have already clicked and downloaded this file, so I have it in my downloads directory. Let's go and check it out. I go to my downloads folder, and here, this is the archive file for Mac. I open it, wait for the archive to be expanded or extracted. Okay, actually installing Android Studio on Mac operating system is probably the easiest way of installing Android Studio on different operating systems. All you need to do is to grab this file, Android Studio file that has the app extension, and drag it to the applications folder. So I drag it to the applications folder. I already have a version of Android Studio Preview that is almost up to date, but not completely up to date, so I decide to replace it with this version. Alright, now Android Studio is installed and ready to use. But if it's the first time that you are installing that, you need to do the setup for Android SDK. And I'm gonna show you what you need to do. Let me minimize the browser. And then from the list of applications, you'll have access to Android Studio. You open it. First, it verifies the application and then it starts it. There's a warning whether to open the file or not to trust it. I trust the file, so I open it. Android Studio is launching. Okay, we have Android Studio here. But, as I said before, if it's the first time that you are installing Android Studio, it will ask you to specify the location for SDK and also the options to install for the SDK. at least you will need to select Android SDK and a latest version of the platform. You will be shown two options for installing SDK: custom and standard. I recommend going with the standard option that is already selected, which will install Android SDK aligned with Android platform tools and also a latest version of Android API aligned with Android emulator, and you will be good to go. In case you didn't set up Android SDK settings when you are launching Android Studio for the first time, you also have the option to go to the settings of Android Studio and do the SDK settings from there. For example, I can go to the settings from the Customize tab in this version of Android Studio and then all settings. And here we have Android SDK under System Settings, which is in turn under Appearance and Behavior. And here there's an option, Android SDK Location, which you specify as the location where the SDK components will be downloaded and saved to. I have these components already installed. For example, I have under SDK platforms Android 8 to Android 11 installed. And also under SDK tools, I have these components installed. Some of them need update that show a minus in front of them. In order to update, I can simply click them, check them, and it will be updated to the latest version: CMake, Android SDK, command line tools, and NDK. This will make a lot of time to complete, so I'm gonna uncheck or cancel these selections for now. But for now, just remember that these are the options that I have installed, but some of them are optional in order to use Android Studio. For example, NDK, you will not need NDK most of the time unless you are doing some native development. And also LLDB or CMake. But most of the time you will need build tools, command line tools, Android emulator and SDK platform tools, and also Android SDK tools, as well as Google Play Services and Emulator Accelerator or HackSem installer. And from the SDK platforms, you don't need to install a lot of these. You can simply go with the latest one like Android 11, and also if you select show package details, you can select an image, a system image for that version of Android that allows you to have a virtual device, to create a virtual device with that version of Android running on it. So that's it for an explanation of different components of SDK if you want to manually install them. But for ease of use, if it's your first time, I recommend that you go with the standard settings on the page that asks you how to set up the SDK, whether to do it custom or go with the standard. Go with the standard most of the time. And cancel for now, and that's it. Our Android Studio is installed on Mac and it is ready to use to create new projects and open existing projects, including projects for Jetpack Compose. Before we can develop Compose applications, we need to know how to create Compose applications. We can either create new Compose applications in Android Studio with initial support for Compose, or we can add Compose support to existing Android application projects. I will show you how to do both in this section. In this lesson, I will show you how to create a new Compose project in Android Studio. For best experience with Compose, it is recommended to use the latest canary version of this IDE, as I am currently doing. This is the latest canary version of Android Studio that I am using. Arctic Fox Canary 8. Alright, let's get started with creating a new project that has initial support for Jetpack Compose. To create a new project, I select New Project, and then on the next window there are several items and templates for the new project. I select Empty Compose Activity because we want to create a Compose activity, a Compose application. I select it and press Next. In the next form, we fill in the information about our Compose application. For example, for its name, I select a name like my first Compose app. The package name can be anything as long as it's a valid Java package name. You can name it, for example, com.example.myapp or something similar. And then for save location, I specified the location for this course, and then for the save location, I save the project in the directory for this course. So I'm gonna edit this to Compose course, the directory for holding the code for this course. And then the language is Kotlin because it's the only language that we use to work with Compose UI and Jetpack Compose. And minimum SDK, make sure that you at least select API 21 because it is the minimum API of Android that supports Jetpack Compose. Alright, I press finish and wait until the project is created in Android Studio. Alright, our project is created, and you see that by default Android Studio has added several composables, and one of them is a preview so that we can preview the UI that we are designing in Android Studio, the UI that is included inside this composable. If you look at the Gradle scripts for this project, you will see that the Compose dependencies have been added by Android Studio. For example, here in the build.gradle file for the app module, you see a list of dependencies for Compose, like Compose UI, Compose Material, UI Tooling, and also Activity Compose, and so on. Also, there are some options that have been used for Compose. For example, here in build features, Compose has been enabled, and there are some other sections that are related to Compose. We don't need to worry about them because Android Studio has done everything necessary to create the Compose project for us. We go back to our main activity, and if you rebuild the project once, the preview will be enabled because when you initially create the project, sometimes it doesn't work, it doesn't show you the preview, given the fact that this version of Android Studio is Canary and it might contain some bugs. So if we build this again, we will be able to see the preview. So I press this build button and I wait until a complete build of the project is complete, and then the preview of the UI will appear. It didn't work again. I close the main activity file and reopen it. This might solve the problem. Yeah, once you reopen main activity or the file that contains your preview function, the preview will start to appear in its special place on the right side of the screen. Alright, we have our preview. But that's not the point. I just wanted to show you how to create a new project in Android Studio that has initial support for Compose. So easy, huh? Don't worry, because I have more difficult stuff coming in the next lessons. In this video, I will show you how to add Compose support to your existing Android applications. For that purpose, first we are going to create a new project in Android Studio that is a normal Android project and it doesn't have Compose support. It is view-based, and then after that we will add Compose support manually to that project. This will help you understand all the steps that you need to take in order to upgrade your projects to Jetpack Compose. Alright, let's create a new project by pressing New Project in Android Studio. From the New Project dialog, I select Empty Activity. I press Next, and then I name it, for example, View-Based Project. Package name, save location, I check these, they are okay. And Kotlin, the language is Kotlin. This will make my life easier later on if I'm going to upgrade it to Compose, because Compose is only supported with Kotlin. And minimum SDK is 21. If it is not 21, at least we can change it later to 21. It's not a big deal. I press finish and wait for the project to be created. Alright, our project is created. Next, we are going to add Compose support to this project. Note that this project has nothing in terms of composables. We don't see any composables, we don't see any preview, nothing related to them. I'm going to add Compose support to this project first by going to the build.gradle file for the whole project. We start the steps for upgrading our project to Compose by going to build.gradle file in Gradle scripts. I open build.gradle under the app module, and first under plugins I make sure that Kotlin plugin has been configured for my project. This means that my project has support for Kotlin. We have Kotlin Android, which means our project has the Kotlin plugin configured. And the next step is to make sure that minimum SDK is 21, and this already 21, so nothing to do here. And then we apply some options under the Android block in order to enable Compose. Before that, make sure that Java and Kotlin both target Java 8. You can see that under compile options we have source compatibility for Java and target compatibility for it set to Java 1.8. This means that it targets Java 8. And for Kotlin, we see that Kotlin also targets 1.8 version of Java, which means it is targeting Java 8. And then we enable Compose with this command, build features, and then inside the block I enter compose true. This will basically enable compose for the project. We also have some compose options that we need to specify, like compose options, like the Kotlin compiler extension version, the extension that allows our code to talk to Kotlin compiler. So Kotlin compiler extension version. And for the version, we need to enter the latest version of Compose that is available. How do we find it? We can go to Android developers website to find what is the latest version of Compose released. So I open my web browser, and then I go to developer.android.com/jetpack. Here you will see different sections. We have a section for libraries that has all the Jetpack libraries listed. And then we go to release notes, and here we look for androidx.compose. That is the top level package for the Compose project. Under this group, we have several other groups like Compose Animation, Compose Compiler, Compose Foundation, Material, Runtime, UI, and all of them have the same version. Here under versions you will find what the latest version is. At the time of this recording, the latest version released for Compose is 1.0.0 beta 01. So this is the version that I need to use in my project. Since there are different components that I need to enter, different dependencies that I need to specify in my build.gradle file, and I don't want to repeat all the version numbers, I am going to define an extension variable in my build.gradle file so that I can change it easily in future and upgrade my Compose version to newer versions. So I go back to Android Studio and this time open my build.gradle file for the whole project. Under build script, I create an extension variable this way, xt and compose version. For the version, I enter exactly the version that we saw over there, beta 01. Back to our app module build.gradle. Here I use the same variable, compose version, as the Kotlin compiler extension version. And next it's time to specify our compose dependencies. So here, compose dependencies. We start with the UI dependency. So implementation androidx.compose.ui, UI artifact, and then the version number, compose version. This is the fundamental dependency that you will need to enable Compose in your project. And after that, we have Compose Foundation. So let me add some comment here. Basic UI capabilities in Compose. And the next one, implementation androidx.compose foundation, and foundation, the version number, compose version. This is a component that is higher level than compared to the UI artifact, but still it is very fundamental to your project and you will need that to create Compose UIs. UI foundation built on top of UI, built on top of Compose UI. The next dependency is material, the material component of Jetpack Compose. The packages that enable you to have material design capabilities in your Jetpack Compose UIs. Implementation, Android X.compose.material, and material compose version, material design. And for material design, we also have two categories of icons that we probably need to use it in our project, so I import them anyways. Implementation, Android X.compose.material, material design, material icons, core, and compose version. And the next one is the same but a little bit different, so I duplicate the line. Material icons core becomes material icons extended. And the next one is the activity integration artifact that enables you to use Compose UI inside activities. So implementation, Android X.activity, and activity compose, and then compose version, activity integration. Let me minimize this left side, the project viewer, so that we have big space here. And implementation, Android X dot lifecycle. This is view model integration for Compose. Lifecycle view model compose, and compose version, view model integration for Compose. Also, we can have integrations for observables in our project, so I include them as well. Implementation, Android X dot compose dot runtime, and runtime live data, the version is compose version, and implementation, Android X dot compose runtime, runtime RX Java 2, compose version. Okay, let's do a final check if we have included everything that we need. Compose UI, compose foundation, material, material icons, core, material icons, core, material icons extended, activity compose, view model integration, lifecycle view model compose, runtime live data, and runtime RX Java. There's another component that you need to add to your dependencies, and that is called UI tooling. It enables Compose integration with Android Studio, so that Android Studio helps you with UI preview and also some other capabilities that help you during development of Compose based UIs. So I added under UI, implementation, Android X compose UI, UI tooling, and the version is compose version, and Android Studio tooling. So we added Kotlin plugin. We made sure that we have Kotlin plugin for our application. We made sure that our minimum SDK is 21. Our Java and Kotlin have both been targeting Java 8, and we enabled Compose under build features, and for Compose options we entered Compose version for Kotlin compiler extension version, and we listed our Compose dependencies inside our dependencies block. Next, I press sync now and wait for the project to be synced with the new dependencies and with the Compose capabilities. Okay, there's a problem. Vue.js project. Okay, this needs to have an equal sign because this is a variable, and I forgot to include this equal sign as the assignment because this value is assigned to this variable. Okay, I sync it again, try again, and wait for the app to be synced with the dependencies and the configuration. Also note that for lifecycle version is different from Compose version because it is not intrinsically part of the Compose project, but it has an integration for Compose. So it has its own version, and for the version, because I don't know what the version is, I can go to Android website and find Android x.lifecycle, which shows the latest version as 1.0.0 alpha 2, or I can use a trick in Android Studio. This trick is using the minimum version that you can specify for an artifact, and that is 1.0.0 alpha 01. This way Android Studio will intelligently tell us what the latest version is, and we can upgrade to that version. I press Alt and Enter, and then it shows me that the latest version available is alpha 02. So I choose that. And also Activity Compose has its own version. So I remove Compose version from here, and for its version, again I use the same trick, 1.0.0.0 alpha 01, and Alt Enter. The latest version will be shown as 1.3.0 alpha 03. I enter and it is updated. Then I press sync now and wait for the project to be synced. Alright, we have enabled Compose for the project. In order to make sure that we have done everything correctly and Compose actually works, we go to main activity and create a composable. Because we have added Compose UI tooling for Android Studio to the dependencies, we can use some live templates for Compose. To create a composable, I can simply type comp and then press enter. It creates a composable template for me, and then I can give it any name that I want. For example, I name it main screen, and let's give it an input variable, an input parameter like message that is supposed to show. Its type is a string, and then it creates a box, and inside the box it creates a text with the message that is given to it. The box has a size of 300 depth, for example, specified using modifier dot size 300 depth, for example. I import depth, I import modifier, I import box, I import text. Note that text is from the material design package for Compose. I import size. And then to make sure that our preview is also working, I create a preview using live template for preview by typing prev and then pressing enter. It creates an empty preview composable for me. I just give it a name. I name it preview main screen. And then in the body of this preview, I call main screen. The reason why I'm not directly previewing this composable is that this composable receives a parameter and previews cannot accept parameters. The workaround is to call your parameter receiving composable inside a preview. So main screen, and for the message I type, for example, this project has been upgraded to Compose. Okay, after a complete build of the application, we should be able to see the preview on the right side of Android Studio. So I press this button, build and refresh, and wait for the preview to appear. Alright, we have it. We see our preview. I just need to press this button, zoom to fit screen, and then I can see the whole text inside the box that we created. We can also add a background by calling background here, background, giving it a color like color.yellow, for example, and then importing background. And then we refresh the preview. We can also change the text size with style parameter. So for the style, I use one of the default styles, material theme. From material theme, typography dot h2. I import material theme. You see that we have several headings. I use h3 and refresh the preview. Great. So our preview is working, everything is excellent. Just one more thing before I wrap up this video, and that is moving this UI into our final application that is installed on our final device, like our virtual device or on our real physical phone. I do that by going to the onCreate method and commenting out set content view. Why? Because we are not setting contents view this time. We are not using view system anymore. We are using composables to create UI. And that is achievable using this function, set content, that is just imported from AndroidX.activity package. That if you remember, we added that dependency in our build.gradle file for the app module. And then inside set content, I write any UI that I want to include from Compose into my final application, into my final activity. I do that by calling main screen. By calling main screen with this parameter, with this message. So all I need to do is copy this line completely, Control C, and go into set content, pasting it here. Now if I run my application, I will see the same UI on the right inside my activity running on the device. Let's do that. I press the run button from the toolbar and wait for the emulator to launch and show my application. Finally, you can see that our application is running on the embedded emulator with the UI that we designed using Jetpack Compose. You can use the steps shown in this lesson to add Compose support to any of your existing Android projects and take advantage of this new declarative UI toolkit for Android. Hello and welcome to a new section of the course. In this section, we will talk about some of the tools and composables that Jetpack Compose has for creating different types of layouts. For example, we will talk about columns, rows, and constraint layouts. Let's start our discussion about layouts by creating a new project in Android Studio. I press New Project and then select Empty Compose Activity. I press Next, and since we are going to talk about layouts, let's call our application Compose Layouts. And the package name, I don't change the package name and save location. Language is Kotlin and minimum SDK is 21. I press finish and wait for the project to be created. Fine, our project has been created. First, I remove the default preview and composables that have been created, and then we will create our own composables. So I remove these two composables from the main activity, and also I remove everything that has been placed inside set content because we will set our own content. And now let's create a composable. I use the live templates again, comp, and press enter to create an empty composable. I name it, for example, item screen. Let's imagine that we are creating a very simple UI that shows an item like a shopping item or a shopping cart, and then below it we have a text view or a text field that shows the number of those items selected by the user, and then below them we have two buttons that allows us to increase or decrease the number of those items. Let's see that in action. First, I create a box to represent something like the image of that shopping item. So I create a box and I give it a size using modifiers. Modifier dot fill max width. I fill the maximum available width for the box, and also I'm going to give it a background. So I continue the modifier chain, and I give it a background with a color, like for example magenta. Let's close this get notification. Let's also give it a height. I give it a height of, for example, 300 depth. I import depth, and in order to have a preview as we are developing this, let's also create a preview that previews this composable. So I create a preview here by typing prev and then pressing enter. I call it preview item screen, and then inside this preview composable I do a call to item screen. Let's close the left pane for the project explorer so that we have more space, and then from this section I select split so that I have a preview for the UI that I am designing. This needs a successful build, so I press build or make project from the toolbar by pressing the hammer icon. Okay, we continue designing the UI. In addition to that box that represents the shopping item or the image of it, we also have a text field. So I'm going to use a simple text field from the material package. It is called outlined text field. It has a value and an onValue change parameter. We are not going to do a full-fledged outline text field. We just want to have this UI in our preview. And then for its value, I enter, for example, 0, the default value that is supposed to be shown in our outlined text field. In addition to the text field, we also have two buttons. As I said before, we have two buttons, so I create my buttons using the button composable from the material package again. So button, I import button. The first parameter is onClick. I give it an empty lambda because it's not supposed to do anything right now, and it also needs a text. So the text that is supposed to be shown on top of the button needs to come in its body. So I give it a body and text. I call it increase, for example. This button is supposed to show this label, and another button for decrease. Again, onClick doesn't do anything, so an empty lambda is passed to it, and the body has a text or label that shows decrease. All right, let's see what we have so far. What happens if we get the preview of this? On the right side of the screen, I press refresh. We wait for the preview to appear. Maybe the preview is already there. I press zoom to fit screen. Now we need to do another refresh. Okay, as you can see, we don't have the UI that we had planned for. We were supposed to have a box on the top or the image of our shopping item, and below that to have a text field, and below the text field we were supposed to have our buttons, but currently everything is stuck on top of one another. This is not what we hoped for. What we wanted is an order and a good layout and the arrangement, at least for the views to follow each other on the screen. In order to fix this, we will need the layout capabilities of Jetpack Compose. The first thing that can help us deal with is a layout called column. If I put all the composables that I have here, including box, outlined text field, and the two buttons inside another composable called column, I will have a better view for this preview. So I select all these sections from the box to the end of the button, and then press Alt and Enter and select Surround with Widget, and then select Column. I want to surround all these composables with another container or with another layout called column. Okay, let's refresh it and see the effect of this change. Okay, better. Now we have a better preview for our items for the UI. As you can see, now the composables that we had are following each other on the screen in a columnar manner. They are placed and arranged on a column. In addition to layouts, we can also use modifier capabilities to give a better arrangement to our UI items in Jetpack Compose. For example, for our single items, we can give also padding to add a space from their starting position to their content. So for these buttons, for example, I add a modifier that padding, and I give it a padding of 4 depth, for example. I do the same for the other button. And also for our text field. So I add a modifier parameter for that as well. Okay, let's do a refresh. There we go. Now the paddings that we added give a better appearance to our composables. The next thing we might want to do for our composables in this UI is to arrange them in a central manner so that when we look at the views in the horizontal orientation, they are placed almost in the center. So these buttons should be placed at the center when we look horizontally, and the text field as well should be placed horizontally at the center. So how can we do that? By adding a modifier to our column. And I go to my column, I open parentheses for it, and then inside it, as you can see, we have horizontal alignment. So one of the parameters that it has is horizontal alignment. I specify it, and for its value we should pass in something from the type alignment.horizontal. Since I want to align it at the center horizontally, I specify alignment.center horizontally. I import alignment by pressing Alt and Enter. And now all the items in our column should be placed at the center horizontally. Let's do a refresh. There we go. Now our items are placed at the center. That's it for this video. In the next video, I will talk about another layout called row that helps us have even more control on the arrangement and positioning of the items in our Jetpack Compose UI. In the previous lesson, we designed a simple UI using a column, a box, and a couple of other composables. In this lesson, we are going to talk about another layout in Jetpack Compose that allows us to have more control over how we arrange our UI items or components on the screen. So this layout is called row, and I'm going to use a row to put these two buttons that I have, increase and decrease, in a row from left to right on the screen. So let's do that by selecting the two buttons that I have and then pressing Alt and Enter and select Surround with Widget. Press Enter and then Surround with Row. I put them inside a row. I did it using Android Studio, but you can enter it manually by typing row and then putting the two buttons as the content of your row. Now if I refresh my UI, you will see the effect of using row. There we go. Now our two buttons are placed in one row. What if we want to place our buttons in a way that they take half of the screen width each? To do that, we can use some responsive design capabilities that are available in Jetpack Compose. For that, we have the weight modifier for row and column. Let's use it for row first. So to use this feature, I'm going to give each of my buttons a weight of 1. I add a modifier after the padding modifier for the first button, weight. For its value, I give 1F because it has to be float. And then I do the same for the second button, weight 1F, and then refresh the layout. There we go. Now you can see that each of the buttons are taking up half of the screen width. We can do the same for our column because column also supports using the weight modifier. For this purpose, I go to my column and first I give it a modifier to fill in the whole height that is available on the screen to my column. I'm gonna give the whole height that is available to the column. So I type fill max height. And then from the space available to the column, I'm gonna give 2 weights to this box and 1 weight to my text field. So I add to the chain of modifiers for the box a new weight modifier and specify 2f as the value. And for the text field, let's make it 3 in fact for the box. And for the text field, I add to the chain of modifiers for outlined text field weight 1f. And also for the button, I can do the same. It already has a weight, but I can do that for the row because row is now member of our column. So I add a modifier for the row, modifier that weight, and for its value I type 1f. Refresh the UI and wait for the new preview. There we go. It's not that beautiful. In fact, we might have wanted to remove the weight, the 1 weight from our text field because it's too high. So I remove from the text field its weight and refresh the UI again. You can play around with these capabilities in order to achieve your desired UI appearance. Another thing that might help us design better UIs is spacer. Spacer allows us to have space between the items that we have in columns and rows. For example, inside my column, I can add a spacer between the box that I have here and the text field that follows it. So I add a spacer with a modifier to change its behavior and define its height. Modifier dot height, and for its height I enter, for example, 20 depth, and I add the same spacer after this text field between the text field and the following buttons. So I copy this line and paste it after outline text field. I do a refresh. There we go. As you can see, now we have some space between the box and the text field and the text field and its following row. And that is achieved using a spacer. So in this video we talked about row, how row allows us to have better control on the layout and arrangement of the items that we design using Jetpack Compose. In addition to column, that also helps us to arrange items in a vertical way on the screen. We also talked about responsive design using weights inside columns and rows, as well as spacer that allows us to add some space between different UI components in Jetpack Compose. So far, we have designed a layout using column, row, and a few composables like text field and also buttons. But now we are going to talk about another composable that can help us create a specific type of layout, and that is box. Note that we have already made use of box to represent a part of our UI as a placeholder, for example, for the image of a product. But the box itself has some layout capabilities. First, Let's see what a box is for. A box is for stacking several items on top of each other. So if you put two boxes inside another box, those two boxes will be stacked on each other. For example, I have a box here, and then if I put in the body of this box two other boxes, those two boxes will be stacked on top of each other. Also, box has some capabilities for aligning items that it contains in a specific way. For example, to align it to the top or to the center or to the bottom or to the start. So now I'm going to add two boxes inside this current box. First, box, and for the box I specify a modifier to give it a size. For example, I give it a size of, for example, 200 depth. And also make sure you give it a color so that we can distinguish our boxes inside the parent box. Background, I give it a background of, for example, blue. And another box on top of the other box. Box, again modifier, we use it to give it a size, modifier dot size, this time 100 depth, and I give it a background of red, color dot red. Okay, now we have two boxes. Let's see what's the output of this preview. I refresh the preview and wait for it to appear. There we go. You see that the boxes are appearing in the order of composition, which means in the order that they appear inside a composable. First, the bigger box is drawn, and then on top of that, the smaller box is drawn, the red box. Now what if we want to make use of boxes alignment capabilities to align these two boxes to the center of the parent box? How do we do that? I go to the parent box and check the parameters that it can accept. In addition to the modifier parameter, it also has a parameter for content alignment. This is the parameter that can help us align its children in a specific way. So I type content alignment, and then for its value, as you can see, the default value is alignment top start, which means the top left corner of the screen here. So I change it to center. Alignment dot center, and refresh the preview. There we go. Now our boxes are appearing, the child boxes inside the parent box. Beautiful. Now what if we have some other boxes that we want to align in a specific way, so that we don't want the parent alignment to apply to them. We want to individually align a specific child inside the parent box. For example, we have a box and I want to align it to the top left or top start section of the parent box. Let's do that. I create several other boxes, starting with this box, modifier, the mandatory parameter of the box composable, modifier dot size. I give it a size of 100 depth again, and for its background I specify the black color. All right, let's make it green. And what I'm going to do now, I'm going to align it to the top start section of the parent. So I use align. This modifier helps us align children of a box, but note that this is available inside the box scope. As you can see, we have box scope starting in the body of the box, and align is usable inside this box scope. If you open it, you can see that it is available inside box scope. Okay, so now I specify alignment dot top start and refresh the preview. There we go. Now what if I want to have 4 boxes at the corner of the parent box? How do I do that? In fact, I'm going to duplicate this box by pressing Ctrl D so that we have 4 boxes of this size, and then I'm going to change the alignment. So the second one, instead of top start, I'm going to make it top end. And for the third one, instead of top start, I change it to alignment dot bottom start. And for the fourth one, instead of top start, I change it to bottom end. Let's see how it looks. Refresh. There we go. So a box allows us to have different alignments for its children, and also intrinsically it allows us to stack composables or UI components on top of each other. So by default, every composable that you put inside a box goes on top of the previous composable or UI component. And this can be useful sometimes to create a specific type of user interface that you have in mind. Alright, that's it for box and how we can use boxes in Jetpack Compose. There are 2 ways to create UIs based on constraint layout in Jetpack Compose. We talked about one of them in the previous video. In that video, you saw that first I created several references for each of the items in the view. So for every UI component, we created a reference, and then we used constraint as modifier and passed those references to the modifier to enable any type of constraint that we wanted on that UI component. But there's another way to create constraint-based UI in Jetpack Compose using constraint layout as well. If you look at the constraint layout composable, you will see that we can call constraint layout in 2 ways. One of them is by passing it a modifier and then its content. The other form of calling this composable also has another parameter called constraint set. And a constraint set is a set of constraints that we create beforehand, and then we pass it to our constraint layout to use it for specific positioning of the items according to the constraints that we pass in. Let me show you that with an example. Imagine we want to rewrite the constraint layout that we already created in the previous video with the new form of creating constraint layout. In fact, let's recreate the constraint layout that we designed in the previous video with this new form of constraint layout that I'm talking about. For that, first we will create constraint set. So I'm going to define a constraint set. So inside this composable constraint item screen, which is just a normal composable, I create a variable called constraints. This can have any name that you like, constraints. And then I call this composable constraint set. I import constraint set from constraint layout library, the first item, inside the body of constraint set, we will define our constraints for different components. So I start with the box. I create val box. And then I create a reference. Again, you see that it's a little bit similar to the first method that we used in the previous video. I create a reference, but this time I call create ref 4. And I specify an ID box. Next, I add constraints for this reference. So for the box, I had a couple of constraints that I'm going to specify here. I use this method for that. Constraint, and then the reference name, which is box, and then in the body of it, I'm going to specify the constraints related to our box, which were constraining its start to the start of the parent, constraining its end to the end of the parent, and constraining its top to the top of the parent. So you know that we already have those constraints in place. We created those in the previous video. So I can simply copy them from the body of constraint as modifier that we used previously. I copy them and paste them inside the body of constraint box. So this is for the box. And next we have input, increase and decrease. I create references for them as well. Val input, create ref 4 input. I give it an ID. This is an arbitrary ID that I specify for the input. And val increase, create ref 4 increase, and val decrease, create ref 4 decrease. And next we are going to use the constraint that we defined here inside constraint layout. How do we do that? First, you need to make sure that you are passing the defined constraints to your constraint layout. So in this form of calling constraint layout composable, in addition to modifier, we also pass in constraint set. So for constraint set, I pass constraints. Let's specify its name, constraint set, the name of the parameter, and the value is constraints. This makes the code more readable. There are some parts that we will need to remove eventually from our previous code, but I can do that later. Next, in order to connect the reference to the composable that is supposed to use that constraint, I use this modifier, layout ID, and I specify the ID that I gave the reference. So for box, the ID that I created is box. So I type box here. I also import layout ID. In this form of calling constraint layout, we cannot use constraint as modifier anymore. So I remove it. We also don't need these references anymore. I delete it. Let's also create constraints for the other three components. So for input, constrain input, constrain increase for the increase button, and constrain decrease for the decrease button. So what are the constraints that we need for these components? These are the same constraints that we used previously. There's no difference. So for the text field, I have these constraints. I copy them and back here I paste them inside the constraint scope for input. Now for increase, these are the constraints that we used for the increase button. So I copy all lines back here and inside the constraint scope, and inside the constraint scope for increase I paste them, and I do the same for the decrease button. I copy all constraint lines and paste them inside the constraint scope for the decrease button. Now, as I mentioned, we don't need constraint as modifier anymore because we are using another modifier, layout ID. ID of the reference that we created in our constraint set. So for the input, it was called input. It is the name that we gave it, input. I remove constraint as modifier for the increase button as well and replace it with layout ID. The layout ID for the increase button was increase. This ending curly brace is extra. I remove it, it's not needed. And I also remove constraint as for the decrease button and replace it with layout ID. And the ID that we gave to the decrease button was decrease. So one review before we refresh our preview, we created a constraint set and we called it constraints. In our constraint set, we created references for different components of our UI. For the box, for the input, for the increase button, for the decrease button. And each of these references were given an ID. We gave them an ID. After that, we created constraints for each of those references. So for the box, for example, we created a constraint that attached its start to the start of the parent, its end to the end of the parent, and its top to the top of the parent. And we created similar constraints for the other components as well. Then, once our constraints were ready, we passed them inside constraint layout. And constraint layout uses these constraints to position and to align and arrange the items that it contains on the screen given the definitions inside constraint set. One of the important parts when using this form of constraint layout is that you must use the layout ID modifier for your component or your composable and pass in the ID of the reference that is intended for this component or for this UI. For example, for the box, we intended this reference called box. We gave it an ID of box with these constraints, and then inside the box composable we mentioned that ID using the layout ID modifier. This allows it to automatically receive the constraints that we intended for it. Based on the needs of your application, you might decide to use the first form of constraint layout or the second form. The second form is good in a sense that you can define your constraints in another function based on different conditions, based on screen size, based on whatever, and then you can pass in those constraints to your constraint layout. So, for example, I can have several different sets of constraints. This can be one of my constraints. I can have another constraint set defined here, and I can have a third constraint set, and in each of them I have arranged and put items in a different place of the screen, for example. And each time that I'm passing a different constraint set to my constraint layout, the arrangement of the items will change based on the definitions of constraints in that constraint set. This way of passing a prepared set of constraints or constraint set to your constraint layout is called decoupled API or decoupled constraint layout API, which you can use for your application based on your needs, or you can stick to the first form that we talked about in the previous video. So let's refresh the preview and see if we have the same UI that we designed in the first form. There we go. You can see that there's no difference in the appearance of our UI because basically we used the same constraints for the same UI components. The only difference was in how we passed in constraints to our constraint layout. So with that, we wrap up this video. In the previous videos, we have designed a simple UI in Jetpack Compose using layout capabilities like column, row, box, spacer, and some modifiers. But what if we want to design our UI in a specific way that needs even more control and a specific alignment and a specific chaining and positioning on the screen? How do we do that? Fortunately, Jetpack Compose also has support for constraint layout. If you are familiar with constraint layout from Android views, you know that constraint layout is a mechanism to put items in relation to each other on the screen and in specific and complex alignment. If we have some complex alignment, complex layout that we want to design, we can use constraint layout. And in order to use Jetpack Compose with constraint layout, first we need to add constraint layout artifact to our list of dependencies in our Gradle files. So I open my build.gradle file, I press Ctrl Shift and N to search for build.gradle. I have already searched it. So build.gradle from the app module, the file that contains our dependencies. Following our implementation for Jetpack Compose dependencies, I add another line of implementation, Android X dot constraint layout, and constraint layout compose. This is the type of artifact that we need from the constraint layout library in order to add support for constraint layout in Jetpack Compose UI creation. So note that it has its special versioning. It's not the same as Compose version, so we cannot use Compose version. Instead, we can use the trick that we talked about in some previous video, that we can ask Android Studio to help us with the version by giving it a minimum version first, like 1.0.0 alpha 01, and then Android Studio will tell us that there's a newer version than this one. I press Alt and return, and it tells me to change it to 1.0.0 alpha 3, and I accept, and now we have the latest version of this artifact added to our list of dependencies. I press sync now. I don't need to do that. It has already been added actually. If it's the first time that you are adding this dependency to your project, you need to press sync now. That will appear somewhere around here on the toolbar. And after that, you will be able to use constraint layout in your application. So to use it, let's go back to our main activity. And what I'm going to do, I'm going to design the same UI, this time using constraint layout. So I create a composable. Let's use templates by typing comp and then pressing enter. And I'm gonna call it item screen or constraint item screen, because it is designed with the help of constraint layout. And I will have another preview that will preview this one. So I type prev and press enter, and then call it preview constraint item screen. And then inside it, I make a call to constraint item screen. Okay. Note that now, because we have two previews, we will have two previews on the right side of the screen. So the first step to using constraint layout is calling this composable constraint layout. And we will need to import it from the compose module of constraint layout library. So constraint layout, I imported androidx.constraintlayout.compose. I select the first one, and now we have it here. Then we define our items and their constraints. So the first step is to define the items references, or references to the items or UI components that we will have on our screen. So the main ones, the main components that we will have, because I don't want to make it very complicated, is this box around here, and this text field, and these two buttons. We can also add the spacers, but it will make it complicated, so I skip it. I create a variable val for reference, as a reference to this box, so I call it box, and then create ref. This will create a reference for the box that I can later use when constraining this box. And the next one is the text field. val input. This is a text input. Create ref. And the next one is the increase button and decrease button. So val increase and val decrease. Both of them create ref, create a reference. So we have 4 lines just for creating references to our components. But Kotlin has a way of doing that in just a single line. And it is called destructuring assignment. You can actually create all these references in just one line. So I'm gonna do that and show how easy and useful it is. I specify, in addition to the box, I specify input, increase and decrease here, and instead of create ref, I call create refs. And to have all of them get value, I put all of them inside brackets, parentheses, and I remove the other lines that used to define them individually. And now we have 4 references to the components of box input, increase and decrease. So I remove these lines, we don't need them anymore. Next, I'm going to use these items. So for the box, I'm gonna copy it from the above one. This box is the parent box with its children. So I copy the whole box and I paste it here. We don't have the weight anymore because weight doesn't apply in the current scope. So I remove weight modifier from this part. And because I'm going to constrain the box to the parent, I'll call this modifier constrain as, and let's not forget to put a pair of parentheses in front of it and name the reference. First we name the reference for the box. The reference is called box, and inside its body we will define its specific constraints for this component. I copy the other items as well, the buttons and also the text field. So I copy this line, outline the text field, put it after the box, and also we have these 2 buttons. So button, the first button increase and the second button. I'm gonna copy both. Copy and paste it after outline text field. Because we are working inside the scope of a constraint layout, we don't need to respect the order. The order doesn't matter anymore because now we have constraint, and these constraints are the things that define how we order and how we arrange the items on our screen. Again, the weight modifier doesn't apply inside a constraint layout scope, so I remove it for both. Alright, let's give constraints to our text field and the buttons. So for the modifier, I put the modifier in a separate line to make it easier to read. Constrain as, what was the reference for our outline text field? It was called input. And let's open the body of our constraint definition. And let's do the same for our buttons. Constrain as, and for the first button it was called increase the body of the constraint definition, and the second one was called decrease constrain as decrease and its body. Before we actually create the constraints, let's see what we are going to do. I'm going to constrain the big box, the father box, to the parent's top and to the parent's start and to the parent's end. And I'm going to constrain the text field's top to the box's bottom, and then the increase button's start to the parent's start, and the decrease button's start to the increase button's end, and also the decrease button's end to the parent's end. Let's do that. First, starting with the box, with the parent box. Where were we? We were here, constraining the box. I say, do this for the box. Chain its start link to parent start, and chain its top to the parent's top, and chain its end to the parent's end. Okay, now we move on to the next composable, the text field. And for the text field, I constrain its top to the bottom of the box. So I say top link to box bottom. And also, let's not forget its start link to parent's start, and its end to the parent's end. This will make it central when we look at it horizontally and give it a better view. And now it's time for the buttons to be constrained. And for the first button, increase, I constrain its start link to parent start, and its top, it's very important this part, link to the input component's bottom. Input here is a reference that we can call, and we can use its bottom and start and other components. That's enough for this actually. For the first button, it's enough. Let's go to the next button. And for the decrease button, I constrain its start link to increase button's end, and also its top link to increase button's top. This will align the two buttons together. We could also have chained its top to the input references bottom. Okay, let's refresh our preview and see if it is indeed what we wanted. Let's scroll down because our preview for the constraint layout will appear down below. Okay, we have some constraints applied, but it's not actually exactly how we wished it to be. One of the reasons is that we didn't give a size to our constraint layout. So actually, let's do that. Let's give our constraint layout a maximum size. If you remember, for our column in the above preview, we actually had a maximum size. You can see that here. We used a modifier fill max height. So I do that for my constraint layout as well. Modifier and modifier dot fill max height. And I have the maximum height now for my constraint layout. Let's do a refresh. Another reason that we don't have exactly the same UI that we designed using columns is that in the columns case we had weights. We could use weights, but we don't have that in constraint layout. In fact, as I mentioned, constraint layout is a layout that allows you to do specific positioning of items in relation to each other. So one item's bottom goes to the top of the other, and one component's start is chained to another component's end, and so on and so forth. Anyways, to make it look more beautiful than this, I'm gonna make some small changes. For example, here for the big box, I'm gonna give it a height. I'm gonna give it a bigger height actually, because it already has a height that was formerly, in the case of the columns, shadowed by the fact that we were using weights, and the weight preceded that. But now, in the case of constraint layout, we can give it a constant height, like for example 500 depth. And also for the buttons, we can constrain them, constrain the decrease button's end to the end of its parent, and it should look more beautiful than this. And also their bottom to the parent's bottom. You can play around with these constraints to achieve the positioning and the layout that you want. The point is that constraint layout gives you a lot of flexibility to create complex UI components in your Jetpack Compose UI. So for the decrease button, I add end link to parent end, and also its bottom link to parent bottom. Refresh the UI. It's still refreshing. It's not actually exactly what we hoped for. As you can see, I can play around with the increase button as well. For the increase button, bottom link to parent's bottom. Refresh. It is refreshing yet. Okay, there must be something wrong. Actually, I need to constrain its bottom to the bottom of increase, the decrease button's bottom to increase button's bottom. So decrease, here we are, decrease, and bottom link to increase. Come on, show me the preview. There we go. It's better now. Okay, although we didn't exactly create the same UI that we had here in the above section in our second preview, we were able to use constraints to constrain our items and our UI components in a specific way. And this shows us that constraint layout can be used for complex constraints and chaining of items with relation to each other and the parent when we need to. But in case you don't need to create complex UIs, you don't need to probably create your UIs using constraint layout, because it might make it a little bit overwhelming and difficult. If you are creating straightforward UIs, you can just comfortably go ahead with columns and rows and nesting of UIs like columns and rows. But anyways, we have this UI created using constraint layout. Note that the big box that we used was just used as a unit, and the constraint layout had nothing to do with the items and with the children of the big box. Those were positioned using its own mechanism for alignment that we designed earlier. But there's a property of constraint layout that we can use to help our buttons have bigger width and use the constraints that they have and fill their width to the maximum constraint that is allowed for them. So let me show that in action. First, I'm going to constrain the decrease button's end to the parent's end and make sure that it is already that way, and link to parent end, and remove its initial constraint, the start constraint, from the increase end. And the property that I'm going to use to allow this button to fill in the maximum allowed width by the constraint, I'm gonna use width equals dimension dot fill to constraints. And I'm gonna use the same property for the increase button as well. And now if I refresh the UI, I should see a better UI for these two buttons. In fact, to help these buttons fill in half of the screen width, I'm going to chain them to each other. So I'm gonna chain the end of increase to start of decrease and start of decrease to end of increase. So let's start with increase, and I'm going to add its start link to increase and decrease start this should be and link to decrease start. Sorry, this is decrease. I'm gonna do this. I'm gonna copy this line for increase. I cut and pasted here, and link to increase start. So end of increase linked to start of decrease. And I'm gonna do that the other way around. So for decrease, start link to increase end. Okay, let's refresh the UI and see the result. There we go. You see that our buttons now take half of the screen width each. By specifying this kind of chaining them to each other, and also specifying their width as fill to constraints. So that's it for constraint layout in Compose. I hope that you liked this video. State or data is at the core of Jetpack Compose. Why? Because Jetpack Compose actually turns data or state into user interface. Therefore, we need to have the knowledge, the minimum required knowledge of how Jetpack Compose handles state and data and how turns them into user interface. So, in this section, we will talk about state in Jetpack Compose, and I will show you the different techniques that Jetpack Compose uses to manage application state. As mentioned in the introductory videos, Jetpack Compose works by often transforming your data into user interface. So data and state is very important in a Compose application. For example, when a user enters some text in a text field, we need a mechanism to keep track of the characters that they enter, and then we might want to display that text somewhere in our UI or perform a real-time search based on it. Therefore, managing state in Compose is very critical and important. In this video, I'm going to show you how you basically manage the application state in a Jetpack Compose app. For that purpose, I'm going to create a new project in Android Studio. I press New Project in Android Studio and select Empty Compose Activity from the New Project page. I press Next. Because it's about state, I'm gonna name my application Compose State. And then I don't change package name, save location, and minimum SDK, and press Finish. We wait for the project to be created in Android Studio. Fine, our project is created. Next, I'm gonna remove the default composables added by Android Studio. I also remove the content set by Android Studio inside set content because I'm gonna set my own content. I create a composable by typing comp and then pressing enter. I'm gonna name my composable, for example, boxes screen or box screen. I will use mostly boxes to show the state that we will manage in this video. In order to have a preview of this composable, I'm also going to create a preview composable by typing prev and then pressing enter. I name it preview box screen. And then inside the box screen, I'm going to, let's not forget to call box screen inside preview because we want to have the preview of box screen in our preview pane. And inside the box screen, I'm going to define a column. And then inside the column, I'm gonna have a big box. And for the box, I'm gonna set a size modifier dot size, a size of, for example, 400 depth. Let's keep the size in a variable, val box size. Let's start it with a small letter, and 400 depth should do it. I'm gonna use 400 depth or dp for the box size and use it here as the size. Let's also give it a background. Import background, A background of red should do it. You can use any color that you like. And then after the box, I'm gonna have a text field. I use Material Design's outlined text field. For the value, I give a default value of 0 in a text as a text. And then after the text field, I'm gonna have 2 buttons in a row. So I will need a row, and inside the row, I'm gonna have 2 buttons. 2 buttons. Button. And inside the button, I'm gonna show their text. The first button is gonna show increase, and the second one is gonna show decrease. Text. And why is that? Because we want to be able to increase the number displayed in the text field by pressing this increase button, and decrease it by clicking this decrease button. Let's refresh the UI on the right by building the project. As the UI is being refreshed, I'm gonna add some padding for the buttons. 8 depth should be good. And for the second button, I enter pad, and then Android Studio helps me complete it. Modifier.padding 8 depth. Alright, looks like our preview is going to appear. I do a refresh. I also minimize the section on the left, the Project Explorer, to have more space for our coding area. And once the preview shows up here, I'm gonna press zoom to fit screen. All right, it doesn't seem right. Okay, the column doesn't wrap around the other composables. I'm gonna remove its ending curly brace and put it after row. A refresh, and it should be good to go. Another refresh. There we go. It's not that ugly. In fact, now I'm gonna center the items that we have inside our column. So I'm gonna do it using a modifier. I'm gonna do it using some parameters that are specific to alignment. And they include horizontal alignment, and that's the main parameter that I'm looking for. Horizontal alignment. And for its value, I need to specify a value that is of the type alignment.horizontal. So center alignment dot center horizontally. All right. Also, I'm going to give a maximum size for my column to fill the whole screen available to it. So I use a modifier for it. A modifier fill max size. It will fill the whole screen size available to it. And then a refresh. Once the refresh is done, we have our UI. Basically, this is the UI that we want. And then after that, we want to be able to increase the number displayed here by pressing the increase button, and decrease it by pressing the decrease button. Also, for every count that we have here, for every number that we have here, we want to have a corresponding box, a child box inside the parent red box. So for example, if we have 2 here, we want to have 2 child boxes inside the parent. How do we do that? First of all, let's try this in interactive mode. Start interactive mode by pressing the interactive mode button in the preview pane. Increase, decrease. You see that it doesn't do anything because we don't manage state yet. And now I'm going to create a variable, a state variable that will keep track of the count of the number that we have here. So inside the box screen, I create a variable var, I name it count, and then its value is mutable state of. This will basically give us a state type value. I import mutable state of, and I give it an initial value of 0 because it will start from 0. You might ask yourself, why are we using a state? By hovering, you see that it returns a mutable state. Why are we using a state and not a normal value? Like, for example, an integer here. The answer is that you cannot use a normal variable because Composable will not understand any changes to that variable. But once you are using a state and your Composable uses a state, whenever the value of that state changes, your Composable knows that it should draw itself again or recompose. That's the reason why we are using a state and not normal type of variables. Okay, now we are supposed to use the value of count in our text field. So for our text field, I'm gonna use the value of count this way, string template, count.value, and in the buttons, in the increase button, each time this button is clicked, this count is supposed to increment by 1. So in the onclick lambda, I'm gonna type count.value plus plus. And what about the decrease button? Each time the decrease button is clicked, we are supposed to decrease or decrement the value stored in count. But what if the value is already 0? We cannot decrement it. We need to have a restriction for this value to not go below 0. So I type count.value equals, I use an if statement here. If count is less than or equal to 0, count.value, in fact, we need its value, not itself. Then return 0. If it is already 0 or occasionally below 0, we just set it to 0 again. We don't want to decrement it anymore. Other than that, otherwise, we decrement it. It is allowed to decrement itself. So count.value minus minus. Sorry, not minus minus, because we want to set the value to the left side to assign it to the left side. So I type count.value minus 1. Decrement by 1 and assign it to the left side. And this is a handy Kotlin if statement that can return a value. Okay, now we expect this code to work once we refresh our preview. So I refresh it and wait for the preview in interactive mode to be available, and then we are going to test our functionality. Okay, the interactive mode is active. I press increase. You see that it doesn't work. The value doesn't change. And the decrease button, it doesn't do anything too. So let's see what the problem is. Look, I told you that whenever you change a state variable, Compose knows that the composable using that state variable should recompose or called again or to be redrawn on our screen. And each time a recomposition is happening, the variables that are defined inside that composable are reset to their initial values. So for example, the count here is initialized to 0 again each time box screen is called, and each time this composable is recomposed. Therefore, we will never have a value other than 0 here, because each time a recomposition is necessary, the value is reset to 0. How can we fix that? Compose has a very nice mechanism for that called composable memory. And the way we use a composable memory and the way we give memory to a composable is by calling this nice function, remember, before defining your state. Remember allows the defined value, the defined variable, to be initialized only once. And then after that, each time a recomposition is done, it is not initialized from scratch. It remembers its previous value, the value that was initialized the first time that composable was called. So once we use remember, we should be able to solve that problem. I refresh my UI. Okay, now let's test our functionality increase. We need another refresh. Testing again. Okay, sometimes the preview just doesn't work or takes some build to perform correctly. What I'm gonna do is just stop using the preview for now, switch to code, and then run my code on the embedded emulator. That will also give the IDE better performance in comparison with the preview. So I'm gonna run the application in the embedded emulator after using box screen inside set content. So I call box screen here as the content of my activity and then run the application by pressing run app or shift F10. Alright, our application is running inside the emulator, and now I'm gonna test the functionality of the increase button. There we go. You can see that the value is increasing and the updated value or state is displayed inside the text field. Also, in order to make this application more interesting, I'm gonna create some child boxes whose number is equal to the value displayed here, or the value of our state. So inside the body of the box, the parent box, I'm gonna have a for loop that will iterate over the number of our count and then create children in 0 until count dot value. A beautiful Kotlin for loop that will go from 0 until count dot value, not including the value itself. For example, if we have 2, it will go from 0 to 1. So I create a child box here and give it a size. I'm gonna make the child smaller than the parent each time. Therefore, I create a size here, var child size, I name it, and I started to box size minus 20 dep, and then modifier dot size for the child. I'm gonna use child size here, and after that, in order to make it even more interesting, I'm gonna rotate it a little bit by some degrees, like for example I multiplied by 3f, a 3-factor of the index of the for loop. And then I'm gonna give it a background of gray, for example. And also, to make it appear more prominently, I'm gonna give it some border. Import border, and the border's first parameter is its width or its thickness, 1.depth, and the color as a second parameter, color.black. I give it black. You can choose any color you like. All right, let's send them to new lines so that you can see all the parts. So basically you see that each time we increase the number that we have, the count that we have, we should have another child box appearing inside the previous boxes. So let's run the application again and see the result. Testing functionality, increase. There we go. We have a child box appearing inside the parent box. Another box, another box, another box. But as you can see, the boxes are positioned on the top left of the parent box. I'm gonna fix that by centering the child boxes. I do that by adding an alignment parameter for the parent box. It is called content alignment. And for its value, I type alignment.center. I run the application again. Testing functionality, increase. There we go. We have a child box appearing. We have count 1 and box 1. Count 2, box 2. 3, 4, 5, 6, 7, 8, 9, 10, 11. Also, I'm gonna decrease the size of the child box each time because I think it will be more interesting. So for the size that I'm using here, child size, I'm gonna decrease it after drawing a child box. Child size equals child size minus 20 depth. I can simplify this by using minus equal. I do it automatically using Android Studio, replace with minus equal. And I run the application again. All right. The boxes are being created, the child boxes inside the parent box. You can see. Once you press the increase button, a new box will appear inside the other boxes, the previous boxes. And when you press the decrease button, the last box drawn inside the boxes will be removed. This gives the impression that our application is intelligently adding or removing the latest box inside the previous boxes. But the fact is that each time we are running a loop and we draw boxes by the number of count that we have. So for 7, we draw 7 boxes inside the parent box. For 6, we are drawing 6 boxes. And this happens so fast and the user doesn't realize that we are doing this trick. So in this video, I showed you how to define a state variable and how to change its variable after remembering it. This is very important part. You must remember a state variable once you define it. And after that, you can follow the events that happen, like a button clicked by a user, and decide what to do with the value of your state, whether to increase it, to decrease it, and so on and so forth. I hope this gives you a basic idea of how Compose State works. But this is not all about Compose State Please stay tuned for more about Jetpack Compose State. In the previous video, you saw that we defined a state variable using mutable state of, and the value that it returned was in fact mutable state. Therefore, each time we needed to access the value of this state, we needed to call count.value. And each time we needed to set a new value to that variable, we needed to call count.value equals new value. For example, you can see that for the outlined text field, we used count.value as the value to be displayed here in the text field, and whenever we wanted to update it, again we called count.value. But you can imagine that this makes a little bit inconvenient to use. This makes the state variable a little bit inconvenient to use, because you might expect that count is an integer, while it is not really, because it is a state and you need to call count.value. But what if there's a mechanism that allows you to use a state variable as the value, so that you can use count as count.value? Fortunately, Kotlin has a mechanism called delegates that allows you to do exactly that, to use count as count.value, as its value. In order to use delegate, we need to replace the assignment operator with the by keyword. And also we need to import two functions in the list of our imports in order to be able to use delegates. These two functions are getValue and setValue. Import Android X .compose.runtime getValue, and I duplicate the line and change getValue to setValue. These two functions are the functions that we need to import in order to activate delegates. You see, the error message is gone. You can also check out the documentation for getValue and setValue to see how they are defined by pressing on them. They are inline functions that allow you to update your state value. Okay. Once we defined our state as delegate, we can simply remove the value part and use count as its value, as an integer. So I remove all the dot value parts and simply use count itself. Alright, we replaced all count.value usages with count, and you see that it really simplified our code. And from now on, you can just use the state by mentioning count itself, and count is just an integer now. It's not a state anymore. So let's run our application to see if it made any differences in the functionality of our application. We expect to see no differences. Alright, our application is running. Let's test the functionality increase. Great, it is working just as before. Great. So you see that using delegates just made defining states easier for us and more convenient. So that's it, basically how you define a state by using delegates in Jetpack Compose. And with that, I wrap up this video. In the previous video, I showed you how to do state hoisting with a simple technique, moving the state out of a composable to its caller. But what if you want to hoist the state to a view model? So nowadays, a lot of people are using view model in their Android applications. How do we do that? How do we state hoist to a view model? So let's switch to Android Studio, see what we have. So I have a simple state hoisting from the previous video, and I'm gonna change this hoisting to a view model. So first, I'm gonna create a view model. So in this file, I can create my view model by defining a class and view model, but before that, you need to make sure that you have the required dependencies for Compose in order to interact with view model. So I'm gonna switch to build.gradle file for the app module, not this build.gradle file. I need the other build.gradle file, and I need to add two dependencies. Implementation, one of them is Compose integration for view model, and the other is Compose integration for live data. So first, the view model, Android X, lifecycle, view model, Compose. And because I don't know the version, I use the minimum version to trick Android Studio to help me. Alpha 1. You can also check the latest version on developer.android.com. Change to 1 Alpha 3. Android Studio tells me the latest version. So this is the first dependency, and the next one is live data. Implementation, Android X, Compose, runtime, live data, and 100 alpha 01. Again, I ask Android Studio to tell me the latest version. Yeah, the latest version is 1 beta 2. So I press Alt and Enter and change to that version, and I press Sync now. We wait for the project to add these dependencies to our application, and that's done. I close these build files and switch to main activity. Previously, I told you I want to create a view model inside this file, but it's more beautiful to create it in another file and not in main activity. So I'm gonna switch to project view, and here I'm gonna create a new file by right-clicking and then selecting new Kotlin class file. And since this is class, the type is class, I name it count view model. I'm not gonna make it very complicated. It's just supposed to change and store the value of count. Okay, I create a variable for it, a field for count, and because this is a view model, this is supposed to hold a live data for us. So private val count, it's a mutable live data. I import it from the lifecycle library, and I pass it an initial value of 0. And then I create another variable to read the value of underscore count, and in fact we will use that to read the value of count, but we will use this one to set the new value of count. This is a simple trick that we often use with live data. So val, note that this one is not private because it is supposed to be accessible. Val count, its value, its type is live data, and its value, let's import live data, its value is count. It's not empty live data, it's live data of the type integer, because the type of count is integer, as we know. Also, we will have a function that we will use to tell our view model to change the value of count to a new value. So I define a new function, fun on count changed. Note that this time I'm calling this function on count changed because this is supposed to change the value of count, and here the value of count is actually changed. The previous ones, the on count change functions that we created in our main activity, like this one, in fact we're supposed to only signal and request a change in the value of count, but this time we are actually changing it. This is the core of change, this is the core of our state and the source of truth for our application. This view model is our source of truth. So this receives new count, so define a new parameter for it of the type integer, and its operation is very simple. All it has to do is set the value of count to new count. All right, that's all we need in our count view model. I return to main activity and see what I'm supposed to do to hoist the state to my new view model that I just created. So because I will read the state from the view model, I don't need this definition anymore. So I comment it out to later remove it. And first I create a view model. Val count view model. I define a new variable, count view model, I name it. Its type is count view model. And I create the view model, the count view model instance by calling view model. This is a function, a convenience function in Jetpack Compose that allows us to create view model in the scope of our current activity. Our current activity, main activity, has a scope, and in its scope, this function will create the view model, count view model, and return it to us. And in fact, you can see that in the inline documentation, it returns an existing view model or creates a new one in the scope, usually a fragment or an activity. All right. So we have our view model, and from the view model, we need to read a state. What is that state? That state is count. So I create a count. I say count VM dot count observe as state. So this will return a state for us, but make sure that you also specify the initial value for it. The initial value is 0, like we created with mutable state of. We passed in an initial value, so make sure you pass that here as well. So now we have the count and we are passing it to box screen. But in order to access the value of this state, we need to use delegates. So I remove this equal sign and make it a delegate, and now it returns the value of the state, which is an integer and is compatible with the signature of box screen definition. Also, we have the handler defined inside our view model. OnCount changed. So we can use it here when we need to change the value of count in our view model. So whenever count changes, whenever we want it to in fact change, we call that. We say count vm.onCountChanged, and then we pass in the new count. Just like this. It was simple, huh? So I think that we are good to go. Let's comment out the section for preview box screen. In fact, it doesn't make a difference. It will work anyways, but I'm gonna comment it out so that you know you should switch to view model here. And I'm gonna run the application, and we are expecting the application to work just as before, but we know that behind the scenes we have hoisted the state to a view model. Run the app again. There was a crash in our application. I run the app again. There was something wrong. Let's check the dependencies of our application, build.gradle file, or before that, let's check the logcat. Cannot be cast to Android X lifecycle view model. Sorry, I had a mistake in defining the view model. The view model, when we define it, the view model class has to be extended from Android's view model. So make sure that you extend your view model from Android's view model, which is from the lifecycle package. So I import it, and also make sure that you are using the constructor invocation here by adding a pair of parentheses, and now our code should work. I run my code again. And there we go. Our application is running successfully. Increase 1 by 1 is added to the list of our child boxes, and by pressing decrease 1 by 1 they are decreasing. Beautiful. So in this video I showed you how to do state hoisting through a view model and hoist the state of your composable to a view model. This way, having a central place for managing your state and a central source of truth. So the general idea for Compose is that data or state always flows down to the composables from the parent to child composables, and events flow up. So you can see that we are flowing the state value of count down to a composable, and that composable is invoking events up, and the color that called that composable above is responsible for changing the state, but not the composable itself. The composable should usually have no direct access to changing the composable's state. So again, data flows down and events flow up. Alright, that's it for state hoisting to a view model. I hope that you liked this video. When creating a composable in Jetpack Compose, it's okay to define your state inside your composable. However, it's preferable to try to move the state out of your composable as much as possible. The act of moving the state from a composable to its color is called state hoisting, and in this video I'm going to show you how to do it. So I switched to Android Studio. I have the project that we created together, and as you can see, we created our state inside our box screen composable. We created a state variable called count that determines the number of child boxes that we will eventually create inside the parent box. But what if we want to hoist the state count out of box screen to its color, which here is set content? So let's do that. In order to hoist the state from a composable, you need to pass in a variable to that composable that determines the value of that state, and also another parameter that determines what the composable should do when that state is supposed to change. Let's see that in action. So I'm gonna tell box screen how many counts I want for the boxes. So I need to create a parameter for it, count, its type is integer, and also I need a handler. I need a lambda that tells box screen what to do when it wants the count value to change. So I say on count change. This is a lambda and it requests the color to change the value of count. So when you define a lambda signature, you define it this way: an empty pair of parentheses, and then the right arrow, and then the return type, which is often unit in Kotlin, which means we don't return anything. But note that we will want to tell our parent, our color, to change the value of count to a new value that we are passing. So we need to pass in a parameter to that lambda, and its value is of the type integer. So I specify int here. Okay. Then, because we want to move the state out of our composable, I'm gonna cut this line, which is the definition of the state, and I'm gonna paste it inside set content. So this initializes my state to an initial value of 0. So I pass count to box screen, and also I know that box screen also has a parameter, a lambda parameter, that it uses to tell us to change the value of count. It doesn't directly change the value of count. Please be careful here. It just asks us as the color of box screen to change that value. So I know that we have a lambda here and we are passed a parameter of the type integer, and it's the change, in fact, is the new value of count, new count. So I name it new count, and once we receive it, all we have to do is to set count equal to that value. Count equals new count. And we have a warning here that tells us because our last parameter of the function is a lambda, it's better to move the lambda out of the parentheses. And this is a rule of Kotlin that tells you it's better to move your lambda out of the composables parentheses when it is the last parameter in the list of parameters for that composable or function. So again, because this part is the second parameter, is the last parameter for the function, and it is a lambda, then we can move it outside of the parentheses. So I do it, I move the parentheses to before the start of this lambda, and the warning is gone. In fact, you can see this usage in a lot of Jetpack Compose's built-in composables. For example, in the case of box, here is the content section of the box, and this is a lambda part. But because it has been a lambda, it has been able to move outside of the parentheses. But we know that it has been a parameter of the box composable, and we can make sure of it by checking the list of parameters for box. As you can see, modifier, content alignment, propagate min constraints, and finally content, which as you can see from its function signature, it's a lambda. So if your last parameter for the function is a lambda, it's better to move it outside of the parentheses. But why? Why do we do that? You can see by looking at this code that by moving your lambda outside of the parentheses, your code is more readable and more beautiful. And this usage allows us to write more straightforward code and more intuitive, because we know that in this section, when we are opening a pair of curly braces, we are opening a space, a scope for creating content. And this holds true for almost every composable in Jetpack Compose. For example, for row, we have this rule, for column, and so on and so forth. But back to our topic, state hoisting. So we created our code to hoist the state and also set the new value of count here. But there's something left to do in the body of box screen, where we will want to request the change in the value of count. So when we press the increase button, in fact, we should ask the caller to make a change in the value of count. And the change that we want is adding 1 to the value of count. So here, instead of directly changing the count, because we don't have the permission to change it anymore, we will want our parent, our caller, to change it. And because our caller has given us onCount change, we can use it to ask for change in the value of count. So I use it on count change, and the value that I want the new count to be is count plus 1. And what if the user presses the decrease button? In that case, I need to make sure that count is not going to be less than 0. So I do a simple check, and I say, again, note that I'm using onCount change. onCount change, change the value of count to this value that I'm passing. If count minus 1 is less than or equal to 0, then pass in 0, then return 0. Else, otherwise, return count minus 1, because this button is supposed to decrement the count value by 1. So, on count change, if count minus 1 less than or equal to 0, return 0, or pass 0 as the parameter of on count change. Otherwise, pass count minus 1. This is the new value that we want count to have. So let's run our code to see if it works the way we expect. Before running it, in fact, we need to make some change in the body of our preview as well, because our preview is calling box screen and it is using the old format of box screen. But we know that we have changed the signature of box screen and now it has a different way of calling. It takes 2 parameters. So in order to save time, I can just copy the code that I have inside set content for preparing the state and passing it to box screen. I can use it inside the preview composable, but we are not going to use preview. I'm going to run the application and get the output from this section, because running the code on the emulator is more performant on my machine than running it in the preview section. So let's run the code. We wait for the application to be built and installed on the emulator. Alright, the application is launched and I press increase. There we go. This is 1, the value of count, and we have a single child inside the parent box. Increase it by 1 and we will have 2 children, 3 children, 4 children, 5 children, 6 children, 7 children, and decrease them 1 by 1. You can see that it is working exactly as before, but this time we have made our composable stateless. This means that it doesn't have the state itself. It is only given the value of a state and then it shows what we want it to show. And whenever it wants the state to change, it just requests the change via the lambda that we have given to it. Here, that lambda is onCount change. Box screen is using onCount change to ask us to change the value of count. So again, let me summarize. The technique that I just showed you is called state hoisting. It allows moving the state from inside a composable to outside the composable to its color. It makes your composable more flexible and more reusable, so that you can have different behavior for your composable based on the parameters that you are passing it. And this process is called turning a stateful composable. You can remember that the previous version of this composable was stateful, and we transformed it to a stateless composable. The current version is stateless. One more thing before I wrap up this video is that you can define the state and also its change handler in one line thanks to Kotlin's destructuring assignment again. So instead of using this code and manually changing the value of count, in fact Kotlin has a way of doing it automatically. So we have the count here, and I can say, for example, var count and on count change. Here the second value or variable that I am specifying is responsible for changing the value of the first variable. So this is a lambda, and Kotlin does that automatically behind the scenes, and it knows that this is responsible for changing the value of count. And we cannot use delegates this time. We use the equal sign, and on count change, count on count change. And in order to use it, we simply say on count change, and we pass in the new count. There we go. So you can use this format of defining your state and its change handler as well. And because here we don't change the value of count explicitly, we can change the var keyword to val, like this. Again, I run the code to make sure and show that it is working as before. Increase. Great. It works without any change in the action and in the performance, just like before. So with these simple techniques, we were able to turn our composable that was stateful to stateless composable. And you can see that in the beginning it might seem a little bit complicated and a little bit like magic, but it's very beautiful, and I hope that you like this video. Welcome to a new section of the course. In this section we will talk about basic Jetpack Compose components when creating UI. I will show you how to create text, button, and image UIs using composables that have been defined in the Jetpack Compose library. So stay tuned. Text is a very important unit of UI when creating Android applications. In this video, I will show you how to create text elements for displaying some text message or some other message in your Android applications. First, let's create a new project in Android Studio. I open Android Studio. I wait for the Android Studio application to open up. Okay, new project. I press the new project button and then select empty compose activity. Next, I name my application compose text. And then package name and save location don't change. I don't change them. Language is Kotlin, and API for the minimum API is 21. Press finish and wait for the project to be created. Alright, our project has been created. I paused the video to save time, and now we can continue. I close the left pane here and also this part on the right, And first of all, I'm going to get rid of these composables added by Android Studio because we're gonna start from scratch. And I remove the content of set content. Alright. Next, I'm going to create a composable in which I will create my text element. Before creating that, let me explain a little bit about text elements in Compose. Note that there are several ways to create text composables and text UIs in Jetpack Compose. Some of the composables that deal with text are inside the foundation package of Jetpack Compose, and some of them are in the material package. First, I'm gonna start with the foundation ones. So I create a composable by typing comp and then pressing enter. This will create a placeholder for a composable. I'm gonna name it text UI. And inside it, I'm gonna create a column to hold several text elements for me. I import column. And as I told you, there are several composables inside the foundation package of Jetpack Compose. I'm gonna start with basic text. Basic text, I press enter, and as you can see, it has several parameters like text, and by pressing Ctrl P, you can see the rest. Text, modifier, style, on-text layout, and so on and so forth. So I'm gonna pass in some text for it, like welcome to Jetpack Compose, and then a modifier. Modifier is not necessary, you can actually skip it. I'm gonna give it some padding. Let's import modifier first, and then give it padding, and import the padding function as well. I'm gonna give it a padding value of 8 dp or 8 dep. Import dep. And in order to see a preview of this composable that we just created, I'm gonna create a preview function. So I type prev and then press enter. This will create a placeholder for a preview composable. I'm gonna name it preview text UI. And inside it, I make a call to my composable named text UI. Text UI. And then I'm gonna display it. Let's refresh the preview pane on the right and see what we have. We wait for the preview to happen, for the preview to appear after a build is done. Showing up, there we go. We have our preview of the text that we passed in to basic text. So you can see that it's pretty easy to display a text UI in Jetpack Compose using the foundation package's basic text composable. Another composable that is available in the foundation package is core text. But it's kind of a low-level composable that is not often used by us as developers for creating common UIs. Therefore, I'm gonna skip it. I'm gonna delete it, core text, and we will only talk about basic text from the foundation package. But what if we want to make this composable reusable by passing a text to it and then asking it to display it for us? For that purpose, we can add a parameter to our composable like text, and its type is string, and then ask basic text to display that parameter for us. Okay. I remove that parameter's value and pass in the passed parameter text. And this text is different from the text on the left. This is the name of the parameter, and this is the value of the parameter that is passed to us via the parameter of the type string. So in the preview function, we are gonna create a text and then pass that text variable to text UI to display it for us. Alright, I create a parameter here. I create a variable named text to display, and then its value will be welcome to Jetpack Compose or whatever that you like, and then pass it to text UI, text to display. And we refresh it. The preview should appear soon on the preview pane on the right. There we go. You see that the appearance doesn't change at all because it's essentially the same text that we passed in, but we passed the value of the text to display as a parameter this time, and we didn't hard code the text to display in basic text. Also, we can press this button, zoom to fit screen, to see the whole area of the UI in the preview pane. And in order to have a border for your text, you can use the border composable, you can use the border modifier on your chain of modifiers. So after padding, I add a border. I import border, Alt and Enter, and then for the border has a width and a color. So for the width, I pass in 4 depth, for example, and for the color, I pass in red. I import color, and then we refresh our preview. I refresh it again. Sometimes it happens like this. You have to refresh it several times for the text to appear. You see that it's not very lovely because our border has some conflict with the dimensions of our padding. So we could adjust that by changing the size of our padding, for example, by reducing our padding and reducing the border size to remediate the issue. Alright. Know what? I'm gonna remove the whole border part. Doesn't stand very well here. So in this video, I told you about creating text using basic text from the foundation package of Jetpack Compose. But there's one more composable that we are going to talk about for creating text, and that is not from the foundation package. It's from the material package, and it's called text. So I'm gonna create in my column, I'm gonna create another composable by calling text, and what it does, it creates a text UI exactly like basic text, but it has material properties, and it's from a different package. It's from the material design package of Jetpack Compose. So I use the same text for the text composable as well. So for the parameter of text, I pass in text. Alright, our text is ready. We can use a modifier or we can skip it. To make them similar, I'm gonna use the same modifier for the text composable as well. That adds 4 dip of padding to it. Alright, let's refresh our preview of the UI that we created. Another refresh. There we go. You see that there's no difference, no apparent difference between the two UI components that we created. One of them is built using basic text and the other is created using the text composable. So basically that's it for how to create text composables in Jetpack Compose. In the next video I will talk about customizing text. So stay tuned. In the previous video, we created a simple text UI using 2 text composables, one from the foundation package and one from the material package, basic text and text. In this video, I'm going to show you how to customize your text by changing their default style. As you can see, we have a default font and we also have a default size for this font. But I'm gonna show you how exactly you can change their style. I'm gonna start with basic text. Unfortunately, both of these composables, basic text and text, have a parameter named style that allows us to customize the appearance of text. So for the style of basic text, we start with passing a style parameter. Note that there's 2 ways to pass a custom style to your style parameter. One of them is using one of the prepared and ready styles of the material package. So material theme, typography, and then one of these styles. As you can see, the type of these styles are all text style and we can use them here. So because this is kind of a headline that we are using, we can use one of these headings like H3 or H4. Let's use H4. And although basic text isn't from the material package, it can use the style value from the material design package, material theme.typography.h4. I'm gonna use the same style for the second composable text as well. I can make a slight change to it, actually, to make them a little bit different. I'm gonna make the first one kind of a headline, or add another text, for example, to act as a headline of this course. So basic text equals welcome, and then for the style I'm gonna use material theme dot typography dot h. Let's see what we have. H2. Yeah, that should do it. There we go. I add a spacer after it to add some distance after basic text, and make its size something like 16 depth in height. Actually, it's gonna be height. Import height So let's see what we have by refreshing our preview. Another refresh. All right, there we go. We have our text. You can see that we have the welcome headline, and then we have the two other text UIs displayed one on top of the other. All right. Next, I'm gonna show you the second method of changing the style, and that is by customizing the style. For example, I want to change one of these styles to a different style of mine, to a custom style of mine. To do that, I say text style dot default dot copy. The copy function from Kotlin allows me to customize an object and return the modified type. So now I can pass in the different parameters for that object that I want that object to differ in. For example, the color can change. For the color, I'm gonna pass different color, like color.red. I can pass in a different font size. So font size can be different. It can be, for example, 50 SP, and the unit of font is SP. You can specify other parameter values like font weight, font style, font synthesis, and so on and so forth. And one of the interesting things that I like is changing the font family. You can even change the font family using this method. So imagine you have a custom font that you have added to your resources, and now you want to use it in your application. It's easy to do it. But first, let's see what the preview is for this code. I refresh the UI and wait for it to appear. Another refresh as usual. The first time doesn't work, apparently. There we go. But you don't have to use textstyle.default all the time to customize your font or customize your text. You can use one of these custom styles that have been one of these ready styles that have been created in material package, and then customize them. For example, the H4 style that we have, I can use copy on it because it's a text style object, and I can customize it with copy, and then pass in a different color to it, like color.blue or color.green, and then change the font size as well. For example, font size, this time let's make it a little bit bigger, 60 SP, and even font weight or font style dot italic, normal, one of these two can be used for font style. I'm gonna use italic, font style dot italic. Okay, let's see what we have by refreshing our preview. Another refresh, please. There we go. And I can use the same method on the first basic text by customizing it, copy, and let's customize its font weight. Font weight dot bold. Let's use a bold font weight for it and then refresh. Let's see what we have. Another refresh. There we go. You can see that it's very easy to customize your text using the style parameter and using the method that I just showed you, using one of the ready styles or just customizing any style type you want. Okay, so we talked about using the style parameter and how to customize it, customizing even the styles, text styles from the typography that was in turn from the material design package of Jetpack Compose. And now I'm gonna show you how to use a custom font. For that purpose, I have already downloaded a font from the internet, actually from Google Fonts. It's a very nice site, I love it. It's in my downloads directory. The font name is Chango. I copy it by pressing Ctrl C and back to Android Studio. I go to the project section and resources. First, I'm gonna create a fonts folder by selecting new and then Android resource directory. The type is font. Press F to select it and then OK. And then I paste my font here inside this folder. I'm gonna make it small case. It cannot be capital case. It has to be small letters. Chango, TTF, okay. And we have our font. So next, the question is how we use it in our composable. You need a font family object that you need to pass into the font family parameter in your style parameter. So let's see what we need to do here. We need to create a font family object. So I create val font family or custom font, let's name it. And then I use this function, font family. There we go. I import font family. As you can see, it takes several parameters. It takes several forms of calling. It has several forms of calling. You can use one of them. I'm gonna use the simplest one that takes a list of fonts, a vararg list of fonts. So you can pass in one or more fonts here. So I'm gonna create a font object, custom font. The next one has to be custom font family. So my custom font, and my spelling sucks, custom font. Okay, let's create a font object. I created using this function, font, with capital F. I import font, and then let's see what it receives. It receives a resource ID. I'm gonna pass it a resource ID. That is the only required parameter of this function. So r.font.chango, and then pass in the custom font object to custom font family, custom font, and then use custom font family object as the parameter of our font family in our custom version of the text style object. So here, where were we? I'm gonna use it on the second text composable. So one of the parameters that text style receives is font family, and I'm gonna use my custom font family. Let's refresh, see what we have. I'm gonna minimize the left part, it's too big. It just deprives us of seeing the code. Okay, please appear. Another refresh. Wow, nice. So we were able to use a custom font in our Compose UI by creating a custom font object and then using it for our customized version of text style. It's nice. Alright, I think we're good to go. We talked about creating text composables using the basic text composable and the text composable from two different packages. The text composable is actually more recommended if you are making your application material and if you want your application to be material, but using basic text is just fine. And also you can customize your text as I showed you by calling copy on a text style object, or using the copy function on text style.default, and so on and so forth, passing your parameters like font weight, like text size, font size, and so on, like even font family. We were able to use a custom font family. Okay, so with that, I'm gonna wrap up this video, and I hope that you liked the video. One of the important questions when developing Compose applications and especially creating text UI is how we can create text input, how we can get text input from user. So in this video, I'm gonna show you how to do that. First, because we are not going to use our preview anymore in this video, I'm gonna close it by switching to code view, and now I also can remove the preview part, but it's just fine. Let's leave it as is. I'm gonna create another composable. I type comp and create a composable. This is a placeholder for that composable, and I'm gonna name it my text input. All right. And inside this my text input composable, I'm gonna show you several ways of inputting text or entering text. Note that Jetpack Compose has several composables from different packages for that. One of them, or one type of them, is from the foundation package, and some of them are from the material package. So because I'm gonna show you all of them, let's create a column. I create a column, and then inside it, first I'm gonna start with basic text field. I import basic text field, and note that here it's very important to know that there are two very important parameters that we need to pass in to basic text field. One of them is the value for the text field to display, and the other is the lambda that handles the change in that text field. So whenever the users enters an input in that text field, it needs to be updated. It needs to be changing the value of the text field. So the user enters, for example, hello, and as any more characters of hello are being entered, the value of their first parameter, text field value, needs to be updated to that newly entered value from the user. So let's see that in action. Value, this is the name of the parameter, and for that I can enter an empty string, and then the other one is on value change, and it can be just an empty lambda. But note that this will not do any change. This will not do anything. The user cannot enter anything. Even if you enter a name here like compose, This will be the only thing that will be displayed in our basic text field, and nothing else will be entered. So to solve this challenge, we need to introduce state. We need to introduce a state that we will use for it. So I'm gonna say var basic text. This will be the value of my basic text field, and I'm gonna create it with delegates, so I use the by keyword, and then remember mutable state of we define it with mutable state of, and then remember. It's very important to remember it. If you don't remember it, the value of the text field will not be updated to the input that the user enters. We also need to import get field, get value and set value from the Composer runtime package. So I press Alt and Enter to see if Android Studio will help me import it automatically. Seems like it doesn't, so I enter it manually. I go to my imports and import androidx.compose runtime.getValue and import androidx.compose.runtime set value. So now I will be able to use this mutable state of with an initial value. I'm gonna pass in an initial value of empty string and no more errors or warnings. So the initial value of the value parameter for basic text field now will be basic text. And on value change, what on value change does is that it receives the input that the user enters, and then we can assign that new value to the value of our text field that will be displayed for the user. So we know that we are receiving a parameter, a string parameter called it in our lambda. So I'm gonna put value equal to it. Actually, you need to use the name of your state here. So the name of your state is basic text, so I'm gonna use basic text. And whenever basic text changes, this basic text field is recomposed again and it is updated to the latest value and displayed to the user. Note that we cannot test this on our preview section. That's why I closed it earlier in this video. We are gonna run it on our emulator. So I'm gonna call my text input inside set content. My text input. Let's run the application and see the result. I run the emulator by pressing Shift and F10. Wait. right? The application is launched, but we don't see anything here. The reason is that it doesn't have a background different from the default background, therefore we don't see anything. However, we can enter some text here. So some text. You can see that we can enter some text here. So that's it, basically how basic text field works. But you can add some padding, and you can also use modifiers to give it some centering and things like that. But this is not the only way to use text fields and to receive text input from the user. Before doing anything more, let's add some padding. Modifier, let's see which, modifier is the third one. So if we use the positional sense of the word, we can skip using the parameter name and just use modifier itself. So I'm gonna use padding, a padding of 8 depth should be fine. Okay, before running our application again, I'm gonna use some other types of text field as well. So I told you there are several types of text fields that you can use in Jetpack Compose. One of them was the one that I showed you, basic text field. The other is text field. Text field, I press enter, and if you open text field, if you open text field, you can see its documentation and how it is defined. You can see that it is from the material package. There we go, compose material. And you can find a lot of information about it. But we're gonna use it very simply. We're gonna pass it some value. So I'm gonna define a value for it. We are not going to use the same value for all text fields. Every text field has its special value that the user enters. So we need a special state for it. Okay, var, I'm gonna define it as text field tf text field text. Again, define it using delegates. Remember, mutable state of. There we go. And for the value, I pass in tf text. And for onValue change, I'm gonna pass in the new value that the user enters to the value of tf text. I'm gonna assign it to tf text. So tf text equals it, the value that the user enters. Okay, why is that? The it is not accepted on value change. So on value change tf text by, remember, mutable state of, and it's got a value, and then we are using that. Okay, tf text and it. There we go. It's now accepting it and it's working. So in order to see what these text fields are for, before them I'm gonna use a simple text that tells us what they do. So the first one is actually basic text field. I'm gonna copy it and use for the second one as well. The second one is text field. And the third one and the more interesting one that is my favorite is outlined text field. The outline text field is actually a text field that is more beautiful by default, and it has a nice outline for your text when you create it, and it can have a text holder. It can have a label for your text, like what you see in HTML forms nowadays. So outline text field, again, it has a value parameter. For its value, I'm gonna define outlined text field text. I define it using, remember, mutable state of, the default value of empty string. OTF text is the default value, and on value change should handle the changes to it. Please receive the new value and assign it to OTF text, outline text field text. So OTF text equals it. And one of the interesting things, okay, what's the problem here? OTF text cannot, okay, this has to be var, yeah, sorry. I define it val. So another parameter that is my favorite when defining outline text field is label. By defining a label, actually you can give it a value. You can give it a text, a default text or placeholder for it to display for us when there's nothing entered in the field. So I define the label. It's as a lambda. You can see from the definition here, label, it receives a lambda that is actually the content that we want to display as the label. So I'm gonna use a text here as label, and let's call it outlined. This is just the label to display. All right. And because it already has a label, we don't need to precede it with a text that says what kind of text field it is. For the previous two ones, we added two text fields. We added two text composables, one of them basic text field, the other text field, to show to the user what kind of text field they are. But for the third one, it already has a label parameter, and it will tell us what kind of text field it is. So let's run our application again and see what we have. Installing. There we go. You can see that each one of these text fields have a different appearance. The basic text field is simply a basic text field. It doesn't have any decoration or something. It's just an empty field. We can enter some text. And for the text field, we see some background color, and it also has some nice baseline color. We can enter some text. And for the outlined one, you can see that it's very beautiful. It shows a default label inside the text field, and as long as we put our mouse inside it or put our finger inside the text field, the outlined label moves to the corner, and we can still see the label of the text field. It's very beautiful. So outline, enter some text just to see how it works. So there we go. So I talked about three types of text fields in Jetpack Compose that you can use for your Compose applications to get text input from the user. One more thing before I forget is that you can also specify the type of input that the user can enter for you. For example, for the outline text field, I can specify the type of the input that I want to enter by looking at the list of parameters that I can enter: visual transformation, read-only, text style, placeholder, leading icon, trailing icon, is error, visual transformation, keyboard options, and keyboard actions. Yeah, keyboard options. You can specify the type in keyboard options. It's the parameter name, keyboard options, that default. I'm gonna customize it, copy, and then as you can see, one of the parameters that it accepts is keyboard type. So keyboard type, I'm gonna change it, for example, to keyboard type dot number. Let's allow our user to only enter number here. Let's run our application. Let's see what I did. Keyboard options, I used the keyboard options parameter. It's also available for other text fields as well. I actually customized the default one by using the copy function on the default object and then changing the default value of keyboard type parameter to keyboard type dot number. This will change the type of the input that is allowed to number only. So now if I want to enter something, I will see a number keyboard and I can only enter numbers. There we go. So that's a basic lecture of how text fields work and how you can manage text inputs. Now you can do whatever you like with the input data that the user enters, because we are using a state variable to keep track of the user input, and then we can pass it to some API. We can use it to make some changes in our view model, save it in the database, or do whatever we want with it. I hope that you liked this video. Button is one of the most commonly used components for creating UI in a lot of applications, a lot of mobile applications, and it's highly used in Android applications as well. So in this video, I'm gonna show you how to create button UIs in Jetpack Compose. Let's start by creating a new project. Empty compose activity I select, and then I change the name of the application from my application to Jetpack Compose Button. I don't change the package name, save location, and minimum SDK. It's 21. I press finish and wait for the project to be created. Alright, as the project is being created, I get rid of the default composables that Android Studio has added for us, and I also empty the content of set content. We will need our own content. We will add our own content here. I will create a composable just for working with the buttons. So I'm gonna create comp. I type comp and then press enter. Let's see if Android Studio helps us. Yes, it creates a placeholder for composable. I name it button UI, and then inside it, because we might want to create several buttons, I'm gonna use a column again. Also, let's give our column some modifier, like some size, fill max size, for example. Fill max size. Okay, that's fine. And then inside the column, the composable that I'm gonna show you that we will use for creating button UIs is named button, and it is from the material design package. So I select button and press enter. It creates the placeholder for the button. As you can see, it has a required parameter named onClick, and it is actually the handler for the click of the button, as we will talk about later. But for now, note that the button is a composable that follows the convention of other composables. So it has an area, it has some dimensions, width and height, and it has a body. Inside the body, you can add any UI that you like. For example, some text. Usually we'll add some text inside the button because it's gonna act like the label, as the label of that button. So I use text here. You can also use basic text from the foundation package. That's fine. For the text, I pass in, for example, Jetpack Compose, and then or show message, for example. Let's imagine it's gonna show us some random message. And then the second parameter, modifier, some padding. Let's give it some padding, but we're good without it. I don't use a padding. The button has some default padding, I guess. And then inside the onClick, we will need to do something about the change, about the state change, because the button click by the user is kind of the change in the state of your application. So you need to manage it if you are going to do something about that click. For example, if the user clicks to see some message, if the user clicks to send some data to the server, and so on and so forth. So before handling the click, let's see what we have by adding a preview. I type prev and then press enter. It creates a preview. I name it button UI preview. All right. Inside the button UI preview composable, I call button UI, and then we go to the split view of our code in order to see our preview and wait for the application to be built and allow our preview to appear for us. Let's refresh it. Seems like we have to wait a little bit for the application to be built, and then we can see the preview. There we go, it's going to show up. Nice. So we have this, we have our button, but currently if we test it, we will not see any behavior from the button because we don't do anything in the state handling part, in the click handling part. So to test it, I start the interactive mode by pressing this icon that has a finger on a screen. We wait for the interactive mode to launch, and now if we click it, doesn't do anything, and it's no surprise because we haven't implemented anything. So here, actually, when that happens, we can ask the button to show a message. And how do we do it? Again, I'm gonna resort to state. State is very important, guys. I define a state variable, var, let's define it as var, val message. I name it message, you can name it whatever you like. By, remember, mutable state of, let's import mutable state of, and remember, okay. Also, we will need to import get value and set value for our delegate to work. So I'm gonna import them manually. In our list of imports, import Android X .compose.runtime.getValue and import Android X .compose.runtime.setValue. And I move on and see no errors anymore here. Okay, first of all, we will not have any message, but we expect the message to appear once the button is clicked. So the message is empty first, but later it will change when the button is clicked. The button is clicked and the message is changed to some arbitrary message, like for example, welcome to Jetpack Compose Development. Nice. And where do we show the message? Because we're inside a column, we have a good opportunity to do that. I'm gonna add a text here and specify the value of its text as message, because message is of the type string and we can use it for its parameter. Text, and let's also give it some nice style. Text style dot, actually let's use material theme dot typography dot h2. Yeah, it should do it. The IDE is a little bit striving in terms of memory, so it lags a little bit, takes some time for the auto-completion to work. Let's minimize the left part, it really annoys me sometimes. And we have the text, we have the button, and the text will only show the message welcome to Jetpack Compose Development once the button is clicked. Also, I don't like the button here, so I'm gonna center it by asking the column to do it via one of its parameters. It's horizontal alignment parameter. Horizontal alignment, and its value has to be something of the type arrangement. It has to be something of the type alignment.horizontal. So alignment dot center horizontally. Yeah, the IDE is really having a hard time with memory and CPU, so it lags a little bit. I have to be a little bit considerate about it and take it easy on him. And now we have center horizontal, it should be fine. Let's see what we have. Let's refresh our UI. Seems like it is appearing, it's refreshing. Another refresh might be a good idea. Okay, we have our UI, show message, let's click it. There we go. Our message appeared. Welcome to Jetpack Compose Development. So you see that we easily added a change in state by handling the onclick the onClick parameter of our button, and then inside that handler that was a lambda in turn, we just changed a state parameter, a state variable that we had defined using delegates. It was message, and we changed its value to this text. Actually, I'm thinking of something to make this a little bit more usable, this button UI. We can pass in the message. We can pass in some message to display for us, not just this hard-coded message. For example, I'm gonna define a message variable somewhere, for example, inside my preview, var message okay, like this. And actually I can define it as a state. Why not? Message by remember mutable state of and the remember has to be finished with the ending curly brace. Okay, and I'm gonna pass it to button UI. So button UI has to input a parameter, has to have an input parameter. So button UI, I define a parameter for it called message. Its type is text. Message. You can see that this message that is received as a parameter, sorry, its type is a string. It is different from the name of the parameter that is here. All right. Actually, I can change it to message text to avoid confusion. Message text. It's better now. And now I can pass in the value of welcome to Jetpack Compose application development. I also changed the message so that you see some slight difference in the UI, but basically it would do the same thing. And pass a message to button UI this time. And since this is only a variable, we could have defined it as a normal variable. It didn't have to be a state. Okay, now let's refresh our preview and see what we have. Okay, it's refreshing. Show message. And there we go. Welcome to Jetpack Compose application development. And we can try without the state as a normal variable by commenting this out. Val message and even just passing the text to button UI, just like this. Yeah, passing the text that you like to display as the message to your button UI. Refresh the UI. Okay, show message. There we go. Welcome to Jetpack Compose app development. Nice. So you see that using button in Jetpack Compose is very straightforward. The composable that you will use for this is the button composable from the material package from Jetpack Compose, and it has a content that you can customize. You can add any content that you like, especially a text composable, some text composables to act as the label of that button. And then you can handle its state change by handling the click inside its onClick lambda, and then change some state inside that lambda, as we did in the onClick section. You can see for the onClick parameter, we had a lambda that inside the lambda we changed some state value to a new value. That was how we changed the state, and we allowed some event to happen. We allowed some message to display for the user. So that's it for how to create button composable and button UI in Jetpack Compose. I hope that you liked this video. Image or graphics are one of the more and most commonly used UI types that is used and seen in almost every Android application. So it's very important to know how to display images in Jetpack Compose. In this video, I will show you how to do it. First of all, note that we often show images in two ways. We might show images, we might load them from our resources in Android Studio inside our application resources, or from a network. And these are two different topics. Therefore, I'm gonna show you how to display images from resources first. And in the next video, I will show you how to load them from network, from the internet. So let's get started by creating a new application in Android Studio. New project, empty compose activity. I name it Jetpack Compose Image. And I don't change anything else. I press finish and wait for the project to be created by Android Studio. Alright, our project is ready. I close the left side. And first I'm gonna get rid of the preview and the default composables that have been added by Android Studio, and I empty the content from within the set content section. Alright. I'm gonna create a composable for displaying images. So I type comp and press enter, and then I create a name for it, like for example, image or compose images. All right. Inside it, I'm gonna use a column because we might want to display several images below each other. I import column. Also, I give it a maximum size, fill max size. And the first thing you need to know about displaying images from the resources is that you can use the image composable for that purpose. So the composable that we will use is image. Image. I import image, and as you can see, it's from the foundation package. I import it, and it has three forms of calling. So we have three ways of calling the image composable, but I will use the easiest one that takes the painter object. So I use the one that has a painter parameter, and for that I call painter resource a method, a function that allows me to load an image from the resources of my application. So here's where I will enter the ID of that resource, that drawable. I don't have that drawable yet, so I leave it empty. And the next required parameter is content description. It's important to enter this as well. So for now, I leave it empty string, but I will complete it later. Because we have two types of images, vectors and raster graphics, or bitmap images, I'm gonna show you both of them. And for each one of them, we will have one image. Therefore, I'm gonna add another image, and I'm gonna use the format that has a painter parameter, again, painter resource, and content description. But since for the first one, I'm going to load a vector, I'm gonna add a text as a title, acting as a title for it, that tells us what it does, tells us that it is actually a vector. So vector graphics, or graphic here, it's one image. And for the second one, it is bitmap, so bitmap graphic. And next we need to load our resources. First, I'm gonna load a vector graphic. How do I do that? You can find one of vector graphics from the internet, one vector file from the internet. That these files have often an extension of XML. You can find them, you can add them to your project, or you can use one of the built-in vectors that are bundled in Android Studio. So for that purpose, I'm gonna use one of the vectors that are bundled in Android Studio by pressing File, New, and then Vector Asset. And then from the clip art section, I'm gonna click it and then select one of these vectors. For example, the Android one. I select the Android one and OK. Also, let's give it a bigger size, something like 100 by 100. Although it doesn't make difference, you can later change it. Vectors are scalable and you can be worryless. You don't need to worry about the size change. It's just a convenience. And I change its name to Android for easier reference, and then press next. Finish, and that file, that XML file, is added to our drawables. Therefore, I can load it here as the parameter of painter resource by typing r.drawable.android. And its content description is Android bot, Android TM, of course, but. And the second one is supposed to be a bitmap. So how do we add a bitmap to our resources? I already have downloaded a bitmap from the internet. I have it in my downloads directory. I go to my pictures directory. Actually, it's in my pictures directory. So I copy it. I come back here to my project and paste it to my resources, drawable, Control V, the drawable folder, OK. And I name it fantasy. It had a file name of fantasy, or let's name it bitmap for a simple reference. OK, now I can use it inside painter resource by saying r.drawable.bitmap. Looks like the bitmap name wasn't allowed, or the image is a little bit too big. So let's change it. Let's change it to something else. Change the name to something else like raster. See if we can reference it. Raster. Not yet. It's a little bit too big, I'm afraid. So I search for another image. I go to pixabay.com and I find another image. Let's use this flower. Free download. Use the minimum size. Download it. I download it to my downloads directory. Okay. Copy back to Android Studio and paste it to my drawable directory. Let's name it flower. I'm gonna get rid of bitmap. Let's remove it. There we go. I'm gonna use flower here. Okay, now let's see what we have by previewing our UI, our Compose Images UI, by defining a preview function, and then I'm gonna name it Compose Images Preview. You can name it whatever you like, and I'm gonna call Compose Images here. There we go. Let's see what we have by switching to preview. I minimize the left section for Project Explorer, and I refresh the preview pane. We wait for the preview to appear. It should be available soon. There we go. As you can see, we have two types of images displayed. One of them is vector graphic and the other is bitmap graphic. And both of them are placed in our column. We have also added a title on top of them by adding a text composable. And we can therefore know what type of image they are. Also, in order to have the maximum width available to them, we can give them some modifier. So for image, I'm gonna add a modifier. Let's see if it's the third parameter. Looks like, yeah. So I can say fill max width and fill max width for this as well. And let's not forget to add a content description for the flower as well. Okay, let's refresh our preview and see what we have. You can play around with these composables and add different modifiers like borders and so on and so forth. There we go. As you can see, now we have the maximum width. We can also change their height if we wish to. And one other thing that we might want to do for our images that we display is changing their content scale. As you can see, currently Jetpack Compose tries to respect the aspect ratio of my image, and therefore it has to put the image in the center of the area that is available to it. But if I change it to another content scale, for example, this will look more beautiful for the flower, of course. One of the parameters is content scale, and I can change it to one of the values of content scale: fill bounds, fill heights, fill width, fit inside, and none. You can play around, experiment, and see how each of them affect your UI. I'm gonna change it to crop. This is essentially something similar to center crop that we used to have in our view-based images that we created for Android applications. Actually, it was used for image views, if you remember. I refresh the UI. Another refresh. There we go. Now you can see that it has changed the content scale, and therefore it is cropping a section of the image, respecting its content, actually respecting its aspect ratio, but scaling it at the same time, therefore cropping a central section from the image, giving it a nice view like this for the flower. Okay, one other thing before I wrap up this video is clipping the image. You can also clip the images using modifiers, of course. So for the modifier, also if you're asking why I didn't use the modifier here, modifier name, the parameter name, it's because it's the third parameter of the image composable, therefore I didn't need to use it. I didn't need to use the name of the parameter. It's the third positional parameter. So I'm gonna clip it this way by using the clip modifier. This allows me to cut a part of the image and create a circular image or something like that. So the parameter that you will need to pass into the clip modifier is a shape, and this can be one of the ready shapes like circle shape. I import it. Let's refresh it. Or it can be a custom shape that you can create by calling rectangle shape or cut corner shape composables. So let's refresh it again. There we go. As you can see, it creates a default image for us, and we can probably see a better view for the image if we add a spacer after the title for it. Spacer like giving it a height of 16 or 64 depth, and then refresh it. Refresh. And because it doesn't have enough height, it cannot show the whole circular area for the image. So if we increase the height of the image, we can see a better result. So fill max width, and I can say fill max height, and then refresh it. We expect that this will give us a circular shape for the image. There we go. It allocates the whole area available to the image and then applies the content scale that we know cuts the central part of the image and displays it for us. Actually, a constant height will be better here, something like 400 depth. Refresh it. You can use this technique using circle shape, clip, for creating profile images and so on. Another refresh. There we go. It's more beautiful. And if you are looking for a custom cut, for a custom clip, you can actually create your own shape using cut corner shape and then passing the size that you want, or round corner shape, rounded corner shape. which will effectively create round corners for you. You can play around with them and see the result. I'm gonna switch back to circle shape, and that's it. That's basically how you can load images from your app resources in Jetpack Compose and display them, whether those images are bitmaps or vectors. I hope that you liked this video. Image or graphics are one of the more and most commonly used UI types that is used and seen in almost every Android application. So it's very important to know how to display images in Jetpack Compose. In this video, I will show you how to do it. First of all, note that we often show images in two ways. We might load them from our resources in Android Studio inside our application resources, or from a network, and these are two different topics. Therefore, I'm gonna show you how to display images from resources first, and in the next video I will show you how to load them from network, from the internet. So let's get started by creating a new application in Android Studio. New project, empty compose activity. I name it Jetpack Compose Image. And I don't change anything else. I press finish and wait for the project to be created by Android Studio. Alright, our project is ready. I close the left side, and first I'm gonna get rid of the preview and the default composables that have been added by Android Studio, and I empty the content from within the set content section. Alright, I'm gonna create a composable for displaying images. So I type comp and press enter, and then I create a name for it, like for example image or compose images. Alright, inside it I'm gonna use a column because we might want to display several images below each other. I import column. Also, I give it a maximum size, fill max size, and the first thing you need to know about displaying images from the resources is that you can use the image composable for that purpose. So the composable that we will use is image. Image. I import image, and as you can see, it's from the foundation package. I import it, and it has three forms of calling. So we have three ways of calling the image composable, but I will use the easiest one that takes the painter object. So I use the one that has a painter parameter, and for that, I call painter resource a method, a function that allows me to load an image from the resources of my application. So here's where I will enter the ID of that resource, that drawable. I don't have that drawable yet, so I leave it empty. And the next required parameter is content description. It's important to enter this as well. So for now, I leave it empty string, but I will complete it later. Because we have two types of images, vectors and raster graphics, or bitmap images, I'm gonna show you both of them, and for each one of them we will have one image. Therefore I'm gonna add another image, and I'm gonna use the format that has a painter parameter, again painter resource, and content description. But since for the first one I'm going to load a vector, I'm gonna add a text as a title, acting as a title for it, that tells us what it does, tells us that it is actually a vector. So vector graphics, or graphic, here it's one image, and for the second one it is bitmap, so bitmap graphic. And next we need to load our resources. First I'm gonna load a vector graphic. How do I do that? You can find one of vector graphics from the internet, one vector file from the internet. That these files have often an extension of XML. You can find them, you can add them to your project, or you can use one of the built-in vectors that are bundled in Android Studio. So for that purpose, I'm gonna use one of the vectors from that are bundled in Android Studio by pressing File, New, and then Vector Asset. And then from the clip art section, I'm gonna click it and then select one of these vectors. For example, the Android one. I select the Android one and OK. Also, let's give it a bigger size, something like 100 by 100. Although it doesn't make difference, you can later change it. Vectors are scalable and you can be worryless. You don't need to worry about the size change. It's just a convenience. And I change its name to Android for easier reference, and then press next. Finish, and that file, that XML file, is added to our drawables. Therefore, I can load it here as the parameter of painter resource by typing r.drawable.android. And its content description is Android bot, Android TM, of course, but, and the second one is supposed to be a bitmap. So how do we add a bitmap to our resources? I already have downloaded a bitmap from the internet. I have it in my downloads directory. I go to my pictures directory. Actually, it's in my pictures directory. So I copy it. I come back here to my project and paste it to my resources, drawable, Control V, the drawable folder, OK, and I name it fantasy. It had a file name of fantasy, or let's name it bitmap for a simple reference. OK, now I can use it inside painter resource by saying r.drawable.bitmap. Looks like the bitmap name wasn't allowed, or the image is a little bit too big. So let's change it. Let's change it to something else. Change the name to something else like raster. See if we can reference it. Raster. Not yet. It's a little bit too big, I'm afraid. So I search for another image. I go to pixabay.com and I find another image. Let's use this flower. Free download. Use the minimum size. Download it. I download it to my downloads directory. Okay. Copy back to Android Studio and paste it to my drawable directory. Let's name it flower. I'm gonna get rid of bitmap. Let's remove it. There we go. I'm gonna use flower here. Okay, now let's see what we have by previewing our UI, our Compose Images UI, by defining a preview function, and then I'm gonna name it Compose Images Preview. You can name it whatever you like, and I'm gonna call Compose Images here. There we go. Let's see what we have by switching to preview. I minimize the left section for Project Explorer, and I refresh the preview pane. We wait for the preview to appear. It should be available soon. There we go. As you can see, we have two types of images displayed. One of them is vector graphic and the other is bitmap graphic. And both of them are placed in our column. We have also added a title on top of them by adding a text composable, and we can therefore know what type of image they are. Also, in order to have the maximum width available to them, we can give them some modifier. So for image, I'm gonna add a modifier. Let's see if it's the third parameter. Looks like, yeah. So I can say fill max width and fill max width for this as well. And let's not forget to add a content description for the flower as well. Okay, let's refresh our preview and see what we have. You can play around with these composables and add different modifiers like borders and so on and so forth. There we go. As you can see, now we have the maximum width. We can also change their height if we wish to. And one other thing that we might want to do for our images that we display is changing their content scale. As you can see, currently Jetpack Compose tries to respect the aspect ratio of my image, and therefore it has to put the image in the center of the area that is available to it. But if I change it to another content scale, for example, this will look more beautiful for the flower, of course. One of the parameters is content scale, and I can change it to one of the values of content scale: fill bounds, fill heights, fill width, fit inside, and none. You can play around, experiment, and see how each of them affect your UI. I'm gonna change it to crop. This is essentially something similar to center crop that we used to have in our view-based images that we created for Android applications. Actually, it was used for image views, if you remember. I refresh the UI. Another refresh. There we go. Now you can see that it has changed the content scale, and therefore it is cropping a section of the image, respecting its content, actually respecting its aspect ratio, but scaling it at the same time, therefore cropping a central section from the image, giving it a nice view like this for the flower. Okay, one other thing before I wrap up this video is clipping the image. You can also clip the images using modifiers, of course. So for the modifier, also if you're asking why I didn't use the modifier here, modifier name, the parameter name, it's because it's the third parameter of the image composable, therefore I didn't need to use it. I didn't need to use the name of the parameter. It's the third positional parameter. So I'm gonna clip it this way by using the clip modifier. This allows me to cut a part of the image and create a circular image or something like that. So the parameter that you will need to pass into the clip modifier is a shape, and this can be one of the ready shapes like circle shape. I import it, let's refresh it, or it can be a custom shape that you can create by calling rectangle shape or cut corner shape composables. So let's refresh it again. There we go. As you can see, it creates a default image for us, and we can probably see a better view for the image if we add a spacer after the title for it. Spacer like giving it a height of 16 or 64 depth, and then refresh it. Refresh. And because it doesn't have enough height, it cannot show the whole circular area for the image. So if we increase the height of the image, we can see a better result. So fill max width, and I can say fill max height, and then refresh it. We expect that this will give us a circular shape for the image. There we go. It allocates the whole area available to the image and then applies the content scale that we know cuts the central part of the image and displays it for us. Actually, a constant height will be better here, something like 400 depth. Refresh it. You can use this technique using circle shape, clip, for creating profile images and so on. Another refresh. There we go. It's more beautiful. And if you are looking for a custom cut, for a custom clip, you can actually create your own shape using cut corner shape and then passing the size that you want, or round corner shape, rounded corner shape, which will effectively create round corners for you. You can play around with them and see the result. I'm gonna switch back to circle shape, and that's it. That's basically how you can load images from your app resources in Jetpack Compose and display them, whether those images are bitmaps or vectors. I hope that you liked this video. Hello and welcome to a new section of the course, Creating Android UIs with Jetpack Compose. This section is about animations. Animations are a very exciting topic in creating Android applications, and sometimes they can get a little bit complex and tricky. Jetpack Compose has very good mechanisms and capabilities for creating animations. We will talk about different types of these animations that are available and usable in Jetpack Compose. I will show you how to create animations using animated visibility, crossfade, and also animated content, animate content size modifier. I will also show you how to create animations using state-based animations like update transition, infinite transition, and animate some unit as state for creating animations. And we will also talk about and learn how to use animations using animatables that are another feature in creating animations with Jetpack Compose. So animations are fun and Jetpack Compose is very rich in creating animations. So stay tuned to this section and let's get going. Animated visibility is a composable in Jetpack Compose that allows us to create animations in a simple way. So in this video I'm going to show you how to use animated visibility to add motion to your Compose UIs. I head over to Android Studio and create a new project. Empty Compose activity and then next. In the project name section I enter a name, for example Compose, and it's about animated visibility, or let's call it animated visibility motion. And then the package name is good and the save location is fine. Language is Kotlin and minimum SDK is 21. It's fine. I press finish and wait for the project to be created. Alright, my project is ready. It's created. The first thing that you will need to do is removing the default composables. Of course, this is my preference. You can leave them alone. And I'm also removing the content added inside my theme, animated visibility motion theme, because I'm supposed to add my own content that will show the animation and I will design in this lesson. And then I create a composable by typing comp and then pressing enter, and then I name it animated visibility sample, and inside it I'm going to create the animated visibility composable. I'm going to use it. Note that you will need to use this type of motion and this type of animation, I mean animated visibility, when you are supposed to show some content or make it disappear at some point on your screen. So for example, you have some content that is supposed to appear on the screen or disappear, and this is a good time to use this composable animated visibility. And it works by receiving an initial state that says whether it is visible or invisible. And when you change that when you change that state, that visible state, the animation changes, and the Jetpack Compose animation library creates an appropriate and suitable animation to show the user that transition in an animated way. Let me show you how this works. Animated visibility. As you can see, it's from the androidx.compose.animation package. I press enter, and as you can see, it receives a visible state. And I'm going to define this visible state as a state variable this way. Val, I'm going to create two variables, one for the Boolean variable that represents this value, and also the other that is supposed to be a lambda and responsible for setting new values to that variable. So checked and unchecked change. You will soon see why I chose checked and unchecked change as the name of these variables. And I use remember to utilize Jetpack Compose's composable memory, and then mutable state of. I import mutable state of, and I give it an initial value of false. And for the checked and unchecked change, I'm going to actually use a checkbox from the material library that allows the user to select the animation to be visible or invisible at any time. So for that, I'm going to add a checkbox here, checkbox, and as you can see, the checkbox, after I import it, has one variable, one parameter called checked that receives its state, and for its state I pass in checked. And this checked, as you can see, has an initial value of false, which means the checkbox will be unselected at first. And it also has a lambda parameter called unchecked change that sets new values to this parameter. So for that, I already have defined a variable. I have defined a lambda called unchecked change using the destructuring assignment mechanism from the Kotlin language, and I use it here, unchecked change. All right, and in order to have a better layout to show these things, the checkbox and the animated visibility that will contain our animated content, I'm going to put them inside a column. So I select the whole area and then press Alt and Enter, and then surround with widget, and then surround with column. So now my column is ready, and I'm going to put the checkbox also aligned with a text box inside a row, and you will see why it is that way. Surround with widget, I put it inside a row aligned with text, and the text is show content. And as you can see, checkbox and then the show content. To give it a good preview, I'm going to add the preview annotation to my composable here, and after that it will start to build the preview and show it to us once we select the split view. And inside the animated visibility, I will pass in the initial value for visible, and for that I have checked, because the user will be able to show the content, the animated content, using the checkbox that we have provided to them. So I'm going to use checked here. Checked. And then we have a lambda that decides what content to show or hide based on this visible parameter that is passed to animated visibility. So as you can see, we have several forms of this composable, and the type that we will use is supposed to be, as you can see from this list of parameters, this list of overrides for this composable, the second form, the visible, and then the content. But we have an error here. I press Alt and return on the error to see why it is that way. And as you can see, it says add opt-in experimental animation API class annotation to animated visibility sample. Because animated visibility is an experimental animation API, we have to add one of these two annotations to our composable for it in order for our composable to work. So add opt-in experimental animation API class, and now I have added it. And in addition to adding it, we also need to make sure that we have compiler argument xopt Kotlin requires opt-in to our build.gradle file. So I go to my build.gradle file from the app module, and in the section for Kotlin options, I'm going to use free compiler options. If I'm not wrong, free compiler options, and then a list that contains the list of the compiler arguments. Here we are passing this argument, Kotlin.requires opt-in. I press sync now and wait for it to finish syncing and applying that change. Free compiler args, sorry, this should be free compiler args. This has to be that. And now the sync is successful. I return back, and here I have my composable animated visibility sample, and the opt-in should do no complaint to us. And it is not yet updated, but we proceed with our work. Inside the animated visibility, I'm going to create my animating content, and for that I'm going to create a box, that has a size of modifier dot size, something like 400 depth. For the size, I import modifier and the depth. Come on. And also the size modifier, I import it. And now that I have the box, I'm going to add inside it an image. an image. I import image from the foundation package, and the first parameter is painter resource. I use painter resource to access a drawable that I will have in my drawable directory. So I go to my pictures directory to access that picture that I will use. I have a picture here. I will use it like a profile picture. Control C, copy, and back to Android Studio and project resource section. I paste it in the drawable directory. Control V or right click and paste. I put it in the drawable folder and I call it profile, and I use it for the drawable ID value profile, and the next parameter is content description. For that I use profile. I don't need the left part, so I close the pane, and then I also minimize a little bit the right panel for the preview. I don't need that much. And let's have the image, and after that let's also have our text. I'm gonna have a text here that, for example, Compose, Jetpack Compose is awesome. Let's use a font size like 30 dip, 30 sp. Let's import sp, and also font style or font weight dot bold. And to make it more discernible, I'm also going to use a color of white for it. Color dot white. Also, we should add some padding to our column, as well as size, fill max size for the column, and some padding like 16 depth, and some shadow like 2 depth. Import shadow. We have the padding shadow for the column and some padding for the inner elements like our checkbox. So I'm gonna do that by adding the padding to row padding. I use 16 depth for it for the row, as well as for the animated visibility. So modifier dot padding 16 depth. All right, we'll then refresh. Hopefully it will solve the issue. I suspect that there's also another problem with our project that needs to be fixed before we will be able to see the preview, and that's something to deal with the compiler version, the Kotlin version that we are using. So let's check it out. As you can see, that's true, and this version of Compose that we are using, RC01, of the Compose compiler requires Kotlin version 1.5.10, but it appears that we are using 1.4.32. So let's update that and fix it. Build.gradle in the project level. Let's change the version of Kotlin to 1.5.10 and sync the project. Most probably the issue will be gone. And we have added the padding to our animated visibility. Actually, let's add it to our box that is inside the animated visibility. Like that. And for the image, I'm going to add a clipping using the clip modifier. So modifier dot clip with a rounded corner shape that is typical of profile pictures. I personally like that style of pictures, rounded corners. Looks like clip isn't imported yet. For rounded corner shape, I apply a size, for example 8 dep. It will be good. And also let's use a content scale for our pictures, for our picture. Okay, rounded corner shape. So here's the end of our modifiers. The clip modifier, and after that I can add the other parameter, which is content scale. For content scale, I use crop. That will center my picture in a nice way in the picture area. Let's see if we finally will be able to see our preview. I have opted in to experimental animation APIs, but still Android Studio shows some notice here. This class can only be used with the compiler argument that, but we have already added that to our build.gradle file. The preview is being generated. Alright, as you can see, the preview is here, and looks like we don't have much to see for now because the initial value of the checked variable is false unless we change it to true, and in that case, yes, we will see some text and we will see some preview of the UI that we have designed here. So each time that the user selects this option, this checkbox, this content here containing our profile picture and the text will be animated in, will be faded in and shown to the user in an animated nice way. And if the user, on the other hand, if the user deselects that checkbox, the content will be faded out and will disappear from the screen in an animated nice way. So to see that in action, let's actually call animated visibility sample composable inside our theme, like that. Animated visibility sample. Before we do that, let's make sure that we have done everything we needed to have a nice acceptable UI here. Something I can do about the text, I can center the text, inside the box. I can do that using the using modifier. If I haven't already used the modifier for text, I can add that parameter, modifier dot align and alignment dot center. I import alignment from the UI package, and now we have alignment.center as the alignment, build and refresh. And for the text and for the image as well, but the image I can use fill max size to make the image fill the whole available space inside our box. So I resort to its modifier parameter like that, rounded corner shape. This was the clip, and then after clip I use fill max size to fill the whole space available inside its parent, which is the box. Build and refresh. Alright, not bad. Actually, let's see if I can put the text below the image using the alignment button. It is not acceptable in this scope. Its type is alignment, but we have used alignment.vertical, which is not acceptable. Okay, that's not bad for now, but at least let's make our text align in the center using the text composables text align parameter. Text align equals text align dot center. Okay, and actually I have a way of putting the text in the bottom section of our box, and that is by using the content alignment parameter of the box composable. So I have the box here, and after the list of its existing parameters, I can use content alignment. Sorry, it is for the image. I'm going to deal with the box parameters. So content alignment equals alignment dot center, bottom center. Hopefully this will be acceptable here. Yes, bottom center is acceptable here. Let's refresh our UI preview to see if we have what we need and what we wish for. Not exactly that. Actually, it's not bottom center. Okay, let's leave it for now. Let's run the application, because the more important thing is what we are supposed to see on our virtual device. I press the run button and wait for the application to be launched on my emulator, Pixel 4 API 27 emulator. The emulator is launching, the application is being installed. Alright, as you can see, by default the content inside animated visibility is being shown, and that's because we are checking the checkbox by default by setting the initial value of checked to true. So I uncheck the checkbox, and as you can see, the UI is faded out. Of course, it was not that obvious, and probably it also has to do something with the performance of the machine on which I'm recording this video. So I select it again. You can see that it's animated in, and then unselect, it's faded out, it's sliding in, sliding out, sliding in, sliding out. Nice. So you can see that by default animated visibility has nice animation for making the content that is supposed to appear display in an animated way in your application. And also it has good mechanism and good default animations for making it disappear and exiting the scene. But that's not all about animated visibility. Animated visibility is very customizable, and you have a lot of options for customizing the animation that will be used and the animation behavior that will be used for animating your content inside animated visibility. In the next part, I will talk about customizing the animation that is used in animated visibility and inside animated visibility. So let's see what options animated visibility has for customizing animations. As you can see, in the list of animated visibility composable parameters, we have visible that receives a Boolean value, a Boolean state, and we also have a parameter called enter that specifies the enter transition that will be used to fade in and to sliding the view and the UI that is supposed to be shown to the user in an animated way. And we also have exit transition that is used to animate the content as it disappears from user's view. As you can see, both of these parameters have default values. Enter by default has fade in and expand vertically, which means the content is by default faded in and expanded vertically as it appears into user's UI. And the exit value by default is equal to fade out plus shrink vertically, which means the content that is disappearing is by default faded out and shrunk vertically as it disappears from the user's view. So we can customize, fortunately we can customize these values, we can customize these parameters. For example, I can simply change these by default. I can, for example, change the enter parameter to fade in, just fade in. I import fade in, and for the exit I can use just fade out, which means just fade out the content that is supposed to disappear from the user's view. Let's close the split part. I don't have any design for now and I need more space for coding. I run the application again. Also, I can change the true value for the initial value of checked to false. It's already installing, so this change will be deferred to other runs. So show content, as you can see, once I deselect it, it is disappeared and it is faded out. Fade in, fade out, fade in, fade out. This is very simple animation that I'm using, but I'm going to show you how to customize it. For example, I can add another animation to this fade in animation using slide animation. Slide in vertically, slide in horizontally, because by default it was sliding vertically, and I'm showing you another type and another animation that is available. Slide in horizontally, which means I'm going to show the content sliding into the scene from the left or from the right. So let's see what options slide in horizontally has for us. It has initial offset X, which by default is minus full width divided by 2. Okay, I change it to initial. First, name the parameter, and for its value, note that it is a lambda, so I need to pass in a lambda, and it here, the parameter it here for the lambda, is the same as full width. So since I'm going to make it appear from the left, I use, for example, minus it. I'm going to set the offset of the view, the UI, equal to the full width minus full width, which means the offset will be something like here, from the left of the view, from the left of the UI area that I have here. And the other parameter for slide in horizontally is its type of animation. So I'm going to change that animation, that default animation, to animation spec, the name of the parameter, and for its value I'm going to use a spring animation. I import spring and I give it a damping ratio, equals to spring dot damping ratio high bouncy. Of course, you probably will not want to use this in real applications because it's a little bit exaggerating the animation, but it's for demo and it's cool here. So animation spec damping ratio is that, specifying how hard it is for the spring to get to peace and start moving and bouncing. And here we have high bouncing for our spring. And the next parameter for the spring is stiffness. By default it is medium stiffness, and I like that, so I don't need to change it. And also for the visibility threshold, which by default is null, I'm going to use some value, like for example int offset for the X I enter 0, and for Y I enter 100, this is for the enter animation. So we customize the enter animation by adding fade in to slide in horizontally, which in return took an animation spec of the type spring. And for the fading out and for the exit animation, I'm going to use another animation that is available as the exit transition type. And I can use fade out. As you can see, fade out returns exit transition, but this time I'm not going to use fade out. Actually, I'm going to just use shrink out, and one of the parameters that it has, shrink towards alignment dot end. Looks like alignment dot end is not accepted. Its type should be bottom end. So bottom end, actually its default value is bottom end, so I don't need to specify that unless I want to use something like start, bottom start, which is kind of equivalent to bottom end. And also, what other parameters it has? Target size. The target size, because I want to shrink it, let's make it shrink it down to 0. By default it is that way. It is shrinking down to 0 and it's fine. And for the animation spec, we need to specify an animation spec for it. Animation spec. This time I'm going to use a simple tween animation. For a duration of 1000 milliseconds or 1 second. And now let's run the application. You will see that there's a lot of ways to customize these animations for your animated visibility composable, because this composable is really rich in terms of giving the user animation options for the content inside it. So show content, as you can see, it is appearing, but we don't see that much of the spring effect. But for the shrink animation, for the exit animation that we used shrink out, we can see that it is shrinking out. Nice. So I can use something like shrink in to give something equivalent to shrink out for the enter animation. But I suspect that there's a problem with our int offset here. If I change that, probably it will work. This is the visibility threshold for the spring animation, for which you need to pass in a suitable value. Fade in. Yes, this time we have a better bouncing than shrink out. Yes. Shrink out. Yes. So for the enter animation, we have a spring animation, and for the exit animation, we have a shrink out animation. And if you want to see the full list of animations that are available for use as enter and exit animations, you can head over to the enter exit transition.kt file that is inside the animation package of Jetpack Compose system. So you can see the full list of composables defined here, the full list of functions that are defined for creating animations. We have fade in, fade out, which return enter and exit transition respectively. And we also have slide out, expand in, shrink out. Sorry, I told you already about something called shrink in. We don't have something called shrink in. We have expand in fact. In contrast to shrink out, we have expand in. So for the enter animation, we actually can use, in addition to fade in, we can use shrink in, expand in. And the good thing is that we can add these animations on top of each other, fade in, expand in, plus slide in horizontally, and the effect of the total effect of these animations is that they can be combined and applied to our content to create nice and exciting animations. So let's see what effect now we have for expand in. But before that, let's check for the options. Alignment bottom end expands from alignment bottom end. Let's change that to actually expand from alignment dot bottom end bottom start. Let's see if I can use top start. Yes, I can. And also we have initial size of 0, which is cool. We start from an initial value, initial size of 0. It expands from nothing to the full size of the UI, and that's good. And for the animation spec, because we have already specified the spring animation for our slide in horizontally animation, we don't need to specify an animation spec for the expand in. So let's run the app to see the result. Show the content, please. As you can see, it is expanding in, and now it is expanded out. It's shrinked out. Okay, expand in, shrink out, expand in, shrink out. And the interesting thing here is that once we added the expand in transition to the list of our animations that we had here, we lost the effect of slide in horizontally, which was a side effect of combining the 3 animations here. So I'm gonna remove the expand in for now, and let's also adjust the int offset to something like 200 for the X, and this is taking an initial offset X because it is moving horizontally, so we should have a better bounce here. I run the app again. Please show the content. Nice. Shrink out, expand in, sorry, show the animation with spring animation, shrink out, enter, exit. Okay, cool. One thing that you might ask yourself is that any content that we have in this area is moving with the same animation. So we have used the spring animation as the enter animation, and as you can see, the whole content, whether it's the image, it's the text, it is animated with the spring animation. And then I use the exit animation, and it is applying and putting its effect on the whole UI that we have here, the text and the image. What if we can have a way to add more animations and add a different animation for a child that we have in our view tree, in our UI tree? The good news is that it is possible. So I have good news for you, that it is possible inside animated visibility to have a different type of animation for your children. For example, I want to have a different type of animation for the text that I have here. So how do we do that? We do it using a modifier that is available in the animated visibility scope. So I go to the text section in the modifier section, in the modifier parameter for the text, and I have a modifier for it called animate enter exit, which allows me to specify enter and exit animations for it. So for enter, I use, for example, slide in vertically. I want to make the text appear from the bottom of the screen. So slide in horizontally, initial offset Y, because I want to go from the bottom, so I use 2 multiplied by it here, as I mentioned earlier, is the full height. These parentheses should be changed to lambda curly braces. And after initial offset, we also have animation spec. So by default it has some animation spec, some default animation spec, but I can use, for example, the spring one or the 2-in animation. So I use a 2-in animation here for a duration of 1000 milliseconds or 1 second, like that. And I run the application. This time, as the content is appearing with an animation, once I check the checkbox, the text should have a different type of transition as it appears into user's view. As you can see, yes. Disappear, appear, yes. As you can see, the text appears from the bottom, and it shows us that it has a different animation that is different from the animation that is used for the whole animated visibility area. So I told you how to add custom and different animation to the children of animated visibility, in addition to the animation that you apply to the whole animated visibility composable. Before we move any further, I really hate the text being displayed into the center of this area. I want to display it in the bottom of the box, but for some reason it is being displayed here in the center. So for the text, I am looking for yes, as you can see, it is using alignment.center. Yes. So alignment dot bottom alignment dot bottom center. Yes, it is accepted. I run the application again. Show the content, and Jetpack Compose is awesome. Yes, it's really awesome. And disappear the content. Cool. Nice. So far we learned how to create animated visibility, how to add custom animation to animated visibility, how to add different animation to the children of animated visibility. And the next thing that I want to tell you about animated visibility is another version or another variant of animated visibility that is a little bit different, and it's a little bit different to use than this version that we already used in the previous parts. Let's see how it's different. So in this version that we used, we had a parameter called visible that took a Boolean value, which was either selected or not selected, which was either visible or not visible. When the state changed to visible, the content was animated in, and when the value changed to not visible and to false, actually the content was animated out in some way, using a variation, using a combination of different mechanisms of animations that we had for enter and exit parameters. But there's another variant of animated visibility that has that takes another variable and from another type. Actually, as you can see, the different versions of animated visibility, we have a version that actually takes a different, let me find it. Yes, visible state. We have here, it's the first version. It has a version that takes a parameter visible state, and its type is mutable transition state. Let's create it. Let's create a parameter for it. I'm gonna define it here. Val show equals remember transition mutable transition state. And its initial value is, I give it false, and then I use apply to also specify its final or target value, its target state, and I specify true, which means it starts from an invisible state. First it is not visible, but then once this animated visibility enters the composition tree, which means once we run the application and we open this activity, then this animation starts running from the initial value of false to the target state of true, which means the animation that we had here will be run using the settings that we had applied using the enter animations. So I'm going to use this show variable, which its type is mutable transition state, inside animated visibility. So I remove the already existing variable parameter and its value visible equals checked. This time I use visible state, and for its type I enter show. Note that we don't need the show content checkbox anymore, so I disable it inside our column. For the checkbox I disable it, enabled equals false, because I don't need it anymore, and I run the application again. Once I run the app, the animation will be run and launched automatically, and I don't need to trigger it manually. Look, there we go. Once I run the application, it automatically faded in, it automatically animated the content in, and let's exit the activity, run it again. There we go. You can see that the animation, the enter animation is running, and the different animation that we had for the text is also running. Exit, launch it again. There we go. The spring animation, exactly what we had defined for the enter animation, aligned with the animation for the text. And we didn't manually trigger the animation. It is disabled. The checkbox is disabled because the animation is just starting to run as the composable enters the composition tree and is being displayed to the user. So that's it for animated visibility. I hope that you liked these lessons about creating animated visibility, creating different animations, customizing the animations for animated visibility, adding different animation for the children of animated visibility, and also using a different variant of animated visibility that takes a different parameter than visible, called visible state, that is of the type mutable transition state, and allows you to run the animation automatically as you run the app and your activity or your composable. See you in the next lesson. Another animation composable from Jetpack Compose system is animated content, and in this video we will be talking about that. Note that animated content is an experimental animation API and it is subject to change or removal in future. However, because it is an important API and it is somehow straightforward to use, we will be discussing it and I will show you how to use it. First, let's see when we will use animated content. When you have content that will be swapped with another content, or you will change it with another content, it's a good scenario for using animated content. For example, here I have a box containing a text that will be changed when the user clicks the right button or the left button. This acts like a counter that increments or decrements this digit. Currently, this doesn't have an animation, it just changes the numbers in a crisp way. For example, it changes 0 to 1, 1 to 2, 2 to 3, and so on. And also we have some content here that is text, and this will be swapped with some longer text when the user clicks the checkbox here, the expand checkbox. Currently this doesn't have an animation, but since here we have some content that will be swapped with another content, it's a good use case for animated content. And another API that we will be talking about in this video is crossfade. Note that the crossfade and animated content are somehow similar. I mean, you use animated content and crossfade when you have some content that will be swapped or changed with another content. However, crossfade is a little bit more limited when compared to animated content. Usually you will use crossfade when you simply want to fade through two contents. I mean, you want to fade out an initial view, for example, an image that you have here, you want to fade it out, and then you want to fade in another image. This is called crossfade, and it's a good use case for using the crossfade animation. So currently we have three parts that have places for swapping content with another content. However, they don't have an animation. First, let's run the application and see how it works without the animation, and then after that we will add the animations step by step. We wait for the application to be built and installed on the emulator. I'm using the built-in emulator, and there we go, it's running. So first, the sample 1 section, animated content, it doesn't have an animation yet, but it will work by counting and by incrementing the digits. So the right button, you can see that the numbers are incrementing and decrementing when I press the left button, but it doesn't have an animation. The changes are just sharp and crisp. And the second part, animated content sample 2, when I press or check the expand checkbox, this content, the show text, I mean the short text, is supposed to be swapped with another longer text. Let's see. You can see that the two text sections are swapped, but they don't have an animation. And finally, the third part, the crossfade animation sample, when I click one of the images, the image that is currently shown, I'm supposed to see another image from that collection. I have a collection defined as an enum class that is supposed to contain different images or pictures of a family. So I press the man picture and it crossfades. Actually, it doesn't crossfade, just switches to the next image, and all the members of the family. They don't have an animation though. And now let's start working on the animation and implementing animated content and crossfade for our composables. First, the counter section. You can see after I minimize or hide the emulator, I'm supposed to work on this part, the digit. The digit works here. This box contains the digit, the text, the digit text. So I select the whole box, and then as you can see, I have also added a comment that you can see in the code that I upload for the course, and this will tell you where to add animated content. Once I select this area, the box, I press Alt and Enter, and then surround with widget, surround with container, and the container that I'm supposed to use is animated content. I press Enter, And animated content works by receiving a state. Here, our state is actually the count that specifies the digit currently displayed here. So, as you can see in the list of parameters for animated content, we have target state as one mandatory parameter for this composable. So for that, I pass in count, and you can see that count is a state variable that I have defined above. If you see the source code, I have defined count as a delegate, using delegate as a state variable that contains the digit currently displayed here, and it starts from 0. I also have other state variables defined for specifying the expand section, the short text and line text section, and also the crossfade section, as you can see. Okay, back to our animated content. So my animated content receives a target state, and for its value I pass in count, and for its content you can see that I have used the box that contains our digit. That's it for animated content. Animated content will have some default animation that now it is ready to run, and I don't need to do anything else in order to run a default animation. But for now, let's move on to the next one, the animated content sample 2 section. And here I select the short text part, and once I select it from the preview pane, it will show the corresponding text on the left part. Alright, this is the box that contains it. So I select the whole box, the box ends here, and I press Alt and Enter, surround with widget and surround with container, and the container that I will use is animated content. Alright, since it requires an initial state, a target state, I pass in the expand variable for it, which is a Boolean variable, a Boolean state. So I pass in expand. I showed you earlier, it is a state variable that I have defined above. And that's it for animated content part 2, and it will have some default animation. I don't need to do anything else. If you look up the documentation for animated content, you can see that animated content has some default animations. By default, the initial content fades out and then the target content fades in. This behavior is called fade through. So by default, when I run the application and when I change the content with the new content, for example here, when I change 0 to 1 by incrementing the count state variable, 0 fades out and 1 fades in. Alright, and the final part, crossfade. Crossfade is also easy to use, and all I have to do is select this part, the box that contains the section, text, as you can see, and also the picture that will be displayed. I select the whole part. Let's see if we select it correctly. Here's the box scope. So I select the whole box. Then surround with widget, surround with container, and the container will be crossfade this time. Let's see what parameters crossfade requires. So for crossfade, we have target state, similar to animated content, target state. And for target state, I'm gonna use pick, which is the state variable that specifies the picture currently shown. And looks like I also need to pass in a picture variable here. Since Compose recommends me to use the parameter passed into the lambda, I'm gonna use it. Actually, I'm gonna use picture here, and then wherever I have used pick, I'm gonna replace it with picture. Picture. Actually, pick here because I cannot reassign picture. And target state. Okay, here's the tricky part. When the user clicks this picture, I'm gonna get the whole members of the items. The actually the picture enum class, it has 5 members, and then I compare the current picture with the length of the whole array, or the whole members of the array, and then if I was less than the count, I can increment it. I can move one step forward and I can increment it and select the next picture. If I have reached the end of the array, then I must start from 0, from the first count, and I cannot increment it anymore. All right. The next item, and now we have our crossfade composable. Let's run the application to see if it works, and how it works by using its default animations. Okay, our application is running. Let's run the first animated content. There we go. You see that we have some fade out animation here. Although it is simple, it's better than nothing. And now the second part, you can see that it has some animation, fade out and fade in. And the third part, you can see that it is working by fading through different components. But next, I'm going to show you how to customize these animations. For example, what if I want to swap the content that I have for this digit in a direction that I want. For example, when I press this button, I want to slide in 1 from the left and slide out 0 from the right. And when I press the left button, I want to slide out 0. Actually, if this is 10, when I press the left button, I want to slide out 10 from the left and slide in 9 from the right. It is fortunately possible, and it's a little bit noteworthy here. You should be careful how to use it. I select the animated content, and I'm gonna add a parameter called transition spec. This is very important, transition spec. As you can see from the list of parameters, transition spec accepts a lambda. As you can see, it is a lambda, and it has to return a content transform. So I create a lambda, and then inside it there's an easy way to create content transform. Of course, you can create content transform this way by using its constructor content transform and then passing it parameters. As you can see, content transform has a constructor that you can pass in transition, enter transition and exit transition to, but I'm gonna show you a better way and an easier way. Instead of creating a content transform object, I'm gonna use these helper functions. Slide in horizontally for the new content that is entering, and at the same time fade in, and then I use the width function. This is an infix function that will return a content transform for me. So on the right of it, I need to use an exit transition. Slide out horizontally, slide out horizontally, plus fade out. And then I can also use the using function, the using infix function, which accepts a size transform on its right. Size transform, like this. And the result of all of that will give us a content transform required by our transition spec. As you can see, the using returns a content transform. Okay, note that I told you I want to slide numbers in a specific way. So I want to slide in horizontally. Let's first examine the right part. When I am pressing the right button, I want to slide in horizontally from the left. So slide in horizontally. Here I have initial offset x, which is the full width. So width, I have the full width. I want to start from the left, so I use minus width. Actually, I reversed the offset in order to start from the left. One full width from the left. And then fade in. Fade in, I don't need to pass in something for it. And slide out horizontally. I want to slide out from the right. So this will accept a target offset x, as you can see from the list of parameters. It also receives full width, and then it will go to one full width. like that. Of course, this is only for the right button, and I will add the logic for the other button as well soon. Size transform. How about the size transform? The size transform deals with the size animation that you want to apply if you optionally want to do so. So because it is also good to know, I'm gonna show you how to do it. Size transform can be created in several ways. I'm gonna use keyframes for it. The keyframes function, if you open it, you can see its list of parameters. Keyframes, it will return a keyframes spec, and in turn it will give us size transform. So it receives an initial size and target size for the animation. So I say go to int size, change the size of the animation, the size of the container, to initial size dot width divided by 2, and initial size dot, or target size, actually target size. Of course, you can play with these parameters and change their values. You don't have to do exactly what I'm doing here. Target size dot height divided by 2, and actually what I'm doing here is just showcasing how keyframes works for creating a size transform, and it will not do any important animation here because our initial size and target size will be the same. And now we have our animation. This is only for the right button. How about the left button? So I add an if statement to distinguish them. I say if target state is bigger than the initial state. This is important because we can decide which animation to run. This means that when we want to increment the number, but what if we want to decrement it? Then we use the else statement. In that case, I use slide in horizontally again, plus fade in for the new content, with slide out horizontally with fade out. What is this 8 that I added here by mistake? And then using size transform let's use using after fade out, and size transform. Let's create size transform, and just like we did here, size transform the lambda form of it, and it will give us an initial size. Actually, because I was just going to show you how it worked, how keyframes worked, I'm not going to use size transform here because I have my content transform here anyways. And for slide in horizontally, because I'm pressing the left button here, the slide in will be from the right. So I will start sliding from the full width to actually the zero width, the zero offset, And for the slide out horizontally, I will slide out from the left. So I will go from the width to minus width because I'm sliding out like that. And now I have a custom animation. And one thing before we say this is complete, actually each of these helper functions like slide in horizontally also has a parameter called animation spec, for which you can specify an animation like a tween animation or a spring animation to give you a custom animation that you want. For example, I can add a spring animation here, but for brevity I'm just going to skip it for now. Let's run the application to see what we have for the custom animation of part 1. Okay, let's test our animation. There we go. You can see that our numbers are sliding from the left to the right, and now from the right to the left. Yes, not bad, better than before. Now at least we have an animation, a sliding animation that moves in a way that we want it. As I said, you can also add some animation spec like a tween animation or a spring animation to give it a more custom look. Now let's move on to the next part, the animated content sample 2. And here I'm going to add some animation spec, some transition spec. After target state, transition spec. Again, a lambda. It has a lambda, and note that I can use slide in horizontally or slide in vertically, but there's also another helper function that is better suited here in my opinion, and it is called slide into container, and I'm gonna use that, slide into container. I'm gonna slide the new content into the container and at the same time fade it in, along with some exit animation. Slide out of container for the content that is driven out of the container, plus fade out. The content is at the same time fading out the old text, and this will give me a content transform. Slide in container has some required parameters. As you can see, slide into container has towards parameter because I want to slide in, let's see, I want to slide in the new text from the bottom. Yes, because I want to slide in from the bottom, I say slide direction dot up. The direction is up, and the old text, the short text, is supposed to slide out of the container in the up direction. So again, slide direction dot up, and of course slide direction itself is part of animated content scope. And fade out. Note that you can still use using here to add a content, to add a size transform. as I showed you earlier. Size transform like this, and this actually use that size transform keyframes. I use the keyframes function, and I use initial size and then target size here. Int size initial size dot width and target size dot height at 150 at this time of the animation. And we also need to specify the and we need to also specify the animation duration. So duration millis, I use 300 for it, 300 milliseconds. And let's also use this format of int size for the previous one. Here I didn't specify the time, int size at 150. Also specify the duration millis. You can pass in any parameter, any value for your duration, any duration that you want. However, I used 300 milliseconds like this. Back to this part, animated content sample 2. So we have a simple slide in container and a slide out of container, along with fade in and fade out using size transform. This will give us a complete chain of animations to customize the swap animation behavior. Let's run the application to see the result. Alright, expand, shrink, expand, shrink. There we go. Now we have a better animation, as you can see. The like text, the short text slides out of the container from the top, and the new text slides in from the bottom. Similar to the previous sample that we had, and then I told you that we can have custom animation spec for our animation behavior. Here we can also have that as well. For slide into container, we can have our animation spec similar to slide in horizontally and slide in vertically. I can add a parameter here. Let's minimize the emulator, and animation spec, I'm gonna use a spring animation here, spring, because the text is being swapped with another text. Animation will be looking good and better with a spring animation. So spring, and I give it a good bounce, somehow exaggerating bouncing behavior. Damping ratio, for damping ratio I use spring dot damping ratio high bouncy, to show you how this animation can be customized. I also use the custom animation spec. Let's import Spring. If you click Spring with Control and click, you can see its definition. It's a singleton, and it actually implements the dynamic animation, the physics-based animation in Jetpack Compose. Okay, we imported Spring, and now if we run it, we will see the effect of using the Spring animation on our text. Okay, expand. There we go. You can see the effect of the Spring animation. That's nice. Wow. Okay. Next, and as the final part, I'm gonna customize my crossfade animation to see what customization options I have for my crossfade animation. Here, after minimizing the emulator, of course, I can see that I have crossfade and what parameters for it. I have animation spec, and the default animation spec, as you can see, is tween, and I can customize it. I can add a custom tween animation, for example, with a custom duration different from the duration of the default tween animation. Let's import tween as well from the core animation package. Duration millis. I'm gonna use, for example, 1000 for 1 second, so that you can see how it fades through the different pictures, and like a slideshow, but not exactly like that. And also we can have delay millis to delay before running the tween animation each time that we slide from one picture to another. And we also have easing to add an interpolation for how we change the animations and how we switch from one scene to another. And the default one is fast out, slow in, but I'm using linear easing here. Linear easing, because I just want a linear and smooth transition from one picture to another. Okay, looks like we are good to go. Let's run the application to see the result. We wait for the emulator to launch. Actually, the emulator is already running. We know that. It's here. Come on. Yes, it is running. We just wait for the application to be built and installed on the emulator so that we can see it. Okay, let's test our animation, the crossfade animation, by clicking one of our pictures, the picture that we have by default. There we go. Fade through, pick different pictures from sun to all. You can see that each picture that we click is faded out and the new picture comes in. Okay, so that's it for the crossfade animation, and you can see that it is simpler to work and implement than the animated content transition and the animated content composable for creating animations. So in this video you saw that we already had some content that was working we had composables that did their job. We had a counter that was working. We had a checkbox that affected our content that was supposed to be displayed. When we clicked the checkbox, when we selected it, the content changed to another content, and it worked without the animation. And we also had something like the slideshow that changed to different pictures in a collection when we clicked the default picture and each picture. But you can see that by adding the animation, we added some meaning and we added some expected behavior for the user, so that user can see some default, can see some natural behavior in how the content transitions on the screen and how the content behaves similar to real world. For example, by clicking the right button, the user can see some behavior similar to natural phenomenon of moving stuff from the left to the right or from the right to the left. And this is the meaning of meaningful motion. That is the recommended way of using animation in Android applications. You should never exaggerate animations in your applications. Just use animations when you add some meaning and you add some useful notice and hint and help for the user, and you make the application easier to use with the animation. And for in terms of the second part, we also added some default, we added some expected behavior that added some meaning for how the content transitioned between different states of the UI. The old content slided out and the new content slided in. And for the third part and the final part, that was crossfade, we also added some expected behavior that made the application easier to use and probably our Android application user happier when they are using our application. So that's it for animated content. I hope that you liked this lecture, and I see you in the next video. One of the categories of animations in Jetpack Compose system is animations that are based on state, by which I mean you have some state variable that determines some animation and the amount of that animation that's supposed to run. For example, you specify the length of a progress bar, or you specify a color to be animated to another color based on some state. So the first type of these state-based animations is infinite transitions or infinite animations that you can use to create, for example, a progress bar, an infinite progress bar, or some other waiting UI. And in this video, I'm going to show you how to create these infinite transitions using Jetpack Compose, of course. So first, let's get started by creating a new project in Android Studio. Empty compose activity. Next, and I name my project Infinite Compose Transitions, of course, and everything is okay. The configuration, I press finish and wait for the project to be created. Alright, the project is created. I remove the composables that have been added by Android Studio. And also the content inside my application theme. and then I create a new composable. I name it my infinite transition demo. Let's call it demo 1. We might create another one also, and inside it I'm going to create some state that will help me create my infinite transition. First, you need to know, in order to create an infinite transition in Jetpack Compose, we need to create a transition object, and we do that by calling this. Let's call my variable infinite transition, and by remember I call remember infinite transition. This creates an infinite transition object and remembers it for my composable. And also I'm going to add a preview annotation so that I can have a preview as much as where possible, you know. And this is my infinite transition. By the way, this should be equal. It is not a delegate, so I remove by. Now I have my infinite now I have my infinite transition. Before I create the transition and apply the transition, let's create our UI that is supposed to be animated. And for that, I'm going to create a very simple UI, a box. And for that, let's add a modifier, fill max size. Let's give it some padding. All right, import padding, and inside the box I'm going to draw a line that is later supposed to act as a progress bar, as an infinite progress bar or something similar to that. So I add a canvas, and for the canvas I add a modifier and fill max size for the modifier, and in the body of the canvas I'm going to draw my line. First, let's see, I need to have for the line some parameters. Draw line, and as you can see I have a color dot blue. I select the color of blue as the color of drawing here, import color, and I have a start, I have end, and I have stroke width. These are some parameters that you might want to specify. Some of them are mandatory, like start and end. Note that because I'm going to make this composable and make this animation infinite, I need to create some state. Let's add the state variable. For the start of the line, actually I can add val start, line start, some variable here, remember, import remember mutable state of let's start with 0f. It's true that this gives me a state variable, but since I'm looking for an infinite transition and a transition that runs infinitely, I'm going to need some extension function from infinite transition, and for that I'm gonna call infinite transition dot animate float. I'm gonna animate some float variable, and this float variable, since this is a delegate, I'm gonna import get value, and parameters for this are initial value, target value, and animation spec. These are very important and at the same time simple to use. Initial value and target value specify the range of my animation. Look, I'm going to animate my line if the length of my line is something like this, from this distance, from this point to this point, then I have to animate the beginning of the line so that the line moves to toward the end of the screen. So here I'm going to specify initial value as 0f and target value some larger value, like for example 300f. And animation spec has to be a repeatable animation, an infinite transition or animation. So to create an infinite repeatable spec, I say infinite repeatable. This is the function that you will need to create infinite animations, and in turn it has its own parameters like animation, which specifies a duration based animation, and that duration based animation can be a simple animation like a tween animation. So I use a tween animation here that runs, for example, for 1 second or 1000 milliseconds. And I leave the other parameters to their default values. I don't change them. So I have my animation here for infinite repeatable and the repeat mode. The repeat mode by default is restart, which means when the line goes to the end of the page, to the end of the screen, then it starts appearing from the right, and it repeats this infinite movement forever. So let's use that in creating our canvas. Draw a line as a start that needs an offset. I create an offset here, an offset object, and for the x variable I need to give it the x coordinate. So for the x coordinate I'm gonna give line start plus some length, the length of the line that I'm supposed to create. For the length of the line you can give, for example, some arbitrary value like 200f, 200 pixels. And for the y variable, for the y coordinate, I'm going to use the half of the available height for this canvas. So I say size dot height divided by 2, and sorry, for the beginning I don't need the length of the line, I just say line start, and I will use that for the end parameter of draw line. So I say here offset, another offset, go from line start to line start plus 200f, and the y coordinate is the same, size height divided by 2, half of the available height, or at the center of the available height. And for the stroke width, let's specify the stroke width, which is a float variable. I give it 5f, and we should have our box. Let's switch to a split mode and also run our application to see how it runs on the emulator. We wait for the application to be built and deployed to the device. Okay, as you can see, we have no output from here on our device, and the reason is that we haven't used our function or our composable inside main activity. Let's call it my infinite transition. Run it again. We won't have to wait long because it has already been built. It should come up very soon. Alright, as you can see, we have an infinite transition that runs. It's not very beautiful, but it shows you the idea. As you can see, the line start parameter keeps animating using our infinite transition, and when the animation reaches the end of the cycle, it repeats itself using the repeat mode parameter that has been provided to the system by default. And you can also reverse it by giving it another parameter. For example, here you can specify repeat mode as repeat mode dot reverse. In that case, the animation will reverse itself. Actually, let's give it a try. Repeat mode dot reverse, import it, run the application again. There we go. As you can see, now our animation is being reversed when line start value reaches the end of the cycle for the animation, and then it repeats itself. Actually, it reverses itself by coming to the start and starting another cycle of animating its value. So actually I can make it more beautiful by giving it more length, by giving a bigger end or target value for the repeatable animation, by giving it, for example, 600f for the target value. And also I can increase the width the width of the canvas, the width of the draw line function. Here I increase the stroke width to 10f, and I can also change the duration to smaller value like 500 milliseconds or half a second, and run the application again. There we go. This is an infinite transition, not too bad. It basically shows you how a transition using infinite transition system in Jetpack Compose works. Now let's go back to our code and create something more complex using the same system that I just discussed. I'm gonna create a composable and name it infinite transition demo 2, and it has a my, the previous one, so I add my infinite transition, and let's make that a preview as well. Having a preview when possible is a good idea because it gives you less pains in order to run the application on the emulator, because you have a preview here when possible. And inside the composable, I'm going to again use canvas to draw something new. This time I'm going to draw 2 circles, and these circles have to be animated, and these circles are supposed to be animated in different directions. And in order to animate them, I'm gonna animate actually their rotation. Let's see that in action. Again, I'm gonna use a box. So let's create a box modifier to give it our desired width and height. Actually, I'm gonna give it a size, fill max size, and let's give it half of the available space. And inside it, I'm gonna create a canvas, and it has a modifier. I'm gonna use the modifier to center the canvas. So I use align to center it inside the box using alignment.center value as the value of this modifier. And it has to fill the available space, fill max size, which means it will fill in the available space inside its parent. And let's also give it a padding like 8 dip, and that's it. Next we have to give it its drawing. For the drawing, I'm gonna draw 2 circles. Draw circle, and these circles will be on each other first, but when I rotate them, when these are rotated in different directions, you will see that they are 2 circles, and one of the circles will rotate around the X axis, which means I will rotate or pitch them. We call this pitch in 3D animation. And the other one will be rotated around the Y axis, or it will perform a yaw. We call this pitch and yaw. So draw circle, the parameters for the draw circle are here. Color dot black, I use a simple color here. and I also accept the default radius, which is the half of the available width or height. Every dimension that is less, the shorter dimension, the smaller dimension, half of it will be used as the radius. And then the center by default is center, the center of this canvas. I accept it, I don't change it. And looks like we don't have for now other thing to override here. Draw circle, the second circle, I draw that with the same color. You can give it another color, doesn't matter, but note that this is the first circle and this is the second circle. These circles are just dead for now, they will not do anything. Let's see the preview. Okay, our preview should appear now. The circles are too small. Let's use the whole available space or maximum size for the box so that we have a big enough available space for our canvas to show us the animation. And now a preview refresh. Okay, that's our circle, but note that this circle is filled with color, and I don't want it. I want this to have a different draw style. So I changed the style parameter from the default value of fill to stroke. And for the stroke, I specify a stroke like to F, the width of the stroke. And for the second one, stroke as the drawing style. And now it's time for the rotations. Note that we have two rotations as I said. I want to give a pitch to the first circle and a yaw or rotation around the Y axis to the second circle. So I create this here. First, you have to also create the infinite transition. It's very important. Val my infinite transition. My infinite transition equals, remember, infinite transition, and the first rotation is, I call it pitch by my infinite transition dot animate float. The degrees for rotation are specified as floats, so I use animate float here, and I'm gonna animate from 0 to 90 degrees. So 0 is my initial value and 90 F will be my target value or degree, and my animation spec, I can leave it to the default animation, or I can change it. I'm gonna change it. I'm gonna use it specifically so that you see more of customization in action. And this has to be animation spec, has to be a repeatable animation. So I need to call infinite repeatable, and in turn it has its parameters, animation and repeat mode. For the animation, I'm going to use to-in for 500 milliseconds, and for the repeat mode, I'm gonna use repeat mode dot reverse. It's very important because reverse mode is the mode that actually makes this animation look the way we want it to look, and restart will not work for us. I mean in terms of beauty. Otherwise, technically both of them work. And the next rotation or state is yaw, or rotation around the y-axis, and it is again an infinite transition, my infinite transition dot animate float. And look, it added the parameters. We don't have to name the parameters manually. Again, it's 0, initial value is 0 to 90f, to 90 degrees, and animation spec is infinite repeatable animation, parameter is to-in. I want the two animations to look like each other. I don't want them to look non-agreeing and fighting with each other. Repeat mode is reverse. Pitch and yaw. And look, actually I have added both of my circles inside one canvas, and in order to have two different rotations and two different transformations on the shapes, I need to add the second circle inside the body of another canvas. So I add another canvas here, modifier, and I move the draw circle for the second circle inside the second canvas, along with their parameters: fill max, size, padding, 8 depth, and alignment dot center. Okay, now let's add the transformations, the pitch and yaw. First, to this circle, in order to add it to this canvas, I need to use the graphics layer modifier. The graphics layer modifier allows us to do special transformations that are not usually possible inside the draw scope. For example, this way inside graphics layer you can have advanced rotations, like rotation around the y-axis, x-axis and z-axis. as you can see, rotation Y, rotation Z, camera distance, and so on and so forth. And here I'm gonna use rotation X, and for its value I'm gonna use my pitch state. And I do the same for the second canvas graphics layer, but this time I will do another rotation, which is yaw. So I will do rotation around the y-axis. Rotation y equals yaw. All right, let's now run after a final check to see we have done everything correctly. We added a box containing 2 canvases with 2 different rotations. Okay, let's run the application on the emulator and see the result. Again, we forgot to make a call to this new composable inside our main activity. So let's do that. My infinite transition. My infinite transition demo 2. Actually, I'm gonna comment out the previous one and call the second one my infinite transition demo 2 and run it. There we go. As you can see, we have our animation running, but yes, it's not very exactly the same that we expected, but it's actually using the whole available space, and probably that's the reason why the height looks so big for the circle when it's rotating. And as you can see, it is doing a reverse transition when it's coming back. Each time it goes from 0 to 90 degrees of rotation, and then it reverses the animation. Let's make it smaller. Let's make our circles smaller, in fact. I give a smaller fraction to fill max size so that I get half of the available space for the box, and run it again. Alright, not too bad, it's better. And I can also increase the stroke width for the circles that I draw. So I change that to 5 or 4 pixels. I exit the app for now, and after increasing the stroke width, in order to make actually this animation more interesting, I'm going to add a transform inside the draw scope to each of my circles as well. So here I select the draw circle line and add a starting and ending pair of curly braces, and then apply a rotation here, a simple rotation around the Z axis. So I import rotate. It's the first option to import, and the amount of rotation in degrees, I give it a 45 degrees of rotation, and I leave other options to their default because they're good. I do the same for my first circle over here inside the draw scope, and rotate in degrees. The amount of rotation I'm going to use is 45, and run the application, see the result on the device. Okay, it's beautiful. As you can see, now we have an animating weighting UI that you can use in your applications, and you can customize it to use in your applications to show some updating or to show some connecting status. Of course, I have seen that, or I have seen similar UI in some application before, and I was trying to emulate it, and meanwhile show the usage of infinite transition in Jetpack Compose. Okay, now before I wrap up this video, I'm going to use both of these two animations inside my final application. So here I'm gonna wrap the two functions inside a column. Modifier dot fill max size, and I'm gonna give the two actually the two functions two weights, two equal weights, so that I don't take the whole available space for each of them. You can also give each of them half of the available height to make it even for both of them. So here inside the box, for the first animatable, for the first infinite transition, I can give it fill max size of 0.5 f, so that I give half of the size, half of the whole size to the first function and the other half to the second one. Okay, let's also give it some content alignment, some horizontal alignment, center horizontally. And now let's run the application. What happened? Looks like it's taking the first function, is taking the whole available height. Yes. Fill max size. I have used fill max size twice, and that's the reason that it doesn't work. The first fill max size takes precedence. There we go. Not too bad. Actually, we have two animating UIs, two infinite transitions, that both of them are running in our application. You can make them a little bit more intelligent by activating or deactivating them, by clicking on them, or by adding some other condition to your application, showing or hiding them based on some other state, and things that you might like to implement for your specific transition scenarios and transition needs in your application. Note that uh, now that I'm running these two infinite transitions on my computer, the computer is getting very hot, and the reason is that animation is heavy, and you should minimize the amount of animation that you use in your application, and use animations wisely and only when it is needed. And the animation that you see here is not supposed and should not be run forever in your application. You should actually consider showing these types of UIs only when the user needs to wait for something to happen, needs to wait for a connection to be established, or for a process to be completed, and so on and so forth. I hope that you liked this video on infinite transitions and Jetpack Compose, and I see you in the next video. One of the easiest ways of creating animations in Jetpack Compose applications is by using the Animate as State APIs. These are APIs that are very simple to use and can be used for a range of different data types like color, integer, float, and so on and so forth. So in this video I'm going to show you how to use this API and some of its different variants, and also how to create a custom animation and a custom type of animation using this API by providing your own type converter to create the animation and implement it. So let's get started by creating a new application in Android Studio. New project, empty compose activity, next, and I name my application animate as state. I can name it animate as state, or simply value animation, and the package name and save location and other things are fine. I press finish and wait for the project to be created. As the project is being built, initially actually I remove the default composables. I don't need them. I will create my own, and also remove the content inside my application theme. And here I will call my new composable that I will create here. I create a new composable comp, and I press enter to provide it. Assign composable, and I'm gonna name it animation demo, or value animation demo. Here, to create the first example, I'm going to use value animation to animate the border of a box. So what I'm going to animate is the border of a box that I will create here. Don't ask again, and I create the state variable that I will use for the animation in the beginning of my composable. I name it border, or actually, because I'm going to animate the roundness, I name it roundness, and then by using delegate and animate float as state. This is the animation API that I'm going to talk about in this video. Like that. And here I will provide the target state for this function animate as a state, and because there are two types of targets that I can have here. For example, based on some other condition, I can have a roundness of 0, which means no roundness, and a roundness of like 25 pixels. So 25 dp actually. So based on that state, val like click, val clicked by remember mutable state of false. Initially I initialize it to false, import remember, and animate float as a state. And here I say if clicked, then animate the border by giving it a border size of 25 if actually, because I'm animating float here, I can provide if, but because I'm gonna animate the border size, and you know that the border is provided as dp values, I animate dp here, animate dp as a state, 25 dp, else 0 dp. I import also dp and also animate as a state and get value from the runtime package. And here I create my box, a box with the modifier dot size. Let's give it a size of 300 dep. Importing modifier also. After size, I give it a background with color dot red. Import size as well. Border. Actually, I'm going to clip the size of the shape with the shape that I'm providing here. So I use dot clip here for the modifier and provide a shape for it, rounded corner shape, which takes the size. The size is this roundness. If you look at up, actually you can see that we can use different types to specify the roundness, including dp, float, and integer for percentage, of course. And we also add a clickable modifier to allow the user to change the state from clicked to unclicked, and vice versa. Let's import clickable, and when the box is clicked, I switch or toggle clicked like that. Let's make clicked mutable and also import set value. And now we can have a preview to show the preview while we are designing, but it's ready to run. So let's call value animation demo inside our theme, value animation demo. We run the application and wait for it to appear on the device. Alright, we have the box, and now we should be able to animate the corners by clicking it. Let's do it. There we go. You can see that its borders are animated, but the problem is that we don't animate the background, because when we clip it, actually the background also should take a shape, but we don't do it. We only clip the size. We clip, but we don't clip the background. So in order to do that, we provide the shape, the rounded corner shape, to the background as well, and also give it the roundness value. Let's run it. Alright, there we go. You can see that we can easily animate the corners this way. Next, I'm going to add another animation by using another variant of this. This time I'm going to animate color. So I'm gonna have a background for the page that will be triggered by clicking the same box, and for that I will use color animation provided with this API, by this API. So var bgcolor by animate color as a state, and this time instead of defining this here, I use it directly in the context. So let me show you that. You can see that sometimes it is easy to use, and it is very convenient to just use it in place instead of defining it beforehand. So for the box, I have my box, and I'm wrapping my box inside the surface, which is essentially something like a box. We are not going to be very deep about surface for now. Just imagine it is like a box, and inside the surface, and for the surface, I'm going to give a modifier, and for the modifier I'm going to use a background, and for the background I'm going to use a conditional background color. So I say animate color as a state. You can see that it returns a color state, and for the target value I can say if it is clicked, if this box is clicked, then use color dot blue, and otherwise use color dot light gray. And because this is a state variable, I need to access its value and provide the value to the background modifier, and that's it. Also, let's align this in the center of the box using the align modifier. So I say dot align alignment dot center top, or top center, and align. Okay, of course, align, the align modifier is for the content of the box, for the children of the box, so I cannot use it on the box itself. Instead, I use the content alignment parameter for the box. Content alignment, or content, yes, it's content alignment, and alignment dot center, top center. Modifier, this was the modifier, and this is the content alignment modifier. Okay. There's some problem with the content alignment. What's that for? And it looks like it's because we don't have a content here, and instead of that I can check to see if I have some option inside the surface for alignment. I don't have it. I don't have to use it, so I just ignore it for now. And actually I replace surface with another box, so use a box inside the box, and now I can use dot align for this box. Align, alignment, dot center, and actually top center works better here. And now it works. We can use align on the child of a box. This box is the child of this box, so it can use align. So let's run it again and see the results. So application is being installed, and this time we will animate the color for the background. And the reason why this is not centered is that it doesn't have fill max size, so the first box needs to use dot fill max size. Run it again. There we go. And now let's run the application. Let's test our animation. You can see that we will have two types of animations: animating the corners, the round corners of this box, and the background. There we go. You can see that the animation works. Both of them trigger with the same event, which is clicking this box, but basically you can have different triggers for each animation because they are independent. And finally, before I wrap up this video, I'm going to show you how to implement a custom animation using this API. For example, you have a class like sealed class my size, and this class has two members like val width, which has this type of float, or dp. Let's use actually dp, or float. For simplicity, let's use float. And val height, which is float again, and then I'm gonna use this class for the type conversion for the vector of the animation that the system needs to animate my custom size. So for that purpose, I'm gonna define a variable here, val my size, and then say equals animate value as state, animate value as a state. And the first parameter is our target value. Our target value can be dependent on the condition that we had, like clicking this box. So I say target value if clicked, then my size 200 f by 200 f, else return my size 250 f by 250 f. And here we need a type converter, and if you look up the converter options, you can see that actually it is a lambda, and you need to create the type converter here. So type converter, actually you need to instantiate the type converter, and the type converter is going to convert your custom size, your custom type, which is my size, to an animation vector, and vice versa. The animation system of Jetpack Compose needs that to animate custom types. So it will animate from my size to float, like that, from class to class. Type converter, let's see that, let's see if it did it correctly. Transition, actually if you look up the samples, you can see that animated value samples section, and the custom value, if we find it here, animated, no, it's not here, we need to find it in the animation core section, animated value samples, and yes, two-way converter, we create two-way converter, two-way converter here, and the two-way converter, once instantiated, has several parameters like convert to vector and convert from vector. Both of them are lambdas, so for the body of them, convert to vector, it receives a size, so we create a vector, this, let's create an animation vector 1D, actually it's 2D because it has two elements, and then for the first parameter I use size.width, and for the second, or v2, the second vector, I use size.height. Like that. Required float, but it gives convert to vector. It is converting to vector, so what's the problem? Float, my size float. No, my size is not float. Okay, the type converter is wrong. The type converter needs to convert my size to animation vector 1D, 2D, sorry. And now the error should go from here, and then this one does the reverse thing, which means converting back from the vector to the size. So vector, it gives it a vector So it constructs a my size from the vector. So vector dot v1 dot value. So to get the value of v1, we get to float, actually, because we want the float variable. Actually it is float by default, so we don't do anything. Vector dot v2 for the second parameter of my size, and my size shouldn't be sealed, so the error is now gone. So we just created an animation vector, and we created a custom value animator using the animate value as a state API, and now this is ready to be animated. Okay, after providing the type converter, we can now close this target value and type converter. So what's the problem again? State my size, required my size, but it returns a state. Yes, the reason is that we don't use delegates. Let's see if we can use delegates. Yes, we can use delegates, and now we have the my size type returned from animate value as a state. Let's use it for the size of this box. By the way, I also add some top padding for the box, or some general padding to the box, 16 dp. And let's now use the size, and for the size I'm gonna use my size dot width and my size dot height. Okay, let's create a dp from these sizes. dp, because these are floats and we need to convert them to dp types. And now the size should work, and yes, let's remove this size modifier that initially we gave it. Let's run the application again. Okay, our app is running. We have the background, we have the box, we have the paddings, and we have the animations in place. We should have 3 animations now: the corners, the background of the surface or the father box, the parent box, and also we have the size of the box animated with our custom value animator. So let's run it. There we go. Beautiful, beautiful. We clicked it, and now let's click it back. Nice. So you see that our 3 animations are being invoked and run. The animations are not dependent on each other. The animations just are triggered by the same state variable clicked that triggers 3 of them, all 3 of them. We can have different triggers and different conditions for running them. But for simplicity, I just used one trigger. Just by clicking it, I triggered all 3 animations. So that's it for value animation. Note that this API is very rich. You can see that animate, if you click, if you press Control and space, you can see that animate as a state has very different variants, like animate DP as a state, animate float as a state, animate color as a state, int as a state, int offset as a state, rect as a state, size as a state, value as a state, and these are the primary and major ones. And you can also create the default, you can create the custom types that you want for your needs, and you don't find them in the API. You can simply create them by using the template that I showed you, just by providing your custom type converter that converts your custom type to an animation vector, which can be one-dimensional, two-dimensional, three-dimensional, and four-dimensional, and also converts the animation vector back to your custom type in the as specified in the convert to vector, in the convert from vector parameter. So I hope that you find this lecture useful and you liked this API for creating animations in Jetpack Compose. I see you in the next video. In addition to special composables and functions that allow you to create animations in Jetpack Compose, we also have a special modifier that allows you to create animation in case you want to animate the size of some UI. And with this modifier you can easily animate content when you have changing sizes. So let's create a project and see that in action. I create a new project and name it animate content size compose. Animate content size actually is the name of the modifier that we will use. I press finish and wait for the project to be created. I removed the default composables added by Android Studio and also the content inside my application theme, and I create a composable. I name it animate content size demo, and inside it I'm going to create a box. Actually, the build needs to be complete in order to have indexes and auto-completion from Android Studio. I give the box a modifier, import modifier. I use the fill max size modifier to have the whole available size for the box, and also I give the box a background color .yellow, for example. Let's import background and color. And inside the box I'm going to have an image. For the painter resource, I load a drawable dot. I need a picture here. Let's add it from my pictures directory. I have already added a picture here. Control C, copy back to the drawable directory and paste it here. It's a picture of Italy, so I name it Italy. car.drawable.italy. No content description. Content description. I set it null. And content scale. For content scale, I give it a content scale of crop. And now the modifiers. Modifier dot fill max size. Note that I want to have two different sizes that will be triggered based on a state, and when I change these sizes, the size change should be animated using the animate content size modifier that I will add to the chain of modifiers here. So I need a state to help me decide that. So I define it var small, I name it small, to help me choose whether I want it to be small or big, the size of the image. In fact, by remember mutable state of true, I want it to be small in the beginning. Import get value and set value. And now I can say if small is on, if it is true, then make the size 0.3 f, otherwise make it 0.9 f. And then I can add animate content size, but for now I need toggleable or a clickable modifier to actually trigger that animation, to trigger the size change. So for the box or for the image, you can add them, you can add your toggleable to either of them. So I add toggleable to the box. It has a value parameter for that. I specify and I pass small, and another parameter on value change, which gives me inside the lambda the new value, and I pass the new value to small. I update small with the new value. So if small is true, by clicking the toggleable it will be false, and if it is false it will be true. It will become true, in fact. Alright, now I will have the size change but not the animation yet. Align, let's also add an alignment dot center inside the box. And now let's call our composable inside set content, animate content size demo, and run the application. We wait for the application to be built and deployed to the device. Okay, the application is being installed and launching. There we go, we have our image, and now by clicking it I should have the size change. By clicking our box, you can see that we have the size change for the image but not the animation. It's not animated, it's just sharp change in the size. Now let's add the animation by simply adding the modifier that I told you about. Because the size change happens for the image, I need to add animate content size to the modifiers of the image. Animate content size. There we go. And note that you can also have custom animation for the animate content size by specifying an animation different from the default one for the animation spec parameter. And it also has finished listener to further customize how the animation behaves. So now let's run the app again. Let's run the animation by clicking our box. There we go. You can see that now we have an animation, default animation, which is spring, and it is simply added by applying the animate content size to our modifiers for the image. So you can see how easy it is to use animate content size, and it is just a simple modifier to add to your UI, and it easily adds animation to your UI when you need it. Just remember that you will need this type of animation, and you will often use this animation when you have animation in the when you have size change and you want to animate this size change. So that's it for animate content size. I hope that you liked this video, and I see you in the next ones. Sometimes we have several different states in our application, and when we switch states between these several states, we want to animate some UI components that we have in our app. For example, between the connected state and disconnected state in a networking app, we might want to run several transitions on on several different components, like on our buttons, or a button, a text, a background color, and things like that. And because we want often to do this on several different components at the same time, we need some efficient capability to do this. The API in Jetpack Compose that allows us to do this kind of transition efficiently is called the Transition API, and in this video I'm going to show you how to use it. So let's get started by creating a new project in Android Studio. I press new project, select empty compose activity next, and I name it compose transitions. Package name, check it. Save location, I check. Minimum SDK, check. And finish. Wait for the application to be created. Alright, our application is created. I minimize the project explorer part and also remove the default composables added by Android Studio. I remove this surface from the application theme. I want to add my own content, and then I define a composable here. I name it transition demo. I want to define my transition here and show you how to use it. I also make it preview so that we can have a preview here. Note that in order to have interactive testing of your UI here and also animation previews, you have to enable experimental features from application from Android Studio settings. So I go to Android Studio settings. On Linux it is from the file menu. I go to experimental section, and here make sure that enable interactive and animation preview tools is selected. And now I can be sure that I will have previews. The first step in creating transitions in Jetpack Compose is by defining your transition, your different transition states. And because we want to create a simple transition that changes state between connected and disconnected, for example in a VPN application or in a networking application, we need an enum class, or at least we can say we can do this using an enum class and define our states in it. I create an enum class and name it connection and give it two members, connected and disconnected. And then I create my first state to give to the transition, because the transition needs to start with an initial target state. So I define my initial state here. I name it var and name it connection state or con state for short, by remember. I use delegate for that. Remember, import remember, mutable state of, import this as well, and for its value I pass in one of these members. I pass in disconnected. I want the application UI to have the disconnected state at first. Connection dot disconnected. Because this is delegate, we need to make sure that get value and set value is imported. And now I can use this state to create my transition object. After creating my transition object, I will be able to create child transitions that will manage different parts of my UI when switching between the two states. So I create my transition, val transition I name it, by update transition. I don't use by here, just equals update transition, import update transition. This allows me to create a parent transition and update its state to our desired state, our desired initial state. So I pass in con state for that. And it is recommended to add the label parameter as well. So this is target state, and for the label I pass in parent transition. Now, as I said, I create child transitions. Imagine we want to have a simple box, a simple connection state box that shows connected when the state is connected and shows disconnected when the state is disconnected. And also while that state is switched to connected, we have round corners and also bigger text. So I'm going to create two child transitions, one for the round corners and the other for the text size. So while corner size by transition, this is the way we use transition. I call the extension function of animate float that is callable on transition. Import animate float because the corner size is float. I animate it with float, animate float, and I'm gonna pass in the label and target value by state. And I'm gonna skip transition spec for now because it has a default transition. I'm not going to customize it for now. So label corner size, and the other is target value by state. This is a lambda that will receive the current state, which allows us to decide how to modify our UI based on this state. So here I pass in the state to the lambda, and as you can see, it receives the state and returns a float. So I say when state, this is the decision making part, when the state is connection dot connected, then I will return 25F, otherwise I'm gonna return 0F. I don't want to have a round corner when the application is not connected. So that's it for animate float. Next, let's create our text size transition. Text size by transition dot animate float again. I use float again, and note that there are other extension functions you can use based on your application needs. For example, as you can see here, we have animate DP, animate int offset, animate offset, rect, size, value, and color. So animate float, actually for the corner size we can use animate DP because we can also specify corner size with DP units. So 25 DP, I return 25 DP here and 0 DP here. So pass in the label for animate float for the text size, and then the target value by state. By this state, I'm gonna have this target value. This is the meaning of this parameter. So when state is connection dot connected, then I'm gonna use, for example, 30F for the text size, and later I will convert this to SP for the text. I will create SP units from this value, and else Otherwise, which leaves us only with one other option, which is connection dot disconnected. Otherwise, return. Actually, when it is disconnected, we will return 30F, and when it's connected, we will return 50F. Okay. Now we have two transitions which we can use. I'm gonna create a box to show that. So let's create a box here. A modifier for the box. Fill max size. Give it a padding of 16 depth, for example. And then inside the body of the box, I'm gonna create another box that will be responsible to show our transitions and actually to show our connection state with transitions. So I give this box modifier as well. Modifier and dot size. I give it a size. Actually, let's give it a size of wrap content size. And let's give it border with the size of 2 depth and the color of color.black. Importing color and the shape of rounded corner shape. Here is where I will pass my corner size. Corner size. Okay. Rounded corner shape and the border. Also, let's add a clickable to allow us to switch between the two states. Clickable, import clickable, and in the body of the clickable lambda, I will switch the two states. Connection state, con state equals if con state equals connection dot connected, then switch it to connection dot disconnected, otherwise connection dot connected. All right, and let's add a text here for string resource. I give it a string resource to load the text for this label, and r.string dot, let's decide what text to show. If it is connected, we will show connected, and if the state is disconnected, we will show connect. So if con state equals connection dot connected, then we will return disconnect. else we will return string resource r.string.connect. When the state is disconnected, we will display connect. Let's go to our string resources file, strings, and create two string items, string name, connect, with the value of connect, and disconnect with the value of disconnect. Back to our code. Let's also make sure that we add a padding for the text with modifier padding 16 depth. And one important parameter that I will need to use is actually the text size, and this will show our transition. Text font size. For the font size I use my text size, but we will see an error here. You can see that the value passed to font size needs to be SP, because we often specify text units with SP. So what I'm gonna do is create an SP unit here. So I say, because the type is text unit, I say text unit. I create a text unit and I pass in my text size value, which I know is float, and specify SP here. Text unit type.sp. Note that this function text unit, if you open it, does have an annotation of experimental unit API. So you need to annotate your composable with this special annotation, experimental unit API. I add this annotation to transition demo. That's imported. Now the error will be gone, and we can give our text a line of center, text align dot center, import text align, and also make sure that you center the text inside your box. So the second box, which has wrap content size, should be aligned in the center of the parent box. So I say align alignment dot center, like this. And now, as you can see, we have used both our transitions of corner size and text size in our UI components, which are basically two nested boxes, and the nested box has used those transitions, one for its border size, one for its corner size, which determines its roundness, and the other for the text that it contains, for the size of the text actually. So let's refresh our preview and see how it works here. We can test our animation in this preview pane or run our composable on our device and see the result. Alright, rendering preview 1 of 1. We have only one preview, so it is rendered. And to test the animation and to test the clickable function of my box, I enable this feature, start interactive mode. I press this button, the button with the finger icon, and I press connect. There we go. You can see that we had a transition from the connect state to disconnect, and now if I press disconnect, we will transition back to connect. Sometimes the preview pane just doesn't work as expected, and what we do here in this state, we run it on our device to see the result. So I stop interactive mode and run it on the device. Okay, Gradle build finished, and soon the application will be fired up in the device. Installing and launching. Okay, the problem is that we forgot to add transition demo to the content. So transition demo, let's call it here, and because it uses experimental unit API, let's add this annotation to onCreate as well. Experimental unit API, and run the app again. Okay, we see our button here, and let's connect. Disconnect. We see the transition from connect to disconnect, and actually we perform the transition from the state of disconnected to connected, and now we can perform the transition from the connected state to disconnected by clicking this box again. There we go. You can see that there are smooth transitions between the two states. Both the text size and the corner size are animated with our transition system, and both of these transitions are performed at the same time based on the parent transition, and they are managed by the parent transition. And one more thing before I wrap up this video is adding a transition spec that changes the way the transition and the transitions animation is performed, and we pass that as the parameter of transition spec to our transitions animation extension functions. For example, for the text size, I'm gonna customize my animation by passing transition spec. I use transition spec here. And for the transition, if you look at it, we can have a transition that is a child of finite animation spec. So we can use an animation like spring, which we know is finite. And for the spring, I'm gonna use a damping ratio of spring damping ratio high bouncy. So spring dot damping ratio high bouncy. This might not be exactly what you want to use for your transition spec, but to showcase the way we customize transition specs for our transitions, I'm gonna use this with this parameter. Spring damping ratio. Spring spec, finite animation spec. So note that this is also the value of this parameter has to be a lambda, and because it is a lambda, I need to wrap it in lambda and like this. And I want to run the transition, actually run this spring transition when we are animating from the disconnected state to connected state, and not vice versa, not in both transitions, only in one of them. So here I check my current state with when, and I say when we are transitioning from disconnected to connected. Disconnected connection state dot disconnected is transitioning to. This is an infix function that we can use here. Let's maximize the code section to have more space. When disconnected is transitioning to connected, then use this spring animation. Otherwise, which means when we are transitioning from connected state to disconnected, we will use a simple tween animation. So I say tween with the duration of 300 milliseconds. And you can see that that's it for transition spec and customizing transition spec. You can decide based on the current transition that is running which animation to use and what animation to use, and customize the type and properties of that type of animation. Here in the transition from disconnected to connected, we will run a spring transition, a spring animation, and when we transition from the connected state to disconnected, which is the opposite of the other transition, we will use a simple tween animation. So now let's run our application on the device and see the applied changes for the transitions. Connect. There we go. My system is a little bit laggy, but so naturally you didn't see it very well, but if we do it again, you can see that it's tween based now to this state, transition to this state, but the other transition has a spring animation, tween, spring, tween, spring. Okay, that's it for transitions. This was a simple introduction to transitions in Jetpack Compose. I hope that you liked it and found this lecture useful. Today we want to create a special animation using the Update Transition API from Jetpack Compose. We are going to implement an animation similar to Instagram's like animation, when you tap on a post and you see a heart that is animated and it appears for a few seconds and then it disappears. So we are going to implement that in Android Studio. Let's get started by creating a new project. Empty compose activity. Let's call it heart animation and save it in our course directory. Everything is okay. Press finish and wait for the project to be created. Alright, the project is created. I minimized the project explorer from the left and removed the default composables added by Android Studio. Let's remove the content inside our theme as well. And let's create a composable that will contain our animation. I'm gonna call it heart animation demo. Let's also make it a preview. The first thing I'm gonna do in order to have several different states for the heart is to create these states, and we need to know which states do we have. Note that in order for the heart to be animated using the transition API in Jetpack Compose, we have 3 states. The first state is the initial state, and then we have the liked state, and we have the gone state, or disappeared, when the heart is disappeared. So we have 3 states. I create an enum class to identify that, enum class, and I name it like, because these are basically 3 states of liking a post. So I name it like, and then the first item is initial, when the heart starts to animate, and then we have liked, and finally gone, when the heart is gone. So let's create a state for the heart, val like state, I call it by. Remember, I use a mutable transition state to specify the first state that I'm going to pass to the transition API. So mutable state of mutable transition state, and then for the mutable transition state I'm gonna pass the gone state, because the heart is not supposed to be animated at first. It's going to be animated only when the user taps the post 2 times or double taps it. So I pass it like dot gone. Let's also import get value and set value. Because this is val, it doesn't require set val, but if it was var, we had to import that as well. So now let's initialize our transition. Let's create a transition object. Val transition, I name the object transition, and equal update transition, import update transition, and as you can see, update transition can be called in 2 ways. One of them takes target state that we have used in another video, and the other takes a mutable transition state, which can use the variable that we have created here. Its type is mutable transition state. So I pass it like state. It does have a label as well. So like transition, I name it. And the first parameter's name is transition state. Also, because we will mutate the value of like state later on when the user clicks it, when the user double taps the image or post, I'm gonna make this var and import set value. Okay, for the heart to be animated, we will have 2 different transitions. One transition for the alpha of the heart, because the heart is going to be animated in a way that it increases its alpha value. Its alpha value starts from 0 and then it becomes fully visible and then it disappears. So we need to animate alpha. I create a transition for alpha and alpha transition, I name it by transition dot up animate float. I'm animating float because alpha is the float value, has a float value, and let's call it heart alpha, in fact, and then specify different parameters of this transition. It has transition spec, which you can see it's lambda I will fill it later. Then we have label heart alpha or simply alpha, and then we have target value by state, which is basically the target values that we have based on the state. So first let's specify the transition spec. We need to decide here which animations to use based on different states of our animation. So I use a when statement here, and I say when we are transitioning from like that initial to is transitioning to like that liked. If we are transitioning between these two states, then we can use a keyframes animation where we have detailed control on how to change different values on different times of the animation. So here I specify duration of the animation, duration millis. I use 500 milliseconds, and then different values for different timestamps of this animation. So for example 0f at 0, and then 300 at 300f at 300, sorry, this is the value of alpha, so it cannot be more than 1. 0.5 at 300, and 0.5 at 255, and 1f at 400. Okay, this is our keyframes animation. And now about other states. If we are transitioning from like that liked to is transitioning to like that gone, if the heart is disappearing, then we use a simple tween animation. We say please hide it in 300 milliseconds, for example. And in other cases, else, if we are transitioning between other states, which basically means, for example, if we are transitioning from gone to initial, then use a simple snap. And snap doesn't do any special transition, any special animation. It just switches the values from one value to the other and doesn't animate between them. Okay, now let's specify the target values of the animation. The target values based on a state, when the state is like that liked, then the target value will be 1f, because the heart has to be fully animated, and otherwise it needs to be invisible if it is liked, then it needs to be fully visible, and otherwise it needs to be invisible. And all our transitions will happen when we are transitioning between these two values. Okay, now let's create our other transition, which is for scale, because when we like and double tap a post, we also want to animate its scale. The heart is animated in a way that it increases its scale, it becomes bigger, it expands, and then it starts to shrink again. Something like a heart pulse. So val heart scale, I name it by transition.animate float again, because scale is a float value. Transition spec label heart scale, or simply scale, and then target values. So for the scale to work, again we consider which states we are transitioning between. So when we are transitioning from like that initial to like that liked, then we use a simple spring animation, because we want to show the heart as animated and as live as possible when it expands. So I use a spring animation with a damping ratio that is considerably big. Damping ratio medium spring dot medium stiffness medium. Sorry, spring damping ratio medium bouncy. If we are transitioning from liked to gone, then again we can use a simple tween animation. So like dot gone, like dot liked is transitioning to like that gone. We use a simple tween animation with a duration of 350 milliseconds, for example. Or in order to be consistent with the other animation, let's use 300. And otherwise use a simple snap to, for example, transition from like that liked from like that gone to like that initial. We just need to swap values without any special effect or animation. And finally, specify the target values of a scale. The scale can be either 0 or 4 or 5, or which scale that you want, whichever scale that you want for your heart. So I say when my state is like that liked, then use a scale of 3f, for example. Otherwise use 0f. When it is liked, we multiply the scale of the size of our heart by 3. When it is initial, it is 0. When it is gone, it is 0 again. Okay, now we have two child transitions from our transition, heart scale and heart alpha, and we can use them for our heart. Let's create a heart inside a box. We can use a box, but you are free to use any other container that you like. Box, modifier, I use a modifier to give it size. Fill max size, I increase its size to the most available space, maximum available space, and yeah, that's good. I am also going to give it a pointer input modifier so that I can detect double tap. Pointer input, import pointer input like this. And if you look at the different overrides of pointer input, you can see that one of them takes keys. So I pass in unit for the key. I don't have a special key here, but instead I detect gestures in the body of its scope. So I say detect tap gestures. I select the second override of detect tap gestures. One of the parameters you can see is on double tap. So I say on double tap. When the post is double tapped, then we need to initiate the animation by switching the like state to mutable transition state with the initial state of liked, initial like dot initial. But how does make the animation work and start working? We need to actually tell the system to do this, and we do that by adding an if statement here inside the body of the box, and we tell it to do this animation in sequence. So we check the current state of the animation, and then we specify the target state of the animation based on that. So I say if like state dot current state is initial, then target state, then its target state will be liked. We tell the animation system, the transition system, what the target state is so that it can animate from the previous state, from the current state to that target state. And based on the transition specifications that we have created for both child transitions, it knows how to perform the transition between those states. So like the target state is equal to like that liked, else if like state that current state is equal to like that gone, if it is equal to like that liked, then the target state will be gone. Like that gone. Yes, just these two. If it is initial, then it will be animated. It will go to liked, and if it is liked, its next state, its target state will be gone. It will disappear from the screen. What if it is gone? If it is gone, we don't do anything because we don't want to animate the heart automatically and repeatedly. We just want to initiate its animation when the user double taps the screen, and that happens with this, actually, with undouble tap that we specified here. And for that, you can see that we specified the initial state as initial, and then it knows where to go from the initial state of like that initial. It will go to liked. Okay, now let's add our heart. I do that using an image. I import image. Let's add, actually I add an image as the image of the post, and then we will add our heart. So image and painter resource to load the image. I need to add an image to my resources. I have it in my pictures directory. Let's add it. I copy this image, for example, back to Android Studio, add it to my resources drawable directory, paste it here. Let's call it apples. r.drawable.apples. The resource and content description. For content description, I type apples, for example. With a content scale of crop. And also let's fill in the whole available space. Modifier dot fill max size. All right, let's also give it some padding. Depth. Actually, let's remove the padding. It's not necessary here. And after the image, I add my heart icon. So I use icon, and for the icon I use icons field.favorite. This is the heart icon available in material icons package. Import icons and favorite. And for the content description, import I type heart. All right, just use a tint. Let's specify its color. I want my heart to be white, so color.white. I want to fill it with white color. Import color, and after tint, let's give it a modifier so that I can give it a size other than the default size, which is a small icon. So modifier dot size, the size of 100 depth, for example. Import size and import depth. Also, because we are inside a box, let's use a center alignment. Alignment.center, so that the heart appears in the center of our post, in the center of our image, on top of the image, in fact. But its alignment will be centered. Okay, now we have our box that will detect the double tap from the user, and it contains the image as the image of the post, and we have the heart that will disappear and that will appear when that event happens, and that appearance and disappearance will be done using a transition in an animated way. So let's now add and apply the transitions to our heart. I do that on the graphics layer because the two properties that we use are modifiable inside graphics layer. So the alpha, for the alpha I specify and I give heart alpha. This is the child transition used for animating alpha. And also scale X, because we don't have a property of a scale, but we have a scale X and scale Y. So for scale X I use heart scale, and for scale Y I use heart scale. Alright, now we applied our animated properties to alpha and the scale in our graphics layer for the icon, and we are ready to run and see the result. Let's minimize the left part, switch to split view, and refresh our preview. Build and refresh. We wait for the build to complete and preview to appear. Alright, our preview appeared. Let's switch to zoom to fit screen and also enable interactive mode so that we can test our animation by double tapping the screen. Let's double tap, and if everything goes well, we will see the heart in an animated way. It appears and then disappears. There we go. We see the heart that appears in an animated way. Both the alpha of the heart and the scale of it is animated. It starts from the initial state, goes to light, and then goes to the gone state. So that's it for how it works, and we saw a practical example of using transition state, using the transition API with mutable transition state to create a nice and practical animation for our application. Let's also use it inside our set content so that we can run the application with. So heart animation demo, and run it on the emulator. Alright, the application is launched. Let's test our transition on the device by double tapping the screen. There we go. it works as expected. So that's it for an example of using the transition API. We created our different states using an enum class, and we created an initial state of the type mutable transition state, and we created a transition object using update transition that took the transition state that we had created, and we created child transitions for it that included the alpha and scale of the heart that we meant to create, and then we used these animated properties, that is scale and alpha on the heart inside the box, and we modified its properties, the heart's properties that needed to be animated in the graphics layer. Those properties included the alpha and scale X and scale Y. So I hope that you liked this video on how to use transition API to create a nice and practical animation. Animatables are low-level animation APIs in Jetpack Compose that you can use to have more control over your animation, and you can define your animation to animate to a target value with fine-grained control. They are basically value holders that you can use to animate to different values. And because many of the features of animatables are provided as suspend functions, you often need to call them in an appropriate coroutine scope. So let's create a new application in Jetpack Compose and see how animatables work. I create a new project in Android Studio, a new Jetpack Compose application. I name it Composable Animatables, and I save it in the project directory, and I save it in the source code directory for this course, and I press finish, waiting for the project to be created. Alright, the project is created. What I do now is I remove these composables, the default composables added by Android Studio, and create a new composable to showcase my animatable animation. I name it Animatable Animation Demo, and I also make it a preview so that I can have a preview of it. And before I forget it, I also make a call to this new composable inside the body of my set content, and in turn my application theme, Animatable Animation Demo, so that later I can have a run of my application and see the output on the device from this animation. And to have more space, I minimize the left part, and here I create an animatable animation. Note that animatables are in fact the API backing the animate as state APIs that we have used in some previous videos. So you might see some similarities between them in this video, but they have their differences, and with animatables you have more control and finer control over your animation. So the first thing we need to do for animatables is creating a new animatable variable. I create an animatable to hold the background color of a box. So I name it BG color. This is my new variable, my new state. As always, I use remember, and inside the body of remember I create a new animatable. I import animatable, and for the animatable we need to pass in some initial value. So let's import animatable from appropriate package. We import it from the animation.core package from the Jetpack Compose library. So you can see that it has an initial value and an appropriate type converter. For now, we will only use the first form which has its default type converter, and we will use the color value for that. So animatable, we initialize it with color dot red. So our background color will initially be red, and then we will animate it to different colors. We will animate it to some other different colors based on some condition. So color.red, and looks like we imported it from a rank package. I press Ctrl Z and import it again. Let's import it from androidx.compose.ui graphics package. Let's import animatable, Alt Enter. There we go. Next, I'm going to have a checkbox that will determine whether I want to animate this color to a new color or not. So I create a checkbox, val, I create a state for it first, val checked, and unchecked change using the structuring assignment from Kotlin, and remember mutable state of false. Its value will initially be false. And now let's create our layout. It's a simple box. The box will have a modifier. Import modifier, background. Before background, specify its size. I give it the whole available width, so fill max width, aligned with some padding. Import padding and background, a padding of 16 dp or dep, and for the background I pass in BG color. And what about the height? For the height, actually I'm going to use another state that is also specified with animatable. So I create another animatable, val box height, I name it, and I initialize it to an animatable. Let's give it its initial value. I give it an initial value of let's say 200f, because By default, animatable support float and color values for animation. And if you are planning to use other data types, you need to provide an appropriate type converter for it. So I pass it float value 200f, and here I say use this animatable as the height of the box. So height will be dp box height. I create a dp from this animatable. In fact, from the value stored in this animatable. So let's access its value and pass it to our dp and instantiate a new dp. So the background color also needs to use the value held inside bg color. Alright, now we have specified our animatables to be used for different properties of our box, like height and bg color, but they are not animated because we have not defined the animation behavior yet. So as I said, many of the features and functions for this API animatable is defined as suspend functions. So you need to call them in an appropriate coroutine context. One of the methods to use that and to provide a coroutine context for your composable is calling launched effect with a key. So one of the parameters is key1, which is the list of parameters that you need to pass. In fact, a minimum of one key needs to be provided to launched effect. So here for key1 we pass in checked. The body of launched effect, which is the block parameter, will run in a composable's coroutine context. So each time the value of key changes, then launched effect will run again, and then inside the body of it we can run our animation based on the new value of that state or key. So here I check for the value of checked. If it is true, I decide which value to animate to, and if it is false, then I decide to animate to a different value. So I say bg color, this is coroutine scope, and I say bg color animate to. If the value is true, if checked, then animate red to white. Let's use another color because white is often the background color of the parent surface. Let's use a different color than white because white is often the background color of the parent surface, and for that I use yellow here. If it is checked, then animate to yellow. Otherwise, animate to color.blue. So this launched box will allow us to do the appropriate animation based on the value of checked on our BG color animatable. So after box, I also actually I put the box inside a column, and after the box I'm gonna have a checkbox. So I wrap this box inside a column, let's give our box a modifier so that we can give it the maximum size. Fill max size, like this, and I put the checkbox here after the box. Checkbox. For the value of checked, I pass in checked, and for unchecked change I use unchecked change. Unchecked change. Alright, I also align in the center these two elements, the children of column. So horizontal alignment, I align them in the center. Alignment dot center horizontally, and now we should be able to run it. But before I launch it on the preview in the interactive mode or on the emulator, you need to look at this value and ask yourself why we have an initial value for our animatable. You can see that an animatable has initially a state, a value that can later be changed and animated to another color, to another value. So initially our box will have a background of red, and based on the value of checked, it will animate to a different color. So when we enter the composition, we are initially red, but we will immediately animate to another color based on whether the checked value is false or true. So first it is false, then it will immediately animate to blue, and then if we check it, if we check the checkbox, it will animate to yellow. Alright, we wait for the preview to appear, and then we can run our animation in the interactive mode of the preview pane. Alright, you can see that it is red. It is initially red, the background color of the box, but if I turn on the interactive mode, which means when the user starts interacting and having access to the UI, then it will animate immediately to one of these states, one of these two values, and because it's false, it will animate to blue. So let's turn on the interactive mode. There we go, it's blue. And if I check this checkbox, it animates to yellow. If I uncheck it, it will animate back to blue. You can see that the animation that it uses is very simple. So this is one way of using animatables, using launched effect. But there's another way also to use it, and next I'm gonna talk about it. Because animatables are giving us low-level access to animations and good control of the animation, we can use it with our gestures, with the user's gestures. So one example of it that I'm gonna use on this box is using a pointer input. This will be a simple one, and probably in another next video we will, and probably in another future video we will talk more about gestures and animations. So I import pointer input. After laying out its template, import pointer input, and inside the body of pointer input I use detect tap gestures. Detect tap gestures, import detect tap gestures, you can see that we have on double tap and other parameters for this function, and we have on press that takes a suspend function. So because it takes a suspend function, we can use a coroutine in it. So it's a good place to use animatables and make calls to animatables. I say on press equals like this, detect tap gestures on press. So here I wait for the user to press the box. So I say I make a call to coroutine scope, because I need a coroutine scope to deal with animatables. Let's switch back to code mode so that we don't use too much CPU for now. Coroutine scope, and inside the body of coroutine scope I wait for the user, await pointer event scope, and then here I wait for the user, await first down, I wait for the user to press the box. So when the user presses the box, I start animating the value of box's height to a new value. So box height animate to we know that first it is 200F, but I'm gonna animate it to 400F. And because it is a suspend function, it needs to be used in launched. So I launch it inside my coroutine scope. It launches a new coroutine. So this is for when the user presses the box, and then I wait for another event to happen, and that is when the user releases the box. Await pointer event, and this time I wait for the user, wait to release the button. So await, you can see the different methods that are available. Await pointer event, So this time I wait for up or cancellation, and when that happens I tell my animatable to animate to a different color. I tell my animatable to animate to a different value. So box height, animate to 300F. So the initial value was 200, and when the pointer event happens, we will have one of these two values as target values of our animation. And note that for animate to, we can also have an animation spec so that we can customize our animation. Here I add an animation spec when we are animating to 400F, when we are increasing the length of our box, the height of our box. So I use a animation spec, a spring animation spec with a damping ratio of high bouncy and a medium stiffness, spring stiffness medium. Alright. In addition to animating our height, we can also animate our color, our background color that we were already animating using our launched effect. So you can animate a value from different points of your composable's coroutine scope. So we were modifying the color both in launched effect, and we can also modify it in the pointer event, in the pointer input modifier for the box. So I can launch another coroutine here, or I can in fact continue my code inside the body of this launch and say bg color dot animate to a different color, a different value, color dot cyan. For example, when the user presses the box, I'm going to animate to color dot cyan. Alright, now let's see the effect in our preview. Let's refresh our preview. Alright, I'm turning on the interactive mode. And now let's check the checkbox. You can see that it behaves just like before, but we have also added the gesture detection pointer input to our box. So if I press it, I will have an animation. I expect to have, yes, I do. You can see, and when I release it, I have another animation. There we go. Yes, you can see we have two animations when I press it, both the height of the box and the color of the background animate to new values. And in order to animate the background to a different color, when I release the box, I also add a simple code here inside this launch body box height animate to 300f. After this I add bg color dot animate to color dot brown, for example. I don't have brown. I can animate to light gray like this, and I'm also going to add a border to my box. Yes, border to dp for the width of the border, and color dot black for the color of it. There we go. Let's build and refresh the preview. Alright, our interactive mode is ready. I press the box. There we go. You can see we have two animations running, and when I release it, it animates to the gray color. And animates back to gray when I release it. And what happens if in this situation we check the checkbox? You can see that it works as expected. The checkbox animation modifies the checkbox. When it changes the value of checked, which in turn changes the value of bg color and animates it to yellow. And if I uncheck it, it will animate back to blue. But the value of background is also modifiable and is modified using our press gestures. Like this. The only issue that we see is that the animation of the height and the animation to the cyan color are not happening at the same time. Let's find the reason for it. So first we can see that first the animation of the box height happens, and when it finishes, then bg color animates to cyan. In order to make them happen at the same time, I'm gonna launch another coroutine for the color, like this, and now they will happen at the same time. Now I expect them to happen at the same time because each of them will launch a separate coroutine that will not block the main thread of execution. The current thread is not blocked. So let's press it again. There we go. You can see that the increase in the length and animation to cyan happen at the same time. And you are also seeing the effect of spring animation that we used on the box height animatable when we press the box, and when we release it, we are using the default animation to decrease the height. So that's it basically for how to use animatables. You can modify animatables and animate to different values inside the body of a launched effect with a key, or you can use your composables coroutine scope by calling coroutine scope in an appropriate context, in an appropriate scope, like on press that will allow us to use coroutine scope to call coroutine scope, and inside coroutine scope we can detect users press and release, and then we can launch a coroutine to run an appropriate animation and animate to a suitable target value. So this was an introduction to animatables and how you can use it in your Compose applications. And with that, I wrap up this video. One of the common usages of using animatables is aligning with gestures and synchronizing your animations with gestures. In this video, I'm going to show you how to use animatables aligned with gestures, and I will show you 2 use cases for such scenarios. So I already have this, I have designed a layout that has 2 parts, an upper part and a lower part. And for the upper part, I have an image that is supposed to be moved around based on the tap on the screen. And for the second one, in the second layout, I have an item that is supposed to be dismissed out of the UI tree based on the users fling to the sides. So I will show you how to implement these 2 items using animatables. So for the first one, as you can see, I have an animatable called offset that defines the location, the current location of my B on the screen. Of course, the upper part only, because I have used the B image inside the box. So I'm gonna use, as you can see, the offset on the image as a modifier, and it is taking the up-to-date value of offset. And the next step that I need to do is applying the pointer input modifier on the box. So I use pointer input with unit as its key, and in its pointer input scope, I'm gonna run a while loop inside the coroutine scope. This is gonna be an infinite loop while true. And here I wait for the tap gesture. So await pointer event scope. I call this function inside coroutine scope so that I can detect the tap gesture. And here I wait for first tap. Await first down. To optimize CPU usage, I'm gonna close the preview pane for now. This is gonna return a pointer input change from which I need only position. So val pos position, and then I launch a coroutine to move the animatable to its new location. So offset animate to the new location. Note that the offset is not known here because I have defined it later. Let's move the definition before the usage inside the modifier. So I move it upper in the tree before the definition of the box. Alright, offset animate to position, and because I'm gonna show that with an animation and exaggerate it a little bit, I'm gonna use a custom animation, a spring animation. let's import spring, and then for its damping ratio I'm gonna use a damping ratio of high bouncy. Alright, let's run the application and see the results so far. Alright, I click on the box, there we go. You can see that RB is animated and it moves to the new offset and to the new location based on where I click inside the box. So you can see that I simply added an animation using animatables and tap gesture. So you can see that I simply added an animation using animatable and tap gesture. Next, I'm gonna move to the second box and implement the swipe to dismiss animation. For that, actually I'm gonna define a modifier, a custom modifier. So that custom modifier needs to be defined as an extension function of modifier, and then I can use that modifier of mine on any item that I want to be dismissible with swipe. So swipe to dismiss, I call it, and I define an action to perform when the swipe has happened. So on dismissed, it's gonna be a lambda that doesn't return anything, and this modifier will need to return a modifier so that it can be used aligned with other modifiers in a chain of modifiers. Composed, it equals composed. Composed is a function that allows you to define your custom modifiers, and make sure you return a modifier inside the composed block. So here I define an offset that is very important for me, val offset x, because I'm gonna move the item in the x direction. So remember animatable 0f, this determines the x offset of my item on the screen, and then I'm gonna run a pointer input to detect the gestures. I'm gonna pass in unit for it, and after the pointer input has been called and it has detected the gesture, it's gonna need to return to call offset, because the new offset will use the final value of offset x that I will be modifying inside pointer input. So int offset needs to be returned, and for its x component and parameter I'm gonna use offset x dot value. Because it's integer, I cast it to integer, round to int or to int can be used for that. And I don't touch the y component because I don't want to move the item vertically. So let's now detect the swipe gesture. Before that, I'm gonna use actually swipe to dismiss on the item that is supposed to be dismissible. It's the text item that I have inside the second box. So I add, as you can see, the to-do tells you where to use it. So I add swipe to dismiss, and the action that is supposed to be performed is specified with this lambda. It can just be setting a state variable like dismissed. I define a state variable inside the box var dismissed by remember mutable state of false. Let's import get value and set value for our delegate to work. There we go. And when the dismiss happens, I'm gonna set its value to true. And after that, dismissed. When that happens, I'm gonna show a toast in my UI tree and as the final item of my box. So toast dot make text local context dot current is used to get access to the current context of my application. Import toast and show a simple message like dismissed, and its duration toast.length.short and length short and show. And in addition to showing the toast, we are also going to remove the item from our UI tree. So I add an if statement before the text item and say if not dismissed. If the item is not dismissed, then this text element will be shown. Otherwise, you need to remove it from the UI tree. It is simply a matter of adding this if statement. It's very simple. You just decide to either show it or not show it. And now the hardest part and the challenging part that I hope will go smoothly and without problems. And here I run a coroutine scope in which I run a while loop to detect the gestures. And first, make sure that inside your pointer input you need to define a deceleration, a decay, that will be used to add physical properties to our fling animation and fling gesture. For that, there's a function spline based decay. It's a mathematical thing used in computer graphics to implement a type of deceleration for movements and flings. So spline based decay, its type will be float because we will be modifying and working with float value. And as the density that it expects, I'm passing the pointer input this, and I also need to define a velocity tracker. So a velocity tracker that I will use to define and to calculate the velocities. So velocity tracker, I define it inside my coroutine scope. Well, velocity tracker, velocity tracker. I import it from the Compose packages, and first I get access to the pointer input, the item, and the type of the pointer, whether it's finger or mouse, that points and that taps the screen, taps the item. So val pointer ID, I call await pointer event scope, inside which I can detect first down or first tap. First down, it detects a tap gesture, and then it returns the ID of the pointer. And here I stop the animation, because when I move the item around, I need to stop the current animation that is running, because I need to snap the offset to the new location that I'm dragging the item to. So I stop with launch. I launch a coroutine and I say offset X, stop any ongoing animation, and then I run another await pointer event scope so that I can detect a drag inside it. I can run a horizontal drag with the pointer that I have detected earlier, pointer ID, and then I decide what to do on every drag. On every drag, I'm actually moving the item to a new location, so I need to update the offset to those new values, to that new location. So I call launch offset X dot snap to the new location. How do I know where the new location is? The new location is calculated by calling offset X dot value. It's using too much CPU. I close it, the preview pane. Offset X dot value plus change in position. So change, here I have a change which has a type of pointer input change, and I know that one of its functions is position change. It returns the change delta for me, and I need the X parameter of it, which is float. And also make sure that you add the changes here to your velocity tracker so that it can later calculate the velocity. Velocity tracker dot add position, the time of the position, the timestamp of the position is change dot uptime millis, and its position is change dot position. Alright, after detecting the first tap and then running a horizontal drag, I have obtained the velocity tracker, I have obtained the needed points, and I have moved the item around as needed by snapping it to the new location. But then I need to calculate the velocity. So val velocity equals velocity tracker dot calculate velocity, and because I'm only interested in the X component and in the X direction, I get its X component. And now let's actually calculate the target value based on the fling and based on the force that the user has applied, and based on the velocity that we have obtained, we can now calculate where the final point after releasing it and where the item will stop after releasing it. So val target offset X to hold the target value, decay, I use decay to calculate it, calculate target value. It has a parameter of initial value. Initial value is offset X dot value, and it also has the initial velocity for which I pass in velocity. And now I do a simple comparison. I say let's run a coroutine, and here I say if the target offset X dot absolute value, if this absolute value is bigger than 75% of my width, then I allow it to be dismissed. So I say when that happens, I animate it with decay to the location that it can go to the new offset. So I say offset x dot animate decay with the initial velocity and with the decay animation spec, for which I pass in my decay. And also, let's not forget to call, don't forget to call onDismissed, which is the behavior that we expect to be performed after the dismiss has happened, like setting the state changes, applying the state changes, and doing some other stuff that you might want to do. So otherwise, if the target value is not big enough, if our force was not strong enough, if the final value was not big enough, then we will snap it back to its initial offset. Offset x dot animate to its initial value, and because we want it to look physical and natural, I run a spring animation as its animation spec, and for its damping ratio I pass in a spring dot damping ratio medium bouncy. Alright, let's see what we have. If the target value that we are calculating with decay is as big as the width, in fact 75% of the width, then we allow it to be dismissed and to move outside of the screen. Otherwise, we are animating it to its initial place, which was 0f. Also, because we don't want to run the animation more than it is necessary, we only want to move it outside of the visible area. We don't want to use too much CPU. So we update the bounds of our offset x. It has a lower bound and an upper bound. For the lower bound, I only want this to move as much as the width, as big as the width from the left, and to as much as its width from the right. So I say lower bound is size minus size dot width dot to float, because I want the float. This expects float values. And then for the upper bound, the right side, it's equal to size dot width dot to float. Alright, this means that our offset x can move only as much as the width of the item to the right and to the left, and that's enough for the dismiss to look okay. You can also add a little bit to this if you are worried that it might be a little bit visible after dismissing. So now I think everything is okay. We are detecting the pointer input, pointer ID, then we stop the ongoing animation, we snap it to the new location with a horizontal drag, and then with those drags we calculate the velocity using the velocity tracker, and then we calculate the target offset x, the target value of our offset. If it is big enough to be considered dismissed, then we dismiss it. We allow the item to move to that new location with the decay that we have defined, and then we perform any action that the user wants us to do as the modifier. Otherwise, we are snapping it back to its initial place with a spring animation. And we have used this swipe to dismiss on our text item, as you can see. And when the dismiss has happened, it changes dismissed to true, and then with that being true, we will see a toast. If dismissed, we will see a toast, and at the same time the text will be removed from our UI tree. Let's run it on the emulator and see the result. Alright, let's dismiss it by swiping to the right. First I apply a small force. You see that it is snapping back to its initial place. Now I apply a bigger force, a bigger fling. There we go, it was dismissed. Again, this time to the left, it is dismissed. Nice, not bad. But as you can see, the removal of the item is a little bit sharp from the UI tree. When we are removing the item after dismissal, it's a little bit sharp. As an assignment, I want you guys or girls, I want you as an assignment to add some animation to the removal of the item from the UI tree based on the animation lessons that we have so far in the course. So I hope that you liked this video, and see you in the next one. Welcome to a new section of the course. This section is about navigation. Navigation allows us to move between several destinations in our application. So we will be able to create a tree of destinations to move back and forth in our application. And Compose has good navigation capabilities that are from the navigation library from the Jetpack system. So we will get started with creating a nav controller and then a nav host that allows us to house our navigation destinations and our composables that are navigatable. I will show you how to navigate to a composable, and then optionally we will add arguments to those navigations so that we can pass in arguments to our destinations. And then we will create deep links that allow us to create links to our destinations in our Compose application and then navigate to those links from another application. This can be very useful in certain scenarios. And furthermore, we will talk about nested navigation. I will show you how to create a group of destinations inside a tree of navigation that allows us to have complex navigation trees in our Compose application. Next, I will show you how to integrate your navigation system and your navigation graph with bottom navbar that allows you to create a good user experience, a good navigation user experience for your users. And then we will talk about interoperability. In case you have an application that uses both framework code and Compose code, you will be able to move back and forth from one destination in Compose to a destination in frameworks, in fragments, and vice versa. And finally, I will show you how to add animation to your navigations so that when you are moving to a destination, you can have a good transition that shows that navigation, like an enter transition or an exit transition. So without further ado, let's dive in and get started with navigation in Compose. In this video, we will create a basic navigation in Jetpack Compose. So let's get started with creating a new project in Android Studio. As you can see, I'm using the high contrast theme for Android Studio to better show the code that I'm typing. New project. I press empty compose activity and then next. Let's name our project compose navigation. Other settings are fine. Package name, save location, and API version. I press finish and wait for the project to be created. Alright, let's hide the project explorer from the left. And I'm going to use the presentation mode for showing the code so that you can see the code better. Appearance, start, presentation mode, enter presentation mode. Okay, it's already in presentation mode. Good. And the first thing we need to do in order to work with navigation and create a navigation in our Compose application is to go to our project explorer, to Windows and project, and then in our build.gradle file for the app module, we are going to make sure that we have the navigation dependency for Compose added. So if we search for navigation, we see that it's not already in the list of dependencies, so we need to add it. At the bottom of my file, at the end of the list for dependencies, I add implementation, androidx.navigation, and then the compose artifact for the navigation library, navigation compose. And then because I don't know the exact latest version of this library, I use a minimum version like 100 alpha 1 and then press alt and enter to get benefit from and to take advantage of Android Studio's intelligent version recognition. And the latest version is changed to 2.4 alpha 8. Okay. And also a newer version of the Compose library is available, so I updated to the latest version, which is 102, and I can find it in my build.gradle file for the whole project. By the way, I press Ctrl Shift and N to search for a file, and once I made that change, I press sync now and wait for the project to be synced with these new changes. Alright, now let's get back to main activity by pressing Ctrl and Tab. And first I remove the composables added by Android Studio and also the content inside my theme. I'm gonna use my own content that will display the navigation that I will create. I create a composable function that will contain my screens for the navigation and definition of my nav host. So I name it my screens. The first step in creating a navigation in Compose is creating a nav controller. So I create a nav controller or navigation controller. I name it nav controller, and you initialize it with remember nav controller, which returns a navigation controller or nav host controller. Its type is a nav host controller. Alright. Then we use that nav controller to create a nav host or a navigation host that will contain the definitions of my different screens and different parts of my navigation graph. So nav host, as you can see, there are two ways of creating it. I use the second form, which takes a nav controller, a start destination, and other parameters. So nav host, and for nav controller parameter I pass in my nav controller variable, and for start destination I pass the root of the default destination or default screen that I want to be displayed. Usually this start destination or start screen is called home, so I name it home. I pass in home, and later I need to create a destination with this root name. And for the builder, which is a lambda, I move it outside of the parentheses like this, which allows me to construct my navigation graph. The way we create our navigation graph inside our nav graph builder block is by calling a composable, the composable function, which we need to import from androidx.navigation.compose by pressing Alt and Enter. And it contains a root string. For the first one, I pass in home, and I define its root as home, which is the default destination for my navigation graph. And for its content block, I'm gonna specify the screen that will be displayed as home. So I name it home screen, but it doesn't exist yet. I need to create a screen with this name, a composable with this name. And since I'm going to have several different screens, I'm going to call composable several times. So composable for the second screen, let's create a screen called B root. Its root is called B root. I name it this way. You can name it whatever you want. And I'm gonna use another composable inside it later, of course. Another screen, C root. Another screen, D root. Each of these roots that I'm using will be used to navigate to a different screen. And composable E root. You can continue adding different composables here, and with each of them you will basically create a new destination that allows you to navigate to a different part of your application. So now let's create different composables that we will use inside our destinations. So first, home screen. You can simply Alt and Enter by clicking on home screen, and then select create composable function home screen. It creates a composable function with that name. So inside that, I'm going to define a column that will contain several buttons to different screens. So let's add a modifier to it. Import modifier. And then fill max size, also background For the default screen, let's use a background of red. Import color. And now let's add our buttons. I'm gonna add several buttons so that I can click them and then navigate to other screens. I add a button to go to screen B, and then another button to allow me to go to screen C. Alright. Also, let's add an alignment parameter. So horizontal alignment, I'm gonna align them in the center. Alignment.center horizontally, and also vertical arrangement that allows me to use arrangement.center and arrange my items in the center. And for the first button, when it is clicked, I need to access the nav controller so that I can navigate to screen B. And for that, I need the nav controller. So I need to pass in nav controller to home screen. So I define nav controller, nav host controller as a parameter to home screen. And when calling home screen, I pass in nav controller to it. This nav controller is passed to home screen. So let's define our other screens like V screen, C screen, D screen, and E screen. Composable B screen. And for this, I'm gonna use a box modifier fill max size, the background of blue, and let's also use a text element inside it. Screen B. Let's use a style for it. Material theme dot typography dot h1. This will show a big text inside my screen. Let's also align it in the center with modifier alignment.center. This will align the text element in the center of my box. And for those composables that don't have a parameter, I can make them preview so that I can see a preview, but let's skip that for now and just continue creating our screens. Fun C screen. We can finally see our output on the emulator. Let's make it composable. Actually, I'm gonna copy the content that I have inside B screen and paste it inside C screen because they are very similar, just the color is gonna be different for C screen, and also the text. In fact, that's not true, because C screen, I'm gonna do something different in C screen. I'm gonna move from C screen to other screens. So here I'm gonna add a column. I add a modifier to it, modifier fill max size, and the background color dot yellow, and then I'm gonna add two buttons here. One of the buttons is supposed to go to screen D, and the other is supposed to go to screen E. And because we need to perform a navigation inside C screen, we need to pass in nav controller to C screen. So back to our C screen. We haven't called it yet. We go to the definition of nav graph builder and C screen. I pass in nav controller to it when calling it. Also for our second route and for our B screen, we need to call B screen. And then for D route, I need to go to D screen. And for E route, I need to go to E screen. Note that these two screens don't exist yet, so I will create them next. I type comp and press enter to create a composable. I name it D screen. It will be a simple screen using a box. I create it. Modifier fill max size, background color dot magenta, let's use for this screen, with the text D screen or screen D, with a style that shows the font size big, material theme dot typography dot h1 I use, and then a modifier that allows me to see the text in the center, alignment dot center, and then let's move to the next composable, E screen, a box, modifier fill max size, background, let's use a background color of cyan, this for this one, and then a text element, screen E, again the style parameter, material theme dot typography dot h1, and modifier dot alignment dot center. All right, we have created our screens. For C screen, let's perform the navigation inside our on-click block, and here when the button for D screen is clicked, then we move to D screen. So I use nav controller and then navigate to D route, which navigates me to the D screen. And when the button for screen E is clicked, then I go to E screen. Again, I use nav controller and then navigate, to which I pass in E route, and Before these, we also have other buttons that we need to take care of. Button for screen B that is supposed to take me to screen B. I use nav controller and then navigate. B route, and then we have the button for screen C that navigates to screen C. Its route is called C route. Note that all of these routes that we are navigating to have to be defined as part of our navigation graph. If you don't define them, your application will crash. So we have start destination home, and you can see that it is part of my navigation graph. And I have B route, C route, D route, and E route. Each of them are available inside my navigation graph, so whenever I have access to nav controller in my code, I can navigate to each of these different routes. Alright, let's test our application on the emulator by calling our my screens composable inside the set content block, and then in turn compose navigation theme block, my screens. Let's run the application. Alright, our application is launched. The buttons are looking very awful. Let's add some padding to our buttons. In our home screen, we have 2 buttons. Let's add some padding using the modifier parameter for the button. Padding 8 depth should do it. Let's import padding and depth. For the second button as well, modifier padding 8.depth. We also have 2 buttons in our C screen that in turn will allow me to navigate to 2 other screens. So I add some padding to them as well. Modifier padding 8 depth. Modifier for the second button in my C screen. Padding 8 depth. And also let's pay attention to how it is constructed in terms of its alignment and whether it will look good or not. Our column doesn't have an alignment parameter here, so I add horizontal alignment, the center horizontally as its value, and also arrangement, vertical arrangement dot center. All right, they will be arranged in the center, and let's see how it looks now. Let's run it. Okay, we are in our home screen. Our home screen doesn't show any text that we are inside our home screen, so I add one. This is my home screen, so I add a text element. Material theme typography.h1 for its style, and let's run it. Alright, this is my home screen, and in this screen you can see that I have two buttons, screen B and screen C. When clicking the screen B button, I will be able to navigate to the B screen composable. There we go, I'm in the B screen. To navigate back, I press the back button. I'm in home screen again. Now I want to go to screen C. I press screen C button. I go to screen C, and here I can go to two other screens, and as you can see, screen C doesn't have the text that I wanted to see, and because I haven't added that, I don't see any text. I added text, screen C, style, material theme dot typography dot h1, and it will hopefully be shown now. And because I don't want my text to be covered with these buttons, I'm gonna change the arrangement a little bit. Top center, use arrangement dot top, and now my text will hopefully be following my two buttons that I have here. Let's run it again. Okay, go to C screen, and in C screen I can go to screen D or D screen, screen E, and the back button, I press the back button, return back to the previous screen, which is a screen C, and from here I can again press the back button and move in my navigation graph back to the home screen. There we go. So you can see that basically you can navigate from every navigation node to another node in your navigation graph. Here we used our home screen to navigate to screen B and screen C, and then from screen C we moved in our navigation graph to screen D and screen E. We can also we can navigate back to screen A. As I said, there is no limitation as long as you are navigating to a route that is defined in your navigation graph. So for example, I can add another button inside my screen C to move to screen A. So screen C, I can add another button. Screen A, or home screen actually, because I don't have a screen A, I have home screen. And I can use nav controller to navigate to home. Let's add some padding. Modifier. Depth. Also in our home screen, let's add some padding and preferably some alignment to our text. So in our home screen, for the big text that we have, let's add some padding. Padding of 8 depth, and we are inside a column, so I can center it vertically, align, I can center it horizontally. Let's run our application again. Alright, as you can see, we have screen B and screen C. I move to screen C from screen A or home, and here I have another button that will take me to home. If I click the back button, I will go back to screen C, and then if I press the back button again, I will then move back in my back stack to screen home or home screen, and if I press the back button once more, I will exit the application because it is the initial item in my backstack entry. So basically you see that it might seem a little bit overwhelming because I created a lot of screens, but it's basically very simple. All you need to do is to create a nav controller and then a nav host that contains the definitions of your navigation graph, different components of your navigation, or nodes of your navigation, and then you can navigate back and forth between those nodes. For example, I navigated from home to B and C routes, and then I added navigation from C route or C screen to D route and E route, and I also added navigation from C route to home. So that's it for basically how you create a navigation in Jetpack Compose. In the next video, I will show you how you can pass parameters to your navigation destinations in Jetpack Compose navigation system. In a lot of cases, it's important to be able to pass in parameters to a destination when we are navigating to it. And in Jetpack Compose, we need to know how to do it. In this video, I'm going to show you how you can pass in parameters to a destination when you are navigating to that destination. As you can see, I have created an initial application that contains a selection screen where I can select several parameters or enter some parameter, and then by pressing the button I can go to another screen to which I will pass in some parameters. So you need to download the source code for this initial application from the resources of this lecture, and then you can watch the video and complete it as you go, or you can complete it whenever you feel like it and you feel comfortable. So as you can see, I have a selection screen. This is called the selection screen, which is referred to by this composable that I have inside my nav host. This is my first and only destination that I have in my nav host, and the selection screen composable in turn contains one column, one big column, and two other columns, the first column and the second column, where the user can make their selections. Here I have two parameters to select: the image that I need to select and its scale to be shown in the other screen to which I will go. And for the second part of the screen, I have a name to be entered by the user, and then by pressing the Greet Me button, I will go to another screen and a greeting to that name will be displayed. So let's see how it's done. The first thing I'm gonna do is to enter the presentation mode because I want to show the code in a bigger size. So view, appearance, and enter presentation mode like this. And here I have a to do: add route to show image. So I add a route here, composable, I name it show, and as I said, I need to pass in two parameters: the image resource and the scale of the image to be displayed. So This is the way we pass in parameters in Jetpack Compose navigation. You add a slash before the parameter and then curly braces. You put in the name of the parameter there, and if you have other parameters, you add it that way. So the first parameter is image resource I want to pass in, and the second one is scale. And then I have the list of arguments. Sorry, I pressed the end button and the screen just scrolled down. And here the second argument for this function and for this composable is the list of arguments, as you can see from the Android Studio hint. Arguments, list of. Here I use list of because I need to specify the list of arguments, and then nav argument, first the name of the first argument. Let's import nav argument, image resource, the first argument, and then I open its lambda where I can specify the characteristics of that argument. For example, its argument type. So its type is image resource is integer, so I use nav type dot int type. Let's import nav type. So nav argument, as you can see, it has two parameters, name and argument builder. I used both of them. Let's import nav argument. If it's not already imported, then nav argument for the second argument, which we know is scale, and scale we know that is a float. So type nav type float type, and then we have a last parameter for our composable where we can get the parameters and then use them for navigation. Here we are receiving a nav back stack entry that contains our arguments, and then we can extract our arguments from that nav back stack entry and pass to our destination composables, which are show screen and greeting screen. So I named the parameter that is passed to the lambda as backstack entry, and then I use them for the call. First I get the image resource val image, I name it for short, and then and then backstack entry dot arguments, and then I use the safety operator here from Kotlin, and then extract this image resource, get float, get integer, because it is integer, I use get int, and the name of the parameter is image resource. And the next one is val scale. I name it scale, and I extract it from backstack entry dot arguments, get float this time, and I get scale, and then I call my destination composable, which is show screen, to which I pass in image resource as well as the scale. Alright, because the types returned by getInt and getFloat can be null, I need to do something about it when I am passing it to show screen. So I say if image is not null and scale is not null, like this. All right. After that, I'm gonna create the next composable, the next destination for the second part of the screen. And this time I'm using another form of passing parameters in Compose navigation, and that's called optional argument passing or optional arguments. Here I'm passing an optional argument that can be skipped by the user when they are navigating to that destination. So with optional arguments, we don't have to specify the argument when we are going to a destination. It's optional, as its name suggests. So I name the argument here. My argument is called, I call it name, and name, and then I specify its argument type. Because it is string, you can skip it, you can skip specifying the argument type, because by default arguments in Compose navigation are considered string. So arguments, list of arguments, nav argument, the name of my argument is name, its type is string, and one important thing to be careful about here and to focus on is that you need to specify the default value of that parameter. Because it is optional, we must specify the default value, or at least set the nullable parameter to true. So I type default value, I specify the default value for this composable and for this destination, and for example I use John Doe as the default value, and then in the final part, or in the lambda of my composable, I pass in backstack entry to it. Backstack entry. And I go to greeting screen with the parameter extracted. So for name, I use backstack entry dot arguments and get string. Name. All right. And because this also might return a string that is nullable, we need to do something about it. We need to make the parameter passed to greeting screen as nullable, or we need to convert this to string. But because we have specified the default value of John Doe for this parameter, we don't worry about passing null to our greeting screen. So now that we are done with our composables, we remove the to-dos. And we check our two composables show screen. As you can see, it will show the image with the given scale, and we also have our greeting screen that will show a greeting for the past name. All right, let's run our application. Oh no, it's not working yet. We have the buttons that need to be triggered and need to do something. For the first button that I have in the upper part of the screen, when the button is clicked, I need to use the nav controller to go to that destination. So I use nav controller and then navigate to show, and then I pass in the parameters that I have. The image resource, as you can see, the image resource is the image that is currently selected image. It is the index of the selected image currently. As you can see, images is a list of image resources, 3 image resources, and selected image is its index. So I pass in selected image as image resource. Actually, I need to pass in images with the index of image that is selected. Images like this. And then the next parameter is scale. So I specify it as well. We are done with the first part. So scale. The scale parameter here is specified with the variable of scale. I have created a variable, a state variable called scale, called slide. it is called slide, and I pass in slide. This slide parameter will specify the amount of scale that I need to perform on the previewed image. So I send slide. So we are done with the first part, with the upper part. And then for the lower part of the screen, for the button that I have there, I send the entered name. So as you can see, the name is entered as the variable, the state variable of name. So I need to send that to my destination. Again, I have nav controller sent to this composable. As you can see, I have nav controller sent to me as a parameter to selection screen. So I have access to it, and then in the handler of this button, I say navigate. Navigate to greeting screen. What did I call that route? Let's call it greet. Let's remove this to do for the first button, and then here for the second button, I'm navigating to the greet destination with this parameter. The parameter that I'm passing is called name, and its value is name. Alright, let's run our application. Run. Alright, I don't have access to images here. Why? Images. Button. Text. Images. Images is inside the row, and the button doesn't have access to it. So I hoist it. I hoist the images variable. I move it upper in the tree. I move it inside the column, and now it should access it. Now my button should be able to access it. And selected image. Yes, I need to move selected image and hoist it as well. Like this. And then run it again. Alright, my application is running. I select my desired scale and the image that I want. For example, this apple, and I want it to be previewed in the target destination by clicking the show image. There we go. You can see that I have a preview of the selected image in the target screen. I go back, I select another image. This image is selected by default, the pineapple. So I select a scale and then press show image. There we go. So we were able to pass into parameters with the first form of parameter passing, and you saw that usage here. Now what about the second part? The second part where I can send my name. Welcome Mehdi. So what happens if I don't specify anything here? Welcome John Doe. The reason is that the default name is used here. If you don't specify a parameter, if you don't specify a value for your optional parameter in Jetpack Compose navigation, it will use the default value. And here we are using the default value of John Doe because we know that we have specified that value as the default name to be displayed and to be passed to our destination. As you can see, here we get its value, and because it has a default value, it is receiving the default value and displaying it when we don't provide any value here. All right. So we talked about two methods of passing parameters to our destinations in Jetpack Compose. The next question that we need to tackle, and we might tackle, is it possible to combine these two types of parameter passing? Am I able to pass in an optional parameter aligned with the first form? The answer is yes. I will be able to pass in an optional parameter when I'm using the first form of parameter passing to my navigation destination. So the only thing that I need to do is just adding a new optional argument to my route. So for example, I want to send a caption to be displayed on top of the image in the preview and in the show screen that I have in my destination. So I specify a name here, a name for my parameter, caption, I name it, caption, and then I specify its type. It's very important to specify it here, nav argument, because the navigation system knows the list of your parameters from this block, nav argument. Its name is caption. You can skip its type because by default it considers the type to be string. So I can just skip adding the type for it, and then here we can pass in the caption that the user enters as a new parameter to show screen. So caption, and for its value I send the caption that I have received. Val caption backstack entry. I extract caption from the backstack entry arguments, get string caption, caption. But as I said, optional arguments need to know the default type. You need to specify the default type for them or set their null to true. So I can set its default value to true. I can pass in a default value to it, I need to do it, or I can set its nullability to true. Nullable, true. I can do this, which I'm not interested in. I don't want to work with null, and I don't want to pass in null parameter, so I use a default value. Selected image. I use the default value of selected image to pass, so that I know I will never pass in some null parameter. And because show screen doesn't yet have a parameter called caption, I need to edit the definition of this composable to add it. So I add caption string like this, and now I can send the caption. Caption is nullable, so I call to string to convert it to a string, and in order to use it, because I'm inside the box after the image, I call text, the text composable from material design, and for its value I used caption, and let's specify a style for it. Style material theme dot typography dot, I can use caption, or let's use h2 and the modifier I use modifier.align to align it in the center of the screen. So alignment.center like this. And now I will be able to see the result. Let's also add some padding. Let's run the application again. Select the scale, show image, selected image. You can see the caption displayed on top of the image in the center of the screen, but the problem is that we are not yet able to send our desired caption, and for that to work I need to add a new UI component here to be able to make the user able to enter their desired caption. So I go back to the definition of this part. Inside my first column, after before the button for show image, actually I use an outline text field which has two parameters that are required, value and unvalue change, and for them I define two state variables, val caption and uncaption change. Let's define them easily using Kotlin destructuring assignment. Caption, uncaption change. Remember mutable state of empty string, and now I can use caption as the value and uncaption change as onValue change. As you can see, uncaption change is a lambda that takes in a string and doesn't return anything. It actually is responsible for updating the caption value to new values when it is updated by the user by entering new characters inside it and editing it on caption change. Let's add a label to it. Label text for its label image caption. All right. And when passing the parameter, I need to specify the optional argument. As you can see, the previous time we didn't call with the optional argument because it was optional. We simply skipped it. We didn't pass that argument, but this time I'm gonna pass it. So because it is called caption, I use caption, and for its value I use the caption string that I have defined. Let's run it again. Alright, I select one of these images, this banana for example, with some scale, and then the image caption. I use banana. As you can see, I haven't added a padding, so it's good to have a padding for it. I add that as a modifier. Modifier, padding 8 dep, like this, and also fill max width to fill the whole width that I have available. So I go to my destination by pressing show image. There we go. The banana is shown with the selected scale and with the entered caption. I return back to my previous screen, and as you can see and as you saw in this video, we had two types of parameter passing: the required parameters or arguments and the optional arguments. For optional arguments, you don't need to specify them because they are optional and they can be skipped. And because navigation system knows that they have a default value, so when you don't specify them, it can use the default values as it did for our caption parameter in our upper part of the screen. When we didn't specify it, it displayed the default caption of selected image. But when we specify it, we call our root. We go to our root with the selected option, with the selected argument. So we add our optional argument and its value to our root, and we call it, and then it displays it with that argument. It displays that by incorporating that argument in our backstack entry. For the second part, we only had an optional argument. When we didn't specify it, again, it used the default value of John Doe. And you saw a mixture of these two types of parameter passing: the required parameters and the optional argument. So you saw that we can have in a root both required arguments and optional arguments. Let's run it once more with the selected UI changes, with the new UI changes that I applied. I select one of the images, select slide, the desired scale for the image, and then image caption, apple, or my apples, sorry. I press the home button, my apple, and I press the button show image. As you can see, my apple caption is displayed on top of my previewed image. Very nice. This is a combination of passing required parameters and optional parameters to my navigation destination. And for the second part, Mehdi, or because I used it last time, this time I use Udemy. Greet me, welcome Udemy, or John, welcome John. And if I don't specify it, the value of John Doe is passed in as the default value of this argument. So that's it basically for how you can pass in parameters to your destinations when you are using Jetpack Compose navigation system. So in short, we had two types of parameter passing: the required parameters or arguments and the optional ones. And the important thing about the optional ones is that they need to have a default value, or their nullability needs to be set to true, which I don't recommend because you have to deal with null values. As you saw, I used some default value other than null. So I hope that you liked this video, and I see you in the next one. Sometimes it's good to have a deep link in your application that can be opened from another application. In this video, I will show you how to create a deep link in Jetpack Compose navigation and how you can open it from external apps. So let's get started by creating a new application in Android Studio. I open Android Studio and wait for the window to appear. Okay, new project. Empty compose activity. Next. I name it deep link and save it in the compose course directory, deep link. And let's change the directory name to the project name to compose deep link so that I can save it in deep link directory. And I press finish, waiting for the project to be created. Okay, the project is created. As the first step, I go to build.gradle file and add the compose navigation library. Navigation compose 100 alpha 01. Because I don't know the exact latest version, I use alpha 1 so that Android Studio can help me with the latest version. Yes, the latest version is 2.4 alpha 9. So change to that latest version by selecting the option, and also Compose version is not up to date. The latest version is 102, but we are using 101. Let's update it. I do that from the other build.gradle file. For the whole project, I change the version to 102. Then I press sync now and wait for the sync to be done. Let's close these files. Back to main activity. I open tool windows, appearance, enter presentation mode, so that we can see the code better. As the first step, I remove the default composables and also the call to greeting that was previously there. I create my navigation screen, a new composable, and I name it my screens. This will contain my navigation and my navigation graph. Let's call it in our surface main screens, and in the my screens function I'm gonna create a navigation controller, val nav controller. Remember nav controller, then a nav host. For the nav host, I have to pass a nav controller and an start destination. I use the home route that I will create soon, start destination, and then the navigation graph I created in the lambda for nav host. Then I create my first route, which is home. It doesn't take any parameters. It just shows home screen, which is a composable that I will create by pressing Alt and Enter on it. It is just a simple box. Let's import box, modifier. Let's import modifier, fill max size, and inside the body of the box I'm gonna create a text element. Welcome to home screen. This is our home screen. Let's use a font size of 30 sp. And the text alignment, text align of center, modifier. I use a modifier to center align it inside the box, alignment.center. Okay, let's now move on to other screen, our next composable. This will be a route to my deep link. So I'm gonna create a deep link here. For the deep link, I'm gonna use a route of greeting. This will take a parameter as the name to greet. For example, I will pass in my name and then it will say hello Mehdi. You can pass other parameters. So this is the route, and also because it needs a parameter, we pass the parameter inside its route. This is a required parameter. You can also make it optional by using this syntax. the question mark and then name and the value for it. But we're gonna use the required parameter syntax, which is simpler for this case. So name, list of arguments, it is a list of arguments. There's only one argument, so list of nav argument is called name, and its type is string because the navigation argument types are string by default. I don't specify the type. And after that we move on to the important part, which is deep links. Because this is a deep link, I need to use this option, deep links. And again, this is a list of deep links, and we create deep links with nav deep link. It has several fields to specify in the nav deep link lambda. The most important one is the URI path. So you can see the list of fields that you can fill with this dot. You can see that we have URI pattern, action, and MIME type. The important one is URI pattern, that is needed here. URI pattern. And the pattern that I'm gonna use is my app : / and then greeting, and then the parameter name. And in the body of the composable, I'm gonna use the nav backstack entry to extract this parameter and use it. So I'm gonna create a composable that will create a screen for it, and that's gonna be called a greeting screen that takes a name, takes this name and greets it. So let's create it, create composable, name string. This is the parameter that it takes, and in the body of it, it's gonna create a box, a simple box, and then inside the body of the box it creates the name, hello, that name, hello name, modifier, fill max size. Let's use a background color, background of red for the box. Import color, import background, and let's use a style for our text, material theme dot typography dot edge 3, for example, and padding modifier padding dot 16 dot depth, all right. Back to the definition of our deep link. Here we need to extract the value of our parameter specified in the deep link. So I say it, which is the nav backstack entry dot arguments dot get string. Its name is name, and because it's a nullable string, as you can see by hovering with your mouse on get string, it is nullable. It doesn't work this way, but I convert it to toString so that it gives me a string value that can be passed to greeting screen. So that's it for my deep link. But note that this deep link is not accessible just as is from other applications. In order to make it accessible, I need to go to the Android manifest file and define some stuff over there, define some filters. So I go to my project explorer and then find Android manifest. Here you can see that there's an intent filter. I can use this intent filter or define my own. I define my own intent filter, and inside it there are some tags that I need to add. One of them is action. For its name, I'm gonna use android.intent.action.view. And the next one is category. Its name is gonna be default and browsable. So android.intent.category.default and category with the name of Android name, android.intent.category.browsable. This way we will be able to open our application with a link from a web browser in our phone. The next required tag that I need to use is data. That specifies the type of the URI to use, Android scheme, which is the prefix of my URI. It's gonna be my app, which lets me use my app colon // later when I want to open this app. And Android dot scheme and Android dot host. For the host, I'm gonna use the path that I created in my deep link, greeting, this way, and I close the data tag. That's it for the definitions in our Android manifest file. I return back to main activity and I run it. Shift F10. I run the application, wait for the app to be built and installed on the emulator. Alright, it's being launched. Okay, welcome to home screen. This is the home screen of my Compose app. And the next step, I'm gonna create another application that's a native Android app. And from that application, I'm gonna open this Compose app that has a nav deep link. And I'm gonna open the deep link of this Compose app from the other native app. So let's go ahead and create that app. File, new project, empty activity, not Compose activity, and I'm gonna name it my native app, and I'm gonna save it in the deep link directory so that I can later package both of these apps as the source code and the projects of this lecture. And I press finish, waiting for the project to be created. It's being built in another window. Okay, the app has been created. As you can see, it has a layout, activity main. I can open it and you can see that it's a text view that reads hello world. I'm gonna change this to a button so that by clicking it I can open the deep link from the other application. So I go to code editor and change the text view tag to button. Also I'm gonna give it an ID, @ID / button, I name it. And for the text I'm gonna use open deep link or greet Mehdi. And in order to make it more usable, actually I can have a text edit text, and inside it let's use 0dp for the width and height, and ID edit text. It needs some constraints, so I'm gonna use some magic constraints for it. Let's use some height and width for it so that we can see where it is. Let's constrain it from the top to our button and from the left and right to the parent. And I'm gonna change its width to 0 dip and height to 0 dip. Actually, for its height I'm gonna use wrap content like this, and it has an ID. Good. There's a warning here, it's not important. I'm gonna take the name from here and pass it to the other application that has a deep link, to that deep link. So greet that name, greet me. Let's go to main activity and write some code. In the main activity, after set content view, first I'm gonna define a button. Its type is button. Find view by ID, r.id.button, and like this. Actually, find view by ID, find view by ID, find view by ID. Its type is button, ID is button. Then I set an onclick listener to it, and inside the onclick listener I take the text, val text, by finding that text editor or edit text. Find view by ID, edit text, r.id.edit text, import edit text as well, and then I take its text and convert it to a string. And in order to open the deep link I need an intent, so I create an intent. I call it deep intent. I'm gonna use a form of intent constructor that takes an action and a URI. So intent action view, the type of the action is view, and then the URI is my app : / greeting, the name, the text that is here. And because this is just string, I need to convert it to URI by calling toURI. I import that function as well, and then open it by calling start activity and passing in the deep intent variable. This way of opening a deep link from another application is called explicit deep link. Actually, we are opening our deep link explicitly using an intent. The other way is opening it implicitly by clicking a link that links to that deep link, and after this one I'm gonna show you that one. So let's run this application first. Build, run app. Okay, the build is complete. It's being installed and launching the activity. As you can see, I'm inside my native app and I'm ready to enter a name here. I enter, for example, my own name, Mehdi, and press open deep link. It should open the other application. There we go. It opened the other application, and this screen is from the Compose app, and the deep link to this screen has been defined in my Compose application using the Compose navigation API. So if I change that name to, for example, John, it's gonna change that name and pass John to deep link. There we go. Hello, John. So we explicitly opened our deep link from an external application this way. The next step and the second way of opening deep link is opening it implicitly by defining a URI or a hyperlink in a web browser and then opening it from your web browser. To demonstrate that, I have created a file. I have created an HTML file. I open it with my text editor. You can see that it's a simple HTML file. It has a hyperlink and an A tag that links to my application, my app / greeting developer. The name that it is passing to the deep link is developer. And the text is click this link. What I'm gonna do is drag this file to my emulator, and now I can find it from my Files app. As you can see, it's here. I open it. Let's open it with HTML viewer. And if I click this link, it must open the deep link from my Compose application. There we go. Hello, developer. It worked. So you can see that creating deep links in Jetpack Compose using the Jetpack Compose navigation API is quite straightforward. Just be careful about the parameters definition and the way you pass in parameters to your URIs and to your Jetpack Compose navigation destinations. So that's it for Jetpack Compose navigation deep links. I hope that you liked this video, and I see you in the next one. Sometimes in our navigation graph, we have a group of destinations that are doing similar things. For example, we have several screens for the login process or for the sign up process. For example, for sign up, we might have a screen for getting the user's email one screen for getting the user's password, one screen for showing the user's progress in contacting the server, and so on and so forth. And therefore a group of destinations are doing something that is similar. Therefore we can group it in one destination. This is called nested navigation, and in this video I'm going to show you how you can create nested navigation in Jetpack Compose. So let's head over to Android Studio and create a new project. I create an empty compose activity and name it nested navigation. I save it in compose course directory and I press finish, waiting for the project to be created. Alright, looks like our project is created. First of all, I enter presentation mode before I forget it. I go to view, appearance, and enter presentation mode. And first, because we are working with navigation, I need to add the navigation library. So I press Alt and 1 and go to Gradle scripts, build.gradle file, and add the navigation library to my project. Android X navigation and navigation compose with the latest version that is, I think, 2.4.0 alpha. It should be alpha 9, but I enter alpha 8 to get help from Android Studio if there's anything newer than that. Yes, it's alpha 9, the latest one. I imported. Also compose version, there's a newer version available, so I go to the main build.gradle file and I update the compose version to 1.02 and press sync now. We need to wait a little bit for the sync to be done. Alright, it's done. Back to main activity and I proceed with the code. Here I remove the composables added by Android Studio to this file, and I'm gonna create a navigation. So first I create a composable. I name it my screens, and here first I create my nav controller with remember nav controller, and I need a nav host for that. I import the one from the compose package. And nav host, as you can see, takes a nav controller and the graph builder. Then we have the graph builder. Also the start destination or the default destination is important to be specified, and for that I'm gonna use A. Let's imagine we have several screens A, B, and C, and then inside B I'm gonna have several other nested screens that are part of B. Therefore I'm gonna start labeling them with alphabet characters. So as you can see, nav host, I'm inside graph builder and I'm gonna use my composable function, composable, that is available in the navigation library, and composable takes a route name. As you can see, these are the same. This is the default or start destination that needs to be part of my graph builder or my navigation graph. So inside A, I'm not going to pass any arguments because the goal of this video is just to show you how you can create nested navigation. So inside composable, I'm gonna create a screen, and because the screens that I will create for every route will be similar, I'm gonna create a composable for that so that I can use it under every composable, inside every composable, and I'm gonna name it screen. And what it does, it takes a label, the route name to display. So it has a label, its type is string, and it also has a lambda for its content. So we can have different content inside our composable, and to make it possible, I'm gonna create a parameter for screen that takes a composable. So this is a composable lambda that I define as part of the definition of my function composable, @composable, of course, and I'm gonna create a column here, modifier. Let's give our column a modifier so that we can specify the maximum size for it. Fill max size. And in addition to that, we might also want to give it a background, but I'm gonna skip it. And here inside the column, first I'm gonna use a text element. A text element that allows me to actually show the label that is passed to the screen. So label, I'm gonna use a big font size for that to show it, like 40 SP or 30 SP should be fine. Let's import SP. And for our text, also I'm going to use a modifier to give it an alignment. But in order to make it easier for alignments to be applied to all elements inside column, actually I'm gonna remove this modifier from here and later add it as a parameter to column, because we know column has a parameter for alignment and arrangement. So we have horizontal alignment, and for that I use alignment dot center horizontally. And then for the text we have a special parameter called text align, to which I pass text align dot center, so that the text inside my text area will be centered. Okay, let's also give it a padding. So finally we need a modifier after all for our text. So padding 16 depth, I import depth and padding. So this is the definition of screen. One more thing before I finish creating composable. this composable is using the content that is passed to us, because we want to make it possible to embed any content that is passed to us here. So I'm gonna use content and invoke it this way, so that content is placed here. Every content that is passed to us is invoked here as in and is placed here. So invoke the content here, the past content, of course. So let's create our screens super fast. Composable B, a destination for B, and composable C, and as you can see, these will be 3 screens or 3 destinations in our navigation graph. And inside A, I'm gonna create links to the two other screens. So here I'm gonna use a column intern, and inside my column I'm gonna pass in 2 buttons. One button for going to screen B, and the other for going to screen C. And also we need our nav controller, so when this button is clicked, I'm gonna use the nav controller to navigate to screen B, to the route that is labeled with B. So navigate to B, and if the C button is clicked, then nav controller navigate to C, like this. And also I'm gonna make these columns, make this column align its content horizontal alignment dot center horizontally I'm gonna use for it. And also let's give it some padding for the buttons. So modifier dot padding 8 dep should do it. For the next button, padding 8 dep, and this should do it. Inside every composable, now we should be able to have our screen. But note that I created a composable to show my content. Therefore, I'm gonna wrap this column definition inside a pair of curly braces and then make a call to screen. And screen takes a label like this, and the label that I'm gonna use is to be taken from my nav backstack entry. I can take it from nav backstack entry. So instead of using A here, I'm gonna say it, which is my nav backstack entry dot destination. I must use it the dot destination and then route. This is the route, and because route can be nullable, I convert it to a string, and this creates a path for me to go from the A screen to B and C. Next, I'm gonna create the content of B. So for this one, I'm gonna use a simple screen like B with no content. I'm not going to use any custom content inside it, just with the defaults, leave it with the defaults. And then for C, I'm gonna use a screen C and with empty content. Now let's call my screens inside our surface so that we can see the output on our phone. My screens. I'm gonna run the application from run app, and we wait for the emulator to launch and run our application. Alright, as you can see, we are in our A screen, and this screen contains two buttons that links us to the two other screens, B and C. If I click this button, I must go to screen B. Yes, that's right, I'm in B. I get back, return, and then go to C like this. And as you can see, this is normal navigation. We have just one navigation graph that has three destinations, A, B, and C. And from every node, we can navigate to the other node in our navigation graph. Next, as the subject of this video suggests, I'm gonna create a nested navigation. By that, I mean when I go to one of these screens, like B for example, I'm gonna have several other destinations. So those two destinations will be part of B and grouped as the B destination. In order to create that, I return to the definition of my nav host, and because I'm gonna put the nested navigation inside B, and the navigations that are going to be part of it, the nodes that are going to be part of it inside B, I'm gonna tell you what you need to use for a nested navigation. Instead of composable, use navigation. So the only difference is that you replace composable with navigation in your navigation graph. I import navigation. I import it from the first option, and as you can see, its parameters are a little bit different as the error shows here. I press Ctrl P. It has a start destination. So for start destination, I need to specify a destination, and in turn it also has a route. So it's important to note that it has a route. It itself has to have a route, and also it needs to have a start destination that specifies its default destination, its default home page. That shows by default when we move to this route. When we move to B, we need to see a default screen, and here's where we specify and determine it. So start destination. For start destination, let's say we have children of BA, BB, and BC inside this navigation graph. So let's use BA, and I'm gonna remove this call to screen. And this is the definition of the navigation graph. So here I'm gonna create 3 other composables. Composable and composable. In fact, let's just create 2 children. This is just to show how it works, so I don't need to make it very cluttered. So composable, let's specify its root. So for its root, as I said, I type BA, which is also the start destination, and inside it I make a call to screen composable with the label of it dot destination dot root and to string, and with some content that I'm gonna create soon, of course. And for the second one, for the second node of my navigation graph, or my nested navigation graph, in fact, I'm gonna use BB label. This is the second destination inside my B route or my B navigation. So when I head over to B, first I see the content related to BA, and this contains a column that I'm gonna create. This is just arbitrary content I'm creating. You can create whatever you want. I'm gonna put here, for example, I'm gonna simply use a button, because there's only one content, there's only one other screen to navigate to, so I use one button here, and as its text I say go to BB, and when the button is clicked I go to BB, nav controller, navigate to BB. And actually I'm gonna add the other composable too. Let's have some more screens, 2 other screens, composable CC and composable, because it's easy to create them here. We have a ready-made composable that makes us easy to create the UI for it. So go to BB, and now that we have several screens, I'm gonna put them inside a column. Surround with column. The first button takes us to BB. The second takes us to BC. Go to BC. Let's not forget its code. Its navigation code. Take us to BC. And sorry, it should be BC, and this one should be BD. These are children of B. And yes, go to BB, go to BC, and another button to go to BD. So text, go to BD, nav controller like this, And now I have 3 buttons, and for the buttons I'm gonna use modifier for the column first, modifier fill max size, and horizontal alignment, dot center horizontally, and for the third one, when I created BD, I go to BD, of course, and also let's add some padding to the buttons, modifier that padding 16.depth, modifier that padding 16.depth, add a modifier 16.depth. And inside each of these child composables, I'm gonna call a screen with their label, so it dot destination dot root to string, and screen it dot destination dot root dot to string, and the screen it dot destination dot root to string. And to make this label look a little bit bigger, I'm gonna change the font size in the definition. Here's my let's not forget to add the content block for our screen. If we don't want to add the content block each time, even when we don't need it, we can specify it as default of null. We can pass it null. Okay, sorry, we can pass empty lambda like this, so that we don't need to specify the content block for our screen. All right. Now, as I said, I want to increase the font size to something bigger. 60, 70, 50 is good. And also I'm gonna change its horizontal alignment. I'm gonna give the text some alignment dot center vertically. I cannot call it in this column scope, so I skip it, and that's fine. Let's run our application to see our nested navigation in action. Alright, our application is running. We are in the A screen as the label shows here. I go to B, and B is a nested navigation and the nested destination, and you can see that it has in turn 3 other destinations in it: BA, BB, BC, and BD. In fact, there are 4 destinations inside this node: BA, BB, BC, and BD. And BA is this screen, which is the default screen or a start destination shown to us when we navigate to the root of B. So inside our B screen, I have link to BB. So I can navigate to BB like this, return. I can go to BC, return, and I can go to BD like this, return, and back again. I'm in the A screen, and here I can also go to the C screen. So the point of this video is that we created a nested navigation here that is routed to by the navigation that we created here to screen B. And with this button, we go to that screen. We go to that route, which in turn has several child destinations in it. So you can use the principles that we used here to create child navigations and nested navigations in your application. For example, if you have a sign up process, you can put all your sign up related screens under the sign up route. In our definition, as you can see, this is my definition. This is my definition of nav host, and these are the children of my nav host: A, B, C, and in turn B has some other children: BA, BB, and BC and BD. So you can use this principle and these principles to create nested navigation in your Jetpack Compose application for making it easier to manage your destinations and make the destinations relevant to your goal of your application, to the goal of the operation that is usually performed using those destinations. So that's it for nested navigation in Jetpack Compose. I hope that you liked this video. So that's it for nested navigation in Jetpack Compose navigation system. So with that, I wrap up this video and see you in the next one. Compose navigation integrates perfectly with bottom navigation so that you can easily go to different parts of your application by selecting the options on your bottom navigation. In this video, I'm going to show you how you can create a compose navigation and integrate it with bottom navigation. So let's get started by creating an Android application and implement our bottom navigation. I open Android Studio. We wait for the window to appear, and I create a new project. Empty compose activity. Next. I name it compose bottom navigation, and I save it in the course directory. Minimum SDK is API 21. I press finish and wait for the project to be created. Alright, our project has been created. As the first step, I go to Gradle scripts and add the dependency for navigation to my Compose app. So build.gradle from the app module, and at the end of the list of dependencies I add implementation Android X dot navigation colon navigation compose, and for its version I think it's around 240 alpha 9, but still I can use the help of Android Studio. You can always search for the latest versions of Jetpack libraries on developer.android.com/jetpack. And yes, a newer version of this library is available. I select change to the latest version. Also, there's an update available for Compose version, so I go to the main build.gradle file and update that version too. I update it to 102 and press sync now. Alright, the project is synced and I can go back to main activity to create my bottom navigation. First I enter presentation mode from the view menu, appearance, enter presentation mode to have a bigger view for our presentation, and then I get rid of the composables added by Android Studio and also the content inside the theme. I create a composable to hold my main screen, so comp, and I'm gonna name it main screen. Inside this main screen I'm supposed to create my bottom navigation. I can also make it a preview because it doesn't take any parameters, and then because we are going to create a bottom navigation we will need a scaffold, but that scaffold is gonna need a navigation controller. So I create a navigation controller, val nc equals remember nav controller. Remember nav controller. And I'm gonna call this main screen inside set content so that when I run my application it will show the UI created by main screen. And for my main screen I'm gonna create a scaffold because bottom navigation that we are supposed to create works better and works best as part of a scaffold. And scaffold, for your information, if you are not that familiar with it, scaffold is a structure, is a standard structure for creating application structures and window structures in Compose applications. So I create a scaffold, and scaffold has different parts to it. It has different parameters that we can specify. Some of them are important for us in this application and we will leave the other ones as skip them. For example, we have top bar and bottom bar, which we will use in this application. We will use top bar to show the application's title and bottom bar to show the bottom navigation. In fact, bottom bar will contain our bottom navigation. So top bar, for top bar, this is going to be my top bar. And bottom bar, like this. For top bar, I'm going to simply use a top app bar. This is a composable from Material Design Library. So there's two ways to call top app bar. In fact, after I import it, you can see that there are two overrides of this composable. I'm gonna use the first one, which has a title. So title, and for the title I'm gonna use a text composable and show the application's title. String resource, I'm gonna use string resource to load a string resource, or that string.app name. I'm gonna load the application's name from the string resources. Next, I'm gonna create my bottom bar. For the bottom bar, because this might be a little bit long, I'm gonna create a composable that will hold my bottom navigation and then call it here. I can of course create the bottom navigation directly inside this, but I prefer to move it to another composable. So I name it my bottom bar, my bottom navigation. In fact, my bottom bar, let's call it. And because it will need the navigation controller, I'm gonna pass navigation controller to it as well. And then because it hasn't been created yet, I press Alt and Enter on it, and then select Create Composable Function, my bottom bar. And yes, it creates it. Inside the composable, I'm gonna create my bottom navigation. Bottom navigation. And you can see that bottom navigation has different options, but the important one that we will deal with is the content part. So I'm gonna remove the parameters parentheses because we don't need it, and only fill in the bottom navigation part. Here's where we will specify the list of items that will be displayed on our bottom navigation. Therefore, we will need a list of screens. It's better to use a sealed class to represent these items, and it's the recommended way. So next I create a sealed screen class. I go to Alt 1 to open Project Explorer, and then in the package level equal with the level of main activity, I'm gonna create a new class, Kotlin class. It's a sealed class, so I select its type and I'm gonna name it screen. And this is going to have several options, several fields. This class, which is called screen, is going to have several parameters when constructed. One of them is title, one of them is root, one important one is root. So val root string, and val icon. For the icon, I'm using an image vector type, and also we are going to have a title, val title string, and then because sealed classes are limited in the hierarchy, we can now create the children of this sealed class that will be known at compile time, and there will be a limited number of children for this screen class, only those that we create now. So screen has a child named home. I'm gonna create a child named home. It's gonna be an object because we will only need one instance of that screen, object home, and it inherits from a screen. For its root, I'm gonna use home, and for its icon, I'm gonna use the home icon from the material icons package. Icons, and you can use the default group or from the outlined group. Outlined, I'm gonna use from outlined, and then home. Let's import icons and home, and for the title, home screen. Next screen, I'm gonna create a screen of a profile, and again it inherits from the screen class, and it's gonna have profile as its root, and for its icon I'm gonna use icons outlined dot person to represent the user profile, and for the title I'm gonna use profile or profile screen or user profile screen. Next object, let's create a screen for notifications. Object notifications, and screen is the child of screen. It has a root of notifications, and it's gonna have an icon of icons.outlined.notifications. And notifications screen for its title. Okay, now we have created our 3 screens. Let's go back to our main activity. I closed the left part, and outside the main screen composable, I'm gonna create a list of screens. In fact, I'm gonna create a list and put in all the 3 screens that I have created. So val main screens list of, I create a list of those screens and then mention those screens here. Screen dot home, screen dot profile, and screen dot notifications. These are the 3 screens that we will use. And then in the bottom navigation, I'm gonna iterate over those 3 screens. So I say for screen in main screens, for every item in the list of my screens, create an option on the bottom navigation. So I create a bottom navigation item here, bottom navigation item, and as you can see, this composable has several parameters that we need to fill in, like selected and unclick. It also has icon as well as title, label in fact, and for selected, first we need to decide when the item will be considered selected. In fact, we need to consider and we need to think whether one item in the hierarchy, in our current hierarchy, is equal to the root of our screen. If the root of one of our items in the hierarchy is equal to the root of our current screen, then we consider that option or that screen to be our current screen. Therefore, it needs to be highlighted as the current screen. So here we need our current backstack entry to extract that information. Therefore, in the beginning of my bottom bar, I get the current backstack entry, and I need it as a state. Val current backstack entry, and I get it with delegate, and I extract it from my nav host controller. nc current backstack entry as state. This will give me the current backstack entry as state. And then I get the current destination from this variable, val current destination, current backstack entry dot destination. And because it's nullable, I need to use safety operator here. Current destination, now I have it, and then I say in the selected parameter, I say current backstack current destination dot hierarchy not any. I use the any function here because I know that hierarchy is a sequence, and any will allow me to check whether any of the items in this hierarchy or in this sequence are equal to the item that I will specify. If it's equal, then it will return true. So if I know that each one of these are a destination. In fact, if I hover with my mouse here, you can see that it's a sequence of nav destination, and each destination has a root. Therefore, I say it.root equals my current screen's root, screen.root. But as you can see, I have used safety operator here because these might be nullables. Current destination as well as hierarchy might be nullable. Therefore, for the value that we need here, it returns a boolean that is nullable, but we need a simple boolean type. To convert it to boolean, I simply make it equal to true. Like this. I compare it with true. and this solves the error that we were getting. After completing this part, I go to unclick part, and here is also very important. We decide where to go when the option is selected from the bottom navigation, and I use my nav controller to navigate to the screen's root. This is enough for a working bottom navigation. However, the navigate function has also some options like nav options builder. We can use this version of navigate, and there are some important information that we can specify for the system here. For example, when we are navigating to the specified route, we can pop up to the start destination in that hierarchy so that we don't return to previous screens that we don't need to return to. So pop up to, we need to get nc.graph navigation controller .graph.find start destination. I find the start destination and then specify its ID. This way I pop up to that destination. This means that I remove destinations before the start destination from the backstack. However, I save their state. This way, when I click an item on the bottom navigation and then I select the back button, then I go to the first destination in the bottom navigation, and I don't go to a very long path of routes that I need to press the back button again and again, because the unnecessary destinations have been removed from the backstack, and I will show you this in action, of course. And also, we want a single instance of the screen that is selected. So launch single top. We don't want to create multiple copies of the screen that we want to open. So I set it equal to true. And also, when we are going to a screen that was already open, we have previously visited that screen and we have saved its state, we can restore its state. This is also important. And the unclick part is done. Let's move to the icon part. In the icon part, I use an icon composable to represent the screen's icon, screen.icon, with a content description. I can specify the name of the parameter, but I skip it. For content description, I can simply use the title. And for the label, I'm gonna use a text composable, screen.title as its text. And then the last part, bottom navigation item, we created our bottom navigation, and I remove the lambda, the trailing lambda, and my bottom navigation is ready. Of course, it will not work yet because these destinations that we navigate to do not exist yet. Let's see what we have so far. I'm gonna run the application on the emulator. let's wait for the application to be built and launched on the emulator. Alright, as you can see, our application is running and we can see the options added to our bottom navigation. Of course, if we click it, our application will crash because the destinations do not exist yet. So, for example, I select user profile screen and it crashes. So let's go and complete our destinations by creating our composable navigations. Before that, I'm gonna shorten the items as titles that I have used. Those titles are a little bit long, so I go to my screen class and shorten them a little bit, the titles, because they are displayed in the bottom navigation. They would be better off to be short. And back to our scaffold. In the body of our scaffold, I'm going to create the composable destinations and the compose navigation. So there's a padding values passed to us here. So I pass it to the body of the scaffold, and then I'm gonna create my compose destinations here inside a nav host. Nav host for nav controller, I'm gonna use this nav controller. And for the graph, I'm gonna build a graph with lambda composable, because we haven't specified the start destination. I use it, start destination. For start destination, I'm gonna use the home screen's root. So screen.home.root will be my start destination, and that home screen will be part of my destinations, will be one of my destinations in fact. So screen.home.root here, and composable screen dot, the next one is profile, and then root, and then the next screen dot notifications dot root, and also we can use our padding values. As you can see, there's a modifier for our nav host, so I can use it. Modifier dot padding. I import modifier, I import padding, and I use the padding values that has been passed to us. And composable, for the first home screen, I'm gonna create a home screen. So home screen, and then profile screen, a notifications screen, and for the home screen I'm gonna create a composable named home screen. So I press Alt and Enter on it and select create composable function home screen. I do the same for profile screen and then for the notifications screen. And to make some simple screens, in fact, I'm gonna create a composable that creates some generic UI. I'm gonna name it placeholder, and it's gonna take a title, an icon, so title string, and icon image vector, as well as a content if required. So for the content, which will be an optional parameter of course, it's going to be composable type, and it's gonna be a lambda unit, and it's gonna be optional, so I add a default value of empty lambda. And then I'm gonna put them inside a column. I'm gonna display these options, the title and icon, inside the column. For the column I'm gonna use a modifier and fill max size, and I'm gonna use a horizontal alignment so that I center align all the items horizontally. Alignment dot center horizontally, and then I use a text composable to show the title, and then an icon to show the icon with the content description of title I can use, and then finally the content, if some content has been passed to us. As you can see, content is being used in a column scope, so I also specify that here so that I limit the options that can be used on the content. It's gonna be only usable in a column scope. So column scope dot parentheses, I import column scope so that the user knows where they are going to pass their content to. They are going to pass their content to a column scope. And for the text, the title, I'm gonna make it a little bit big. I can do that with modifier or with a style. Let's do that with style. Material theme typography dot h3 I'm gonna use with a text align of dot center. You might think that I'm doing these in vain. In fact, I'm going to save some time by creating only one screen and then using this placeholder for all of these screens, just with different parameters. And then for the icon, let's use a modifier with a modifier that I can use to increase the size of the icon. Modifier dot fill max size with a fraction of the screen size. So I'm gonna use 0.3f, fraction of the screen for the size of the icon. And then for the content, nothing, content is fine, but only for also for the text I can also use a padding modifier. That padding padding 16.depth will be fine. Alright, now let's use our placeholder to create the UI for our different screens. For our notifications screen, I'm going to use placeholder with the title of screen.notifications.title, and for its icon I'm going to use screen.notifications.icon. For profile screen I'm going to use placeholder with the title of screen.profile.title, and for its icon I'm going to use screen.profile.icon. And for the home screen I'm going to use placeholder with the title of screen.home.title and icon of screen.home.icon. Now all my destinations are ready and I can navigate to them by selecting an option on the bottom navigation. Let's run our application and see the output. Alright, as you can see, now we have our bottom navigation and also our default destination is being displayed in the content section of our scaffold. And because home screen is currently selected and we are currently in the home screen, it's being highlighted as the current destination. And if I go to profile, you can see that it becomes highlighted. Of course, the highlight might not be very significant, but still you can distinguish it from other available options on the bottom navigation. Notifications, profile, and home. Note that you can have subsections and sub-destinations for each of these options that you have in your bottom navigation. In fact, what I mean by that is that you can have destinations inside each of these destinations. And for that, I'm gonna assign you a work or an assignment to further explore the options that you can create and implement with bottom navigation. And using what I have told you in previous video about nested navigation and also what we talked about in this video, I want you now to create another option on the bottom navigation called more, and for it I want you to create two other destinations inside the more section, so that when the user selects the more option here, they see two buttons here, and when they select those two buttons they go to two other destinations. For the two buttons you can name them as you wish. For example, you can name one of them gallery and the other settings, and when the user selects each of those buttons they go to a relevant screen. For example, by selecting the gallery they go to a gallery screen. Of course, you can use placeholder to create them as well. I don't want you to create complex screens. Just I want you to explore and experiment a little bit more with the bottom navigation and compose navigation, and therefore you will add another option here called more, as I said, and when that is selected you will see a screen here that has two buttons, and those two buttons in turn go to two other screens. So that's it for bottom navigation and Compose navigation. I hope that you liked this video, and I see you in the assignment. Before there was Jetpack Compose navigation, we had the fragment-based navigation, and that was a system that was introduced a couple of years ago as a Jetpack library. And in this video, I'm going to talk about hybrid applications and how you can navigate between destinations in a hybrid application where you have both the fragment destinations and compose destinations, how you create navigation between those destinations. So let's get started by creating a new normal Android application in Android Studio. I open Android Studio and wait for the IDE to open up. I create a new project. It's a normal Android application, so empty activity. Press next. I'm gonna name it Fragment Compose Navigation, or simply Hybrid Navigation. And I'm gonna save it in the Compose course directory. I press finish and wait for the project to be created. Once our project is created, I'm gonna go ahead and enter presentation mode to have a better viewing experience for you. Enter presentation mode, and I'm gonna open the project explorer and add the dependencies for fragments and fragment navigation, in fact, to build.gradle in the app module. So implementation, Android X navigation, and navigation fragment KTX. We are working with Kotlin, and the latest version for this library is 2.4.0 alpha 10. You can check out the latest version on developer.android.com/jetpack Android X navigation and navigation UI KTX. Again, the same version, alpha 10. I press sync now to sync the project with these new dependencies. Alright, next I'm gonna add a fragment based destination and fragment based navigation graph. So I right click on the app module and select a new resource file, Android resource file. It will be a navigation resource file, so I name it my nav. You can name it whatever you like, as long as it is a valid name for resource. And then for its type, select navigation, press OK and wait for it to be added. And as you can see, we have a preview of our navigation graph. It doesn't have any destinations. I press this plus button to add some. And first, I create a new destination using a very simple fragment. I select fragment blank, and it's gonna be my home fragment, my default destination. So home fragment for its name, and press finish. Let's add some other destination. I'm gonna create a settings fragment, for example, its name settings fragment. Press finish. a third one. I'm gonna use, for example, a full screen fragment this time. Full screen fragment for its name is fine. Press finish. Okay, now that we have our fragments, let's add it to our navhost fragment. We need a navhost fragment, and we will add that navhost fragment to our main activity. So I open main activity, and you can see that it has used the layout named activity main. I open it by pressing Control and clicking on it. As you can see, it only has a simple text view, so I'm gonna replace it with a navhost fragment. Let's go to the design view, and from the palettes, I'm gonna add a fragment container view. You can find it under containers, fragment container view. I drag it and drop it on my layout file. It needs a fragment name, so I select a home fragment for now. You can select any of them, it doesn't matter. We will replace it with navhost fragment. So I go to the code view, and I'm gonna replace the fragment name with Android X dot navigation dot fragment dot nav host fragment. This will host my fragments. Okay, nav host fragment, and looks like it is not found. Let's see if we have added everything correctly. Build. Yes, fragment is wrong. I haven't used the correct spelling, so I go back to my build.gradle file and correct it. That was why we got that error here. What is fragment? Fragment. Okay, sync now. Okay, this time it resolved that library name, and back to our navhost fragment. We need to introduce the navigation graph for this fragment container view. So the nav graph, we specify it with app nav graph, is the navigation resource named myNav. And also this navhost fragment that we created needs to be the default navhost fragment of our application. So default navhost true, I make it true, and then we still get some errors, but I think we can ignore it. Is not constrained. Yes, because we have used it inside the constraint layout, we need to constrain it. Actually go to the split view or design view. Let's open up some space for us, and let's constrain it magically by pressing this band here, and top, bottom, left and right, I constrain it. And also for its width and height, I'm gonna specify 0 dp so that I can get the maximum width and height for it, like this. Back to my code. That's fine now, it should be fine. Activity main, okay. Next, we are going to open up the home fragment and do some changes over there and design some UI sections over there. So let's go to my home fragment by searching classes and then open home fragment. Here, when we create onCreate view, we need to have we need to access two buttons that will take us to the two other screens. but those buttons do not exist yet. So let's create them inside our fragment home layout file. So I open it, and inside this fragment I switch to the code view, and here I'm gonna add two buttons, wrap content for width and wrap content for height. For its ID I'm gonna specify settings. For the first button, let's give it some gravity as well. So layout gravity, top center. And another button, let's add another button, wrap content for width and wrap content for height. For its ID I'm gonna specify full screen. This will take us to the full screen fragment. And for its gravity, layout gravity, I'm gonna specify bottom center. And let's also get rid of this text view, we don't need it. And next I'm gonna go to the source code of my fragment, home fragment, and here, because we are using view binding and it has been enabled by default, we can check it from the build.gradle file. Yes, view binding is true as a build feature, so our life will be much easier now. I comment out the returning code that returns the view created using inflator, and instead I access a view binding feature. So val binding, I create a view binding, and I create fragment home binding dot inflate, and I pass it the inflator that I receive in this function. I import fragment home binding, and then I get access to the settings and full screen buttons. So settings dot set on click listener, and binding dot full screen dot set on click listener. Looks like the ID hasn't been given to it, so let's go to my other file. It actually has the full screen ID, so but it hasn't been terminated the button tag, so it should work now. Button dot binding dot full screen dot set on click listener, and then when the settings button is clicked, I will go and I will take the user to the settings screen or fragment. So find nav controller, navigate, and the ID of the fragment r.id. settings fragment settings. Let's see if it's correct. No, actually the fragment ID needs to be made sure of. So let's go to our list of fragments and check their IDs. I go to my nav. Okay, my navigation resource doesn't contain any fragments, so I need to create those fragments. I need to create some fragments as destinations. As you can see, I have settings fragment and full screen fragment. Let's specify them here. Settings fragment, and also the fragment full screen. And let's create one fragment for our home. It's actually there. I specify that it's the default fragment. But I think I already created this navigation graph. It wasn't showing it. Anyways, Anyway, I just set this as default, set as start destination. The home fragment needs to be our start destination, and back to our home fragment. From here we can now navigate to the settings fragment and find nav controller, navigate r.id.fullscreen fragment. When the full screen button is clicked, I go to the full screen fragment, and eventually let's return the view created by this view binding. So return binding.root. So we created our nav host fragment, we created our navigation graph, and we also added some logic to navigate from our home fragment to the two other fragments. Let's run our application and see the result. I press Shift F10 and wait for the AVD to open up and launch my application. Okay, as you can see, we are in our home screen, our home fragment, and our buttons do not have labels. So let's fix that by adding Android text, settings, and full screen. Let's apply the changes. There we go. Let's go to the settings fragment. Yes. Back. Full screen. Yes. So our navigation works in a traditional way, and you can see that we can navigate from one fragment to the other fragment, and yet we have not added our compose and any compose screen and compose capability to our application. What if we add compose and some compose screens, and we want to do navigation back and forth to a compose screen and to fragments? The general recommendation for such an application and for such a navigation is to wrap our compose screens in a fragment and then use the fragment-based navigation, because actually the compose navigation also uses under the hood the navigation library that was initially created using fragments. So we will stick to navigation using fragments and wrap any compose screen that we have inside a fragment. So I will show you how to do that. Let's first add our compose dependencies to our application. So I go to my build.gradle file by searching it. You can open up this search using Control Shift and N. If you are on Mac, it should be Command Shift and N. Build.gradle, and let's add compose, and I'm gonna specify the compose version here using a definition and CV for compose version, and then for its version 1.0.0, it should be 1.1, the latest alpha version of compose. You can check out the latest version on developer.android.com/jetpack, and alpha 5 it should be, and implementation androidx.compose.ui and UI compose version and implementation androidx.compose.ui and UI tooling compose version implementation androidx.compose.foundation compose version implementation androidx compose material and material compose version. I think we have added the bare minimum that we need for compose in our application. Let's next enable compose inside build features, compose true, and let's sync the changes. But first, let's open the build window from the tool windows so that we can see the successfulness of our sync. Yes, the sync was successful. Compose was added to our project. Next, I'm gonna go ahead and add a compose screen to my application. So on my package, I right click and select new Kotlin class or file. It's gonna be a file, so I'm gonna name it compose screen, or just screens I can name it. KT, it's a file I created, and now I create a composable by typing comp and pressing enter, and I'm gonna name it my compose screen. Actually, let's call it compose screen. It's gonna be a simple box. Let's add some modifier to it. Modifier, import modifier, and then fill max size. Let's give it some padding of 16 depth, import depth and padding. Let's give it some clip, rounded corner shape of 5 dp. Let's add it some border. For the border, let's specify the width 2 dp or 2 depth and a color of red, and then the rounded corner shape again with the size of 5 depth. And also let's give it a background color dot yellow, for example. Simple text inside it. Welcome to compose screen. For its style, let's use material theme dot typography dot h3, for example. And also, because we want to navigate from this compose screen to another fragment based destination, actually we can add a button here. Go to, for example, the settings screen. This button needs to have its text in its body. So text, go to settings. And for the onclick, we need to do something. I don't enter the code for now. I will tell you why later. But let's run our application. It doesn't show anything yet, any change so far. So as I said, when you add compose screen and you want to use it aligned with your fragment destinations, you need to wrap it inside a fragment. So I'm gonna create a new fragment and I'm gonna name it compose fragment. So let's head over to our navigation file by pressing Control and Alt, Control and Tab to switch between files. And then I'm going to create a new fragment as a new destination. Create new destination. It's going to be a simple fragment again. For its name, I'm going to use Compose Fragment. I press Finish and wait for it to be created. Yes, Compose Fragment. I open its code by searching for the class, Control N and Compose Fragment. And here in the onCreate view, first I'm gonna comment out the return code, and I'm gonna use again val binding. Actually, because we want to wrap our compose here, I'm gonna use compose view. I'm gonna return a compose view. So compose view actually is a function from Jetpack Compose that allows you to use your compose based UI inside the traditional view system. So I'm gonna pass it a require context. This gives it a context that is used in Android views, and then I'm gonna use apply to create the UI that I want, and then return it. Apply, set content, and inside set content I'm gonna use my compose UI and call my compose UI. My compose UI, as you saw, its name is compose screen, so I call it here compose screen. And in order to be able to navigate to this destination, I'm gonna add a third button to my home fragment. So let's go to my home fragment and add a third button. Wrap content, ID. For its ID, let's use compose, and let's use a text for it. Android text. For its text, let's say compose screen. And for its gravity, let's align it in the center of the screen. So Android layout gravity center. And what does happen when the user clicks this? We need to add the logic for it to perform the navigation. So we need to go to the home fragment class, home fragment, and here, in addition to settings and full screen buttons, we need to add the logic for binding dot compose button, and then set on click listener for it. When that happens, find nav controller. We navigate to r.id dot compose fragment. That's the ID of the fragment, and you can find that ID in our navigation file. Again, Control Tab, and if you switch to the code view, you can see that any one of these fragments have an ID: full screen, settings fragment, home fragment, and compose fragment. And we use these IDs to navigate to the fragment destinations. Let's run our application and see the result. So we had a failure. This version of Compose compiler requires Kotlin version 1.4.32, but you appear to be using 1.5.31. So let's use 1.4.32 to suppress this message. Build.gradle file. Sorry, it needs to be the build.gradle of the project 1.4.32. Sync the changes, and hopefully it will be solved. Let's run the application, Shift F10. Okay, a third button was added, compose screen, and we should be able to navigate to our Compose screen by clicking this button. Compose screen, yes, it is working. Compose screen, and we have a button over there then that we need to use it to go to the settings screen, to a fragment destination. If we click it, it doesn't work because we haven't added any logic to it. So far you can see that navigating from a fragment to a Compose screen is simple as long as you wrap your UI, your Compose UI, inside a normal fragment, and in that case it's very easy to navigate to a Compose UI. But what if we want to navigate from a Compose destination to a fragment destination? I'm gonna tell you how to do it next. So let's go to the definition of our Compose UI. It's in my screens file, and here we use the principle of state hoisting for that. And actually we hoist, or we lift the destination that we want for the responsible fragment so that it knows where to go and how to perform the navigation. We just bubble up the destination that we want to go in our Compose screen or in our composable, and then the fragment in charge knows how to perform the navigation. We don't need to be concerned about the navigation ourselves as long as we are inside our Compose screen. We just bubble up the destination that we want, and then the fragment decides to perform the navigation. The way we do it is by adding a new parameter to our composable called onNavigate. You can name it whatever you want, but onNavigate is a good name, appropriate for this use case. And what it does, it takes a resource ID, the ID of the destination that we want to go to, and then we actually return nothing. We just receive an integer. This onNavigate just has an integer as an input parameter, and then it passes this onNavigate to the calling fragment, and that fragment knows how to perform the navigation. Before we go any further, let's add a alignment for our button using modifier.align, so that we can center this button or align it off our text. So alignment dot bottom center, for example. And in the logic for our button, when the button is clicked, we say call onNavigate and pass it the destination that we want, r.id.settings, like this. We are not performing the navigation ourselves. We are just using the function that has been given to us, the lambda that that has been passed to us, and we are giving it the ID of the resource, the ID of the destination that we want to go to. So this way we can ask the fragment, we can let the fragment decide how to do the navigation. So our fragment in charge that wraps around the Compose screen is called Compose fragment. So let's open Compose fragment, and when we call Compose screen, we need to also call the onNavigate. We need to provide onNavigate. So for onNavigate, here's where we write its code, and because we are inside the fragment here, we can say find nav controller and go to the destination. So because this is the latest parameter of this function, I can take it out of parentheses like this, and then I can say on navigate. Actually, on navigate was the name of it. So what I'm gonna do, I know that this lambda receives an integer, so I say find nav controller and then navigate to the destination that has been given to us. So destination has been given to us. Okay, let's use the destination. So you can see that this fragment performs the navigation based on the resource ID that has been given to us inside the lambda, and that destination was given to us by the compose screen that was creating the UI for this screen. So this is the way we created link between compose navigation, between a compose screen and a fragment destination. Finally, let's remove the parentheses for this composable because we are not using it, so we can get rid of it. And let's try our application in action. Shift F10, let's run it. You can also run it from the menu, run and run app. Okay, our application is running, compose screen. Let's use the button to go to the fragment destination, go to settings. It failed. Why? Let's check out for the errors. View, tool windows, and logcat. We need to open the logcat. So the problem seems to be the fact that we don't have an action from our compose fragment to our settings fragment. We can fix that by going to our navigation graph, the design view, and adding an action from our compose fragment to our settings fragment. Like this, and hopefully this will solve our problem. Compose screen, go to settings. No, yet we still have the problem. So to fix that, actually I'm gonna add another screen. I'm gonna create a fragment, a new fragment, and navigate to that fragment for now. Create a new destination, and I create a simple fragment. I name it profile fragment. Like this. And in my compose fragment, I'm gonna navigate to that fragment. Compose fragment. Inside my compose screen. Oh gosh, in on navigate I have used a very wrong ID. This ID is ID of the button settings. It needs to be settings fragment. So the problem was with the wrong ID. Let's run it again. We can go to the settings fragment now. Again, the version was reverted to 1531. Let's fix that again. I don't know why that happened. 1432. Sync now. Looks like Android Studio loves to automatically update the Kotlin version to the latest version. Let's run it again. Let's go to compose screen, and then from compose screen to our settings screen. There we go. You can see that it is working. Back to our home fragment, and also we can go to the other screen, to the other fragment from our compose screen. So in our screens, I can change this destination to profile fragment, and run the application again. I can navigate to any fragment that I have in my navigation graph as long as that fragment is available there. Compose screen. This time let's go to the profile fragment. There we go. So that's it, basically how you create destination navigation and navigation between different parts of your application in a hybrid application where you have both compose screens and fragment destinations. And this is the recommended way. There might be other alternatives, but I recommend that you stick to this method. You wrap your compose screens around with some fragments, and then you navigate between those fragments easily using the fragment API, using the fragment-based navigation API. So that's it for this video. The only thing that I want to emphasize a little bit again before I wrap up this video is how we created a bubbling mechanism, a lifting mechanism, or hoisting mechanism to notify our hosting fragment when we are inside our Compose UI about the destination that we want to go to. We pass our destination of choice to the lambda that is passed to us, and that lambda then takes it to the hosting fragment or to the wrapping fragment, and that wrapping fragment then decides how to perform that navigation. And because it is in the context that it has access to the fragment based navigation, it can simply call find nav controller and then navigate to the destination that we have selected in our Compose UI. So that's it for this video. I hope that you enjoyed it, and thanks for watching. In the transitions that we have used so far, we didn't have any special animation when we moved around the screens, when we moved between different screens. So in this video, I'm going to show you how you can add animation and transition to the movement between your screens in your Jetpack Compose navigation application. So as you can see, I already have created an application, but it doesn't have the transition APIs and the transition capabilities that we expect. So you can see that the transitions that are by default implemented in it are very simple. It's a very simple fade where the previous screen is faded out and the new screen is faded in, but it's very simple. We are looking for something more customizable. I will show you how you can add customizable transitions to your screens in this video. So the first step is to know what libraries we need to add and what dependencies we need to add. Note that the navigation library currently doesn't have these animations that we expect to use. So because animation APIs that can help us do this are experimental, we need to use another library that is called Accompanist, which allows us to use experimental animation APIs that are not yet available for us in the navigation library. So the first step will be adding the Accompanist library. I will go to my build.gradle file in the app module and add the dependency for Accompanist. Implementation com.google.accompanist and Accompanist, the artifact for navigation animation, Accompanist navigation animation, and the latest version is 0.20.0. And to make sure that you are using the latest version, you can actually check its page on GitHub by opening your browser and going to github.com/github.com Google accompanist. This is the page for the accompanist library. As you can see, it has several different libraries from which we need to use navigation animation. If you open it, you see the dependency that you need to add in order for your application to take advantage of this library, accompanist navigation animation, and the latest version is 0.20. So back to Android Studio, I press sync now. Okay, now that this library has been added to our application, I also make sure that I'm using the latest version of Compose. That supposedly is true. I'm already doing that, yes. So I go to main activity and start going through a couple of to-dos that I have created for your convenience. You can follow these to-dos and do what they tell you to do, and then you have transitions added to your application. After that, you can easily customize your transitions for your screens by following the APIs and the documentation for the APIs that are available for the new API that you add to your main activity. So the first step, to do 1, replace remember nav controller with remember animated nav controller. Let's do that. Remember animated nav controller. It's from the accompanist library, and there's a warning from Android Studio telling us this is experimental animation API, so we need to add annotation for it to this composable. I add it, and then I remove the to-do after performing what needed to be done, and I go to step 2, which is to do 2, replace with animated nav host. Replacing our nav host with animated nav host. Let's import it from the accompanist library. I remove to do 2 and go to do 3. To do 3 tells us to replace our composable with composable from the accompanist library. So I type composable again. Hopefully it will help me import it again, this time from the other package. So to make sure that I'm importing it from the accompanist package, I'm going to comment out the package that is already imported for this composable. So I go to my list of imports and I comment out this line, Android X navigation.compose, which also includes that composable that I showed you. And I go back to that line, and here to do 3, replace it with composable. So I import composable this time from the accompanist library. As you can see, the first option is from the accompanist library, so I import it. You can see that the names are identical, but the functionality will be different. This composable has option to add customizable transitions, This composable has the option to add transitions. So I remove to do 3. We are done with it. Let's go to do 4. Replace navigation with navigation from the accompanist navigation library. So I have comment out also navigation by commenting out the parent package for this composable. So this time I imported from the accompanist library. The first option is from accompanist, so I select it, and now all my to-dos are done, and I have added navigation to my navigation animation to my application. But now it will not have any transitions yet, because although I have added the foundation for transition and the libraries needed for the transition to work, I haven't specified any transitions, so it will not work naturally. Also, there are some warnings yet, because these APIs that I added are experimental. We need to add the experimental animation API annotation to any composable or function that is using it. So Alt enter here, and experimental animation API added to onCreate. Also, we need to import current backstack entry as a state from the compose package. This error was caused by commenting out that line from our list of imports earlier. So now I have added transition to my application. The next step, and the more interesting part of this video, is where we define our transitions for our nav host. We start going through the different arguments that are available for our animated nav host. So the first parameter is nav controller. The second is start destination. I add a comma and then press Ctrl P. As you can see, there are a list of different parameters, but this time they look a little bit different from what we used to know about nav host. We also have transition related parameters like enter transition, exit transition, also pop exit transition, and pop enter transition. Pop enter transition, in fact, let's start with enter transition. Enter transition is the transition that runs when you enter a screen. Exit transition is the transition that runs when you leave a screen. And pop enter transition is the transition that happens when you press the back button and therefore you leave a screen. And pop exit transition, pop enter transition is the transition that runs when you press the back button and you leave a screen. And pop enter transition is the transition that runs when you press the back button and therefore you pop one item off your backstack and you enter a new screen, and that transition runs at that time. So let's specify these parameters. First, enter transition. Enter transition takes in two parameters, initial and target nav backstack entry. I specify them, but I will not use them here. These are the parameters passed to our lambda. However, we are not going to use them for now. For enter transition, I need to return an enter transition. There are a couple of different functions that return an enter transition. For example, slide in horizontally, and slide in horizontally allows us to slide in a horizontal manner from the left or from the right. In order to enter the scene, I'm going to enter the new screen from the left. Therefore, I'm gonna specify the initial offset for it. As you can see, the first parameter is initial offset, and it takes a lambda. Initial offset x, of course. It takes a lambda. It has a lambda which takes the full width as input parameter, and then we can use that full width to say where our initial offset x is. Because I'm going to slide the screen from the left, I'm gonna specify initial offset x as minus width, like this. And then I'm gonna specify the animation spec also, for which I'm gonna use a simple tween animation with a duration of 1 second, imported from the animation core package, importing tween. And that's it for our enter transition. Now exit transition. When we enter a new screen, the previous screen, the already present screen, moves out. I'm gonna move it out with a slide from the right. So again, I'm gonna use a slide transition. Let's also pass it the initial and target backstack entries and slide out horizontally, because this will be sliding out the present screen. And again, it has some parameters, target offset x this time, which specifies its target offset. To that offset we will move, and it takes full width as parameter. I'm gonna move it up to width, which means the offset, which is already 0, will move to that point, to the end of the width of the screen. So this means that the current screen will move out. And then the animation spec parameter tween with a duration of 1 second. And that's it. This will give us a very simple and nice transition for all our screens. Because it is defined in the root navigation graph, it will be used for all of our screens. And you noticed that I didn't use any value for pop enter transition and pop exit transition parameters. The reason is that pop enter transition by default use the enter transition that we have defined here, and the pop exit transition by default uses the value that we have used for exit transition. So let's run the application with these changes and see what transition we have for our different screens. Alright, by default we are in home. We go to the card screen. There we go. I go to favorites, nice, and more. You can see that by default all the screens are using these enter and exit transitions that we have used in our root navigation graph. So let's get back to our navigation graph and enter some new transitions for our pop enter and pop exit transitions. First, pop exit transition. Again, it takes initial and target parameters that are backstack entries, and let's also define pop enter transition with the same parameters, and start completing pop exit transition. Pop exit transition uses exit transition. It needs an exit transition type. So we can use any transition, any function that returns an exit transition. Because we are popping off the backstack when we press the back button, I'm gonna move the screen that I have and shrink it. The screen that needs to be exited, I'm going to shrink it. So I'm gonna use a shrink transition. Shrink out, and you can see that it has some parameters. Shrink toward, shrink it to, its type is alignment, and I'm gonna use alignment.center. And some other parameters, target size. It takes a lambda, it has a lambda that takes the full size, and then we decide which size to finish at. In fact, you can see that it shrinks down to 0. It completely disappears, but I'm going to actually change it to int size of 0. The width will be 0, but the height is going to be equal to the height of the screen. So size.height. And also let's specify its animation specification. So animation spec, let's use a tween with 1 second of duration, and pop enter transition. For pop enter transition, I'm going to actually move the new screen inside the visible area from the bottom. So I can move the slide, or a variant of it, slide in to container, for example. And for towards parameter, I'm going to use slide direction dot up. Let's import it, and then we have animation specification, animation spec, tween, like this, and with a duration of 1000 milliseconds or 1 second. And because I want this animation to happen after the exit transition, after the pop exit transition, first the current screen needs to be shrunk out, and the new screen then needs to be slided in. I'm going to add some delay, some initial delay to when this animation starts. So tween, for its delay, I'm gonna use 300 milliseconds, and this 300 milliseconds is the duration of the previous exit transition, the pop exit transition. 300 milliseconds should be enough for the pop exit transition. Let's run the application and see the changes. Let's move to a screen like cart, and then pop enter, pop exit. I move one item off the back stack by pressing the back button. There we go. I go to favorites and do this. There we go. You can see that the existing screen is shrunk out and the new screen comes in from the bottom of the screen. Back button. There we go. So we were able to add some different transitions to our route navigation graph by adding them to our animated nav host, and therefore it works for all of our screens. But it is more capable than this. Actually, we can check the initial and target backstack entries and then decide which animation we want to use. For example, for our enter transition, in fact, we can check the value of initial and target backstack entries. Initial meaning the screen from which you are coming, and target meaning the screen to which you are going. And here I can check for these values, initial and target. We are interested in target because we are going to a screen, we are entering a screen. And for example, we can decide if we are going to the favorites screen, we can have a different enter transition. So here I check for it. I say when t dot destination dot route, when it is equal to screen dot favorites dot route, then I'm gonna use a different slide transition or any other enter transition. Otherwise, I'm gonna use this transition. So I copy this line, which is the transition for the default screens, and before that I need to define my transition for this screen. So let's use a simple enter transition here, and to see your list of different transitions you can actually go to the file where these enter exit transitions are defined. You can see the different functions that are available: slide out vertically and many other functions that are available and defined. So here I use, for example, simple fade in for this screen, and else I use the transition that I have already copied. Let's change fade in to something more interesting. For example, slide in vertically, and this time let's slide it from the top of the screen. So slide in vertically, initial offset y, one of its parameters, initial offset y, specifying its initial offset, so it takes the full height, and then we decide what value to return. Because I'm going to enter the screen from the top, I'm going to use minus height. And then we have the animation spec parameter, animation spec, for which I'm gonna use a spring animation. Let's import spring. There we go. I'm gonna use a damping ratio different from the default value. So damping ratio spring dot damping ratio medium bouncy, and leave other options to the default. Let's run the app. You will notice the difference this time we have for the favorite screen when we move to it, because we have conditionally defined a different animation for it. Favorites, there we go. You can see that it is entering to the screen from the top. There we go. But for its exit, but for other types of screens, for other screens, we are still using sliding horizontally. You can see that we are sliding in horizontally. We are only doing it different for our favorites. All right. In addition to defining your transitions for your root navigation graph, you can also define them for your sub navigation that are defined using the navigation function under your root navigation hierarchy. So here I can define my transitions for the more screen and the screens that are available inside it. For example, for the email screen that I have here. So I define enter transition and exit transition for them, and enter transition, I define it with lambda similar to what we defined in our root navigation graph, and pass it initial and target backstack entries. This time let's use some different transitions. Let's, for example, use fade in. Let's fade in with an initial alpha of 0, which is the default, so I don't change it, and an animation spec of tween. 1 second. And fade out for its exit transition with an animation spec of tween with a duration of 1 second again. So when we exit a screen, under that destination, under the more sub navigation or nested navigation, we will use this transition, the fade out, and when we enter a screen, we will use the fade in transition. So let's run the app. Okay, let's go to more. There we go. You can see that the enter transition was a fade in, and we already saw that. And if we go to the email screen, the current screen is faded out and the new screen is faded in. If we press the back button, which means a pop exit transition, it will use this exit transition, which is a fade out. There we go. You can see it's fade, and this website button, of course, is running and launching the system browser, so it might not be the exact transition that we expect. Yes, it launches an external browser to open up the website that we have defined in our code here. So You saw that we defined enter exit transition, pop enter, pop exit transition for our route navigation graph and also for our nested navigation. And the interesting part is that you can mix and match to your liking, and for your different needs in your application. You can even, in addition to what I said already, you can even define specific transitions for different destinations. So for example, for cart, I have the option to define a different screen transition. So I go to my composable that is defining the cart destination, and for it I'm going to use a different enter and exit transition, or simply just I'm going to use a different enter transition. You can see that the transition related parameters are available for our destinations in the navigation graph as well. So enter transition, exit transition, pop enter transition, and pop exit transition. I'm only going to deal with enter transition here to show you that it is very customizable and flexible. It takes initial and target parameters again. Here I can use different transitions for enter, exit, pop enter, and pop exit transition for this destination. But I can also define conditionally what transitions I can have. For example, I'm going to customize the enter transition for cart destination in my navigation graph, and I can say if I'm coming from home to this destination, then use this enter transition that I specify, otherwise use the defaults. So I specify that using this. I say when I.destination, which means if the initial destination, if the initial backstack entry, the previous screen from which I'm coming, when I dot destination dot route destination, if it is home, so screen dot home dot route, then use, for example, a simple slide in to container, and otherwise else use the defaults. Using null here means stick to the defaults and use the defaults learned from your root and parent navigation graph, which means use the defaults and the transitions that have been defined for your parent. The parent is this animated nav host. So in other cases, the value defined for enter transition for the animated nav host will be used. So let's specify the different options for slide into container. For example, in fact, let's use expand here to make some difference. Expand in, and expand is has some parameters. Expand from, I'm gonna expand it from the center. So alignment dot center hopefully will help me achieve that. And initial size, I'm gonna start it from full size and return this size as initial size. In size with a width of 0, size 0 and size.height as the initial height, like this. And the next parameter is our animation spec. I think a spring animation will be fine here. Spring animation with a damping ratio of medium. Spring dot damping ratio medium bouncy. So if we are coming from home to cart, we will have this transition. Otherwise, we will use the defaults. It's very nice. Let's run the app. We are at home. If we go to favorites, it's like before. If we go to cart, this is what interests us here. It's not what we expected. In fact, initial, if you are coming from home, we should have a different transition here. Yes, let's go home and come from home to cart. Yes, I think it's working. The initial screen is the screen for cart is expanded in. In fact, with a tween we can see that better. So I'm going to swap spring with a tween with a duration of 1000 milliseconds to help us see that animation better. We are at home. Let's move to cart. Yeah, it's kind of, because it is mixing with the exit transition from home. It's not that beautiful, but we can see that it is working and it is using the expand transition for it. In fact, to help this transition look better, we can go to our home destination and define the exit transition to match with the enter transition of cart. So I go to my home screen and here define exit transition. It has all other transition related parameters available, but I'm interested in exit transition. I pass it I and T, initial and target parameters, and define and say if the target is cart, then do this. When t.destination.route is equal to home to screen.cart.route, then use the transition I'm telling you. Because it was an expand for the cart, I'm going to make this a shrink. So shrink vertically. Let's shrink it vertically, and then the new screen will expand horizontally. So let's make it a shrink vertically this time, and you can see that it has shrink towards parameter. I'm gonna shrink it down to the bottom, so I can say alignment dot bottom. It's in fact the default value, so we even didn't need to use it. And target height, let's specify the target height. It takes the full height and returns 0. Nice. Default value is also 0, but we can return it anyway. And I return 0 because I want to shrink it vertically. And then we have animation spec, for which I use tween. Let's use a smaller tween, like for example 300 milliseconds, and also add a delay to the other enter transition so that after this exit transition finishes, we can have the other transition show itself. So I'm gonna add a delay of 300 milliseconds to this transition, to my enter transition of cart. So when I am at this destination, when my target screen is cart, I use this transition for home. Otherwise, I use the defaults. By returning null, I'm telling the API to use the defaults, which are inherited from the root navigation graph. Hopefully this will fix our issue that we already had. We are at home. Let's leave home and go to the target of cart. There we go. You can see that the existing screen, which was home, was shrunk out. It was shrunk vertically, and then we moved to the new screen. Let's run it again. We are at home. Yes, it is shrunk vertically, and then the new screen comes in to the visible area. There we go. Shrink and expand. Alright, so in this video you learned how to use the transition APIs for navigation by adding the Accompanies library to your application. Because the experimental animation APIs are used in Accompanies, we are able to use transitions in our screens in our current navigation library, but in future these animations will likely be added to the navigation library itself, so we will not need to add Accompanies in future. But for now, we are taking advantage of the transition APIs by using the Accompanies library. And also you learned what changes you need to make to your application, to your navigation code, in order to have these transitions by following the to-dos that I showed you. And then you learned how to add transitions to your navigation graph, add default transitions, and also add transitions to your sub navigation or your nested navigation, and also to your individual destinations. You learned how to define those transitions and mix and match. You learned about different functions that are available for creating enter and exit transitions. And that's it for transition and navigation transitions in Jetpack Compose. I hope that you liked this video. In this video, I will give you some general recommendations on how to make your navigation code testable. So, in order to show that, I have one of my applications created in one of the previous videos of this section. As you can see, we have a selection screen composable in which we select some parameters for our image of choice, enter some caption for it, and then go to another screen to see those information. As you can see here, for selection screen composable, we are passing our nav controller. The first principle you need to know about making your composables and making your navigation code testable is that you need to pass only the parameters that you need to your composable. The second principle is that you should never pass your nav controller to a composable. This means that what we see here is not good for testing. We need to change this. instead of passing our nav controller directly to our composable, we need to pass in some lambda that will be invoked, and once it is invoked, it allows us to change our navigation code and to perform the navigation here instead of doing it inside the body of our composable. Currently we are doing the navigation inside the body of our composable. As you can see here, we have received our nav controller inside the body of selection screen, and the button directly performs the logic for navigation. It navigates to the show route. And there's another button that performs the navigation to another route called greet. In order to change this, I'm gonna define a lambda instead of the current parameter that it has. The current parameter is the nav controller, so I'm gonna remove that, and instead I'm gonna create a lambda on navigate. This lambda will take a parameter. Its type is string here because our route types and our route names are string, as you can see. Therefore, we will receive a string. We will pass a string to our lambda, and it doesn't return anything, unit. And once we have this parameter, we don't need to worry anymore about how to perform the navigation inside the body of our composable here. So the button's logic here changes from what we have currently to on navigate, and then the parameter that it is already passing, we copy that parameter and pass it to on navigate. We are just passing it to the lambda so that the caller knows what to do with it. We are only surfacing up this parameter. We are not performing the navigation ourselves. And we do that same thing with the second button in our selection screen. I comment out the current line that directly performed the navigation and instead call on navigate, and I pass in the parameter that it was using to perform the navigation. So now this composable is much better because it is not concerned about performing the navigation itself. It is much testable, much more testable than what it was before. So the principle that you need to use, as you saw, is using a lambda instead of your nav controller for your composable of choice, for your destination composable. Also, once we change this signature for this composable, we need to make some changes in how we call it. Currently, we are calling it in the body of one of our navigation graph nodes. As you can see, our home route was calling selection screen and it was passing nav controller. This will change because we are not passing nav controller anymore. It doesn't accept nav controller anymore. This time it is actually calling on, it is using on navigate. And you know that on navigate now takes in the route string as a parameter so that we can perform the navigation here. So because I have nav controller here and I have access to it, now I can perform the navigation right here. So I say nav controller, navigate, route. Just as simple as that. You see that it's very simple. Let's run it. See if it works. Okay, let's change some parameters like scale and enter some description. There we go. You see that the behavior is not changed. However, the principle that we used allows us to have a testable composable. So the principle that you need to use to make your composables testable is very simple. By following this principle, you can make your navigation code testable. We only pass the parameters that we need to our composable of choice, to our destination composable, and that composable invoked this lambda, and inside the body of the composable function and the lambda we added some minimal logic to perform the navigation for us. Although it's very simple, it's very effective and it's necessary in order to have testable navigation code. So that's it for this video. I hope that you enjoyed it. Hello and welcome to a new section of the course. In this section you will learn how to add Compose UI to existing Android views, or vice versa, add Android views to your Compose UI. Also, I will teach you how to reuse your existing Android view themes for your Compose UI. In this video, I want to show you how to add an Android view to a Compose UI structure. So let's get started by opening Android Studio and creating a new application in Android Studio. I create a new project. It should be a Compose project, empty Compose activity. I select and then next. Because I'm going to integrate an OSM map view to my Compose application, I'm gonna name this OSM map, and the package name is fine. Save location, I'm gonna change it to Compose course, where I store the source code for this project, for this course, and then I press finish and wait for the project to be created. Okay, my project is ready. As the first step, go to Build Scripts. I open the app modules build script, and I add the dependency for OpenStreetMaps or OSM. And the library that I'm gonna use to add that functionality is called OSM Droid. Implementation org.osmdroid. The artifact name is called OSMDroid, and the version is 6.1.1. The latest version is this. And I press sync now and wait for the project to be synced. Let's see if the project was actually successful. To find the artifact, so tool windows and build. Yes. No, actually it failed to find it. To make sure what the latest version is, I open my browser and search for GitHub OSM Droid. I open the project's page on GitHub, and as you can see, the latest version is 6.1.11. Let's go to the releases section. Yes, it's 6.1.11. So we correct this version, and the artifact name, let's make sure we are using the correct one. Org OSM Droid Android. Also make sure that you have Maven Central added to your main build.gradle file. This new version of Android Studio is using another mechanism. It's not adding the list of repositories to the build.gradle file. So hopefully it has Maven Central already configured. So let's press sync now and wait for the project to be synced. Alright, yes, it was successful. So once the library has been added, the native library has been added to our project, I go to my main activity, and here I'm going to add my map UI. So I create a new composable for that, and I'm gonna name it map UI, and here is where I'm going to add my map. And this map is not using Compose, it's using Android views, so we need a mechanism to integrate this view-based UI to our Compose UI. So what I do is using this composable, Android view. And this enables us to perform interoperability between Android views and Compose. And first of all, it requires a factory. Factory is where you create your Android view, and it receives a context inside this lambda as parameter, so we are free to use that context to construct our view. So because map views are created using a context, and I have access to context, I can create it here. Map view, and I pass it the context, and it's created. Next part is the update parameter. The update parameter is called when something changes that requires recomposition, and we can set the required changes, we can apply required changes to our view object. So here it is a lambda we have, it's a map view that we have constructed it in the factory section, and here we can apply the changes that we might want to apply to it. For example, inside this block, I'm going to set its tile source where it can fetch its data and its tiles for the map. So set tile source, and the tile source that I'm gonna use is tile source factory.mapnik, one of the famous sources for tile source that I can provide to my map view. So now that I have applied it, I know that it will load the tiles from this source and it will display it for me. I might need to make some other changes to my map view, so instead of directly calling set tile source, I'm gonna say it or map view. Instead of this, I'm gonna use map view and then say apply, and make these changes inside the apply block. So this is for our map view for now. Let's go to the rest of our UI that we want to create. What I'm planning to do is to create a UI structure, a compose UI structure, where I will integrate my map UI. So I'm gonna name it fun screen or fun UI, and inside it I'm gonna have a column like this. Let's actually give it maximum size, fill max size, and then I'm gonna include my map view as well as some other changes. For example, I'm gonna create a selection row where the user can select which city they want to go and they want to navigate to on the map. So first of all, I'm gonna place a selection row here, selection UI, and this selection UI is a composable I'm gonna create next. And following selection UI, I'm gonna include map UI, because map UI will be displayed after selection UI. Let's create selection UI now. Selection UI. So what does selection UI do? It requires a label inside a row, of course, modifier, fill max width, of course, and inside this row I'm gonna use a label, text, string resource, r.string dot select region from drop down. I create a corresponding resource, string resource here, select a region to from the drop down, and following my text I'm gonna create a drop down. I'm gonna create a drop down menu. It's a UI from the material design library in Jetpack Compose. So it requires a expanded variable and some values for undismissed request, and also its content. So first let's create a state for its expanded parameter. Var expanded equals or by, remember, mutable state of false. First it is false. This is a delegate, so let's import get value and set value as well by pressing Alt and Enter, and then let's put our drop down menu inside a box so that the user can press the box in order to open the drop down menu. Box like this, import box, modifier, some modifier that I might want to use later, and let's actually use it now. For the box I'm gonna set a half weight, and I'm gonna give the label also a half weight, modifier dot weight 1F. I'm going both of them equal weights so that they occupy half of the available width inside the row. So I'm gonna pass this expanded variable, the state that I created, to expand it, and then I'm going to make some changes and add some variables and add some content inside the body of my drop down menu. I'm gonna add 3 states or 3 municipalities inside the drop down to enable user to select them and go to those cities on the map. So I'm gonna create a variable outside the composable, something like a global variable, and I'm gonna name it val cities or municipalities. Map of, I select the third form so that I can create an arbitrary number of municipalities, and this is going to be a pair, a Kotlin pair. So first of all, let's consider some municipalities from the California state. I'm gonna start with Los Angeles. Actually, let's start with San Diego. San Diego. And for the second part of the pair, for the second parameter, I'm gonna pass its geopoint, the geographical point that determines its coordinates on the map. So I import geopoint, and I have already prepared these values. It's 32.716144, the double values, and the second coordinate is minus 11716 2942, and the next one is, let's use San Francisco, and its geopoints are 37779379, and the next coordinate is minus 122 418433. The next pair is for San Jose, and it is 9.9445591, and the next coordinate minus 8 for 1152506. Now we have 3 municipalities. This is supposed to be a pair, a geopoint, sorry, and now it's fixed. Now I can use my municipalities here. I can say for item in municipalities, let's create 1 item each. So I can use a box here, or I can simply use a text box. But the important thing is that you should use drop down menu item composable. It has already some capabilities that makes it easier to communicate with your drop down menu API. So drop down menu item, it has, for example, the onClick parameter that allows you to invoke an event. So before completing that, let's first add the items. I'm gonna use a text box for the item, a text, and I'm gonna use the item's value. Sorry, the item's key, because the item's key is the municipality's name. So that's what I'm interested in seeing inside the drop-down menu. And when the onClick is invoked, I'm gonna say I want this navigation to be performed. And instead of doing the navigation here myself, note that we don't have access to the map view ourselves here. So we have to hoist this. We have to fire this event up and ask our parent to do that. So in order to be able to do this successfully, I'm gonna add a parameter as an input parameter to selection UI, and I'm gonna name it on navigate or on show on map, something like this. And it's gonna be lambda, and it's going to receive a geopoint, and therefore once I have this signature, I am allowed to call on show map aligned with the on show on map, of course, passing along my selected coordinates. My selected coordinates is item dot value, because it determines and shows the coordinates of the selected municipality. So let's complete our drop-down menu. First of all, the drop-down menu should be closed. How do we specify that? It is first closed, but when the box is clicked, it should open up. So I add a clickable to the box, a clickable modifier, I import it, and then I say, sorry, inside the box I have another better way to do this. I add an icon button, and inside the icon button I add an icon with the icon of menu, icons default dot menu, with a null description. And when this icon button is clicked, I'm gonna open the drop down. I do that by setting expanded to true. And when the onDismiss request is called, which means when I click with my mouse or I press outside the area of the drop down should be collapsed. So the value for expanded should be changed to false again, like this. So I have my row. Inside the row I have my label, and then let's also not forget to add some padding to our label, 8 dp for example. And then we have a box. Inside the box we have an icon button and our drop down menu. This combination allows us to open and manage the opening and selection of drop down menu items, and then we tell our parent, our caller, which geopoint has been selected to be displayed on the map. Next, I will show you how to use the value passed to our parent. So, selection UI. selection UI is called, we have to pass in the event that is supposed to be fired here. So on selection, on show, on map, we receive the point here, the due point. We have to do something with it. So first of all, we can pass to our map view some arbitrary due point. For example, I can define a new signature for map view. I can change its signature to accept some parameter, show, or instead of passing lambda, I'm gonna pass some points to show. So coordinates is gonna be a due point. So we will pass a due point here, but let's go add these definitions, this new signature to map view itself. So coordinates, this coordinates type should be due point, and once we receive it, we know what to do with it. For example, I get a controller here, a map view controller like this, val controller, and I receive it from this dot controller, or simply controller. And controller allows me to navigate to an arbitrary point on the map view. So I say controller set center, or animate to. This is more beautiful. This goes to the selected due point with an animation, with a smooth animation. So I pass in coordinates to it, and it performs the navigation to that point. Also, let's add a reasonable amount of zoom. So set zoom, 11 should be fine. Zoom level is double, so 11.0, and that's it for our map view. And let's now complete our fun UI. Inside the fun UI, we need to pass in the selected coordinates to map UI. So I'm gonna define a state for coordinates. I'm gonna say it is var selected coordinates by, remember, mutable state of. You see that I'm using states to achieve this, and it's a due point with an initial value of the coordinates for Los Angeles. So 34, 05, 33, 45, these are the due points for Los Angeles, and minus 118, 24, 23, 49. So I ask the map UI to initially display selected coordinates, and once the selection UI that includes my native Android UI selects another value, another coordinates, I can update my selected coordinates to that selected to that coordinate that is passed to us from selection UI. So I know that selection UI sends me requested point, and I can use that requested point to update my selected coordinates. So selected coordinates is the due point, so I simply assign requested point to my selected coordinates. It's very nice. To see if it is working, let's remove the greeting composable that is used inside my surface, and instead let's use fun UI inside set content. Let's run our application to see if it is working. So Control Shift A to trigger our action and run. Alright, our application is running, but something that I forget to add is adding the permissions for the map to work. So let's go to Android Manifest and first of all add the permissions for internet. Android.permission.internet. And also let's add user permission for Android.permission.access network state. If you want to work with the location access, the user's location, you should also add the location permissions, for example, access find state, access find location, or access course location, or access background location, but in this application we will not need them. The other change that we need to make to our application in order for the map tiles to load is setting the cache settings for our map view. So I go to the definition of my map view in the main activity, and here in the factory settings, where we usually set the one-time settings for our view to initialize it, I add an apply clause, and then here I call configuration, which is part of this library that we are using for the map, OS Android, and then get instance load. I pass it context, which is it, and then the second parameter is shared preferences. For that I use context again and then call get shared preferences. I use a string for the preferences of this application, for example OSM map, and then the access mode for it, I use mode private, which makes it private to this application. And also, because factory section is for doing the initial and one-time configuration for the view that is being created, I can move set tile source that we are already using it in the update section to the factory settings section. So I cut this line and I move it inside the apply section. Alright, let's run our application. Run. There we go, our application is running and the map tiles are being loaded. As you can see, this is the amount of zoom that we are using, 11, but we can change it for a bigger zoom, and the changes are instantaneous. You can see them on the map. You can also select other cities, other municipalities from the drop down menu to go to different areas like San Diego. San Francisco. And the last one, San Jose. You can also change the amount of zoom from the map itself using its built-in controls. To see more details on your map and load them. Alright, that's it for our Android view. You can see that whenever we have a view that has not yet been implemented in Android, like map view or add view or something like that, that doesn't have a corresponding counterpart in Android framework, we can use Android view to use Android's native views inside our Compose code. And as you saw, it has a factory section where we set its initial and one-time settings and initializations. We perform its initialization, we construct it, and it also has an update section that can run several times in different compositions when, for example, something changes, some variable changes, some state changes. It can recompose and it can apply the UI changes to that Android view that we are using in our Jetpack Compose application. And with that, we wrap up this lesson. In this video, I'm going to show you how to add Jetpack Compose UIs to an existing Android view hierarchy. You can use these instructions to upgrade an existing Android view application to Jetpack Compose. Note that for migrating to Jetpack Compose, you have two options. First is the top-down approach, in which you select one whole screen, for example this screen, which is currently all view based, and you can design everything in this screen using Jetpack Compose UI. Or you can use the bottom-up approach, in which you can perform the upgrade gradually by designing smaller parts of that screen one at a time and perform this upgrade gradually. This is called the bottom-up approach, in which you essentially create a hybrid application. So by adding Jetpack Compose components as part of our view hierarchy, we are basically creating a hybrid application. So for this video, I have an Android view application called EasyNote that you can find on my GitHub page. You can clone it and you can play with it. You can even send pull requests with your suggested improvements. So this application is completely view based. What I'm going to do in this video is to migrate parts of this application to Jetpack Compose to show you how you can integrate Jetpack Compose technology to one of your existing Android View applications. I will start by adding Compose support to this application, and we will do that in build.gradle files. So I go to the main build.gradle file of my app. You can see that I have a section here under all projects and ext, under which I have defined several versions for different libraries that I have used in my app, like Room, coroutines, and lifecycle. I'm gonna add another version called Compose that specifies the version of Jetpack Compose that we will use, and I'm gonna specify the latest beta version of Compose that is currently available at the time of this recording. And then I'm going to move to the other build.gradle file in the app module, and I'm gonna add Compose dependencies here. So let's add them one by one. Android X dot compose dot runtime live data, and the Compose version, implementation, Android X dot compose dot foundation, and foundation, version of Compose, implementation, Android X dot compose dot UI and UI, Compose version. The next one is UI tooling, Android X dot compose UI and UI tooling, the version, implementation, Android X dot compose material and material version, implementation, Android X dot compose material and material icons core, and the version, implementation, Android X dot compose material icons core, and the version of Compose. Once we added these Compose dependencies, we also need to enable Compose for this application, and we do that using build features in this build.gradle file. So you can see that already we have a build feature called view binding enabled. I'm gonna enable Compose here as well. Next, after we have enabled build features of Compose, we go to other options that we need to configure for Compose to work, like Compose options. For Compose options, I need to add Kotlin compiler extension version, and here I specify the version of Compose that I am using for my project, and this is basically the compiler extension version that my app will use to connect to Kotlin compiler and create the Compose view hierarchies. Okay, let's press sync now. Let's see if the build was successful and everything was fetched. Yes, it was successful. Now I'm gonna start with my second activity. Note that I have already two activities. The main activity that shows the list of available nodes, the nodes that have been added, and also I have another activity, edit activity, that allows me to create new nodes or messages or edit existing nodes like this. So I'm gonna start by making some changes to my edit activity and convert some of its existing view components to compose components. So in order to do that, when you want to migrate parts of your view hierarchy to compose, first you need to start with your layout file. And the layout file for that activity is the edit activity edit, and let's open some space for our work. And you can see that we have a component called message. Its ID is message, and we have another text view for name where the user enters their name as the author of the node, and we have a button take action that can display the message, update or add based on the request that is sent to it. If we are supposed to add a node, this will display add, and if we are supposed to update an existing message, this will display update. So first, let's start with the header. We also have a text view called header, and I'm gonna change this to compose, and I'm starting with this because this is the easiest and the simplest one to start with. So first of all, I copy the definition of this view, and then I comment it out because I'm going to replace it with a compose view. I delete its tag, and then I use Android X Compose UI platform and compose view. Note that I keep its ID and I keep its constraints, its layout definitions, but I remove the components and the attributes that are not defined for compose view, like padding. So I remove padding. Then I go to the definition of edit activity, and here, as you can see, we have a binding that inflates that layout file and initializes the view components. Here, for example, binding header, it is setting its text, and it is using requested action that is received from the intent in order to decide whether to display editing message or add a new message for the header. So I'm gonna change this because compose view does not have a component attribute text. So I comment this out, and I comment the other line as well. And now I'm going to make that change myself. In fact, I'm gonna perform it here outside of the block of code that is dealing with view hierarchies. So I say binding dot header, and this time we know that header is not text view anymore. Then I say apply because I'm going to apply my changes. And before I define my compose UI here, I need to set a view composition strategy. Most of the time, the default view composition strategy, the strategy that Compose uses to lay out this file and to compose it, is sufficient for us. The default composition strategy is called dispose undetached from window, which is sufficient most of the time. However, it's good to know that there are other composition strategies like dispose on lifecycle destroyed and dispose on view tree lifecycle owner destroyed that you might need to use in case you are dealing with fragments or when you want to work with transitions. So, in order to show you how it is used, I call set view composition strategy and then view composition strategy and the value of dispose on life cycle destroyed. Let's import view composition strategy. Dispose on lifecycle destroyed has a parameter. It needs to receive the lifecycle. I pass in the lifecycle of this application, of this activity. And once we have set the lifecycle, once we have specified the view composition strategy, we set the view that we want to create, the content of the compose structure. So I say set content. Let's create our compose content for this view, and in order to do that, we start with a text, and in fact text is all we need for this view to work. I import text from the material library of Jetpack Compose, and to decide which text to display, editing message or add a new message, I need to process requested action that I receive from the incoming intent. So I say when, or let's say if requested action equals action edit, then use string resource r.string editing message. Otherwise, use this message, add new message, string resource r.string add new message. That's it basically for how we create that view equivalent in Compose. Note that the view that we replaced with Compose view also had some padding. If you look at the definition of the view in its layout file, you can see that it has 8 dp of padding. So I need to replicate that in Compose. I do that using a modifier dot padding 8 dep, exactly that amount of padding that we had in our layout file, and that's it for this. That's it basically for this header. So let's run our application to see our changes for now. There we go, our application is running. Let's go to our edit activity to see if the change we made using our compose view has been applied. I open an existing node, and yes, you can see that it has been added, editing message, when we are editing an existing node. And if we are supposed to create a new node, it shows add new message as the header. Nice. So we basically created a hybrid application. We added compose view and replaced it for an existing Android view that was text view. We basically replaced it with a compose text composable. Next, I'm gonna replace this part, this edit text that displays the message that the user is supposed to enter, or they are supposed to edit an existing message here. So I'm gonna replace that with a text field composable from Jetpack Compose. So again, as before, I start with my layout file, and the layout file is activity edit. So I go and find this edit text just like before. Let's open up some space, and I'm gonna copy the whole definition of this edit text, and then I'm going to comment out this whole edit text, and I'm gonna replace it with a compose view. So I paste the definition of the edit text that I just copied, and I replace the tag name of edit text with compose view. Let's type Android X, compose UI, platform, and compose view. Okay, you can see that it has ID of message. I keep it. It has layout width and height. I keep it because we need it to lay out our compose view inside this view hierarchy. And we have margin start, margin end, which also are needed because they specify the outer margins, and we need them for correct layout of our compose view. And also we have EMS that is specific to text, and we don't need it because it's not known to compose view. It's specific to edit text, so I remove it. And we have hint, we don't have it for compose view, I remove it. We have input type, we remove it. We have padding, we remove it. And then we have the constraint set and the constraint definitions for our view that are also needed, so we keep them as well. Then I go to my edit activity, and I do a similar thing, something like what I did for header. I do that for message this time. So I comment out all the lines that are currently using and accessing the message that used to be an edit text, because they cannot access the text attribute anymore. I remove them, I comment them out, and I go and do something similar for that composable that I am supposed to create inside my new compose view. All right, after binding.header, I say binding.message. Let's create the content of our compose view using Jetpack Compose. I say apply, and again I set view composition strategy, and dispose on. You can see that there are three types of lifecycle three types of view composition strategies. And again, I'm gonna use on view tree lifecycle destroyed or on lifecycle destroyed. And lifecycle destroyed is a method that requires us, you can see that it's a class that has a constructor. It requires the lifecycle to be passed in. So I pass in the lifecycle of this activity, and next I create its content using set content. And because we usually create the content of text, edit text and their equivalents using text field, I use a text field. It's a composable from the material design library of Jetpack Compose. It has a value parameter and an onValue change. Note that these are two values that need to follow the state definition in Jetpack Compose, so that whenever the value changes inside the text field, the Compose system knows that it needs a recomposition to refresh the UI and reflect the changes to the user. So I create two variables here, input and on input change. One of them is the initial value and the other is a lambda that changes that value when the user enters a new value and updates an existing value inside the text field. So I use remember mutable state of, like this, and initially I give it an empty string, and I pass input to the value of the text field, and I also pass on input change as the value of onValue change to deal with the changes and update to our text field. Also note that our edit text had some properties set on our view in the layout file that we need to replicate using modifier or some other parameters that might be available to text field. So modifier, let's see what those changes and what those properties were. For our edit text, you can see that we had a hint, for example, and we had input type. We can set these changes. Hint. For the hint, let's look at the parameters. If we have hint, we don't have hint for it, but instead we will be able to use label, something specific to Jetpack Compose, material composable of text field. But for now, we are just going to use the simplest ones like padding. So I'm gonna use this, I'm gonna specify the padding, and the padding, for the padding I'm gonna use the padding value from the resources. As you can see, it was using the default padding from the daemon resources, and dimension resource r.daemon dot default padding. Let's import also dimension resource like this, and okay, for now that's fine. We might later add other properties that make it more similar to what we had in the view structure. So let's run our application for now and see how it works. Note that the text is not known here, so for now I define a temporary text variable with the value of empty string so that I can run the application. Okay, let's open an existing. Yes, you can see that our edit text has been replaced with a composable, with a text field composable. However, the text that we are sending to that activity, the text of the note that we are supposed to edit, is not displayed inside this text field, and we need to fix that. And also we cannot add a new message for now. As you can see, we are entering the message inside our text field. This is a new message added. You can see that it is not working. We cannot add it for now. We need to fix them. Note that whatever text that the user enters inside our text field, we also need to pass it finally to the requesting activity in order to add it to our view model and to our list of messages. Let's do that by defining a field inside edit activity called text, the text that the user is entering inside our text field. And I'm gonna receive it from the intent. Note that this can be late init private var private late init, and I'm gonna initialize it inside the onCreate using the received intent. So mtext equals if intent get string extra message. We use this key to extract the input message from the input intent. Get string extra. If it is not null, we are going to use it as the value of mtext. Otherwise, we are going to use an empty string. So, in fact, we can make it simpler like this. We initially started to an empty string without the late in it, and then if it was not null, we use the received extra for the message to be edited. So mtext equals it, the message that we receive from the input intent. And because we want to initially show the content of that message inside our text field, we are going to change the definition of input and uninput change state modifiers inside the set content, and we are going to initialize that state to mtext instead of an empty string, like this. And finally, when we are pressing the add button or the update button, we need to use the value that has been set, and the value needs to be set as part of our composition. You can see that whenever that changes, whenever the input changes, we need to update the value of mText. So let's update that. Here on input change, on value change, I need to change the way I call this, because I also have to make some other changes. I want to change the value of mText here, and I need to pass the modified text to mText, assign it to mText and update its value. All right. Once I have kept the track of that text and the text that the user enters, and I have access to the value that has been edited or entered by the user, I can eventually pass it back as part of my intent information in setResult. So for text, this time I'm gonna say put extra mText. So I don't need this temporary text definition. If text is not blank, if mText is not blank this time, and author is not blank, we are passing back the results. Okay, let's run the application to see how it works. Okay, let's enter some text. This is my first message entered inside my hybrid compose text field. Note that there are some changes, like also the tab is not working anymore in the emulator for this component, so I cannot press tab to go to the other field. Enter my name and add the message. There we go, you can see that the message was added. And then let's try its editing feature. This is my first message, my first edited. I modify the text that I'm entering and I update it. Yes, you can see that the message was updated. Nice. So that's it, basically how you add a hybrid compose view to your existing Android view hierarchy, and you can follow this to perform gradual upgrade to Jetpack Compose component by component, or you can select to actually upgrade the whole screen to Jetpack Compose and design all this screen from scratch and handle everything and create their equivalents like they behaved in Android view structure and your Android view application or activity. Next, I'm going to show you how to migrate and how to add compose views and compose UIs as part of a fragment. Here in this application, I have a simple fragment that allows me to delete existing messages from the database. For example, I want to delete this first message. I can line press on that message, and then this dialog is displayed to me. This dialog is defined as a dialog fragment, so its definition is a fragment. Therefore, we can migrate parts of it or all of it to Jetpack Compose. First, let's see how it works without the compose and without compose. and later we are going to upgrade it to Jetpack Compose. To delete an item, I can press yes and it is removed from the database, or I can press cancel to dismiss the dialog. So first I go as before to the definition of that dialog. It is my dialog. It's got a layout file for the fragment, and you can see the different components that make that dialog, like the text views and the buttons that we have. And I'm going to change the existing text view as just example. The existing text view to a composed text. So as before, I copy the definition of this text view, then I comment it out, and I replace it with compose view, like this. Let's hold everything that is relevant to compose view and omit others, like ID is good and the constraint definitions must be retained. Let's remove the padding and style because these are not defined for compose view. And also I want to upgrade this text view, the message to be displayed. Item text, it's got the idea of item text. I'm gonna copy the whole text view, then comment it out and replace it with compose view. Let's delete the tag name text view and replace it with compose view. Let's keep everything that is relevant. Padding is not, text is not, max lines and ellipse size also are not, and the constraints are retained. Now let's go to our code to make required changes inside the definition of my dialog class, our fragment class. And as you can see, as you know, the fragment UI is constructed inside onCreateView. So that's where we need to make our changes and apply our Compose UI. First of all, you can see that it is setting the text of its text view, dialog text, using the input text like this. But we don't have the text attribute anymore, so I comment this out. And because we started migrating from our, what was the ID for that? Alert text. Because we started with that, I'm going to create that first. So I say m binding dot alert text dot set content, and this is where the view composition strategy matters. Because we are inside a fragment, we need to use a special view composition strategy. Set view I need to use apply here, and then set view composition strategy, view composition strategy, and a special view composition strategy that is called dispose on view tree lifecycle owner destroyed. Yes. Dispose on view tree lifecycle destroyed. And once we set the composition strategy, we set its content, we create its content. And for the text, I use a text composable. Let's import text from Jetpack Compose, material library, and string resource. To access the string resource for the message to be displayed here, are you sure you want to delete this message? Are you sure you want to remove this item? And see what other attributes it used to have so that we can replicate. Like padding, it had a padding of default padding. Let's add that using a modifier. Import modifier, and then padding, dimension resource. I use the dimension resource composable to load the dimension resource that I had. r.dimen.default padding. All right, that's it. Now we are done with the definition and with the content setting of our alert text composable, our alert text compose view. We basically replaced it with a composable that sets its content. Next, we are dealing with the body text, with the text of the message, and it's called dialog text. So mbinding dot dialog text, again apply, set view composition strategy, and view composition strategy, dispose on view tree lifecycle destroyed. Make sure you are using this view composition strategy inside fragments. Then create its content using composables, and again I'm gonna use a text composable because this was a text view and it's best to be replaced with a text composable. And to set the content of the text, we are supposed to receive that text here. You can see the definition of mtext, and it is received when the dialog fragment is constructed. You can check out the definition of set arguments that is initializing, and it is giving values to mtext. Set arguments, it is receiving a bundle from the creating activity and extracts this extra message and passes it to mtext. So we are sure that we have a value in mtext. We only need to use it. So mtext, I use mtext inside the text composable, and let's replicate other properties of the edit text of the text view. like padding, max lines, and ellipse size. So first modifier padding. Yes, it's using default padding. So dimension resource r.dimen.default padding. Other parameters like max lines, these are defined as parameters for text composable. So max lines was 1. I'm going to replicate that here. And then we had ellipse size. So you can see that there's no parameter called ellipse size. However, we have another parameter that deals with ellipse size that is called overflow. Text overflow dot ellipsis. This basically does what that ellipse size attribute did for the text view tag that we had inside the layout of this fragment. All right, that's it. We simply upgraded these two text views that we had in our fragment to compose views and to compose UIs. Now let's run our application to see if it is working. Let's select an item with line press. You can see that we have that alert message. Are you sure you want to remove this item? And also we have the content of that message displayed here with an ellipsis at the end of the message and with a max line of 1. So it is working, and we were successful in replicating our Android view in Jetpack Compose. You can see. Let's remove one of the messages when adding Compose view. Yes, that's it. So what I did, I replaced two of the view components of this alert dialog with compose views. So in the second part of this video, you learned how you can migrate parts of a fragment to Jetpack Compose. In this fragment, we were able to migrate this text view and this text view to Jetpack Compose. Now, as an exercise, I want you to migrate the whole screen of the fragment, the whole content of the fragment to Jetpack Compose. You can do that one by one, or you can do the whole screen once, because this screen is simple and you can simply do it. Note that you need to deal with the callbacks with the click events for these buttons as well. You need to dismiss the dialog when the cancel is clicked, and you need to call a callback that notifies the calling activity to remove the requested item when the yes is clicked, and then dismiss the dialog. So that's basically how you migrate an existing Android view application to Jetpack Compose, one component at a time or one screen at a time. If you are creating a new Compose application, you don't need to worry about creating Compose views and Compose UIs inside Android views, because you are designing all your screens using Compose and using Jetpack Compose UI and composables. But if you have an existing Android view that you want to migrate to Jetpack Compose, you can follow the instructions that I gave in this video. So I hope that you liked it, and I see you in the next video. When you are migrating an existing Android application to Jetpack Compose, you can reuse your existing themes for your Compose components. In this video, I will show you how to do this. So I have an existing Android application, my EasyNote application, and it is view-based. It has just a few Compose components, like in the edit activity, some components like this header as well as this text field are written in Compose. And now I want these components to follow the theming of my application that is defined inside themes.xml. Also, I have a dialog fragment that is used for deleting items from the list, and it has its components written in Compose, and I want these components also to follow the theming of my application defined in this themes.xml file. So let's see how we can do this. First of all, you need to know there are two types of themes that you might want to use for your Android application: a material design based theme or an app compat based theme. I have already defined two themes called theme my app theme and theme.myappcompat theme. The first, my app theme, is based on material design, and it's a material design theme, and the second one is an app compat theme. Fortunately, we can reuse both of these themes for our Compose components. So whether your application is using a material design theme or an app compat theme, you can make your Compose components follow that theme's characteristics. I'm gonna start with material design theme. So the first thing I'm gonna do is go to build.gradle file and add a dependency. We need a dependency called Compose Theme Adapter from the material design library to enable us to reuse our view components theme for our Compose components. So Compose Theme Adapter, and it's from the material design library, and implementation com.google Android material Compose Theme Adapter, and the latest version Android Studio helps me with that, 1.10. And also we have another dependency in case we want to reuse app compat themes, and that is called accompanist app compat theme adapter. So this is material theme adapter, and the second one is accompanist app compat theme adapter. It's from the accompanist library or group of libraries, and I write it implementation com.google.accompanist and accompanist app compat theme, and the latest version for it is 0.21.0 beta, and looks like the version is not accurate, so Android Studio tells me that it is 21.3 beta, the latest version. So I updated to that version, and then I press sync now for these changes to be applied. Alright, the sync was successful. The dependencies are now added. Let's start with applying material design theme for our Compose components. We know that our application is already using a material design theme, so it will make it easier for us to reuse that view theme. So I go to my edit activity where I have defined my Compose components, and as you can see, I have a Compose component header and another called message. In order to use material design theme for them, I'm gonna wrap my Compose tree, that is here text, I'm gonna put them inside a pair of curly braces, and then I'm gonna use MDC theme. This is a composable from the new dependency Compose theme adapter that we just added that enables us to read theme characteristics from XML files and reuse them for our Compose component. So I import it, and now our text should use the theme characteristics from our theme defined in themes.xml. And let's do the same for our text field defined for our message, this text field. So I select the text field. I can just type 2 curly braces around it, or in Android Studio it is easy, just enter your curly braces by pressing Shift and then your starting curly brace, and then it wraps the whole area with a pair of curly braces. Then I type MDC theme, like this, and then because we have some other components written using Compose, like for our dialog, let's go to my dialog. For the dialog, I have designed the whole UI of the dialog using Compose, so I can simply wrap the whole column . The whole column should be third one from the left. So it's this. You can press Alt and Enter to see if there's an option to wrap it with something, with some other composable. No, there isn't. So I use what I did before. I just enter my curly braces here around it, and then type MDC theme to make it follow the material design theme of my application. Alright, that's what we needed to do in order to apply our material theme from the application for your Compose components. Now let's run our application and see if the themes were applied. Alright, let's start with our edit activity. And there we go. You can see that it is using the material theme that we defined in themes.xml. It is applying those theme characteristics to the header as well as the text field. Of course, the text size that we are using for the theme is too large, but it is showing that the theme was successfully applied to our Compose component. Let's also zoom to fit screen. There we go. You can see that the font family is also changed to match the font family that we have defined inside our theme.myapptheme. Josephine Sans, the font that we have defined for this theme, for our material theme. Let's press back and check out our dialog. There we go. The theme is also applied for our dialog as well. Alright, so you learned how you can use your material themes for your Compose components. Now what about our AppCompat theme? What if your application is using an AppCompat theme? Let's first switch our application theme to our AppCompat theme to create a consistent look in our application. And then let's go to our edit activity to make our Compose components follow AppCompat theme. We are not using MDC theme anymore, so let's change it to AppCompat theme. The way we do it is using a composable from the accompanist theme adapter called AppCompat theme. I import it. I also replaced the second MDC theme with AppCompat theme. And then I go to my dialog. In fact, before applying the change to my dialog, I can run the application to see the changes, but the fact that we are using MDC theme here, but our application is not using a material theme, can cause some problems. So I make the switch here as well. So I use AppCompat theme and import it. So now all our Compose components should follow our AppCompat theme. Let's run the application. Okay, you can see that now we are using a new theme, our AppCompat theme, and this AppCompat theme is using a different font family. You can see that in the themes.xml file, we are using Gemuno this time, and the colors also are different. And if we go to edit activity, you can see that the changes and the theme changes have been applied to our Compose components as well, like for the font family. You can see that now we are using an updated theme for these components as well. I press back and I check out the dialog fragment by line pressing an item from the list. And there we go. You can see that we are using an updated theme for our Compose components as well, which means our Compose components are now using the characteristics of our Vue theme. And that was thanks to this composable AppCompat theme, which reads the theme characteristics and properties from our app.compat theme in the application level and then reuses it for our Compose components. That was exactly like what the MDC theme composable did when we were using the material theme for our application. So that's it basically for how you can reuse your existing Android View themes for your Compose components. Whether you are using a material theme or an app.compat theme for your application, you have options to reuse those themes for your Compose components as well in order to have a consistent and beautiful look for all parts of your application. So with that, I wrap up this video. In this video, I'm going to show you how you can create a basic list in Jetpack Compose. So let's get started by creating a new application in Android Studio. I switch to Android Studio and create a new project. It's an empty Compose activity from the project type, and next I name it my Compose list and I save it in my Compose course directory. All settings are fine. I press finish and wait for the project to be created. Alright, my project is created. Next, I'm going to create the list, but for the list, I will need some items and some data in order to be used in the list. But I will need some data in order to display in the list. So let's create a data type, a data class in fact, that I will use to construct my list. So I go to the main package of my application and then I create a new package. I name it data, and inside data I create a new data class. I name it profile. It can be used to create some profiles for people. And this class is going to have properties like name and ID. So let's specify them. Val name, its type is string, and it will also have picture. The type of picture is going to be integer because I'm going to use Android resources for that, and I'm going to load the pictures for profiles from the drawable directory, and we know that its type is integer. It can also have an ID. It's a good idea to create another property called ID that has a unique value by default. So I'm gonna use string as its type, and for its value I'm going to use the UUID class from Java util package, and I'm gonna use random UUID and then cast it to string in order to have a unique string for its ID. Alright, next I can construct the list that is the data supposed to be displayed in my list. So outside my main activity class and in the same file, I create a temporary list. I name it my list or simply profiles list. I created using list of and then profile. I'm gonna create several profiles. Let's enter profile from the data package, and then I'm gonna specify the names like John, and then the picture, which is integer. I use r.drawable .john. Note that I don't have any picture added to my drawable directory yet that I can use them for profile, so I will add them next. I have some pictures in my pictures directory. I have them here. I copy them. I go back to Android Studio and paste them in the drawable directory. So paste them here. Okay. Now John is known for my code, and then I create profile Andrew r.drawable.andrew The next one is Elisa r.drawable.elisa profile Edward r.drawable.edward Jackie r.drawable.jackie Jade r.drawable.jade Jane r.drawable.jane and profile Jennifer r.drawable.jennifer next profile Gerard r.drawable.gerard and the next one is John, but we have already specified John, so I use Ted r.drawable.ted. Note that the values do not have to be unique, the values for names, so I can duplicate these lines to have a longer list. So I press Ctrl D and duplicate the lines in order to have a longer list. The next step is displaying our list. In order to display a list, we can use a composable called lazy column or lazy row. If you want to display a vertical list, you can use lazy column, and if you want to display a row, you can use lazy row. So I'm gonna create a composable inside which I will create my list. So I type comp and press enter and name it my list UI. Inside of it, I'm going to use the list items that I have created in the same file. So I use lazy column and I import lazy column. Note that lazy column works similar to a normal column, so you can have some modifiers for it. So I'm gonna add a modifier to the lazy column so that I can have fill max size. Like this. And in fact, I can make this my vertical list UI. And once you have your lazy column, you can use several ways to display the items. First of all, you use items. And you can see items has several forms. The first two forms are items, 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 and the next two forms are items indexed. And I will show you how different they are. Basically, they will do the same thing. They will display your items. But I'm gonna start simple. I'm gonna use the form that takes in a list. So items, and I'm gonna use the items parameter. In fact, items, you can see the form that has items parameter, and for its value I'm gonna specify my the profiles list, and then we have, let's import items, and now we can display the items here. I press Ctrl P and you can see that we are inside item content lambda, and this lambda receives a profile item. So it's a profile item that I can use. I'm gonna create a row let's import row. Let's have a default preview. I'm gonna change the content of my default preview here so that I see a fresh preview of what I am creating and designing. My compose lists theme, I put my new content inside my Compose list theme, that is the theme of my Compose application. So I call my vertical list UI here, and now I should have a preview. Let's build and refresh. Inside the row I can have a text that will display the profile name and an image to display the profile picture. Profile.picture, and for its content description I'm gonna use profile name, and now let's add some alignments. I'm gonna put the row in the center of the column. Therefore, I'm gonna add another parameter for the lazy column, and that is the horizontal alignment. For its value, I use alignment center horizontally, so that they will be centered horizontally inside it. And you can see that we have a list that is not yet beautiful, so I need to make some changes. For example, inside the row I add a modifier. I add a weight of 1F. I give equal weights to both UI items. Weight 1F. And also for the image, I'm gonna clip it. I'm gonna clip it in order to have a round image. These are for profiles, and often round images are used for profiles. So I use rounded corner shape. Let's use 50% as the amount of roundness. And also for the image, let's use a content scale of crop in order to crop from the center of the image and have good aspect ratio. For the text, I'm going to also use a style material theme dot typography dot like caption, and let's also have some alignment for the row. This is a row, so I can align it vertically, center vertically, so that the text will be displayed in the center. I can do the same for my image, but the image doesn't need it anyway, because the image has enough height to fill that height. So build and refresh again. Build it. Alright, let's also add some padding to our row. Modifier dot padding, so that we have enough outer padding for the items in our row. 16 depth. And I'm gonna also increase the roundness percentage to 100. Yes, you can see the changes in real time. 100. And also I'm gonna give it a size. I'm gonna give the images a size. Like 150 dp. Importing size. All right. Okay, not bad. I'm gonna increase the size of the caption a little bit. So for the style, I'm gonna change it. I change it to H4. All right. Next, I'm going to use a horizontal version of the same list, because you will often want to also create horizontal lists in your application. So I'm gonna showcase how it works. I create another composable. I name it my horizontal list. And I will use the same content, but I will use lazy row in it. Like this. Lazy row. And I'm gonna use a modifier I use the maximum width, fill max width, and again I'm gonna use items. In fact, to save time, I'm gonna copy the content of the previous lazy column and add it inside my lazy row, like this. And this time I'm gonna give the rows a fixed size, because I want to have a smaller size. I want to display them in the top section of my application screen. So I'm gonna give it a size let's give it a width of 150 dp. In fact, I'm gonna make it the size instead of giving different values for width and height. My horizontal list. And also, in order to be able to click on the items, I can add a clickable modifier to the rows. So I add clickable to the rows, both rows, and once any item is clicked, I can display a toast. So toast make text. I need to use the context, so I get access to the context in my composable with this val. I create a variable context, and I access the application context with local context.current. Let's import local context, and now I can construct my toast. Profile dot name clicked, and then the duration toast dot length short, and show it. I'm gonna use the same toast for the lazy row as well. Okay, I didn't have the context for my horizontal list, so I define it local context current. Let's preview our list with a preview annotation. Background like the other preview, show background true. And now I can see it. Let's give it a smaller amount of height. You can see that the size is not that nice, so I use 150 as its width and 100 as its height. Build and refresh. So I now also change the caption's style. For the lazy row, I change it from h4 to caption, like this. Okay, Next, we can run our application to see the list and how it works on our emulator or on our real device. So I go to the set content section, and here inside the surface that I have, I'm gonna use a big column with a fill max size modifier, and then I'm gonna use both lists inside it. So first I use my horizontal list, and then I use my vertical list UI. Now let's run it on the emulator to see how it works. Alright, you can see that we have our list. We have both our horizontal list and our vertical list. We can even click them because we have made them clickable. Yes. Looks like for the vertical list I have used the wrong item when adding the clickable modifier. So for my vertical list, let's check it. Yes, I have added to the text. I need to add it to the whole row. And now it will be fixed. Okay. Yes. Now we can see that we can click the whole row for the list and see our toast. In case you want to access the indexes for your items, you can use another version of the items function. So for example, for my vertical list, I used items. I can change it to items indexed. And the difference between this function and the previous one is that this function also gives us the index of the items. You can see that from the signature of the function. It also gives us the index as well as the item. So I also get the index. The first one, you can see the index, and the second one is the item. So for example, I can use that inside my toast. So profile name with this index, clicked. And I can use that for the other as well, but I don't need that, so I just leave it as is for the horizontal list. I run it again. You can see that now we have indexes as well. 6 Jane clicked, 8 Gerard clicked. Alright, that's it basically for how you can create a simple list in Jetpack Compose. You can see that you can use vertical lists. You can display vertical lists using lazy column, and you can display horizontal lists using lazy row. In this video, we will continue our discussion of lists. First, let's start by adding some new pictures that I have downloaded from the internet to my project. So I copy these new pictures and I paste them inside the drawable folder of my project. Alright, the new pictures are added. So I replace the second part of my list with the new items that are available in the drawable directory. So I change John to Adam, and its corresponding drawable to Adam as well. And the next one will be Anastasia, and its corresponding drawable to Anastasia. Next one, Chris, Clara, and its drawable Clara. Florina, Yan. The reason why I'm doing this is that I want to have distinct items in my list, and also a longer list. So r.drawable.yan and Richard, the initials should be in capital. Richard. Next one, Roman or Roman, and Roman, it's drawable. Tor, it's drawable. And I think we're good to go. I have mentioned all the names, so I remove the last one, which is Ted. The first thing I'm going to talk about in this video is support for content padding in lazy lists. So with content padding, you can add padding to the content of your list. For example, let's consider this list. I can have a padding from the start of the content, this part, and I can also add a padding to the content from the end of the list, or from the top, or from the bottom, and for the other list as well. So before I do that, I'm gonna arrange my previews a little bit so that I can have both previews in the same screen. So I move the second preview to the first one in the default preview. So first I'm gonna display my horizontal list, and I'm gonna put both of them inside a column. This way it will be similar to what we see in the application that is running on the emulator or on the phone. So let's build and refresh. Alright, now we have our previews here in the same screen, and I'm gonna add content padding to my vertical list. So I open it, and in my vertical list UI I have a lazy column. I'm gonna add a parameter to lazy column, content padding, and for its value I type padding values. Note that for padding values I can pass only one parameter, or two parameters, or four parameters. There are three forms to call padding values. If you want to have the padding for all four sides, you can use the first form. If you want to have the same padding for start and end side of your list, you can use the second. And if you want to have a different padding for every side, for each side of your list, you can use the third form of padding values. I'm gonna use the second form for horizontal sides. I'm gonna use a different padding from what I will use for the vertical sides. So for horizontal I'm gonna use 16 depth, and for vertical I'm gonna use 4 depth. Let's decrease the horizontal to 8 depth. Let's refresh our preview. We can change this in real time so that you can see the change that is applied by modifying the value of these components of content padding. So for example, I change the horizontal component to 32. You can see that the paddings are changing. I change it to 42. It changed more. I change it back to 4. I change it to 8. You can see that the padding is applied to the content, not to the list itself, and this is very important. I can also change the vertical component from 4 to 8 or to 16. You can see the change that is applied. So I change it back to 4. I can have the same thing for the other list as well. So I go to my horizontal list and I add this parameter content padding to lazy row padding values, and I'm gonna use the third form for the start. I'm gonna use 8 depth or 4 depth, and for the top I'm gonna use 2 depth, and for the bottom I'm gonna use 4 depth. These are arbitrary values that I'm using to only show how it is used. So I build and refresh. Let's see how changing these values affects the display of the horizontal list. So I changed the top component from 2 to 16. You can see that the padding is obvious 32, and now it is more. So I change it back to 2, and now we are back in the same padding that we were initially using. So this was for content padding, the padding that is added to the content of our lazy list. The next topic I'm gonna talk about is content spacing, and with that I mean the space that we can have for the elements of the list, between the elements of the list. And this is easy to implement and to use. First, let's start with our horizontal list. The way we use it, because in a horizontal list we are arranging the items in a horizontal manner, I'm gonna say horizontal arrangement. This is a parameter of lazy row, and for its value we say arrangement dot spaced by, and then we specify the space that we want to be used between our elements. So for example, I'm gonna use 8 depth between the elements, and I do the same for my vertical list. I go to my vertical list, and because in a lazy column the items are arranged in a vertical way, we are gonna use this parameter, vertical arrangement, and for its value I use arrangement dot spaced by, and then I specify the space that I want to use between the elements. This time I'm gonna use 16 depth, although it's a little bit too much. We can adjust it. Let's build and refresh. Alright, as you can see, we have a bigger space now between our elements. We can see the change that is applied as we change this value. Let's change it from 16 to 32, and you can see the change that is applied. I can change it to 64, and now it's too much, and you can see the obvious change that is applied. And I change it to 8, like this, and even that is much, so I use 4. So that's it, how we use content spacing for adding space between our elements. The next thing I'm going to talk about in this video is going to be sticky headers. And with sticky headers, you can keep one header sticked or stuck to the top of your screen and then scroll the other elements. This is especially useful for implementing a list of contacts, for example, that you are sorting alphabetically, so that, for example, when you are browsing the list of contacts, you can stick the first letter of contacts that are starting, for example, with A, and A is going to stick to the top, and then you scroll all other contacts that are starting with A, and then you go to B, and then B is sticking to the top, and you scroll all the elements that are starting with B, and you go to C, and C is sticking to the top, and you scroll other elements, and so on and so forth. But before I do that, I'm gonna make some apparent changes to my list so that I can have completely round images for my elements in the list. So first, let's start with our horizontal list. In this horizontal list, I have my items in a row, and as you can see, I have used an equal weight for both items, for the name and for the image. So I'm gonna remove the weight from my image, and now the size will be 150, and it doesn't have to follow the weight that is forced onto the image, and therefore it will have the round shape that we are applying to the clip. So let's refresh our preview. It is still not displaying in a round way. The reason is that the height is not enough. The height that I am using for the row is less than the height of the image. So I have to make it more, 150, and you can see that it is displaying the images round. And also I'm gonna remove the name element. I'm gonna only use the image. I don't need the row here, so I remove it. I paste the image instead. So I have a size and then the clip. Let's build and refresh. There we go. I'm gonna use a similar thing for the vertical list. In my vertical list, I'm gonna remove the weight from the image and make sure that the height of my row is enough for the image to be displayed in a circular way. There we go. Now the image is round. All right. The next thing I'm going to do is, as I mentioned, applying and using sticky headers. Let's show that with a simple example. First, with my vertical list. In this vertical list, inside the body of my lazy column, I'm gonna use a header that will be the title of the list, the header of the list. So I use this function, sticky header, and inside this sticky header, I'm gonna use the content that is supposed to be displayed there. I use a simple text element, and for this text element, I use a string resource r.string.list of contacts, for example. Let's create a string resource named list of contacts by pressing Alt and Enter. List of contacts for resource value, and let's use a text alignment to align the text in the center, and also a style so that we can use a text with a style that is suitable for title. So I use material theme.typography.h3, for example. And also let's add a little bit of padding with modifier.padding for depth, and we see a red notice here which says this foundation API is experimental and is likely to change or be removed in future. So in order to be able to use this function in our application, we need to add this annotation: opt-in experimental foundation API, or experimental foundation API to the function that is using it. So you can see that sticky header is used by my vertical list UI, and it is in turn used by default preview. So I add it here, @experimental foundation API. It is still there, the notice is still there. So instead I use opt-in, and also I make sure that my onCreate function also doesn't need it. Okay, it doesn't need that annotation, so I'm good to go. Let's refresh our preview. We have list of contacts to see if it is really acting as a sticky header, and it doesn't move with our scroll. I run it on the emulator. You can also use the interactive mode in the preview pane. Alright, the application is running. Let's scroll. There we go. As you can see, the title of the list of contacts, is sticking to the top, and we have a sticky header. it's not that beautiful. That's because it doesn't have a background color, so we can add a background color to it so that the items are not overlaid. So I go to my sticky header, and for the text I'm gonna use a background. First, let's actually use a fill max width so that we fill the whole available width, and then let's use a background color dot white. Let's import color from androidx.compose.ui.graphics package. All right, let's run it again. All right, there we go. Now the sticky part sticks to the top, and it is also not overlaying with the items of the list because it has a background color. Okay, that is an easy usage of sticky header. But what if you want to have a list that is grouped? So for example, you have a list of contacts and you want to group them with their initials. Let's see that in action. Here, as you can see, I have several names. For example, John, Jackie, Jade, Jane, and Jennifer, and Gerard all start with J, so I can group them as the contacts starting with J. So when I scroll those elements, the letter J is going to stick to the top, and when I scroll the names starting with T, that include Ted and Tor, T is going to stick to the top, and then the items will be scrolled until the next letter, and so on and so forth. So first, in order to do that, I'm gonna create another list for holding these values that will be sorted and grouped. So val contacts or profiles grouped, and I'm gonna use some Kotlin functionality here. Profiles list dot sorted by. I'm gonna sort it by the name. This will give me a list that is sorted alphabetically from A to Z, and then I'm gonna group it again by the initial, the first letter of the name. So it dot name index 0. I'm gonna group it with the initial letter. Now I have the list of contacts or profiles that are grouped by the initials, and therefore I can do what I wanted to do. So I go to my vertical list UI, and here before items indexed, I remove this sticky header, or I comment it out, and what I'm gonna do here is use the grouped list profiles grouped, and as you can see, this profiles grouped variable is a map of character to list. So each character in this group is mapped to a list. For example, J, the letter J, the character J is mapped to a list that includes John, Jackie, Jade, Jane, and Jennifer and Gerard. So now that I know it is a map, I can say for each item in this map, entry, for each entry, I will use one sticky header, in which I will display the initial letter. So entry dot key, which is the initial letter, to a string. I convert it to a string, I cast it to a string, and also I use a style of material theme dot typography dot h4 or h3, and a text align of center like this, and after the sticky header I'm gonna display the other items. So I say entry dot value, which is the list, for each item in that list, create an item in my lazy list. So create an item, and what will be the content of each item? It will be this row, and I already have that row implemented previously, so I copy that, actually I cut it, and I paste it inside this item. Like this. I remove items indexed. Because I have used profile previously for each entry, I'm gonna use profile here as the item that is passed to for each, and I'm gonna remove index from here. Now it should work. I have a sticky header for each letter, and then will follow all the names that start with that letter. And when scrolling those names and those profiles, that letter will stick to the top. Let's run it and see the result. There we go. As you can see, I have the letter A for all the sorted names that starts with A, and A is sticking to the top as long as I'm scrolling those names. And when I reach C, then C is going to stick to the top like this, and then E is sticking to the top, and I scroll Edward and Eliza, and then I reach F, and F is sticking to the top, and so on and so forth. That follows. the same convention, but I'm going to add a background to this letter, to this sticky header, so that those items do not overlay each other. However, this is beautiful the way that it is displaying. It's not that bad. I'm gonna add a little bit of background to it, a little bit of different background. So let's add a modifier, background color dot green, for example, and run it. There we go. A little bit of padding as well. Padding and some clip. Add a circle shape to it. With a size of 50 depth, for example. Okay, it's not displaying that in a circular shape. Let's skip it for now. I'm not gonna use size and clipping for now, and that's good. So in this video we talked about content padding, content spacing, and sticky headers for compose lists. In many applications, creating a list with a grid display can be very useful. In this video, I will show you how to create a grid in Jetpack Compose. So for this purpose, I create a new composable in my main activity file, and I name it, for example, my grid. The composable that we need from Jetpack Compose in order to create our grid is called lazy grid. So this is the composable to go for, lazy vertical grid. This is the composable's name, and it has two parameters, cells and content. The cells parameter specifies how you want the cells for your grid to be constructed, the number of your cells and the minimum width of them. And the content, as the name implies, is the place where you put your content, the content of your items. So first I start with cells, and for cells, if you press Ctrl P or Command P if you are on Mac, you will see that we have the type grid cells for this parameter. So I type grid cells dot, and then you will see that we have two options, fixed and adaptive. First, I use fixed. With fixed, which is a class and it takes an integer parameter, you specify the count or number of cells or the number of columns for your grid, the number of columns that you want to have in your grid. So I initially start with 3. I want 3 columns to be created for my grid. And if you open fixed by pressing Ctrl and clicking it, you will find that it is a class. Actually, it's a sealed class. Alright. Also note that the lazy vertical grid composable is an experimental composable. So in order to use it, you need to add the required annotation to the using composable. So we will make sure to use that. And as you saw, I also removed the content parameter to move it outside of parentheses and put it in the trailing curly braces. Here is where I want to use my content. So for the content, I'm gonna use the profiles list that I had. This profiles list that has a number of profiles available with names and drawables and also ID that is not specifically here, but we know that it is automatically created for each profile. If you open profile, you will see that it has an ID field or property that is assigned a random UUID each time a new profile is constructed. So now that we have our list of items, I can create my list items with one of the ways that we can use in a lazy scope. For example, I can use items as we discussed in a previous video, or I can say profiles list for each, and then inside the body of for each I can use item to construct each item. So I'm gonna use this one, item, and here we receive a profile and we pass it to the lambda, to the for each lambda, and for the item I'm gonna create a picture, an image. So I use the image composable. For the painter parameter, I'm gonna use painter resource, and for its ID I'm gonna use the profiles image, profile dot picture. And then for its content description, I'm gonna use profile dot name, and then let's use the content scale parameter to have a content scale that is suitable for profile pictures. So content scale dot crop is the one that I'm gonna use, and then let's use a modifier so that we are free to give it our desired width and height. So I'm gonna give it a width of, for example, 100 depth, and also let's give it a padding. Let's give it a background first, a white background, and then a padding of 2 depth, for example. Okay, let's deal with the experimental aspect of this API. Let's add opt-in experimental foundation API annotation to this composable, and then let's create a preview composable for this. So I type prev and press enter. It creates a template for a preview composable, and I specify a name for it called preview grid or preview my grid. And then inside its body, I'm gonna call my grid, like this. Okay, and in order to call this and see the output in our device, on our device, we need to make a call to it in our onCreate and set content section of main activity as well. So I'm gonna remove the content that we previously had added for displaying our previous list, and instead I'm gonna make a call to my grid. All right, let's refresh our preview. The project needs to be recompiled. No, it's fine. As you can see, we have a grid with a pretty nice display, and it's nice. Let's add a background to our grid so that it looks a little bit better. So I add a parameter to lazy vertical grid modifier background, and I'm gonna use a color, a custom color I'm gonna use, and I'm gonna make it 0x 1 2 3 4 5 6 7 8 8 digits for an RGBA color. And if you click this section, it will open a color picker for you, and here you can select one of the colors that are available from this material palette. So I'm gonna use this color over here, the second color from the first row in the material 300 section. Of course, you are free to use any color that you like. Let's refresh our preview. And there we go, it is nice. Okay, before we move on to discuss the other option to use instead of fixed for the cells parameter, let's change the count parameter a little bit and see how it changes the display of our grid. As you can see, with the 3 parameter, with the 3 value, we have 3 columns in our grid. What if I change it to another number, 2? You can see that now we have 2 columns, and the change is reflected almost instantaneously as you change the value. What if I change it to 4? We have 4 columns. What if I change it to 5? We have 5 columns. What if I change it to 6? What if I change it to 1? We have only 1 column. So you can see that this composable is a pretty powerful API for creating grids. So I reverted back to 3, and again we have 3 columns. Also, if you don't like the height of some of your items that are different from the others, you can also give the image for each item a fixed height so that it is predictable and it has a predictable height. For example, let's use 150 depth as the height of all of our image items. So refresh our preview. And now we have our images all having the same width and height. And probably this is a better display for a lot of apps that are displaying a gallery or a grid of images. Next, we talk about adaptive. Let's change fixed to adaptive and talk about what it does. In case you are using gridcells.adaptive class, you need to pass the min size or minimum size that you expect for each item of your list. For example, here I want my images to have at least 100 depth of size. And if you open adaptive, it's also another class. Let's refresh our preview. The display is not much different from what we had with the previous option, but from the effect you can infer that using this option, adaptive, allows Compose to divide the available width to the given min size or minimum size and see how many columns it can provide for you. And it decides how many columns it is appropriate for your grid. In fact, you are making Compose responsible for creating the appropriate and suitable number of columns based on the size. And based on your application scenario and your application needs, this might be a better option in some cases compared with fixed. For example, if you are creating a list of files for your application, you have a file explorer application, and you want to allow the user to change the icons size, and you want to allow Compose to decide about the number of columns that it can create for your file icons based on the size that is received from the user or from the user's preference. Let's change it to 200. You can see that now we have only one column, because with the 200 minimum size it can have a maximum column of 1. And if you see the documentation for it, you can see combines cells with adaptive number of rows or columns. It will try to position as many rows or columns as possible on the condition that every cell has at least min size space and all extra space distributed evenly. And it has Alright, let's change this back to 100. And one other thing that I want to talk about before I wrap up this video is making one of these items in the grid selectable. In fact, I want to allow the user to emphasize an item by clicking it, and then as the user clicks the item, I want the scale of the item to increase so that the user knows that the item has been selected and has been clicked. So for that purpose, we are going to use clickable on the image. So I add the clickable modifier to the image. And in order to keep track of the item that is currently selected, we need to use a special function for each item so that we make sure each item in our list is unique. Note that our items in a lazy list require a key so that these items are distinct and unique in the list. By default, the position of the items in the list, like 0, 1, 2, 3, 4, are used as key. However, a better way and a more certain way is to provide your own keys so that you know these keys will be stable and appropriate. So I wrap my image with curly braces and I use the function key. With this function, I will be allowed to use my desired key for each item. And because I know that each profile has a unique ID, I can easily use ID as the key here. This will allow me to keep track of the current selected item, the current clicked item, and have a stable way of referencing each item in the list, rather than just relying on the position that is used by default as the key for each item. So Now that I have my profile ID for each image used as key, I'm gonna create a parameter named var selected item. Remember, mutable state of, and because the type of the key is string, I'm gonna use an empty string initially as the type of this state. Let's also import get value and set value. And then for each image, once it is clicked, we make it the current selected item, the current item that is selected from the list. So once this image is clicked, I make the value of selected item as the value of the current image, profile ID. And I specify a scale parameter, a scale modifier for the image, where I animate the scale based on whether the current image is selected or not. So I say if selected item equals profile.id, which means if this image is selected, then increase the scale to 1.5. Otherwise, just use the default scale of 1 that doesn't change the size at all. Alright. Note that this doesn't animate the scale, it just snaps the scale to one of these values, 1.5 or 1.0. In order to have animation for it, I use animate float as state, and then I put the if statement inside its parentheses. I import animate float as state, and because this is a state, I need to use its value, which is a float. Also, I'm gonna use an animation spec so that I can give it my desired animation. I use a spring animation. Let's import spring from the core animation package, and let's use a custom damping ratio, spring.damping ratio medium bouncy, like this. All right, now let's refresh our preview and actually run the application on our device, because it will give us a better running experience. All right, our grid is displayed. I'm going to select or click one of the images in the grid, and hopefully it will be animated. The image size will increase with an animation. There we go. Let's select another. Nice. You can see that we see the effect of the used spring animation. That's pretty nice. So we created a pretty nice grid display for our list by using lazy vertical grid composable from Jetpack Compose, and we also added and experimented with a little bit animation for selecting an item in the grid, and I hope that you liked this lecture. When working with lazy lists in Jetpack Compose, it's often useful to have information about your current list state, like which item in the list you are scrolling by, where in the list you are, and have information about the list state so that, for example, when you are past the first item, when you are at the bottom of the list, you can, for example, add a button that allows you to return the user to the top of the list. Fortunately, Jetpack Compose has the capability that gives us information about the list state. So in this video, we are going to talk about lazy list state and also the scrolling capabilities of lazy list that allows us to scroll to a desired item in the list. So let's get started with our list from the previous video. It was a grid, but I'm going to change it back to a normal list, a vertical list that we had created in previous videos. So in the set content section, I'm going to change my grid by commenting it out, and I'm going to call instead my vertical list UI. Let's run it. Okay. Next, I go to the body of my vertical list UI, and here I'm going to create a state that allows me to track the state of the list. So I type val list state, and for its value, remember lazy list state. All right, now I have a variable that is assigned, remember, lazy list state, that allows me to track the state of the list by using it as a parameter in lazy columns parentheses. There's a parameter for lazy column called state. For its value, I use this variable, list state. All right. Now the value of list state will be automatically updated by Jetpack Compose, and it will reflect in real time where I am in the list, which item I'm scrolling by, and some other useful information that can be useful for our purposes. So let's see what information is available in list state. For example, list state has first visible item scroll offset, which reflects the amount of scroll offset for the first item in the list that is visible. The amount of its scroll is reflected in this variable. Also, it has first visible item index, which item we are currently scrolling. For example, when I am in the beginning of the list, the value will be 1 because I'm at the first item index. Then it will be 1. It was 0 for the first item. Then when I'm at the second item, it will be 1, and so on and so forth. We also have information about interaction source that we are not going to deal with, and we also have layout info that gives really useful information, like for example the number of items in your list, total items count, and viewport end offset, viewport start offset. And based on the scenario of your application, these information can be really useful. But in this video, we are only going to use 2 of these pieces of information. First visible item index and first visible item scroll offset. To show you how these values are updated when we are scrolling the list, I'm going to change the layout of my lazy list first from the current one that creates this sticky header for groups of information. I'm going to change that. Let's actually copy this section, the row, because it will be useful for us. The row section, let's copy that. And then I'm going to comment out the present layout, and in the body of my lazy column, first I'm going to create a sticky header. Already we have a sticky header, so I uncomment that. It's already showing list of contacts. It's showing a title for the list. I'm going to change that. I will show different information here, and also I will change its text style to a different style. I will use subtitle 1. Let's use a background of yellow for it. And what information we are going to show? First item index. The current item index is available in our list state, so we can display it here. Inside the string, I access list state, first visible item index, and some description for it. First visible item index. All right, let's go to the next line by adding \n, and then I add a plus to go to the next line to continue the string. And then the other piece of information that is available in our list state is the amount of scroll offset for the first visible item. So I access that information as well. List state dot first visible item scroll offset. First visible item scroll offset. Let's make them capital, the first letters of these words. And then let's add our row. After the sticky header, we have our row for the items. So I add items, and its list is profiles list. And for each item, we are going to create a row. We need to pass our profile item to this list so that the variable profile is known here. All right. And I'm going to change the background of my rows to something different. Let's see what it is currently. For the row, let's add a background. After clickable, I'm going to add a background of color dot dark gray, and I'm gonna run the application. Let's see the output, what we have so far. All right, as you can see, we have our items in the list. Our row needs a little bit of a padding, so let's add our background before the padding, because the modifiers are applied in order, and now it displays better. All right, as I'm scrolling, notice that these values are being outdated. First visible item is being changed. First visible item index changed to 2, now changes to 3. And in order to see the difference better, I'm going to specify the name that is currently displayed. So add a \n here to go to the next line, and the name that is being displayed, current profile the current profile that is being displayed is profiles list state dot first visible item index. This gives us the profile object at this index from the list, and then we can access its fields like name. We need to display the name here. Let's run it. Alright, current profile is John, the first visible item index. Let's also align the text to the beginning. Text line is center. I'm gonna make it start so that the text is aligned to the left. Alright. Current profile is John, then Andrew. As we are approaching Andrew, the current profile changes to Andrew. And when we reach almost the half of the height of Andrew, by scrolling, it changes to Eliza. The first visible item changes to Eliza. Then it changes to Edward. The item index changes to 4, and the scroll offset is also being updated. For Jackie, you can see that it is decreasing until it reaches 0. And when we scroll by Jackie, at this point, when it's about to switch to Jade, it also reaches 0. It actually increases to 500 at this point, and then when we scroll forward, it decreases. Yes. You can use this information based on your application needs. What we are going to do with these values, for example, I'm going to use item index, first visible item index, to decide whether I want to display a button or not. When this item, the first visible item, is beyond the first item, this means that I have scrolled the list forward and I'm not at the first item, so I can display a button here or anywhere else on this screen that allows me to scroll back automatically to the top of the screen, and this will allow the user have a better user experience by facilitating the navigation of this list. So let's create another list that will allow us to achieve that purpose. I'm going to create two other variables here. First, I'm going to create a derived state based on this state. Val show button by, remember, this is the way that we create derived states. a state that is derived from another state. Derived state of list state dot first visible item index is bigger than 0. If it is bigger than 0, we know that we need to display show button. Other than that, it will be false. And also, I'm going to create a coroutine scope because we need it for scrolling the items programmatically. So I create a scope variable, I name it scope, and then remember coroutine scope. And in order to scroll the items, and as I said, we need a button, and to add the button easily to my list and to a part of this screen, I can use the scaffold class, the scaffold composable. It's not a class, it's a composable from Jetpack Compose that allows me to easily define a floating action button. So what I'm going to do is I wrap all my lazy column that I have here. This is my lazy column. I wrap the whole lazy column like this, and then I press the opening curly brace. It will be automatically wrapped in a pair of curly braces like this, and here I'm going to type scaffold to use the scaffold composable. I import it from the material package, and then I add a parameter for it because it has a lot of parameters. One will be especially useful for us in this video, and that is floating action button. For the floating action button, I'm going to use an extended floating action button. Extended floating action button, and as you can see, it has a text parameter and an onClick. For the text parameter, I'm gonna use a simple text jump to top, and for its onClick, I perform the scroll, and that scroll is performed using the scope that I created here, the coroutine scope. I launch a coroutine scope here. I launch a coroutine using the provided scope, and then I say list state animate scroll to item. Which item I'm going to scroll to with that button? I'm going to scroll to the top item, the first item, the item with index 0. So I use 0 for the index parameter, and also I don't want to display this button all the time. I want to display it only when I need to, only when show button is true. So I can say if show button, then display floating action button. Sorry, I put it before extended floating action button. I say if show button is true, then extended floating action button. But in order to add a little bit of animation to it, I can wrap my extended floating action button and put a pair of curly braces around it by pressing Shift and the starting curly brace, and then use animated visibility. This will use a nice animation for the appearance and disappearance of the button. Animated visibility, it has a parameter visible. For its visible parameter, I use show button, and that's it. It will animate the appearance and disappearance of the button automatically. But since this composable is experimental, I need to add opt-in experimental animation API to the using composable. All right. Also, let's add an icon for our floating action button. This was for the text. After text, I add another item icon, and for the icon I use icons dot default dot, let's import icons from the material package, and then keyboard arrow up. Let's also add a content description for it. I use null, and that's it for our floating action button. Let's run our application. As you can see, by default the button is not displayed, our floating action button, but if we scroll our list forward and pass to the next items, the item appears with an animation using animated visibility, and as we scroll, this button remains visible, and we can use the button by clicking it, and it will help us animate to the beginning of the list. It will help us scroll to the beginning of the list like this. Yes, we are back in the beginning of the list, the first item indexed 0. One more time, the button is displayed. When we pass the first item, it remains visible, and anytime we can click it and it will scroll the list back to the first item. Since I'm running this application on an emulator, the animation for the scroll is not very visible, but on a real device this will be better visible, and you can see how it animates and scrolls to the first item in your list. Note that in order to move to an item in your list, and it doesn't have to be the first item, based on the requirement of your app, you might need to scroll to a different item in your list, like for example scroll to item number 6, item number 10. You can say animate scroll to item 10, and it will scroll it to that item. And also, to move to an item, we have another function scroll to item, and it will perform a simple scroll without animation. Let's run it with this function, list state.scroll to item, jump to top, and as you can see, it is scrolling to the top but without animation. So I change it back to animate scroll to item. So in this video you learned how we can keep track of the current state of our lazy list by using remember lazy list state, and also how we can scroll to a certain item in our list. We created a coroutine scope that allowed us to scroll to a desired item in the list. So with that, I wrap up this video. In this video, I'm going to show you how to use Jetpack Compose lazy column to display data from the paging library. For this purpose, I'm using the Android paging project from Android Code Labs. I have created a fork from this project on my GitHub page, and I have made some changes to it. I have added Compose support, so you can go to the Compose branch, which has the Compose support, and I'm going to add the lazy column and replace the existing recycler view with lazy column in this video. So let's see how it's done. First, you can go to the build.gradle file to see the dependencies that I have added. You can see that I have added paging compose artifact, and then you can run the existing project without the lazy column implementation because it is currently using the recycler view implementation. And you can expect that after converting the existing list to lazy column, we will not need the existing adapters and view holders because we will use the lazy column, which we know works directly with the data. Here's the existing application that is run, and you can see that on the emulator. So let's add the lazy column. First, I go to the layout file for the activity that I have, search repositories activity, that allows the user to search for a repository, and then it connects to the GitHub API and loads those repositories that contain that keyword that the user searched for. So let's open the repository search repositories activity, and here I'm going to replace the existing recycler view with a compose view. So I open split view, and then I select the recycler view. I copy the existing recycler view, I comment it out, and I paste it following the commented one. I change the recycler view tag to compose view, Android X compose .ui.platform compose view, and I'm going to keep most of these existing attributes like the ID and constraints. I'm gonna remove scroll bars, and yes, we're good to go. Also, I'm going to change the constraints that I have here. I'm going to remove the top constraint from the retry button, and also I'm going to remove the top constraint from the progress bar. Actually, I'm gonna remove the visibility, make them invisible. So make them invisible. Attributes, visibility, invisible, and now the progress bar, it's invisible. Back to the code view, retry button. Yes, it's invisible. And next I go to my activity code, and here I'm gonna remove the parts that are working with adapters. The list doesn't accept an adapter, so I comment out this part. And binding the list that invisible. Because we are not going to need adapter, I comment out the adapter code here. Like this. And we have a binding. You can see we have a binding for our layout for the activity. It is set as the content of this activity, and we have the search method that is called from the onCreate. You can see the initializations that are being performed. Let's reload from disk. So that activity search repositories binding is resolved. A view binding has been used in this project. And binding.list add item decoration is not available. We don't need decoration for lazy column. We initialize the view model init adapter. We don't need it, so I comment it out. We receive the query from the user or use the default query, and we search for the query, and then init search that deals with search controls and initialize the search when the user presses search. And we have the retry button that is given an onClick listener. We don't need it. And in the search function, I'm going to implement my list. So as you can see, we have a coroutine scope for performing the search, and inside it I'm going to access binding.list, which is my compose view, and then apply. First I set the view composition strategy. I set it to view composition strategy dot dispose on view tree lifecycle destroyed. You can use other available values as well. And then I set content. Inside the set content, I access my view model in order to get the data from my paging library. So val, I get the data from the view model. So val lazy items, I call this variable lazy items, and then view model dot search repo, and then I pass the query, and then from the result, which is a flow, I collect items as lazy paging items. Now I can pass it to the items composable, the items function inside lazy column. So I create lazy column, import lazy column. Inside the body of the lazy column, first I check for the loading state. So if lazy items dot load state dot refresh, if it is being currently refreshed, equals load state dot loading, then I display a message that the user needs to wait. Please wait for items to load. Import text. I give it a modifier. Import modifier. Modifier wrap content width. And I put the text inside item, because we are in a lazy list scope. We need to use item to hold our content. And then we display the list items with items. There are several overloads of items. One of them receives lazy paging items. That's what we need. So I pass lazy items to it, and then we create its body. And in the body, because the item type that we receive has UI model type, and if you look at the definition of UI model, you will see that it has two types. It can be either repo item or separator item. So we check for it. If item is UI model dot repo item, then I use the repo UI composable that I have already created to display that item. Here's the preview for repo UI that I have created earlier in Compose. So repo UI, I pass in item.repo for it, and else if item is UI model.separator item. If it is a separator item, then I use the separator UI composable that I have created from before. Okay, let's fix some minimal errors that we have. Our list is now a compose view, so it doesn't support scroll to position. So I comment out this part, and the adapter is not needed anymore. So comment all this part like this, and the lifecycle scope.launch part, and let's run the application to see if it works. Okay, it's not loaded yet. I have some connection problem probably. I go to my layout for activity search and make sure that progress bar is invisible. visibility, invisible. I run it again. So I go back to my search repositories activity, and here seems like we have some errors. I reload from disk, sync project with Gradle files. Hopefully these red lines will disappear. So lazy column, searching for load state. Let's add another if statement for the append condition. If the list is being appended with new items, if lazy items dot load state dot append equals load state. If new items are being loaded into the list, load state dot loading, then I display a circular progress indicator. I add a modifier to it with fill max width and wrap content width to align it in the center with the default value of center horizontally, so I don't specify anything. And I put it inside an item because we are in a lazy list scope. Like this. And also I removed the code that was searching for repositories from before and passing the items to the adapter. We don't need it because we are making another call to search repo. So I run the application again. There we go. It is now displaying the list using our composables and using lazy column. So that's basically how you can display data from a paging library, in a lazy column. It removes the need for adapters and it removes a lot of the complexities of the paging adapter and paging library. All you need to do is go to my Android Paging GitHub repository, which is a fork of Android Paging code lab, and from the Compose branch you can find a tag that says start here. You can get the code that is the starting point where you will add the list and convert the existing recycler view to a lazy column. Welcome to a new section of the course. In this section, we will talk about theming in Compose. First, let's talk about material theme, which is the theming system used by default in every Compose application created in Android Studio. Let's see how a material theme works. Note that material design and material theme is a quite complicated and complex design system, but it allows your application to have a consistent look and feel across the different parts of your application. Let's take a look at are theme that is created in a sample application that has been created before, and let's see how it works. As you can see, I have created a sample application called Theming Play, and it has a main activity. In that main activity, I have created a sample UI. I have created a composable called main screen, the result of which is visible on the preview screen as you see now. It's a simple scaffold created using the scaffold composable. It has a top bar, a body, a floating action button, a button bar with several items, and it also has a very simple drawer, also with 2 sample items. So as you can see, it has a certain color in the light theme, and it has the button. It has one button here in the body and one floating action button. These buttons have round corners by default. These are all related to the default behavior of material theme that has been applied to this UI. And material theme has been used in the theme of this application that is called Theming Play theme, which is the name of the application plus the word theme. So every Compose application that you create by default creates a theme called the name of your application plus the word theme, and it is created in a file called theme.kt inside the theme package of your application, which is in turn located inside the UI package of your application package. So if you open the theme file, you see that there's a composable by the name of your application theme. It takes a parameter called dark theme, which allows you to pass the current state of your application and your system, in fact, whether it is in dark theme or light theme. It has a method called isSystem in dark theme, which allows you to know whether your system is currently in the dark theme or light theme. So if it is light theme, it will show you this UI. But if it is dark theme, it will change the theme of your application to dark theme, which will change the colors accordingly. Also, note that a material theme has several main and principal components which it is made of: the colors, the shapes, and the type. These are the 3 main components of a material theme. And how do we know that these are used in a material theme implementation? Using this function, using this composable, in fact. As you can see, material theme takes several parameters: colors, typography, shapes, and content. Content is in fact the content that we create in our application, like the thing that I have defined here, my scaffold, or anything else that you want to create and define in your application. Colors is the colors that we want to be defined in material terms, which we'll talk about more in a second. And the typography allows us to customize the typography, the fonts, the font weight, and everything related to text in our application. And shapes allows us to customize the shapes of different components of our application, like the buttons, allowing us to have round corners, how much of roundness we have, or if we want to have cut corners, not just round corners. So we can customize all of them using this parameter in our material theme implementation. As you can see, we simply create a wrapper for material theme. We create a wrapper called the name of the theme of our application, in which we define the colors that we want for our theme based on whether it is dark theme or light theme. And then we call material theme and we pass along our content to it. So the content that the user has provided, that we have provided, is passed along to material theme, which assigns it to its content parameter. Next, let's see how this color parameter is defined. Note that we have a file called color.kt, which contains the definition of the colors that we use. So let's open it. As you can see, we have several colors: purple 200, purple 500, purple 700. These are the three colors that define the main colors that we will use. And then we have teal 200, which we will use a little bit more rarely in the application, in the theme. Let's see how it is used in the theme. We have a variable called dark color palette and another one light color palette, which are used for dark and light themes respectively. So let's check out the dark color palette definition. As you can see, for dark color palette, we have a call to dark colors, which is a helper method from the material package, allowing us to define the set of colors that we will use in our app's dark theme. And for that, we have three main colors that we need to define: primary, primary variant, and secondary. And the teal color that we saw earlier in the color.kt file is used here as the secondary file, as the secondary parameter for this method. And then we have the other variable, light color palette, which uses another helper method called light colors that define a set of colors that we will use for the light theme of our application. And for this one, we use purple 500 for primary, purple 700 for primary variant, and secondary for and teal 200 for the secondary parameter of this variable. So as I said earlier, material design is a complicated design system, and to learn more about material theme and material theming, you can check out the material docs on material.io website. However, what we need to know right now is that a material theme is mainly composed of three main components: color, shape, and type. And once you customize these three components for your theme in your Compose app, you have a unique and personalized theme for your application and for your brand. So that's it for this video. In the next video, we will customize the theme of this application so that we can have a quite customized and personalized look and feel for our Compose app. Okay, now let's customize our material theme for our Compose app. First, let's start with the typography. To customize our typography, I open my theming play theme definition, and as you can see, we have a variable defined called typography that is passed along to the typography parameter of material theme composable. So typography, as you can see, is defined in the type.kt file, and it only defines the value for the body1 parameter, and it doesn't do much. In fact, it just uses the default font family for the font family parameter of body1, and normal font weight for font weight, and 16 sp for font size. Now what we can do, we can define and customize different components and parameters like h1, h2, h3, which mean all headers, subtitle 1, subtitle 2, body 1, body 2, and so on and so forth. However, in order to have a consistent font family, which is recommended by Material Design, Material Design recommends you to use a limited number of font families across your application. So what I'm gonna do is define a default font family to be used with all different text styles in my theme by defining the value of default font family parameter of typography. So this takes a font family value. So let's define a font family. I define it using that font family function. As you can see, it's a function from the fontfamily.kt file, and it takes several variables, several fonts, for which I'm gonna pass only one font. I'm gonna load a font from my resources and use it across my app for displaying text. I have already downloaded a file from Google Fonts. It's a font, in fact. Let's go to my downloads folder. It's called Handily. I copy it. I go back to Android Studio, go to the resources section, and here right click, new Android resource directory. For resource type, I select font. By typing F, it selects font, and then OK. I press my font here by pressing Ctrl and V. I paste it here, and then I change the name of the font to comply with the naming conventions and requirements of resources in Android. Handley, regular, and OK. Now I can use it for the font function, r.font.handley regular. Just like this, I define the default font family that can be used across my app for displaying text. Now I go back to my main activity and refresh my preview, and hopefully the text will reflect the changes. There we go. As you can see, the text changed to my new theme font that I have defined. So this way I customized the typography of my theme. Also note that before I go any further, let's see the effect of using the light theme, dark theme parameter of material theme and see how it affects our application. Let's open the theme file, and when we are calling the theme of our application, in fact we can do it in the preview, theming play. Here's where I preview my UI, and for dark theme I pass through to show you the effect of it, and refresh the preview. There we go. This is the default behavior of material theme. When we change it to dark theme, it changes the colors accordingly, as you can see, and it shows beautifully a default implementation of dark theme for our application, and it's pretty nice. So let's now change back to light theme and go further with our customization. Okay, next I'm gonna customize the colors, the color system that is defined. I'm gonna define a family of red colors for my theme, for the theme of my application. So I define red 200, and I define a color like, we know that RGB is FF like this, and the first one is for the alpha, so I defined the second pair as FF, which changes that color to red. But this needs to be red 200, the 200, so I click this icon here, and from this drop down I go to material 200 because this intensity needs to be 200, and I select this color. Now I copy the resulting hex for the color, and it changes that. In fact, we didn't need to copy that color, it automatically updates this value over here. Next I define red 500, I go color, and I'm gonna copy the same color over here for now, but we will customize it. We will go from the drop down to material 500 and then select the color again. The hex value is updated to the new selection. Let's continue. Val, this time red 700. I paste the same value, but we will customize it. I open it by pressing the icon, and I change the intensity to material 700, and the color I selected. The hex value is updated to the selection, and instead of teal 200, let's select a new color like cyan 200, for example. Again, I paste the same color here, but we will customize it. Let's select a color like green, but its intensity needs to be 200. Yeah, it's automatically updated to the selected value, and let's call it green 200 because it was a green family. Alright, now that we have defined a set of colors, let's use it in our theme. I go back to my theme, and in the body of dark colors and light colors, I will use these new customized colors. I comment out these 3 lines and define my own colors. Primary. For primary, I use a red 500, red 200. For primary variant, I use red 700, and for secondary, I use green 200. Next, I do a similar thing in the body of light colors. For primary, I use red 500. For primary variant, I use red 700. And for secondary, I use green 200. I hope that the result of this color customization is not something awful and we can deal with it. Let's wait for, yeah, not bad. We could change the color of that green color to something better from the blue family, for example, but it's fine. It's a matter of taste after all. So this way we customized the result, the color theme of our application, by defining a set of colors and passing it along to the colors parameter or material theme. Let's see how it looks in the dark theme. So in the preview, I pass the dark theme as true and update the preview. Okay, not bad. So you can see that in dark theme, not all of the colors that we defined are used. For surfaces, we often have a family of dark colors, something from the black family. But for buttons, we have we can see the color that we have defined, our customized color. And this is necessary to ensure that this complies with material design requirements, and every component that is defined is visible, and this set of rules is defined by material theme to have maximum usability of our application and of our UI, and maximum usability and visibility. So let's change back to light theme and continue our customization of the theme with shapes. This time we're gonna customize the shape of our material theme for our Compose app. As you can see, by default we have round corners for shapes. We have round corners for buttons, which are considered small components in material terminology. For this button we have round corners, for the floating action button, for this button as well, and for large buttons, for large components, we have 0 round corners. We don't have any round corners, and this is intended. In fact, this is defined in the shape.kt file. As you can see, there's a very simple definition and customization already in place. For small components, we have rounded corner shapes of 8 depth. For medium ones, we have rounded corners with the 4 dp amount, and for large ones we have 0 round corners. What I'm gonna do is change this a little bit so that we see that in action, how it changes the shape behavior and shape appearance of components of our application. Note that an example of medium shapes in material components is alert dialogues. And for small ones, as I said, buttons are considered small, and for large ones we have something like the modal drawers and drawers in general. So I'm gonna first customize the large components. So let's change it from 0 to something quite observable like 32, and refresh the preview. Okay, the preview is refreshed. As you can see, once we open the model drawer, it reflects the change that we applied to the shape. We have now round corners with the amount of 32 dp, and it's quite nice. So based on your taste, you might want to have round corners for large components or not. We can also, in addition to round corners that is defined by a rounded corner shape, we can have cut corner shape. So for example, for small components like buttons, I'm gonna change it from rounded corner to cut corner shape. So cut corner shape with the amount of 8 depth, and refresh the preview. There we go. The buttons have now our customized shape, which is cut corner, and it's quite nice. So we changed from round corners to cut corner shapes by defining the amount of cut that we wanted to have for our buttons, for our small components. You don't have to define the roundness or cut corner shape for all 4 corners of your shape. You can have it for either one of these corners or for a few of them, and leave the other ones intact. And this is true about most regular buttons, but it's not true about fab or floating action button. And this is I think something intended in material design, that you cannot have a different corner from other corners for a fab. If you define a cut corner for one corner, it will have cut corners for all other three corners as well. And that's true about round corners as well. You cannot have round corner for one corner and zero or other type of corner for other three corners of your fab. So let's customize just a few of the corners of our regular button. I go to my shape.kt file and I'm gonna change the type of the cut corner that I want for only the top start corner, which is this corner, and leave the other ones intact. There we go. As you can see, now we have the cut corner and customized corner for only one corner of our button, the top start corner. Then we have top end and bottom start and bottom end. So to have it more beautiful, I changed the bottom end corner as well to cut corner. So bottom end, and I change it to an 8 depth as well. Refresh the preview. There we go. We are starting to have a completely customized theme and brand for ourselves, and it's nice. So once we have customized these stuff, we know that how we can customize the shapes, mainly the corners of our application. We can do a similar thing for our large components like the model drawer. I can customize only the top end and bottom end corner of my model drawer this way. Now, before applying the change, we have the round corners for all four corners, but let's refresh the preview, and then we will have for two of them as well only. Okay, the preview is applied. There we go, and it's nice. Now we have the round corners only for the sides that are facing the user. It's beautiful, isn't it? So that's it, how you customize your Compose material theme in your application. Before I wrap up this video, note that if you want to use the values that you have passed to your theme, to your material theme in your theme.kt file, for example, you have passed in colors, you have passed in typography, you have passed in shapes, but inside your application, in the deepest branches of your UI tree, you are, for example, you need to use one of these values. How do you do that? In fact, material theme makes it very easy for us by providing us with values that we can access. For example, if you want to access colors inside your tree, let's do that with a more practical example. For example, I want to have a tint for my icon. Yes. For example, I want to have a tint for one of my icons, and I want to use one of the colors that I have defined in my material theme. So I simply say material theme dot colors dot one of the components of the colors that we define, primary variant, or secondary. So let's use secondary. Let's apply the changes by refreshing the preview. So if I zoom in, you can see that the tint has been applied, and it is using the color that we had defined inside our theme as the secondary color of our material theme, and it is applied here. So my point here is that if you ever need to use the colors or any other parameters that you have passed to your material theme, all you need to do is call material theme dot that field, like colors, like typography, like shapes, and it is available for you, because material theme defines an object called material theme using the values that you have passed to the material theme composable, and then it makes it available to you across your UI tree. So wherever you need it, just call it and use it, and it's quite amazing and nice. So I hope that I made myself understood, and I hope that you liked this video. See you in the next one. Let's see how we can customize the theme of our Compose application. We have three approaches to customizing our Compose theme. The first one is by extending material theme. The second one is by replacing some design types of material design system or material theme. And the third one is by designing a completely custom design system to use instead of material theme. In this video, I'm going to talk about the first one, extending material theme. Let's see how it works. The easiest way to customize a specific property of your theme is by adding an extension property to your theme. For example, I have a floating action button and I want to have a custom color for it. Because this is a minor change that I want to apply to material theme, I can add simply an extension property to material theme to be used whenever I want to customize my material floating action button. So let's see how it's done. And before that, note that this is a simple application that I have created. It has a material scaffold with top bar, with button bar, and some components that are designed with very simple design here. So I go to the theme.kt file and add my extension property here. Because it's part of the colors class, and we know that colors is used by material theme, I define it like this: val colors dot fab color. Let's name it fab color, and its type we know that is color, and to access it I make it a getter, and then I say if is light, which means if we are using a light set of colors, then use this color, return this color, otherwise return this color. And which colors? Let's design them, let's define them. I fill them with F so that I can access this nice icon here and I can customize it. Let's see, let's say for the light theme we want to have let's use this drop down over here, this color. For the light theme, let's use the 300 intensity of this color, the second color from the top left, and I'm gonna copy and paste the same color for the second color, and then I open the icon and then select the higher intensity for the dark theme, 700 intensity, the same color. Okay, now that we have defined an extension property that is a goodness from something good, some good characteristic of the Kotlin programming language, allowing us to add an extension property to a class, we can use it wherever we want inside our application. In the definition of my floating action button, which is located in main activity, I go and find my floating action button and then look for customization of colors. By pressing Ctrl P, I can see that it has, thankfully, background color and content color. I can customize either of these. I customize background color. And just to show you how it works, I access material theme dot colors and then my custom property fab color. This might look a little bit miraculous to you, but it's nice. It's nothing special. It's just an extension property for the colors class, which is in turn used by the material theme object. If you open material theme, you can see that it has a member of colors that is using the local colors composition local, allowing us to use some special values of colors. Okay, let's refresh the preview to see if the effect is applied. Nice. So you can see I have two previews, light and dark, and I get the intended colors for light and dark, the colors that I defined for the floating action button. What I just showed you was a simple and minor change that I wanted to have in my material theme. But what if we have a little bit more complicated customization to do? For example, we are defining a set of colors like background color and content color that we want to use for buttons. In that case, it's recommended not to use extension properties. Instead, we are recommended to use a special class that we define to encapsulate those custom values, those custom properties. I create an immutable data class for that, and you need to make it immutable to make it compose friendly. Data class, I'm gonna name it my button colors. For this custom class, I'm gonna define two properties, background color and content color. So val background color as the first member, and Android Studio is playing intelligent here and making me a little bit nervous. Background color, its type is color, and then I have content color, and once you have defined your custom class, you need to define also a local composition for it. And later we'll probably have a dedicated section to talk about composition locals, but for now, composition locals allow us to provide our custom values two UI trees, something like what global variables do in programming languages. So let's define val local my button colors. We define our static composition local of. We define the composition local using this function static composition local of. We import it, and then I specify an instance of my button colors, my custom class, with initial values of color dot unspecified for background and color dot unspecified for content color. Okay, my local composition variable is ready, and now I need to pass it to my theme and to my UI tree. This is a tricky part, but you will easily get a hold on. We need to create an instance of the class that we created to pass it with the values that we want to the UI tree. So my button colors, I create an instance of my button colors with the values that I want. For background color, use this value, and for content color, use this value. Which value? Let's now define them. If is system in dark theme. If we are in dark theme, use this color. Otherwise, use this color. And we will define the colors shortly. And for the content colors, well, if is system in dark theme, use this color. Otherwise, use this color. Note that you will not normally need to do that, defining both colors, background color and content color. Material theme has a specific function called content color for that allows us to have automatic content color selection for the given background color. But because I'm talking about defining custom classes that customize our theme and use it for our theme, this is how we do it. So is system in dark theme, use this color. Which color? FF 0 0 0. If okay. I had an error with my if statement. If we are in dark theme, then use this color for background. Which color for the background? Let's see. For the dark theme, use this color for the background. And if we are in light theme, then for the background use this color, for example. And for the content color, let's define the colors that we want. Use the black color for as the content color in dark theme, and in light theme use, this is just an arbitrary color that I'm defining. I will customize it. In the light theme, use this color. Use, for example, white as the content color. In fact, let's replace them. In the dark theme, use white color as content color, and in the white theme, in the light theme, then use a black color as the content color. All right. Now that we have defined our custom value, let's provide it using a composition local provider to our UI tree. Composition local provider with some body that we will fill in soon. Let's import composition local provider and provide our values inside its parentheses. We are only providing one value, one composition local, and it is local my button colors. So local my button colors provides, this is how you should use it. Local my button colors, the name of your composition local, then the infix function provides, and then the value that we want to pass along. The value is this, my button colors. So my button colors, and then the body that we want to take the effect of this composition local is this material theme. In fact, this way we are wrapping material theme with our custom theme. This is also the meaning of extending material theme, because we are relying mostly on the properties of material theme, but we are also passing our customizations to material theme content. Okay, now in order to use it, instead of making the customizations directly to a composable like our button, because we are defining the customizations with that class for the buttons, instead of directly applying them, we will define a custom composable and then wrap the material composable inside that composable and apply our theming values to inside that composable. Let's see that in action. I go to main activity and I'm gonna create a custom button. I type comp and then press enter. I name my composable my button, and because I want this to look like a button and act like a button, it should have a signature similar to material button. So I'm gonna define its signature with one parameter named onClick, which is lambda, a modifier with an empty modifier as its default value, and also its content, which is a composable lambda. Composable, and because I want to allow the content that is passed to the button to be placed in a row, I'm gonna make this a row scope. This way. Content's type is a composable and it's defined like this. Okay, now let's use the button, material button. For the onClick of button, I'm gonna pass the onClick value that I have received. For modifier, I'm gonna pass the modifier that I have received. And for the content, I pass the content. Then where do we apply those customizations that we intended to apply? We will apply them using the color related parameters of button. And fortunately we have colors for it. Colors, we define it with button colors, helper class, it is button defaults, helper class, and then button colors function, allowing us to pass in custom colors for our button. For the background color, I'm gonna use the value that I have defined for the background, and for content color, I'm gonna use the color that I have defined for the content. But we don't have an object like material theme dot colors for our theme to access those values. What do we do now? Okay, we need to define an object or a singleton like what we have for material theme with the name of our theme. Its name is custom theming theme, so I copy its name. Then I define an object with that name and pass the latest value of my local composition for the my button colors to that object, and put it as a member of this object. So val my button colors, its type is my button colors, and I'm gonna use it in compose context, so I'm gonna make it a composable get. Then I access it using local my button colors dot current, like this. Okay, after all this hard work, we can access that custom value using custom theming theme dot my button colors dot background color for the background, and custom theming theme dot my button colors dot content color for the content color. Okay, are we done? Not yet, because we need to replace the stock button that we have used in our UI with our custom button. Let's go to our UI tree definition and find the button. Where is it? It's here. Yes. Let's add the button here, my button. For the onClick, I'm gonna pass the value that I had previously passed to onClick for the stack button. So I copy that and I paste it here. Then I have modifier. For modifier, I add the modifications from the previous button. It's only an align parameter, so I add it here. And then I have the content. I'm copying the content and put it in the body of the button, like this. Okay, now I can get rid of the previous button. Refresh the preview. There we go. As you can see, we have different set of colors for our button in light and dark theme based on the colors that we defined in our custom color set definition. And remember, it's important when you are extending material theme to wrap material components in your custom composables when you are applying custom material theming values, because otherwise you will pollute your application with a lot of complicated customizations that later it will be hard to manage. So keep that in mind. This was for how to customize your Compose theme by extending material theme. I see you in the next video. In the previous video, we talked about customizing our application theme in Compose by extending material theme. In this video, we will be talking about replacing some of the systems of design in material theme. For example, we can replace the existing colors system or typography or shapes. As an example, for the application that we have from the previous video, I'm going to replace some of the existing systems. For example, I can replace the typography as well as the colors and keep the shapes as they are. So let's get started doing it. I go to the theme directory in my packages, and here I have my theme file, and it defines the existing definitions that result in the current look and feel of my application. Here I create a new design system, design system to replace typography. For example, I create a new file, a new Kotlin file, and I name it my substitute type.kt. It's not a class, of course. First, I create a class for it, but the file is not the class. Immutable data class, my substitute type, and I'm gonna make a very simple typography. It's going to have one header and one normal typography. So let's define it as val header, its text style as the type. I import text style from Compose packages, and I add also body for body text. Its type is text style again. I also add a parameter for default font family, and its type is font family. I import font family from UI text.font package. Then I create a local composition for it, a local composition type. I name it val local my substitute type, and I create an instance of it by using static composition local of. I create one type, one instance of my substitute type as the default font family. I use font family.default, and as header I use text style.default. As body I use text style.default. And that's it for my substitute type. I create now another file for the colors. I name it, it's a Kotlin file, my substitute substitute color. I create an immutable class to hold the values that I desire for it. I create a data class, my substitute color, and again I'm going to make it very simple. I'm going to use a few colors like background color and content color. So val background color with the type of color, and val, let's also import the color from Compose UI graphics package, and content color, its type is color. Let's create an instance of composition local for it. I name it val local, my substitute color. Make sure that you start your local composition variables with the word local. It's a convention for these types of variables. I create an instance with static composition local of, a new instance with my substitute color. For background color, I use color.unspecified because these are the initial values and later I will specify them. And for content color, I use color.unspecified. That's it for these replacement types or substitute types. Now I go to my theme file and I then go to my custom theming theme object and add two fields, add two members to return the latest values of my substitute types. So val, I name it my substitute type. I specify its type. I receive it using a getter, which is also a composable, and I access it with local my substitute type.current, and I create another member for my substitute color. Its type is my substitute color, composable, get local my substitute color dot current, and inside the body of the theme composable, which is custom theming theme, I create two variables to specify my values for these two types that I want to pass along to my theme. So first I create a variable, my substitute color, to create a new instance of it, and for background color I specify one value, and for content color similarly. For the value of background color, I check for is dark, which is passed to us as a parameter. It's dark theme. It's a Boolean parameter. So if dark theme, I use, for example, color dot light gray as background color, and otherwise I use color dot white as background color. And for content color, again I check for dark theme. If it is dark theme, I use color dot white, otherwise I use color dot black as the content color. In fact, for dark theme I'm gonna use yellow as content color. Just very simple colors. Let's now create an instance of my substitute type. My substitute type, it has default font family. Let's specify a font family for it. Importing font from UI text.font package and font family. I need to specify a font from my resources. I have two fonts. I can specify one, like I'm going to use Gucci hand. So R is not resolved here apparently, so I use the full package name, example dot custom theming, the package path of my application, and then R, and then font dot Gucci hand. So this is for my default font family. Then the next parameter, header, I use a text style with font size. For font size I'm gonna use something like 40 sp, and for the body I'm gonna use a smaller font size, text style 20 sp for the font size. As you see, it has many parameters, the text style, but I specify only the most significant one, which is font size. And for font family I'm gonna use the default font family, and to make it easier to use I'm gonna specify font family here. Font family font, just the same font, use it here. And I'm gonna copy the same font family for the body as well, font family, paste it here. There we go. Now I'm gonna pass these new defined instances to my theme with local my substitute color and type. Local my substitute type provides my substitute type, and local my substitute color provides my substitute color. Okay, now that we are going to substitute the existing colors and typography with our own color and typography. I'm gonna skip passing colors and typography from our previous values, so I remove them, or we can simply comment them out, colors and typography. And now let's go to our main activity and refresh our preview, see what we have and whether it has any effect so far or not. There we go. As you can see, although we have replaced the colors and typography, we are still seeing not much difference in terms of our look and feel of the application, and that's because we are still using material components, and material components have their reasonable defaults. So in order to customize your components after you have replaced some of your design types, you need to wrap your composables. You need to wrap the material components in your custom composables and then directly apply your desired style from your replacement types. So what I do now, I go to main activity and I start, for example, with the button. I go and find the button. As you can see, I have already replaced the button with my button, which is my composable to wrap material component of button, but it doesn't yet follow the exact styling that I intend for it. So I go to the definition of my button, and here I define its colors using the new color type that I defined in this video. So I remove the color styling that I had added in the previous video, and I use button defaults dot button colors to define the colors using my new color type, and I use the name of my theme object, custom theming theme dot my substitute color dot background color. This is for background color, and for content color I'm gonna use custom theming theme dot my substitute color dot content color. So now I get my color types and my colors for the button from my substitute types in my theme. So refresh the preview. As you can see, the button is not yet following the new colors that I specified for it. Let's check the other button. Okay. No, in fact it is working. For the button, it is using the white color as the background color in the light theme and black as content color, and in the dark theme it is using yellow on light gray. It's not very beautiful, but it works. Let's change the background a little bit to something with more contrast, like dark gray. So I go to my substitute, in fact my theme.kt file, and when specifying the color that I use, my substitute color, let's use dark gray here. And while it's being refreshed, as you can see, we have only customized the color, but although our theme provides a substitute typography, the typography does not follow our substitute type. Why is that? The reason is that when you are wrapping material components in your custom composables, you cannot specify the text style for your composables content with parameters. You have to use provider functions, and in this example here for our my button, we are not yet doing it. In order to do it, we need to find the content part, and it's this parameter, and then we need to wrap our content inside a lambda like this, and then we need to wrap the content again with provider function like provide text style, which is specifically used to provide text style and typography. So provide text style, and we specify the text style that we are going to use for that element's content, and that is again extracted from our theme object, which is custom theming theme dot my substitute type, and then we can use either header or body. Header is too big for the button, so I use body. And then because we put the content inside curly braces or the body of this function, we need to invoke it with parentheses. Okay, let's refresh the preview. There we go. As you can see, our button is now styled with the typography that we have defined as the substitute typography for our customized theme. One thing that you are also noticing is that because we have replaced our color system with the customized color system, now our dark theme doesn't work as before. It doesn't show dark surfaces. It is using the same color that we have in the light theme, and that's because we have removed the colors that we were previously passing to our material theme, and we take that responsibility upon our own shoulder to customize and to style the color of the surfaces and any other component, in fact. So for these surfaces, in order to give them the color that we want, we can do a similar thing to what we did for the button. We can define a wrapping composable to hold the material component in it. For example, for this one here, which is a surface or acting as a card, we can put it in another composable, and then inside that composable we can style directly using the customized color system. So let's find this surface over here in the body of our material scaffold. It's this surface, and it starts here, it goes as far as here. I'm gonna create another composable with the name of my card. It's gonna have similar parameters like modifier. Let's in fact use the same parameters from surface. And because it has also body, I copy the content of its body. Control C and paste it in the body of my card. Then, because this is still undefined, I define a new composable, create composable my card. I adjust its parameters, default value of empty modifier, and for elevation I import dp. For shape I import corner based shape or simply shape. In fact, I'm gonna use just shape, import shape, and then its content, the last parameter, it's gonna be a composable, and I'm gonna make it a box scope. So box scope like this. Let's customize its background. I'm gonna add a box here, and inside the box, in fact, as I said, because we are going to wrap the material component with our customized composable, I'm gonna use surface here, surface, and for modifier I pass modifier. For color I need to pass the color here. It has content color also. I need to get these values from my theme, and also it has shape. I'm gonna use the shape that I'm receiving. What else do we need to specify? Also elevation that we receive from our composable. Okay, for our color, let's now specify the color from our theme. So custom theming theme dot my substitute color dot content color, sorry, background color, and for content color, custom theming theme dot my substitute color dot content color. And then we have the content, and because we want to allow the content to get styled using our custom typography, I use provide text style with the value of custom theming theme dot my substitute type dot this time let's use body again. Initially I was going to use the header, but it's going to be too big, and then let's invoke the content. And because this is inside the box scope, it wants us to provide it in a box scope, so I'm gonna put it inside the box. Like this. Alright, now let's go back to where we defined and used our my card composable, and before it we had surface. We don't need it anymore. We have replaced it with my card, so I comment it out. Now I refresh my preview. As you can see, we customized the background and the content color as well as typography of this special component. So far, as you can see, we have only customized the theme of two components, this button and this component, this surface. So it's not as simple as it seems when you opt into replacing the default color, typography or shape system used by material theme with your own system. It is certainly possible, but you'll probably have a lot of work to do, and you have a lot of customizations and creating a lot of custom components and composables for your application that need to be done. So that's it basically for how you can replace some design systems in material theme like typography, shape or color with your custom designed types, as we did in this video. I hope that you liked this video. In previous videos, we talked about customizing Compose themes by extending material theme or by replacing some material systems of material theme. In this lesson, we will be talking about another way of customizing Compose theme, which is designing a completely new design system from the ground up. So let's get started. First, I create a new folder in my UI package. I create a new package and I name it my theme, and inside it I'm gonna create some replacements for my theme to replace the equivalent of design systems in material theme. So let's create one for shape. I name it my shape. I create another for typography, my type, another for color. And because material theme also provides things like content alpha, we are gonna create equivalent for them as well. So I create another one for content alpha. Note that content alpha in material theme is used to emphasize and de-emphasize elements like text and icons. And in addition to that, material theme also provides ripple theme and some other things like text selection colors. So if we are going to create our own theme, we probably need to think about these elements and replace them as well. So let's start creating my type. First, I'm going to create a data class similar to what we have done before. I make it an immutable class and I name it my type, and it's gonna have some elements, some members, val. I'm gonna create a very simple type that has small, medium and large text. So for small, I'm gonna create it. It's gonna be a text style. Its type. Let's import text style. Val medium text style and val large text style. It's also going to have a default font family. To specify font family that is default for using in text elements. And then I'm gonna create a local composition for this, val local my type, static composition local of my type. For font family, I use font family default, text style dot default for small and medium and large default, and text style default. Now let's go to the color and create it as well. A data class that is immutable. Import immutable. And then I'm gonna have some members that represent colors. For example, background color, content color, and button colors. I'm gonna define a separate color for buttons. So val background color, val content color, and val button color, which is also color, import color. Also, I'm gonna create a color to represent the background color of the bars, like top bar and bottom bar, and it's going to be a gradient. And in order to create a gradient, we need at least two colors. So I define two colors, val bar color. So it's gonna be a list of colors. So our specific color system is going to have one special type of color that is gradient and consists of two colors. Let's create a local composition for this. Local my color, static composition local of my color, color dot unspecified. Initially we initialize these colors to unspecified, but later we will pass appropriate values to them. Color dot unspecified and list and an empty list for the latest field. So our color is created. Let's now create our shape. Again, I create an immutable data class. I name it my shape, and I'm gonna create a simple shape system that has shapes for buttons and components or for surfaces. So button shape is gonna be a shape. Let's import shape. And val surfaces or surface shape, and it's gonna be a shape again. Let's create a local composition for it. Val local my shape, static composition local of my shape, and it's gonna be simple shape initially, rectangle shape and rectangle shape, but we will obviously customize them when we want to use them in our theme. And for content alpha, I'm gonna create a content alpha object, my content alpha, and it's gonna be several levels of alpha to emphasize and de-emphasize elements. So small or low, val low, and for low it's gonna be 0.3f, and val medium is gonna be 0.6f, and val high is gonna be 1f. Let's also make them const. Okay, now we can create our theme. I create another Kotlin file. I name it my theme or new theme. It's gonna be my theme name. And it needs to be a composable new theme. It has a Boolean parameter called isDark, and its default value is system in dark theme. And it also has a content parameter, which is a composable unit, and inside this we are gonna create the values that we need for our theme from our special types and pass them to our theme. So let's create them. Val colors, my color, background color, content color, and button color, as well as bar color. Okay, let's start with background color. For background color, we say if we are in dark theme, if is dark, then give this color, otherwise this color. Let's create a simple color, import color. Okay, I have added 1, 2, 3, 4, 5. And 0x ff 00 ff 00. I will customize both of them. For background color of our dark theme, I'm gonna pass a color like this color, and for light theme I'm gonna use this color. Let's select material 300, intensity, and second color from the right. Now for the content color, again we say if is dark, use this color, otherwise use this color. Let's copy these colors and customize them. For content color in the dark mode, I select A700 intensity, and for content color, let's use actually I'm going to select color white. White in dark mode and color dot black in light mode. Now select the button colors. If is dark, then select this color with the value that we copied earlier, and in light theme use this color. Again, I paste the same color, but I will customize it. For button color in dark theme, let's use this color from the 700 intensity. Let's use this color. Third from the left in dark theme, and for the light theme, let's select the same color from A700 intensity. And for bar color, I'm gonna pass in a list of colors, a list of 2 colors in fact. Let's pass 2 colors. I'm gonna use again A700 intensity, and I'm gonna use yellow and red. Alright, this is for our colors. Let's create shapes. My shape, for button shape, let's create a rounded corner shape with corners from the top start and bottom end. So top start 8 depth and bottom end 8 depth. And for surface shape, let's use a cut corner shape, import cut corner shape, and this time I'm gonna cut it from top end and bottom start. So top end 16 depth and bottom top end and bottom start 16 depth. Let's create our next variable for typography. Val typography. I create my type, and for default font family I use font family font, import font and font family r dot font dot r dot font dot, let's import font r Gucci hand. This is a font I have saved in my resources. Small, for small I'm gonna use text style. Let's use a font size of 10 sp and the font family with the same value as the previous parameter. For medium I'm gonna copy the same line and I'm gonna change the font size. I'm gonna change it to 20 sp, and for large I'm gonna paste the same line but with a bigger font size, like 40 sp. Okay, this is for our typography. Now let's create our elevation system. We can create a custom elevation to pass to our elements like our buttons. So I'm gonna create a type for it, my elevation. Let's create a data class called my elevation. You can create as many desired custom systems as you want for your theme. This is just another custom type that I'm creating to use for my theme. Let's create two values and two fields for our elevation, like normal and pressed. So for normal, its type is gonna be depth, and val pressed. Let's create a local composition for it, local my elevation, static composition local of. I created using a static composition local of, and my elevation. Initially I pass it as unspecified, but later I will give specific values to pass to my theme. So normal in normal state, and pressed when we press something like the button, a button. So I go back to my theme. I create an elevation, my elevation. For normal, I use 4 depth, and for pressed, I use 16 depth to create a bigger cast, a bigger shadow. This way I create a bigger shadow which shows the element has been pressed. So now that these values are ready, I can pass them to my theme. So I use a composition local provider for it, and I pass as many values as I want to my UI tree. So I pass local my color with the value of my colors in fact, local my type with the value of my type or typography here, local my shape provides shapes, which is the name of the variable that I have created here, and local my elevation with the value of my elevation. And also you can pass the values that are defined, values for types that are defined by material theme. For example, for text selection, you can create custom text selection and pass your values to it. So val my text selection colors and text selection colors. Import text selection from material from foundation text selection package. Import handle color. It has two members, handle color and background color. For handle color, I'm gonna use yellow, and for background color, I'm gonna use blue, or let's use light gray. So how do we pass it to our theme? This way, local text selection colors provides my text selection colors. And what about material ripple? As I mentioned earlier, also material ripple is used for material components. So if you want to customize it in your theme, you need to create an equivalent for it and pass it to your theme. So local ripple theme provides, we need to pass our value here. So let's import local ripple theme, and we need to create a ripple theme and pass it here. Let's create it as a new type. I'm gonna create a class here. I'm gonna create it my ripple, name it my ripple, and it's gonna implement material ripple or ripple theme interface. Import ripple theme, and I'm gonna press Alt and Enter on my ripple and press implement methods, and it has two methods that need to be implemented. And because this is often used in compose context, we need to make it composable. Both of these need to be composables. let's specify the color for the ripple theme. So return, here we return the color dot blue, and for the ripple alpha I'm gonna return ripple alpha, return ripple alpha. Dragged alpha, it has dragged alpha. For dragged alpha I'm gonna use 0.2f. For focused alpha I'm gonna use 0.5. For hovered, let's make it 4. For hovered alpha let's use 0.6f, and for pressed alpha let's use a full alpha of 1. Okay, now we created our custom ripple theme. Let's pass it in our theme, local ripple theme. Let's create a new my ripple here and pass it to our theme. What else do we need to create? I think we are good to go. We have text selection ripple and our shape and elevation, as well as type and color. All right, now let's call the content here. What if we want to use our theme values inside our components? We need to create an object for our theme to make them accessible. So at the bottom of my file I create an object with the name of my theme, and it's gonna have values for most of these variables that I have created and most of my custom types. So val my color, it's my color, it's type, and it's a getter. It's a composable getter, in fact, because we are using Jetpack Compose, and it returns local my color dot current, and it also has val my type. For typography, its type is my type, and it's a composable getter. So local my type dot current is its value that is returned, and val my shape, its type is my shape, and it's a composable getter again, and local my shape dot current. Okay, we can also pass our elevation, val my elevation, it's a composable again, and local my elevation dot current. What else can we pass here? I think we are good to go. What about my content alpha? It's already an object, so we can access it directly. We don't need to embed it inside our theme object. Okay. If I run this now, you expect that you see a lot of changes, but we will not. Let's press the button. Yes, we don't see much difference. What about the dark theme? Yeah, not much difference yet. So once you have created your theme, you need to make sure that you are passing your theme to your composables by wrapping your composables inside your theme. In fact, your root composables. So I go to my main activity, and in my preview as well as the set content section, I'm gonna change the theme of my composables to the new theme. So new theme, import new theme, and in the set content as well, new theme. Let's run our application so that it runs on the device as well as in the preview, shows in the preview. Okay, it's running, but we are not seeing any sign of the typography, shapes, and colors that we defined for our theme, and it's expected. In fact, the reason is that we have not defined them for our composables and components. We need to do them manually. But first, take a look at this. You can see that the ripple is already working because we have defined the ripple. We passed the ripple to our theme with the blue color. You see that it is working. And if we switch it to dark theme, in fact it was dark already, but if we go to light theme, you see it's apparently a little bit different, and it's automatically done by ripple theme object, which is an implementation of ripple theme interface that we have implemented. Okay, what about the text selection? See if it works. Some text selected. There we go, it is working. The handle color is yellow, and the text selection color, the background is light gray. Okay, now let's deal with other issues in our theme. Not in our theme, in fact, with our implementation. Let's go to our main activity. As you can see, we have some components like the button. I have my button that wraps material component of button. As I mentioned in the previous lessons, if you are using custom types and custom theme, you need to wrap material components in your own composables and make your customizations there. You should not pollute all over your application by tinkering your material components with custom values and custom theming specifications. So wrap them in your composable and do your changes there, like my button. So in my button, I'm gonna specify the colors. This time I'm gonna take the colors from my new theme. New theme for background color, new theme dot my color dot background color, and for content color I'm gonna use new theme dot my color dot content color. Let's refresh the preview. While it's being refreshed, let's also add shape. There we go. The button colors are applied. Let's now add our shape. New theme dot my shape dot button shape. Refresh it. Refresh. There we go. The shape is also applied. You can see the round corners for top start and bottom end for both dark and light themes. Okay, what about the disabled colors? In the color section, disabled content color, let's specify them. Let's use the disabled background color, and for this we are gonna use this background color. In fact, we're gonna use the content color and we are gonna compose it on the background color. So new theme dot my color dot content color. First, let's create a copy of it with a custom alpha. For its alpha, I'm gonna use new theme my content alpha. In fact, let's import it and then let's use a low alpha. And once we created a copy of that color with this alpha, then composite it over the background color, which is new theme dot my color dot background color. All right, now let's see the effect by switching it to disabled and see how it looks. This is just an example of how you can use content alpha. And there we go, it shows disabled. You can also check out the documentation for composite over, why we used it. You can see that it composites this color on top of the background color that we specified using this algorithm, Porter-Duff source over mode, which is a graphical concept. Okay, after that, let's deal with other components. Also change this back to enabled. We don't need a disabled color. All right, let's deal with our card. We already have a card here. Let's go to our main activity and check for my card. Yes, we have my card. And for colors, I'm gonna get the colors from my new theme dot my color dot background. And for content color, I'm gonna get the color from my color dot content color. There we go. And as you can see, we have also used provide text style to pass our text theme to the content inside the box. So because we have switched our theme, we need to change this as well to our new theme. So let's do that. New theme dot my type dot large. Because we are on a card, in fact, I'm gonna use a medium one. And let's also change the shape to our specific shape where my card has been called. Let's pass our own shape. New theme dot my shape dot surface shape, and again go to the definition, shape elevation. For our elevation also we can do We can pass our own elevation from the theme. So new theme dot my elevation dot normal. We can use this elevation for the button as well. Let's refresh the preview and add that elevation to the button as well. So elevation button defaults dot elevation, and get the values for default elevation and pressed elevation. For default elevation, I'm gonna use new theme dot my elevation dot normal, and for pressed one, I'm gonna use new theme dot my elevation dot pressed. There we go. Our button, our surface has taken the shape and the typography from our theme. Nice. That is great. Now refresh the preview. We have some changes that have not been applied. So far we have used shape, typography, and colors to customize some components. Next, we are going to change the color of our top and bottom bars to the gradient that we intended to use in our theme. So in order to do that, when you have a completely new specification like that gradient background, it's better to define a new component for it instead of just wrapping it in a composable. So I'm gonna create my top bar composable, or simply my bar, to use it both for the top and bottom bars. And then I'm gonna create a row and I'm gonna pass the content that I receive, content box scope. It's not box scope, it's row scope. In fact, row scope unit, and it's a composable. Row scope we put the content inside our row. We have some errors here. What is that for? Let's go to our top bar in the scaffold. It has this content, which is the text. I change it to my bar. And I define it let's delete it and create it again. My bar takes a content parameter, which is a composable. and just gonna use it in a row. Let's make this a row scope. And call the content here. Row content. Now let's modify its background. This is the tricky part. Let's also define a modifier parameter for it with a default empty modifier. Like this. And for its background, because I'm gonna use the gradient color from my theme, I use background, and for background I'm gonna define a brush, and brush allows us to create backgrounds using gradients, so I'm gonna use a horizontal gradient with two colors that I have from my theme. So I say my new theme dot my color dot bar color. This gives us the two colors that are available in the list. And there we go. This is for our top bar. And for the content, because we want to give it the text theme that we have defined in our theme, let's wrap it here. Let's provide text style new theme dot my type dot small. This is just the title, it's small, and call the content inside it. Let's do the same for our bottom bar. My bottom app bar, let's create a composable with that name, or just use my bar to make things simple. This way my bar will be called and it will put the content in a row scope with this background. So refresh the preview. Okay, there's a small problem. It doesn't take the whole width. Let's apply that. For the row, let's give it fill max width. Refresh it. There we go. It's not bad. Now let's deal with this text. It's around here, this text. Let's use my text for it. My text is not yet defined, so I'm gonna define it. Let's copy and paste this text and rename text to my text. As you can see, it takes several parameters just like text, but I'm gonna pass my text theme to it, my text style. So new theme dot my type dot large. So let's define my text, but after removing this old text or commenting it out. So Alt and Enter, I press Alt and Enter and create composable function my text. Let's name this text. Let's give it a default value of text style.default for style, and an empty modifier as default modifier. Okay, I know that it's not used. Let's now call material text with it. For text, pass text, and for style, pass style. Text align, and for modifier, let's use modifier. Modifier. Yes. Okay, refresh the preview. I don't know what this warning is saying here. Should be the first. Okay, you're right. Modifier should be the first parameter. I'm gonna put it after text. Like this. There we go. Another refresh. What about my button? My button is not yet following the text style that we give it to it, and that's because we are not using my text. So let's use my text in the body of my button, and what parameter are we missing here? Text align. Okay, let's make it a default one. Text align dot center. This way the function will not ask us for parameter when we don't provide it. Okay, the error is now gone. What else do we need to do? The surface, the bigger surface, the body. So let's create a composable for surface. Let's call it my surface. I'm gonna put everything here on top of the surface so that it can get the background color from my theme. So surface has modifier that I'm gonna take from a parameter to my surface, and shape, it has shape, color, content color, it has border, elevation, and content. Let's define these values. Modifier, and then shape, color. In fact, we are going to give those values directly from our theme rather than passing them to our composable. because this is a special component that is customized from our theme, so we are gonna get these values from our theme. So my shape dot surface shape, and for color we get it from my color dot background color, and for its content color, new theme dot my color dot content color. So we don't pass shape, we pass content, which is a composable like this. And now let's wrap everything that we have in our new composable surface. So I'm gonna pass my scaffold, I'm gonna wrap my scaffold, let's find its bounds, the scaffold ends here, so select the whole scaffold, and then Alt Enter, surround with widget, surround with container, and the container is going to be my surface. There we go. Let's refresh the preview. I hope I didn't mess up. I put my scaffold on top of my surface. Okay, it doesn't work that way. I need to undo here, and I'm gonna select the content of my scaffold, and wrap it inside my surface. So Alt and Enter, surround with widget, container, and my surface is the container. Refresh it. There we go. You can see that it is taking the effect. The problem is with my surface. It doesn't take the whole height available to it. So let's specify fill max height. There we go. Now it's better. You can see that we customize some of our components using the values from our theme. This is a theme that we created from the ground up. We replaced our material theme with this theme. You can keep customizing this theme by wrapping your composables inside, wrapping components of material design like extended floating action button, surface, and other components in your own composables, and then applying your changes there in order to have a completely custom theme. Why this button is not taking the change that we wanted for it. So my text, new theme dot my type dot medium. Refresh the preview. There we go, the button's style is changed. So you can follow the steps outlined in this lesson to create your own custom theme from the ground up and use it for your Compose applications. As a small exercise, I want you to apply the theming values that we created for this floating action button. As a hint, wrap this component in your own composable and apply the theming values from our custom theme to the composable. So I hope that you enjoyed this lesson. In this video, I'm going to show you how to add support for Material Design 3 in your Compose application. Material Design 3 is a new design system developed by the Material Design team that has new features like color schemes and dynamic colors, as well as new upgraded typography and other features that are still in development like shapes. So we have this application. It has some theme that we have designed in previous videos. It has its own theme that we designed, and now I'm going to add Material Design 3 to this application. What I do first is to go to my build.gradle file and add the Material Design 3 dependency. So I open build.gradle file from my app module, and then I add implementation androidx.compose.material3 and material3, the name of the artifact and its version. In this version of Android Studio, I can simply press Control and space and it will auto-complete it for me. The latest version is 1 alpha 9, and in order to make it consistent with other dependencies, I cut it from this point and paste it after the other material 1 in the file. This is just for beauty. It doesn't affect any functionality. I press sync now and it's added to my dependencies. And once the dependency is added, we will design a Material 3 theme for our application. So I go to the UI package of my application, and there, first let's collapse these two packages, and in the UI package I right click and press select new package. I name it M3, and inside it I'm gonna create a file called color. You can name it whatever you like. I'm gonna define color definitions inside this file, and I create another for typography, type.kt, to define the typography definitions for Material Design 3, and the final file is theme.kt, where I will define my Material Design 3 theme. Let's go to the color file and define our colors. Note that in Material Design 2 we used to use a class called colors, but in Material Design 3 we have color scheme. This is the class that we will use, but it has builder functions that we use as developers to return a color scheme for us. So I define a color scheme for light theme and a color scheme for dark theme. So for light theme, I define light color scheme, and the builder function is light color scheme. Note that once you import it, you can see that it has many different parameters, but I will define just a few of them that are so-called the primary and the main slots, the main color slots of the color scheme. So the first one is primary, then secondary. You can define all of them or many of them, but I will define just these three: primary, secondary, and tertiary. The tertiary parameter is something that we didn't have in Material Design 2. And it's like a third color that adds to the variance and variation of the colors that is available in our application. So for primary, I define a color, for secondary as well, for tertiary as well, and for primary I import it from the UI package, UI graphics package, and I add a color. For example, let's have a red color, a red family color for primary. So something like this. And for secondary, let's define a green color. So just a simple color RGB, the second pair of F's denotes green. And for tertiary, I'm gonna use yellow. So yellow is defined by mixing red and green. So we have two pairs of F's that create yellow. So this is for light color scheme. And for dark color scheme, I define another parameter, dark color scheme, that we will use for dark theme. And the builder function that I'm going to use is dark color scheme. And again, it has primary, secondary, and tertiary. At least these are the prominent colors in our application, so I'm gonna define these colors, these three colors, and I'm gonna use the same colors that we used. Let's copy it, paste it here, the same colors that we defined for the light theme. But because we are in the dark scheme, it needs to be a little bit brighter. It has currently very much contrast, and I'm gonna decrease it. In Material Design 3, we say let's use another tone of this color, because we use tonal palette in Material Design 3. But for simplicity, I just select it from here. So let's use a brighter color towards more light. So a tone starts from 0 and goes up to 100. 100 means 100% light, and 0 means 0% light. So for example, this part is 0% light, is 100% black, and this part is 100% light. So the tone is 100 at this point, and the tone is 0 at this point. So it's not that much of issue and importance here. Let's select just a color that has a higher percentage of tone. And for the green, let's do a similar thing. So I'm gonna select a color with a higher tone, and for yellow as well, something like this. So once we have the colors, let's go toward type and create our typography. I create a parameter called M3 typography, and the class that I'm gonna use to create the typography is typography from the Material 3 package. So as you can see, it has several parameters to construct the class, and as you can see, if you see it more carefully, you can see that it has a simplified system of typography. It has several groups, and each group has 3 members. For example, one group is for display, the other for headline, the other is for title, body, and label. But each group has 3 members: display large, medium, small. Again, large, medium, small, large, medium, small. So we have 5 groups of text style, and each group has 3 variants: large, medium, and small. This is why we call it a simplified typography. So I'm gonna specify just the generic display text style that I'm gonna use in my typography, and it will have effect in my application. Therefore, I'm gonna specify the 3 members of the display group. So display large text style, I import text style from UI text package, and for font family I use font family to specify a font family that I imported from the right package. Yes, and font family, let's specify the font r.font. I'm gonna import a font. Let's import R, and then this time let's use Capriola font family. This is for display large. Let's also specify font weight. Because this is a large display text style, I'm gonna use font weight dot bold or extra bold for font weight. And then we have display medium and display small. I'm gonna copy the definition of display large and paste it twice, and then rename display large to medium and display large again to small, so that I have the 3 definitions. So for the display medium, I'm gonna use the same font family but a different font weight. Let's use bold here for font weight, and for small let's use the normal font weight but with the same font family. That's it. I only specify these 3 parameters for typography, and now our typography is ready. You might ask why we don't design shapes. That's because the shape system is not yet available for Compose. It is under development, and once it is available, we can also define the upgraded shape system for Material Design 3 in our Compose applications. But for now, we can take advantage of the many exciting features that Material Design 3 has and it can have for our Compose applications. Now in the theme file, I'm gonna define my theme. With the composable, I define my M3 theme. I name it M3 theme, and like we did with other theme definitions, I specify a Boolean parameter for is dark with a default value of is system in dark theme, and also content, which is a composable. Like this. And inside the body of it, I'm gonna make a call to material theme, but the material theme from the material 3 package. Because we have added material design 3, we have access to both material design 2 and material design 3, but we use the 3 version. So material theme, and it has several parameters, as you can see: color scheme, shapes, and typography. So for color scheme, I specify color scheme. For shapes, I don't specify anything because I haven't customized the shapes. I leave it to the default. So typography, I specify typography. For color scheme, I check for when is dark. If it is dark, then I use the dark color scheme, and otherwise I use the light color scheme. And for typography, I specify the M3 typography. In order to use this theme, which should now be ready, it's not yet because we skipped the content. I need to specify the content as well. So I pass the content to it. And now my theme is ready. It's quite ready. I can use it in my application. What I'm gonna do is go to main activity and change the theme for my preview as well as my output. So let's find the preview file, the preview composable, and change the theme from new theme to M3 theme. This way you can follow the steps that we took and upgrade your Compose applications to Material Design 3. And I do the same for the set content. I change it to M3 theme. Let's run it, see if it has any effect. Okay, our application crashed. If we look at the error that we encountered in preview or in the logcat for the output, we can probably find some traces of what went wrong. We have illegal argument exception. Colors must have the length of at least 2 if color stops is omitted. And it is for the gradient part. So we created gradient, if you remember, in a previous video for one of our components, and because now we have changed our theme, probably that's causing the issue. So gradient, I'm gonna remove that part that deals with gradients and run the application again. There we go, it's running. As you can see, it is running, but it doesn't have any of the effects of the theme that we designed, nor the color, nor the typography. And that's normal. Why? Because we haven't used, in fact, material components of Material Design 3 yet. What we have used in our previous videos is Material Design 2 components. Let's see that. This is the scaffold from Material Design 2. If you open it, you can see that it's from this part. You can see that it's from Material Design 2 package. So I close it and I change it to scaffold. When I type it, I can select the scaffold from Material Design 3. So if I press enter now, it will complete the path to a scaffold to show that it is from the Material Design 3 package. So because it has a different syntax, it doesn't have scaffold state parameter, so I remove it. And I also press Ctrl P to see the different parameters that are available. As you can see, we don't see any drawer content parameter for this scaffold. Probably it's not yet available. So we need to remove that drawer part, the drawer content part. So I remove it. And I hover over it, and it needs opt-in for experimental Material 3 API. So because it is still experimental, we need to opt in by adding this opt-in annotation to the composable. And now the error is gone. So this is now using the scaffold from Material Design 3. But we also need to specify the colors from our theme for this scaffold. So let's see how it works before that. Okay, it's running. We don't see any effect of the colors yet. So I specify the color parameters like container color. So because the theme that we defined doesn't have any color specified for container, that's normal that we don't see any color available here. So I'm gonna use the primary color that we defined in our theme for the container. So container color, I access the color that we defined using material theme. Make sure to use the one from Material 3 package, and then color scheme, and then primary. And this is for scaffold. Next, I'm gonna define the colors for other components like the floating action button, and for the my bar that defines the top bar and bottom bar for our application. So let's do that first. Let's go to my bar definition, and here I'm gonna define a background, and for background color I'm gonna use I'm gonna use material theme, again from the Material 3 package, color scheme, and let's use primary. Yeah, I'm gonna use primary for the bottom and top app bars, and secondary for the container. So let's go to our scaffold definition and change the container color from primary to secondary. And for our floating action button, let's find our floating action button. Yes, floating action button. It's the extended floating action button. I'm gonna use the extended floating action button from material 3 package, like this. And let's remove the parameters that are not available, like background color. And let's see what other parameters it has. Container color. For container color, I'm gonna customize it by using the tertiary color, material theme dot color scheme and tertiary. You might think that this is an ugly way to specify the color because the package name is very long, but that's how we have to do it now because we are using both design systems, Material Design 2 and Material Design 3. And if I removed Material Design 2 completely, my application would probably crash and break. So because we are doing a gradual upgrade, we have to go with this method for now. So now that I defined the custom colors from my new Material Design 3 theme, let's run application. There we go. You can see that our application is now using the new theme that we defined, and it uses the different color scheme for the dark theme as we defined in our application theme. Next, let's define and customize some of our typography for the application. For example, for this component, welcome to my app, the easiest way is to go to my text composable. That is a custom component that I have defined, and change the default style from new themes typography to material theme dot typography dot display small or display medium. Let's use this default style. And next, let's go to welcome to my app. It is defined in the body of the scaffold. In fact, let's use this default style in the definition of my text here. So I copied and pasted display medium from my theme as the default text style for this composable. Let's go back to the previous one. My text. Welcome to my app. Let's add some padding to it. A padding top of 16 depth, and run the application. Alright, there we go. You can see that some of the components are already taking the effect of that text style from our theme. We can use that for other components as well. For my bar, for example, I can change it to my text instead of text. So here's where we specified the text style for the content of my bar. So instead of the text style from our previous theme, I'm gonna use from my new theme, material theme, typography dot display medium. Like this. And also for the other component, I can do the same. For the my surface composable, for example, provide text style. I can say material theme dot typography dot display medium, or display small. Let's use display small for this one. And for our floating action button, we are using text. I change it to my text so that it takes the effect of the default text style from our upgraded theme. Let's run the application. You see that the colors that we are using for light theme have too much contrast. We need to lower them a little bit. Once we run this application, I'll go and change that. Okay, my surface broke. I shouldn't have made that change for my surface. So I change. Oh, no. That's okay, but I forgot to specify the content. There we go. Run it again. There we go. One of the exciting features of Material 3 that I'm a huge fan of is the concept of dynamic color. And dynamic color is a feature that allows the users and their applications to take the color of their background, their wallpaper, and use it in the application. It kind of uses an algorithmic feature, an algorithmic extraction of the background color, the wallpaper color, and applies it to the application. This is called dynamic theme. For example, if I change the wallpaper on my phone to blue, then the theme of my application changes to the blue color, to a family, a variant of blue color. And if I change it to yellow, then it changes, the theme of my application changes to use the yellow color, or a family, a yellow color from the yellow family that is extracted from that wallpaper, and apply it to the theme of my application. So let's go to my theme definition and see how it works. The first thing you need to do is to make sure that your Android version supports that. The dynamic color feature is only supported on Android 12 and above, or API 31. So we need to check that with using the Android APIs. So I define in my theme a variable called dynamic, and then here check for build version build dot SDK build dot version. Let's import build, and then SDK int. If it is higher than, greater than, or equal to API 31 or Android S or Android 12, then it means that a dynamic theme is supported on our phone. So version codes build.version codes s is the version that we need to compare against. If you open S, you see that it is 31, API 31. So now in the place where we specify the color scheme for our material theme, I can check for dynamic as well. So I say if dynamic is supported and is dark, then we prefer to use dynamic dark color. So dynamic dark color scheme, and we pass the context to it, local context dot current. Let's import local context. Otherwise, if dynamic is supported, and is not dark, then we will use the dynamic light color scheme, dynamic light color scheme, and we pass local context current to it as well. Also make sure, let's not forget to change this high contrast color to a little bit moderate color. I go to the color file and decrease the severity of this color for all three colors. Okay. Now that our colors are ready and we have also incorporated dynamic color feature, let's run the application. There we go. Now our application is using the dynamic light color. Because I'm using Pixel API 32 emulator, this is higher than API 31, greater than or equal to API 31, therefore dynamic color is supported. And why this color is blue? Because I'm using this wallpaper, which has the dominant color of blue. Let's change it to another background color and see how it affects the theme of our application. Let's go back to the app. It's still not much different from the previous background. So I change it to another, to a red, for example, wallpaper. Back to the app. There we go. You can see that it changes to red color, to a variant of red. Let's close this screen capture that I took by mistake. And what if I change it to dark theme? If I change the theme of my phone to dark theme, how it affects the theme of my application? You can see that now it is lighter. So this is the effect of dynamic light colors and dynamic dark colors. Now this is using the dynamic dark color scheme. Back to light theme. Let's change to this wallpaper, which is predominantly green. Back to the app. There we go, it's now green. This is what we call dynamic color and dynamic theming. So, in this video, you learned how you can upgrade your existing Compose theme to Material Design 3. You learned about color schemes you learned about dynamic colors and the new upgraded typography system introduced in Material 3. I hope that you enjoyed. Before I go, I want to mention again the Material Theme Builder, the online tool, Material Theme Builder. That's a tool that you can customize your material theme online, and then you can use it. Material Theme Builder, there we go, materialfoundation.github.io. this is the link to it, and here you can play around with different values and for different backgrounds for your theme and see how it affects the theme, and also change to different colors, customize the primary, secondary, tertiary, neutral, and other colors in your application. And once you are happy with the values that you have selected for your theme in terms of the colors, then you can press export and get Jetpack Compose theme.kt file, which gives you several files including theme.kt, colors, and typography, and then you can add them to your application and use them. So that's it for Material 3 in Jetpack Compose. I hope that you enjoyed, and happy theming! Hello and welcome to a new section of the course. In this section we will talk about testing and how you can test your applications in Compose. So what we need to know first is that Compose uses a concept called semantics for testing, in which a semantics tree is created for your Compose UI components. So let's create a project and we will discuss along the way how it works. I create an empty Compose activity. I name it my Compose test, and I create it in an appropriate directory. A minimum SDK of 24 is selected. I leave it to default and press finish. We wait for the project to be created. Okay, our project has been created, and now the first thing we need to know and we need to make sure of is the dependencies for test has been added to our project. So we go to the build.gradle script file in the app module and we check for these dependencies: UI test JUnit 4 and UI test manifest. And the first one is prefixed with Android test implementation and the other debug implementation. Also, you can see that we have Android test implementation for the Espresso Core artifact. This is important because in case you want to interact with Android views and you have a hybrid application that uses both Android views and Compose UI, then you will need to use Espresso for testing Android views and Compose test for testing Compose components. Therefore, that's why we have added Espresso Core as well. And this is added by default by Android Studio, so we don't need to do anything on our part for the projects that we create in Android Studio. So first I'm gonna remove these composables and I'm gonna create a new composable. I'm gonna name it my box, and I'm gonna create a variable called greet by remember mutable state of false. First it's gonna be false. Let's import mutable state of and remember, as well as get value and set value, because this is a delegate. And then I'm gonna make it, I'm gonna create a box for a greeting. I'm gonna put a text inside it, welcome, and with a font size of 50 SP. And this, I'm not going to show this all the time. I'm gonna show it only when the greet is true. Therefore, I'm gonna put it inside an animated visibility. Animated visibility with this. So I cut the text and put it inside animated visibility, and I'm gonna pass a value to control animated visibility content. So I pass greet to it. Just as simple as that. And for the box, I'm gonna allocate all available space, fill max size, and then I put a button inside it to control the greet value. So greet, so I add a button here with a text of greet me. And for the onClick property of button, let's import button first. For the onClick property, which is the first parameter, I'm gonna enable greet, switch it to true. Just as simple as this. And we can also enable preview. Okay, I'm gonna call it inside surface. Let's see the preview with build and refresh. And while it's being built and refreshed, let's check out our test and where we need to add the test. Note that you need to make your compose test inside the Android test package. And why we created under this package, it's important because Android compose tests are instrumented tests, which means they are supposed to run on an Android device or on an emulator. So we write them under Android test. So we go to this package. You can check out the template example that has been created by Android Studio. I'm going to skip that and create a new file, Kotlin class. I'm going to name it my awesome test. And I'm going to create, the first thing I do is create a rule. And this is a compose rule. It's very important. The way we create it is like this. Val rule or compose rule, create compose rule. But you need to annotate it with get rule. So make sure you do that. Also, if you need to have access to a certain activity, you can create this compose rule using create Android compose rule with this. So I'm gonna skip that and just use create compose rule to make things simple. And once I have the rule, I can test different scenarios. The first thing I'm gonna show you is showing you the semantics tree that I talked about. So I create a simple test to show that. So I add an annotation for test. I import it from org.junit test, and then I name my test with this. print semantics tree. As I said, we have a semantics tree created for our Compose UI tree. So we print it here with compose rule. First, you need to set content, because compose rule doesn't assume any content by default. You need to specify the content that you need to have for your rule, and then you can test different scenarios inside it. So first, I set the content, my box. I specify my box inside it, and then I simply print that tree that is available in my box. So compose rule on root, and then we have an important property here called use unmerged tree. If you use unmerged tree, the default value, which is false, then an unmerged tree will be used, which means that some of the available nodes in this tree will be merged to each other. For example, if you look at button that we have in our box, button has two components, one button and one text. So if you use the unmerged version, both the button and the text will be mentioned in your Compose semantics tree. But if you use the unmerged tree of true, if you use the unmerged if you use the merged tree, which means you use unmerged, you set the flag for use unmerged tree to false, then both these components will be merged to each other. Therefore, we set this value use unmerged tree to true. We don't want it to be merged, so we use the unmerged tree. And once we are on the root, then we can print to log with my test log, my test tag. We specify a tag for our log with this. Okay, now let's run our test and print our semantics tree. I select this button and run my awesome test. Okay, you can see that our test was launched and the functions inside our test class were successfully run. You can now check the output log for the tests, and we are looking for the semantics tree that was run here and was printed here inside the logs. So let's look for that. Yes, that's here. You can see that the tag is here, my test tag, and here's this tree that has been printed, node number 1 at these coordinates, left 0 0, top 36 0, and right 480, and bottom 800 pixels. And again for node number 2, which is our button, we have left 0, top 45, right 148, and bottom 99 pixels. So we have 4 nodes in our tree. Each of them have their roles, you can see, with their actions and some other properties that are specific to the semantics tree. So this was for semantics tree and how you can access it and how you can log it for your tests. In the next video, we will talk about how you can access different components, how you can find different components, you can perform actions on them, and you can test their behavior. So stay tuned. In this video, we will talk about finding different nodes and performing actions on them, testing their behavior. So for our application, we have a simple UI. Let's check it out. In the preview pane, you can see we have a box containing the button and the text with an animated visibility, of course. And this button has not been aligned, so I'm gonna align it to the top center. So modifier and align to alignment center, top center. Let's do the same for animated visibility. Modifier, alignment, this time to the center. It's being updated. Import alignment, of course. And now it is aligned. Refresh. In order to test, I'm gonna first find this node, and then I'm gonna click on it and then check the value for animated visibility's text. If this is found, then this means that this test is successful. So to write that in test, I'm gonna go to the test file. I'm gonna write another test. Fun and text or greeting is displayed. I name it this way, and this is a test, so annotate it with test. And then compose rule, again I set content as my box and set content my box, and then once that content has been set, I check for that node. I use the search APIs in Compose testing APIs, so that is called on node with text. I search for a node with the text with greet me. We are looking for a node that has this text, greet me. And once we find it, we assert that it exists or is displayed. Assert is displayed, and we are more interested in it being displayed, not just being existent. Once it is asserted to be there, then we perform the click action on it. So I click on it with perform click, and then we check for the text of welcome. So again, compose rule on node with text welcome, and we assert that is displayed. If this happens, this means that the test has been passed. It has passed and it has been successful. Just as simple as that. So let's run the test again. You can run the whole test class or the individual functions defined in it. So I prefer to run the whole test because it just has 2 test functions. Let's wait for my machine to launch the test on the emulator and show the results. So we run the test by running the whole test class and we wait for the results. As you can see, the tests are running. Print semantics tree, one of our functions for the test, and the other will be greeting is displayed. There we go, one of the tests is successful. The semantics tree has been displayed and has been printed to our log. And now the second function is being run. As you can see here from the top, an instrumentation activity is launched and its content is our test. The content that we define for the test is displayed inside it, and then the behavior that we mean is tested on it. Yes, greeting is displayed. So both tests passed. As you can see, it's pretty simple to find different nodes with compose rule and then test different behavior on it. Also note that you can use other methods in order to find different nodes, and the compose tests are very flexible in that case. And for example, you can find different nodes just using onNode and then use a matcher like has text or has test tag or has content description or onNode with content description. And these are different APIs that are available from the testing APIs. They are classified as 4 groups of APIs called finders, matchers, actions, and assertions. And you can find more about that in the Compose documentation. And there's also a very good cheat sheet for Compose testing that is available from the same page. You can find it from developer.android.com/jetpack/compose/testing. And that's it for this test and for this lecture. I hope that you enjoyed it.